Welcome to Building.NET REST APIs, a complete course where you will learn how to build a production-ready .NET-based REST API completely from scratch and step by step. My name is Julio Casal. I'm a software engineer with many years building different kinds of .NET applications, and I'm the founder of .NET-Microservices.com, where I help .NET developers build cloud-ready .NET systems at scale. By the end of this course, you will have a complete REST API that uses the latest and greatest tech and best practices from the .NET platform, and that will be running not just in your box, but will also be fully deployed to the Azure cloud. So let's get started by taking a quick look at the topics we'll cover in this course. This course covers everything you need to know to build a complete REST API with .NET. You will start by learning how to use ASP.NET Core and C# to create a REST API to manage the games catalog of a fictional game store. In this REST API, you will initially implement the traditional post, get, put, and delete operations with only a few lines of code. After the initial implementation, you will learn how to future-proof your API by incorporating several essential techniques like route groups, input validation, extension methods, and data transfer objects, as well as useful patterns like dependency injection, singleton, and repository. Then, you will stand up a SQL Server database in your box, and you'll learn how to use the ASP.NET Core configuration system and the .NET Secret Manager to securely connect your REST API to the database. And following that, you will learn how to use the popular Entity Framework Core ORM framework to easily query and modify your database data using only the C# language. Here you will also start using the asynchronous programming model to improve the API performance and get it ready to scale. Then, you will switch gears towards securing your API. You will learn how to use token-based authentication along with role-based and claims-based authorization to ensure that only allowed clients and users can get access to your API. Then, you will explore the multiple features of .NET's login system, which will be fundamental for understanding what's going on with your API as it leaves your box. This will lead you to understand the right way to do error handling in ASP.NET Core applications, which will be essential for troubleshooting issues in production. And you'll understand and take advantage of the platform's middleware feature to centralize and simplify error handling for the entire application. Then you'll dive into another essential topic, versioning. You will learn how to establish multiple versions for your REST API to make sure that you have a solid way to introduce new features without breaking your clients. Now, I want to make sure that you don't just build this REST API in isolation, but that you're also aware of the different challenges of integrating it with client applications. That's why the course includes a ready-to-run single-page application that you'll learn how to connect to your REST API so you can see a real use case end-to-end. One of the challenges of integrating the client is having a way to identify users and understand the permissions that both the client and users require to access a REST API. That's why here we'll integrate Auth0 to act as the OpenID Connect provider that will provide access tokens to talk to your REST API. Next, you'll learn how to implement pagination to ensure that your REST API has a way to return smaller chunks of data to clients for a much better user experience. And then you'll also implement a search feature so that users can quickly find what they are looking for. Then, before looking at the cloud integration aspects, you'll learn how to properly document your entire REST API using OpenAPI and Swagger so that other developers and clients can easily tell what your API is all about and how to make best use of it. Next, you'll dive into your first cloud integration with the Azure Blob Storage service, which you'll need to enable image file uploads through your API. This will complete the user scenarios for this fictional game store. However, I also want to make sure that you get a complete picture of what it means to take a REST API all the way to a production environment. That's why next you'll stand up a SQL database in the Azure cloud, and then you'll deploy your REST API as an Azure App Service website that will be integrated with the cloud database and that you'll be able to access from anywhere in the internet. Finally, you will get a chance to deploy the client to the cloud via the Azure Static Web App Service, and with that, you will have a complete picture of what it means to run not just a REST API, but a full stack application in a production environment. Next, we'll take a look at the finished REST API in action. Let's take a look at the finished REST API in action so that you get an idea of what you'll be able to do by the end of this course. Across this course, you will create the REST API for a fictional game store, and in particular for the games catalog section of that game store. So if we scroll down a little bit here, you're going to see that we have a bunch of endpoints to perform the typical CRUD operations for games management. So in this case, it would be an endpoint for getting all games, an endpoint for getting a game by ID, for creating a game, for updating a game, and also for deleting a game. And there's also an endpoint over here to upload the image that's going to be associated to each of the games. Now, of course, for each of these endpoints, you have a full description. Let's say we expand the put endpoint here. You get a full description of what this endpoint is for, what are the parameters supported by that endpoint, what is an example request body that you can send for that endpoint, and all of the expected responses that you can get from that endpoint, right? The same thing for all of the endpoints. And if you go all the way to the end, you're also going to see that we have the full list of all of the contracts or DTOs that are supported by this REST API. And one thing that you may notice here is that there is a mention of a version right here, right, V1 for one of the DTOs, and that is because this REST API actually supports multiple versions to allow for introducing new features without having to break our clients unnecessarily. So if you go all the way to the top, you're going to see that you can actually select up here, you can select between V1 or V2 of the API, right? Where in V2 we have only implemented a couple of endpoints, but they return a different DTO, in this case with a different payload for the clients that are supporting that new version. Now, going back into V1, if you notice here, this REST API exposes its OpenAPI specification via this swagger.json file. If we click on that, this is the OpenAPI specification for the REST API, which allows any other kind of tool to easily start interacting with that API. And in fact, what I did is I just took this JSON here and I brought it into my Postman tool, which is a super popular tool for interacting with REST APIs. And after importing the REST API, I have the capability to start interacting with it in a very easy way. So for instance, if I wanted to go ahead and get all the games that have been created in my database, I'll click on the Get All Games endpoint over here, and then I can go ahead and click on Send, and that's going to go ahead and retrieve the games that are stored in the REST API, as you can see. Now, one thing to notice is that I'm not querying this in my local box. I'm actually going ahead and querying this directly from the Azure cloud, right? Because across this course, we want to show not just how you can create this API in your local box, but how you can interact with it and deploy it all the way into a production environment in the Azure cloud, right? So everything here is coming from the cloud. Now, in this endpoint, you can also do things like paging, right? So you can go ahead and just add a little parameter here to say, let's say I want to do a page size of 10, right? To get 10 games as opposed to the default 5 games. And so if I hit send, now I'm going to get a list of 10 games as opposed to the initial 5 that we had before. And we also support a feature of a search, right? So you can do now filter, and we can say, okay, so I want to filter and only get the racing games, right? As opposed to all the games. So I'm going to click on send, and this time I only get the racing games, Mario Kart 8 Deluxe and Forza Horizon 5, which are my racing games, right? So you can search either by the name of the game or by the genre of the game. And if I wanted to create a brand new game, I could go into the post endpoint over here to create a new game, and I'm going to expand this a little bit down here. So we have a payload here to create a Minecraft game. So I'm going to click on send, but what we're going to notice is that it doesn't succeed, right? We get 401 unauthorized, and that is because all of the endpoints that allow for any kind of modification of the data are protected, right? So they are behind the authorization and authentication features of ASP.NET Core. So you will not be able to just access that way. So in order to actually send the request, what we have to do is go into auth, and we have to enable, let's go ahead and enable OAuth 2. And I have pre-configured a bunch of settings here. And so what I'm going to do is just get a brand new access token over here. And that is going to actually open up the page from the Auth0 service, which has been configured for this REST API. And I'm going to log in as the admin. Okay, so I'm going to log in. And after a successful login, I'm going to go ahead and receive my token. As you can see, here's the access token. And then I'll do use token so that we now have the ability to actually go ahead, and I'm going to hit send once again. And the game has been created. As you can see, that was a success. Okay, so across this course, we'll learn how to perform all of this integration to make sure that your API is fully secured. And of course, we could keep trying the different endpoints over here in Postman, but I think the best way to really show off what your REST API can do is by integrating it into a real and modern client UI, right? So that's why this course includes a ready-to-run client application that I can show you right now, and which is an application that you don't have to code. All you have to do is just download the source code that's included with the course, and you can go ahead and just run it, and it's ready to go ahead and connect to your .NET REST API. Now notice that this application is also running fully in the cloud. As you can see right here, this runs in the cloud, so that you can get an idea of how to run both your client and your REST API end-to-end in a production environment. And of course, in this application, you can also see all of the features that we saw in the REST API also enabled here in terms of querying, right? So you can go ahead and do pagination. As you can see, you can go to page 2, page 3, and here's a brand new Minecraft game that we just created via the REST API, which doesn't have an image just yet. And then we can go back to page 1. I could use this search box to just type here, let's say Final Fantasy. That's going to retrieve all of the Final Fantasy games from the REST API. Or if I wanted to just look for racing games, again, that's going to retrieve all of the games from the REST API that have the racing genre. All right, and so let me clear those search filters. And of course, one feature that we seem to be missing here is the ability to modify this games catalog here. And that is because we have not yet logged in into the application. So let me go ahead and click in the login button in the top right over there. So I'll click on login, and that's going to once again pop up the Auth0 authentication page. So I'm going to log in as an admin. And after doing that, the client recognizes that I am an authenticated user and I have the correct role, an admin role, to be able to do these modifications. And as you can see now, we have a bunch of new elements showing off over there and also down here and down there, right? For each element, for each game, we can go ahead and do modifications. So now let's go ahead and, for instance, let's go ahead and create a brand new game. So let's say we're going to be creating the Super Mario Bros. 3 game, right? Which is going to be, and we can select here, of course, that is going to be kids and family. And let's scroll down, and the price is going to be $19.99. And the release date, it was 10/23/1988, so a while ago. And so here you can also go ahead and choose a file that you want to use as the image for this game, right? And so here's the game catalog that you're going to get also as part of the downloads for this course. So you can go ahead and select one of these images. I'm going to select the Super Mario Bros. 3 one, open, and this is going to go ahead and upload the image into the Azure Storage Service, right? And retrieve the actual URL back into your REST API, so that when you save the game, you now have, you see page 3 now, you can see that we have our Super Mario Bros. 3 game with its nice image right there. And of course, just like you can create games, you can update your game. So for instance, let's say for Minecraft, we don't have an image there yet. So I'm going to click on the edit button right here. And I'm going to say that this is actually Minecraft for Nintendo Switch. And then we're going to say that we actually want to choose a file for it. So I'm going to click choose file. And then I'm going to select my Minecraft image over here. Click open. Again, the image gets uploaded into the Azure Storage Service. And then I'm going to click on save. And if you go back to page 3, you're going to see that Minecraft now shows its nice image. And finally, you also have the ability to delete a game, right? So I'm going to go back to page 1. And if I didn't want to see anymore my Fortnite game over here, I'm going to click on delete. I'll say delete there. And now the game is deleted and it is replaced by a game from the next page. So now that you know what you're going to build in this course, let's talk about what you need to know before starting with the course topics. In order to take this course, you should have some basic knowledge of C#, Java, or a similar object-oriented language. You should also know the essentials of web development, and it would also help if you have some experience with relational databases. However, this is a beginner-level course, so you don't have to be an expert on any of these topics since we write every line of code from scratch and everything we do is explained in detail. Next, we'll go over the software prerequisites that you will need in your box to get started. In terms of the software prerequisites for this course, all the tools you'll use are cross-platform, so you can use any computer with Mac OS, Windows, or Linux as their operating system. You will also need to download and install the following: the .NET Software Development Kit, or SDK, which includes everything needed to build and run .NET applications; Docker Desktop, which you will use to run your database server; Postman, the popular API client that you will use to interact with your REST API; and Visual Studio Code, a lightweight but powerful source code editor that you will use to write, build, and debug your code. You could also use any other code editors if you prefer, but VS Code is your best choice to follow along step by step. Please make sure you download and install these tools in your box using the URLs on screen before starting the coding part of the course. In this lesson, you will get an overview of ASP.NET Core, why you want to use it, and the different types of applications that you can build with it. So, what is ASP.NET Core? Well, in simple terms, ASP.NET Core is a popular web development framework for building web apps on the .NET platform. ASP stands for Active Server Pages, which was Microsoft's first server-side scripting language and engine for dynamic web pages, and was released in December 1996. It was superseded by ASP.NET in January 2002 with the first version of the .NET framework, and several years later, around 2016, it was superseded again by ASP.NET Core, where Core mainly hints to the cross-platform capability of this web framework. Now, it would be good to also briefly mention what is the .NET platform and how it relates to ASP.NET Core. .NET is a free, cross-platform, open-source development platform for building many types of applications that go from apps for Windows desktops to web applications, cloud applications, mobile applications, games, apps for Internet of Things, and even apps designed for artificial intelligence scenarios. .NET is a unified platform that serves the needs of all app types to make it easy to reuse code across all of your apps. Now, in this course, you will focus only on ASP.NET Core, which stands for the web type of applications that you can create with the .NET platform. Now, how do you create ASP.NET Core applications? Well, you got to use a programming language, but that language is not really .NET or even ASP.NET Core. You get to choose between 3 languages to create your ASP.NET Core apps, which are C#, F#, and Visual Basic. But in this course, we will be using the most popular one, which is C#. When you install the .NET Software Development Kit, or SDK, you get access not just to these languages, but also to a series of tools that make it very easy to get started with the platform, even before choosing a code editor or IDE. You also get access to a Microsoft and community-supported set of libraries and packages that can quickly expand the functionalities of your app so you don't have to reinvent the wheel. There are many ways to deploy ASP.NET Core apps to make them available to your users, that go from simple Xcopy deployments to fully Dockerized deployments ready for the cloud. Your ASP.NET Core apps are cross-platform, meaning that the same code that you write once can run on macOS, Linux, and Windows. And it's all open source on GitHub. Along with .NET Core, it has thousands of contributions by hundreds of developers and companies, making it one of the fastest growing and loved projects on GitHub. We talked about the different kinds of applications that you can create with the .NET platform, but even with ASP.NET Core, there are also a few types of applications that you can create. On one side, you can create very rich, dynamic, and interactive web UIs or frontends with the extensive UI framework included in ASP.NET Core. But on the other side, you can also create many kinds of secure and powerful backend services that can provide data to the web UI or take care of long-running or compute-intensive scenarios that don't need any user interaction. Now, when you create web UIs with ASP.NET Core, you have the choice to create either server-rendered or client-rendered UIs. A server-rendered UI dynamically generates the HTML and CSS of the pages on the server in response to browser requests, so when the page arrives to the browser, it is ready to display. To create this type of apps, you can choose either ASP.NET's MVC framework, which uses the model view controller pattern, or the Razor Pages framework, which follows a page-based model. A client-rendered UI dynamically renders the UI elements on the client, directly updating the page you see in your browser as necessary. These type of UIs are also called single-page applications, or SPAs, since usually there's only one single page that is continuously updated as you interact with the site. ASP.NET Core includes a complete UI framework known as Blazor for building this type of application with C#, HTML, and CSS. There are also several choices for building backend services. Web Application Programming Interfaces, or Web APIs, are the most common form of backend services, given how easy it is to use them to query or send data from and to backend servers using the HTTP protocol. ASP.NET Core offers 2 approaches to creating APIs. Controller-based APIs, which use controller classes to handle API requests, and minimal APIs, which define endpoints with logical handlers in lambdas or methods. Besides Web APIs, you can also create real-time applications via SignalR to push content directly from the server to the client, or gRPC apps, which allow for high-performance remote procedure calls between clients or services, or even background worker services, which can perform tasks that usually require no user input, like long-running or compute-intensive operations, or even tasks that start based on some sort of external event. You could also create microservices, which are business-aligned, loosely coupled services that small and focused teams can build and deploy independently using one or more of the available backend service technologies I just mentioned. Now, in this course, we will focus only on backend development, and more specifically, we will only cover the creation of production-ready REST APIs using the minimal APIs approach, since it's the easiest way to get started with minimal code and configuration. In the next lesson, we will get our development environment ready to start creating ASP.NET Core applications. At this point, you should have already installed all the software prerequisites that I mentioned in previous lessons. If you have not done so already, please go back, install the prerequisites so that you're ready for what's coming next. Now here I am in Visual Studio Code, and the first thing that we're going to do is to just change a few settings so that our C# development experience becomes much better. So what I'm going to do is just go into File, and then let's scroll down into Preferences and then Settings. And here we're going to be looking for a setting called Place Open Brace. And the settings we're looking for are Place Open Brace on new line for control blocks and Place Open Brace on new line for functions. So you want to tick both those settings, and that's going to allow us to make sure that anytime we create either an if-else or a switch or any of those control blocks, so that the curly brace starts in the next line. Same thing for functions, we want that curly brace to go to the next line. So this is more of a personal preference, but I find that it makes the code much easier to read. And the next setting that I want to enable is one called Format on Save. So you're looking at this setting over here, Format on Save, and you want to tick on that one. And this is going to allow us so that anytime we save a file, the editor itself is going to format that code so that it just looks better, right? So that's going to save us a little bit of keystrokes. Then what you want to do is go into File, and then you want to look at this setting over here called Autosave right there. Okay, so I'm going to go ahead and click on that one. And so with that one, what's going to happen is that anytime you make changes to your code files, those changes are going to be automatically saved into your machine without you having to save or hit Ctrl+S or anything like that. The code is just going to be auto-saved. So I find that also very useful as I go through the changes in my machine. So that's it in terms of our settings. And I'm going to close this and also close that. And the next thing that we're going to need is a couple of extensions. So if we go into the extensions hub right here, the extensions hub, click on that. The only extension that I have installed so far is this one called VS Code Icons. And I'm going to close this. VS Code Icons, which just gives some nice coloring into the file explorer in VS Code. But the one that we really need is this one called C#. And this is going to be the very first one, the one created by Microsoft, this one over here. You want to install this one, so just click on Install. All right, and that's going to install in just a few seconds. And this is going to bring in all of the C# productivity features enabled by the OmniShard server, which is an open source implementation that allows you to have really all sorts of IntelliSense and all sorts of nice productivity features of C# in your Visual Studio Code experience. Lastly, you also want to bring in another extension called C# extensions. Okay, and that's going to be this one over here. And notice that this is the one by JOS Creative, right? There are a bunch of versions, but this is the one that you really want. And you want to just click on that and click on Install. And this is going to add a few other context menus that are going to make it much easier to create C# files inside Visual Studio Code. So that's it in terms of the extensions, and I'm going to close this and close that. And the last thing that I'd like to do is just to verify that .NET has been properly installed into the box. So what I'm going to do is just go into my terminal by going into View, Terminal. And of course, you can also do this, if I close this, by just doing Ctrl+ on Windows, or you can also do Ctrl+J, which is my favorite shortcut. And in this terminal, all I have to do here to verify that .NET has been installed is just do .NET-info. And that's going to bring in all of the information about the version of .NET that you have installed. And as you can see, here's the version that I'm using right now. It's version 7.0.203. So with all this ready, let's move on into the next module where we're going to learn how to start creating our first .NET REST API. In this module, you will learn the basics of REST APIs and how to create your first REST API using the tools included with the .NET SDK. By the end of this module, you will have a solid understanding of the following: what is a REST API, how to identify resources in a REST API, how the different REST API HTTP methods work, how to create and configure a web API project in ASP.NET Core, how to implement a basic REST API with ASP.NET Core, and how to test your REST API using Postman. In this lesson, you will learn the essentials of web APIs in ASP.NET Core, how to identify resources in a REST API, and how the different HTTP methods work. So, what is an ASP.NET Core web API? Well, it turns to be that it is nothing more than a REST API implemented using ASP.NET Core. And your next obvious question is going to be, what is a REST API? To understand what a REST API is, start by thinking about all these apps that you have in your phone, like your weather app, Twitter, or Spotify. These apps use a ton of data, like the latest weather information, the top tweets of the last hour, or the hundreds of hours in your favorite playlists. However, that data can't live in your phone, which is what we know as a client, because it will be way too much data to store in your device and you want fresh data all the time anyways. So the data has to come from somewhere, and that somewhere is going to be some sort of server computer that usually lives somewhere in the internet cloud. How can these apps talk to that server in the cloud to retrieve that data? Well, by using an API. API stands for Application Programming Interface, and is how a service defines the functions it provides to clients. So for instance, going back to the Spotify example, the Spotify Cloud Service could define an API with two functions. Get recent songs function that receives the username as a parameter and that returns the 10 most recent songs for the specified user. There could also be a play song function that receives the song name as a parameter and that returns the stream for that song so that a client can play it. Like this, there could be dozens or hundreds of other functions offered by the service that clients can use to interact with it. So an API helps clients communicate what they want to the service so it can understand and fulfill the request. So what is REST? REST stands for Representational State Transfer, and it defines a set of guiding principles that impose conditions on how an API should work. We won't dive into each of these principles in this course, but the important thing to know is that thanks to them, you can build APIs that are scalable, flexible, and independent of the technology being used in the client and in the server. So going back to the original question, a REST API or RESTful API is one that conforms to the REST architectural style. Now, the main reason why we want to stand up a REST API is so that our clients can interact with the data that it manages. But how do they actually reach that data? Well, for this, it is good to first understand the concept of a resource in a REST API. In a REST API, a resource is an object, document, or thing that the API can receive from or send to clients. For instance, in our game store application, the main resource is going to be our games. That's what clients want to query and modify. But in other applications, like the Spotify example, one of the resources could be the songs. And in the Twitter example, one resource could be the users, and another one the tweets themselves. These resources will be hosted on some domain, which could be a public domain, an intranet location, or it could be just your dev box. And they can be accessed either via the HTTP protocol or the HTTPS protocol, which is a must in public environments. So when you combine all of this, you get what we know as an Uniform Resource Identifier, or URI, and that is what your clients will use to identify and reach the resources on a REST API. There could be more parts to this URI, but these are the essential elements. Now, how do you actually interact with the REST API? Well, just like with traditional web pages, when clients want to request something from the servers, they will send an HTTP request using the resource URI to the server, and then the server will send back a response. However, in REST APIs, these requests and responses will look a bit different depending on the specific HTTP method used to call it. The most common methods are POST, which creates new resources, GET, which retrieves the representation or state of the resource, PUT, which updates an existing resource, and DELETE, which deletes the resource. So these methods allow you to create, read, update, and delete resources, and therefore they are also commonly known as CRUD operations. There are other methods too, but for the purposes of this course, we'll focus on these four ones. Let's take a quick look at each of these methods in the context of our game store example to understand better how they work. To request all games, a client will send GET request to the game's endpoint, and the server will respond with something like this. The first part of this response is the status, which is 200 OK in this case. This means that the operation was a success. There are many other HTTP status codes that a REST API will send back depending on the result of the operation, many of them for failure scenarios. The next part is the body, which contains the list of games in this case. Notice that this body is not HTML, which would be expected to render traditional web page. Here the format of this response is known as JSON, which stands for JavaScript Object Notation. This is the de facto format for sending and receiving data in REST APIs because of how easy it is to read and write and is supported by all major programming languages. If instead of getting all games you wanted to get a specific game, you would again send a GET request, but this time you would append the resource identifier at the end, number 1 in this case. The server will respond with the state of the game with that identifier, assuming it is able to find the game. To create a game, the client can send a POST request, once again using the game's resource URI, but this time it needs to specify the desired resource state in the body of the request, which in this example only includes the name of the game, but could include many other properties of course. The server will usually reply with a 201 created status code, and if the resource identifier was not specified as part of the request body, the response will usually include it. To update an existing game, the client sends a PUT request with the same resource URI as the one to get a game, but this time it includes the resource state, just like in the POST scenario. The server will completely replace the state of the game associated with the specified identifier with the new state and will typically respond only with a 204 no content status code. Finally, to delete an existing game, the client sends delete request to the URI that identifies the game to delete, and after deleting the resource, the server will usually respond with a 204 no content status code. So, in summary, your complete game's REST API would look something like this, and should offer all the support that your clients expect from a modern backend. Let's now jump back into the code to see how to implement this REST API in ASP.NET Core. So let's see how to go ahead and create our first .NET REST API. So here I'm back in Visual Studio Code, and the first thing that we're going to need is some sort of directory where we're going to be storing all of the files for the REST API. So what I'm going to do first is to just get rid of this welcome screen, and I'm actually going to click on this checkbox over here because we're not going to be needing this welcome screen anymore. I'll close on that. And then what I'm going to do is to open my terminal. And to open the terminal, what you can do is to go into View, Terminal, right? That's going to open it. Or you can also use a shortcut, like on Windows, you can do Ctrl+, or you can also do Ctrl+J to open and close your terminal. And now we are in the terminal, I'm going to go ahead and just switch into my D drive, and I'm going to go into my projects directory. And here I'm going to go ahead and just create a brand new directory that I'm going to be calling Game Store. Of course, you can create or use any other directory in your box. This is just the one that I chose for this course. And now that we have our Game Store directory created, let's go ahead and open it in Visual Studio Code. So I'm going to go into File, Open Folder, and then we can go into my D projects and then Game Store directory right here. And then I'll just click on Select Folder. And that's going to open Visual Studio Code in the context of the Game Store directory. Okay, so now it's the time to go ahead and create the project. So to do that, we're going to be using the .NET CLI in our terminal. So let me first collapse this pane for a moment, and then I'll open up my terminal using Ctrl+J. I'll open up this a bit more. And then to use the .NET CLI, all you have to do is just use .NET, and in this case, the new word over there. And then before we create the project, let me show you just a quick list of all of the project types that you can actually create here. So I'm going to say just list. And then, as you can see, this is a full list of all of the different project types that you can create with the .NET CLI. And that goes from ASP.NET Core projects, as you can see here. We also have some Blazor projects that you can create. You can create class libraries, you can create console apps, and you can create really a bunch of different types of projects. But the one that we're mostly interested in here is this very first one over here, ASP.NET Core empty application, we short name web, because that's the one that's going to provide us with a very clean slate to start very small with this web API, and we will start building up on top of that over and over across this course. All right, so let's use that template. So for that, let me just clean my screen, and I'm going to say .NET new web, and then we'll use the -n argument to specify the name for the project. So the name is going to be GameStore.api. Right? So I'll hit enter, and then the .NET SDK is going to go ahead and provision or create the project files for us. So if I now go, and let me just restore my terminal over here, go to Explorer, and if we expand on the left side, you're going to see that we have a bunch of new files just created. So let's take a quick look at each of these created files so that we get a better idea of what each file is for. So let me just close my terminal, and let's open up GameStore.api.csprog. So this file here is known as the project file. So you always have a project file, and this is the file that's going to describe what type of project this is. So in this case, as you can see here, this is going to be a web type of project, which makes sense because this is a web API. Okay, and then another important setting here is the target framework, which in this case it is Net 7.0. Okay, so this target framework defines which are going to be the set of APIs from the .NET SDK that are going to be available for your project or for your application, right? So since we didn't specify a specific version when we created the project, it just defaulted to the version of the SDK that we're using, which is .NET 7. I'm not going to go over the other contents of this file right now, but just know that there are going to be another important thing here is going to be the project dependencies that we're going to bring in later on, but we'll take a look at those when the time comes. Now, the next file that I'm going to look at is program.cs, and this file is known as the entry point of the application. Now, usually when you open up a C# file in Visual Studio Code, you're going to get this prompt over here. And what you want to do is just click on this yes button over there. Just click on yes, because that's going to go ahead and generate a brand new .vs Code folder over there, which we're going to be talking about in a moment. But it's very important to enable a nice building and debugging experience in Visual Studio Code. Now, also notice that as we open this program.cs file, the OmniSharp server was started. And you can tell it because of this little fire icon that you can see over there. Okay, that means that the OmniSharp server started. And like I said before, OmniSharp is the component of the C# extension that enables all of the nice C# features, IntelliSense, and a bunch of productivity features of C# inside the Visual Studio Code experience. So you want to make sure that you always have OmniSharp up and running in your C# projects. Now, if for any reason this VS Code folder did not get generated when you open the CS file over here, you can always generate it manually by just going to your command palette. So you can go into View, Command Palette, and then what you want to do is just look for this option called .NET Generate Assets for Build and Debug. So you click on that one, and then in this case, of course, it's going to ask me to replace what I have, but in your case, it can just go ahead and generate the files for you. Okay, so that's another way to get these things up and running. So I'm just going to hit cancel here. Now, what is going on with this program.cs file? Well, just a few important things. The first thing is that we're creating this object here that is a web application builder object, right, with this very first line. And this object is going to be used to define or to register a bunch of services and to configure a few things that are essential for your application. Right now, we don't have any services really to configure, so that's fine. But later on, you're going to see how we're going to be using it extensively to configure and to set up a bunch of services for the application. Now, the next line here uses that builder object to build what we know as the web application, and which is this app object over here. So that app object over there is the one that you're going to be using for defining the application pipeline. We're going to define multiple things, like for instance, the endpoints are going to be available in your REST API. As you can see, by default, we got one endpoint defined right here, right, which is listening is going to be a get type of endpoint, so it responds to the get operation, and it's listening, it's going to be mapping into the root of the application, and then this lambda here defines what's going to be the response when somebody invokes that endpoint. And we'll see this in action in the next lesson, but for now, just know that this is a very simple way of defining your initial endpoint there. And then the last line, app.run, just goes ahead and starts the execution or runs the application in the host, in the Kestrel host in your box, right? So that it can start serving requests. A couple of other files that we have available here are appsales.json and appdevelopment.json. And these files are normally used to define a set of configurations that you don't want to hard code in your code files, right? So that way you can have different sets of configurations that can have different values depending on the environment where you're executing your application, right? For instance, appsales.json is usually the one that's going to be available for the production application, but you can also have appsales.development.json that's going to set specific values for your development environment. And you can see how we're defining logging here for the development environment, but we'll talk more about logging in a future model. Another important file here is going to be inside properties, launch settings.json, and this one defines what we know as profiles, right? That define a bunch of different settings that are going to be available for your application only where you're running in your development environment or in your dev box. For instance, this first section over here under profiles, this section here is known as the HTTP profile, and it's going to be the default profile that's going to be activated if you don't specify a specific profile. And this one is going to define a few things, but the most important one is going to be the application URL right here. So this is the URL that you can use in your box to access the REST API. Now that port number over there, 5115, got automatically or randomly generated for me as I created the project. So you're not going to get that same port usually. You'll likely get another port, but regardless, this is going to be the location of your application for HTTP purposes. Now, if you do want to use HTTPS in your box, you can also go ahead and use this other profile over here, the HTTPS profile. Right? So there are arguments in the .NET CLI you can use to start using that profile there. And as you can see, that defines an HTTPS URL that you can use to start using HTTPS instead of HTTP. Now in this course, we'll be mostly using HTTP. There are also some other settings for IIS, but we're not going to be using also IIS Express or IIS in this course at all. Now, we also saw that we got this VS Code folder generated on the left side. And so this folder has two files. The first file is named task.json, and this one defines how you're going to be building your project using the built-in tools of Visual Studio Code. And then we also have the launch.json file, which defines how is that Visual Studio Code can start and initiate a debugging session of your application within Visual Studio Code. And so now that we know what all of these files are for, in the next lesson, we're going to see how to build and run and also debug the application within Visual Studio Code. Let's see now how you can go ahead and build, run, and debug your application inside Visual Studio Code. So to build the application, what you can do is the following. Let me go ahead and open the terminal. I'll use Ctrl-J. So this opens my terminal, and I'm going to switch into my GameStore.api directory, okay, because that's where the files actually live. Now from here, all you have to do to build the project is just type .NET build, like that, and that will go ahead and build the project and produce the output DLL, as you can see right here. Here is the GameStore.api.dll generated, which you're going to find under bin, under the bin directory. You're going to find your DLL right there. Okay, so that represents the compiled version of your application. Now, in order to actually run the application, what you can do is the following. So let me clean this. You can go ahead and say .NET run, okay, hit enter, and that's going to spin up and start hosting the application locally in your box. And you can see that you also get your host and port right here. This is the host and port that you can use in your box to access the application. Okay, so what happens if we just navigate over there? So let me show you this. I'm going to just copy that URL and I go into my browser now. Over here, I'll just paste that, hit enter. And as you can see, we are getting our hello world displayed in this very, very empty web page. And this makes sense because if you go back into the code, you're going to remember that in Program CS, what we have is just one endpoint over here that when you go into the root of the application, it responds with hello world, right? So that's what we have right now. But of course, we're going to be expanding this significantly to define our API later on. So that's kind of one way to do build and run of the application. Now, another way that you can actually build the application, and let me close this for a moment, is by using the integrated Visual Studio Code experience. Since Visual Studio Code generated these launch.json and task.json files, right, what you can do is this. You can go into your menu bar, and in this case, it'll show 3 dots here because it's a bit smaller, but you want to look for the terminal menu in your bar, and then just go into Run Build Task or Ctrl-Shift-B. So you click on that, and that's going to go ahead and build your project directly using the Visual Studio menu. Now, because we can do this using the integrated build menu, it also means that we can just do Ctrl-Shift-B, as I just did, and then build directly. And all of that is enabled because of the task.json entry that you have defined over here. If you see in task.json, you have this build task defined over here. And because of that, you can do what I just did, right? So like I said, Ctrl-Shift-V will go ahead and build your project. Now, if you wanted to debug your application using Visual Studio Code and use breakpoints and stuff, what you can do is just let's go into program.cs for a moment, and let's put a breakpoint, let's say over here, okay? And let's see if we can hit it. Now, in order to start a debug session, what you want to do is go into this debug view over here, the debug view. So you click on that, and that's going to show you this pane over here, run and debug, where in this dropdown, you're going to see the different launch configurations that are defined in your launch.settings, launch.json file. So let's click on .NET Core Launch Web. And then what you can do, I'll just collapse this for a moment, and I'll click on the Start Debugging button over there. And what you're going to see is that the debug session actually starts. We hit the breakpoint right here, and you can even inspect the variables if you wanted to. And then, of course, you can step over and do the usual things. You can see the content of all the variables, and then you can just click on play so that this continues executing. And as you can see, this opened a browser window, right? With our hello world displayed right there, just as we saw before. So that's how you can debug your application inside Visual Studio Code. And like I said, and I'm going to stop this is enabled again because of the launch.json file that was defined when that was auto-generated by Visual Studio Code. Now, one thing that I'd like to change here is this one setting over here. And this is because this is a setting that enables opening the browser anytime you start debugging, right? So if I just do like I just did, right, with the debug section here, or even with F5, I can just hit F5, right? And what's going to happen is that it's going to start application and it's going to hit breakpoint. I'm going to remove this breakpoint for a moment. Hit play and it's going to open yet another browser, right? So as you can see, this is going to get a little bit polluted with too many browser windows for our web API. And the thing is that you don't really use the browser to do any sort of testing of your web APIs. So this is really not needed. So what I'm going to do is just go back to Visual Studio Code. I'll stop this, close that, and then go back to launch.json. And what I'm going to do is just remove this section here that says server ready action, right? Because if you just remove this, the browser is no longer going to open anytime or every time you start a debugging session. So I'll hit F5 once again, F5, and this is indeed going to start the debugging session as it did, but it's not going to open a browser anymore, right? I find that super convenient because otherwise, like I said, you end up with so many browser windows. Most of the testing of the API is going to be happening in the Postman application, which we're going to take a look pretty soon. So now that we know how to build, run, and debug our application, let's go into the next lesson where we're going to learn how to define the entities that are going to be needed by our REST API. It's time to define the class that is going to represent the resources that our REST API is going to manage. So for that, what we're going to do is just right-click at the GameStore.api directory. So you just right-click there. We're going to say new folder, and then we're going to be typing entities. So here's where we're going to be defining our game entity, right? So the game is what defines the resources that are going to be managed by our GameStore API. Let's just go ahead and right click on entities and then new C# class. And the name of the class, like I said, is going to be game. Now, one thing that you can notice here is that the C# extension that I'm using in VS Code is actually defining the namespace as a block scope namespace, right? As you can see here, because of the curly braces that is here, so the class is inside the namespace. And that is okay, but I think these days a better way to do this is by using another thing called block scope namespaces, which saves a little bit of space on screen. So if you just step over anywhere in the namespace name over here and you click on this light bulb, what you're going to see is that you can select this option that says convert to file scope namespace. So if you just click on that, you're going to see that now the class is at the very, very left, right? And then the namespace has this semicolon on the end, right? So it's kind of the same thing, but now we're saving a little bit of horizontal space, which I think is a big saver, a small improvement, but a big saver in terms of horizontal space. And just like we did that, let's also go ahead and clean up a little bit these namespaces at the top. So what I'm going to do is, once again, you can just put your cursor anywhere in these namespaces here, click on the light bulb, and then you can select remove unnecessary usings. So I'll be doing this exercise of using file scope namespaces and just cleaning up the namespaces over there, just so we have a cleaner code overall. So now let's go ahead and define the actual properties of our game class. And the first property is going to be the ID. So let's define, and you can just type prop and then tab. That's going to define a property just like that. And then the type is going to be int. That makes sense. And then the name is going to be just ID. Right? So that defines our ID property. And let's go to the next one. This is going to be the name of the game. So again, just type prop, tab, and then this is going to of type string, and then it's going to be name. Now, one thing that you can notice here is that we have a small squiggle here with a warning, right? That what it's saying is that we have defined a property of a string type, but we have not set any value for that property, right? So what the compiler wants us to do here is to actually define some value for that string property, or define that the property is going to be nullable, right? So you could do something like this, right? Some value if you wanted to, like that, and that's going to satisfy the constraint. Or you could do something like string.empty, there, right? Or if you wanted to keep it nullable because you're saying, well, it doesn't have to have a name, then you could just add this question mark over here, right? And that is going to turn it into a nullable, right? So the point here is that the compiler is trying to make sure that we don't end in a situation where we define a property that could be nullable, but we have not declared that it could be nullable, and later on we run into issues because of not defining this properly. Now, the thing about the name is that we don't want it to be nullable. We do want it to be a required parameter, right? It has to have a value. And these days, luckily, what we can do is just to define a keyword that allows you to specify that, yes, a value has to be specified for name, but we don't have to specify it right here in the definition. You just have to say that this property is required, just like this. Required. That means that whoever creates an instance of this game class has to specify a value for name either in the constructor or as part of the property initialization when the variable is being declared. And yeah, it's a very handy feature, and we'll be using this required keyword quite a bit across this course. So now that we have a required, we have the name, let's go ahead and define prop string. This is going to be our genre, right? The game genre, and this should also be required. So let's do required. The next one is going to be the price. So this is going to be of type decimal. I think it's a good type for prices, for money. So let's just name it price. And the next one is going to be the release date. So whenever the game got actually released. So let's do prop. It's going to be date time. The name is going to be release date. And lastly, we're going to be adding a property here for the URL of the image that is associated to this game, right? The picture of the game. So let's do prop, and this is going to be string, and let's name it image URI. And then this should also be required. So let's do required just like the others. And so with that in place, we now have our game entity ready. And what we want to do now is to define some initial list of games that our REST API, which we're just going to start building in the next lesson, that the REST API can start using right away, right? So this, for now, this is going to be a list in memory, an in-memory list of games. And later on, we're going to transition into an actual database, right? So, but because right now the focus is on creating the API itself, let's just use a very simple list of games so that we have something to work with. So let's go into program.cs. And what we're going to do, and let me collapse this for a moment, what we're going to do is just to go to the very top, and here we're going to be defining our list of games. So this is going to be list of game, just game. And then since we are introducing a type that lives now in a different namespace, right? So remember that game lives in GameStore.api.entities. What we want to do is to introduce the namespace into program.cs. And to do that, what you can do is just step into or click into the game word over here. And you're going to see this light bulb over here. What you can do with that is show code actions, right? So you click on that. That's going to show a series of options that you can use to automatically make changes to your code. So in this case, we're interested in the using GameStore.api.entities as you see here. So I'm going to click on that. And as you can see, that went ahead and right away added my using for GameStore.api.entity. And then just so you know, another way to do this, and let me just do a Control-C here. Another way to do this is just by, while you're in the word that has the curly braces, you can just do, at least on Windows, you can do Control dot, and that's going to, again, just pop up the dialog, and then you can click the option that makes sense. So like I said, in our case, it's using GameStore.api.entities. And then we have our namespace right there. So I'll be using Control dot all over the place across this course. I find that that's the easiest way to do this. So with that in place, let's go ahead and say games. That's going to be the name of our list. And this is going to be new. And then let's define our list right away. So for our list, let's define our first game here. It's going to be new game, right? And now let's define the values for the different properties. Let's also close these curly braces, just like that. So first thing is going to be the ID. Okay, so let's just start with a simple number. ID is going to be 1. Then the name. For the name, I'm just going to pick one of my favorite games of all time, Street Fighter 2. And then for the genre, it's going to be, in this case, fighting. And then for the price, I'm going to say $19.99. Now, the thing about this number here, $19.99, is that it could map to different data types, right? Not just decimal. Now, our price is decimal, but since 1999 could map to different types, the compiler gets a little bit confused here. So what you can do is just actually follow the guidance that you can see in the warning here. It says use an M to create a letter of this type, right? So you want to be explicit here saying that, yes, I do want to define a decimal and not just any other random type. So just by placing the M right here, you're clearly stating that this is a decimal, so that makes the compiler happy. And let's go ahead and say release date is going to be new date time. All right, so the date time for this one is going to be 1991-1. And lastly, we want to specify the image URI. Right now, what image URI we want to use here? Really, you could use really any image URI. It doesn't matter really too much at this point. But later on, when we get all the way to trying to show the games in the client, you may want to have something that just doesn't render a broken image or a random thing. Because of that, what I like to do is just use this very nice service that's called placehold.co, which provides you with kind of a placeholder of an image of any size. So for instance, I can do the following: https placehold.co/100. What that's going to do is to generate a simple placeholder of 100 by 100 pixels wherever you try to display the URL. So in fact, let me show you that. So I'm going to copy this. So let me just copy that, and I'm going to go into my browser very quickly here, and I'm going to paste it, and then I'll hit enter. And we're going to see, as you can see right here, is a super simple placeholder image for an image of type 100 by 100, right? And just like that, if you wanted to, you could go ahead and do another size, right? 200, or you could do 300 as you need. But I think 100 is good enough, right? So all it does is just provide us with some placeholder for the images, as like I said, that we're going to see later on in the client. So placehold.co/100, you don't have to use it. You could use any other URL, but I just found it very handy. So just like we did that, let's go ahead and define just a couple of more games so that we have some data to work with in later lessons. So let me just copy this over here. And so this second game is going to be, let's scroll down a bit, ID2. And then I'll just put another of my favorite games here, Final Fantasy 14. And then this is going to be role-playing. And the price, this is more expensive, $59.99. Release date is a bit more recent, 2010, 9:30. And then for placeholder, for the image URI is going to be the same thing, right? There's no need to change that. And then let's add one last game here. Okay, let me scroll down again. So this is going to be ID number 3. The name of the game is going to be FIFA 23. Very nice game. And then the type is, the genre is sports. The price is fairly expensive, $69.99, and the date time is much more recent, so 2022, 9/27. And for image URI, we'll just keep the same thing. And so with that in place, now we have our game entity and we have our initial set of games, which, like I said, we're just going to do in memory for now. And later on, it's going to be an actual, it's actually going to be coming from a database. But for now, this is going to be great for us to move to the next lesson, where we're going to go ahead and implement our first API endpoint to retrieve the full list of existing games. Let's now go ahead and define the first endpoint for our REST API. And this is going to be the endpoint that's going to retrieve the full list of games. Here we're back in our program.cs file over here. And as you remember, we do have our in-memory list of games defined right there. And what I'm going to do is to just go ahead and collapse this just to save a little space on screen. And what we can do now is to just pretty much follow the lead of this initial get endpoint that has been defined here. And we're going to be reusing it to return our list of games. Now, like I mentioned before, there are a bunch of methods like this one here, mapGet, that you can use to map different patterns into handlers that can take action whenever that pattern is invoked in a REST API. So just like mapGet, if you do Control spacebar, you're going to see that there are a bunch of other options like map post, map put, map patch, and map delete and others, right? So let's go ahead and define our get. And the first parameter in here, like I said, is the pattern. So this is the pattern that has to be matched as a call from the client so that the handler can get activated. So in this case, it's going to be just the path, and the path that we're going to be using for our games REST API is going to be just games. Notice that I'm going to be using plural here, right? So games and not just game, because that is the correct way to define a RESTful API. So this is going to be defining the resources that are going to be managed by the API, right? And this is going to be games. So all of our calls are going to be starting with games, not just game, but games. And once we have the pattern, we want to define the handler. So this handler can take a few shapes, but it's really, in this case, it's just going to be a simple lambda expression that's going to be defining what we're going to return. So in our case, what we want to return is just this list of games that we have over there. So what we can do is just replace this with games. And just by doing that, you have already defined your very first endpoint for your REST API. Now let's see how this works. So I'm going to do Ctrl J to open my terminal over here. Okay, I'm going to be closing that and cleaning up this. And I'm just going to switch into gamestore.api, which is our actual directory. And I'm just going to type .NET Run. Okay, so this starts the API. And once again, it gives us the location of the API. In this case, it's localhost 5115. So I'm just going to copy that. And I'll paste that in my browser for now. So let me just go into my browser over here. So here's the local host and the port. But remember that we need to define here the full route into the REST API endpoint, right? So if you remember, the API endpoint is actually under /games. So I'm going to copy that because that's the part of the endpoint that we want to hit. And then back into the browser, I'll just paste that over here and then I'll hit enter. And as you can see, we are getting now a representation, a JSON representation of the resources that the API is returning. Right there, you can see the list of games, right? So the 3 games are showing up right there. And that pretty much defines the result of our REST API invocation. Now, of course, looking at the REST API responses like this is not going to be very useful, as you can tell, and there are much better ways to do this. So in the next lesson, we're going to be learning how to use the Postman tool in order to properly query and work with our REST APIs. Let's see how we can use the Postman application to start working with our REST API. Now, the first screen that you're going to see usually when you start Postman is this one over here, which is asking you to either create a free account or to sign in into your Postman account. Now, if you wanted to, you could also go ahead and just click on this link over here to skip and go into the app directly. But I found that the experience is a little bit better when you actually have an account. So I would encourage you to go ahead and create a free account if you don't have one already. In my case, I already have one. So I'm just going to click on sign in over here, and that's going to take me into this tab over here. I'm going to just select my account here and then I'll click open, and that's going to bring back the Postman application over here. As you can see, I am now into the Postman UI. Now in Postman, the main way that you're going to be tracking all of the things that you do in Postman is by using what they call as workspaces. So the workspace is the one thing that's going to keep track of a bunch of things that are kind of related. So for that, what I'm going to do is just go into workspaces over here at the top, just go into workspaces, and then I'll click on create workspace, and I'm going to create a workspace for the work that we're going to be doing across this course. So you could put any name here. I'm just going to put a name here named building.NET REST APIs, right? Because that's the name of the course. And then I'll just click on this option here, personal. Okay, that should be good enough. And then I'll click on create workspace. And now we're here, we can go ahead and start creating requests, right? That's the main thing that you're going to be creating in Postman. So I'm going to just close this overview section here, and I'm going to click in this plus button right there. That's the one that you can use to start creating requests. So I'll click on that, and that's opening up this request over here. Now to save space, I'm going to collapse the left section like this, so that we can see better what's going on. Now, for some reason, it looks like the zoom is too much in this screen. So let me just go over here. I'll do view and I'll do view zoom out. So yeah, now I can see much better. Now on this tab, what you want to do is first select the type of operation that you're going to invoke into the REST API. As you can see in this dropdown, there are many different operations that you can use. But in our case, we're going to be starting with the get operation. So I'm going to just click on get. And then on the text box on the right side, you want to enter the URL to the endpoint that you're going to invoke. So let's remember what's going to be first the host and port that we want to invoke. So let's go back into Visual Studio Code over here. And then you can always find that by going into properties, launch settings.json, and in this case, it's going to be in the HTTP profile. That application URL is going to be right here. Okay, so I'm just going to copy this, localhost 5115. Okay, I'll copy that and paste it in the text box. And then remember that we have to specify the actual route into the game's endpoint. So once again, let's go back to VS Code. Let's go into program.cs. And remember that that's what we have in our map get. The endpoint is actually in /gains. So I'm going to copy that, and then I'll just paste that over here. Okay. Now let's also make sure that our REST API is actually running, right? So I'm going to go back into VS Code, Ctrl J to open my terminal. I'll clean this, and then I'll just do .NET Run. Okay, so that starts the server, and now I can go back into Postman, and I'll just go ahead and click on this send button over here. So I'll click on that, and that's going to send the request into the server. So I'll click on that, and as you can see down here, we got our results, right? So we have our 3 games, and this time things look way better, right? So it looks like proper indented JSON, right? That we can understand and that we can explore very nicely, and we can work with that later on. You will see as we move into the course that there are many utilities inside Postman that are going to be super valuable, and it makes way more sense to just work over here as opposed to working directly in the browser or somewhere else. So now that we know how to use Postman, let's move to the next lesson where we're going to learn how to create another get endpoint, but this time to retrieve a game by ID. Let's go ahead and define the endpoint to retrieve one game by its ID. So here we're back in our program.cs file, and then right here, just after our previous map-get call, we're going to be defining a new call to retrieve this game by ID. So let's just say app.mapget, okay? And in this case, the pattern is going to be very similar. So it's going to start with games, as expected. But in this case, we have to add one more thing, which is going to be the ID. So the RESTful way to specify this is just by adding the ID at the end of the route. And then in the handler section, we're going to be defining how is that we're going to handle such a request. Now, the handler is going to be similar to the previous one, but in this case, we have to do more things, right? So we have to actually find that game before we can return it back into the client. So for that, the first thing that we're going to be needing is the parameter, the ID parameter. So for that, you can just go ahead and define a parameter just like this by opening and closing parentheses like that. And then we're going to be defining our int ID. Okay, now this ID variable name over here has to match the pattern that has been defined on the left side right here. So it says ID, it has to also be named ID as the parameter that we're going to be defining in the handler. Now here we're going to be defining an arrow function on the right side that's going to say that we're going to be returning the games, but then we're going to be executing the find function that's going to expect us to provide some predicate to match the actual game that we want to return. So here we're going to say, okay, so we want to find the game where game.id equals the ID that has been received as the parameter. Okay, then I'll just close semicolon like that. And that is the way that you can define your get by ID. And so let's go ahead and try this out and see how it works. So let's go ahead and do Ctrl J. I'm going to go ahead and do .NET Run in the GameStore.api directory to start our server. And so let's go back into Postman. And what I'm going to do is just to copy this URL that I have here in my previous GET request. And I'm going to spin up a brand new tab over here. Again, with the GET operation on the left side. I'll paste this, but this time I'm going to go ahead and add / and the ID of one of our games. So if you go back into our previous list, we know that we have IDs 1, 2, and 3, right? So I'm going to go with ID number 1. So I'll just put 1 on the bar here, and then I click on send. And as you can see, that allowed us to return the specific game that we wanted to find. Also notice that we are getting the expected 200 result over here, 200 OK, which means that the request was successful. Now, one thing to consider here is what happens if somebody requests a game with an ID that does not actually exist, right? What would we do in that case? So let's see what happens right now. So in this case, I'm going to ask for a game with an ID of, let's say, 4, which does not exist. So I'll click on send, and then what happens? Well, we are getting a very strange null response over here. And for some reason, we are still getting a 200 OK over here. So this is completely wrong, right? That's not what should be happening if we are not able to find the game. So to make this RESTful the right way, what we have to do is to figure out a way to return a not found result here in this case. Okay, so let's go back into Visual Studio Code, and I'm going to do Ctrl C to stop my server. And what we want to do is to expand this handler here a little bit more so that we can handle the case where the game does not exist. So I'm going to open curly braces over there and then close curly braces over here, just like this, perhaps. Okay. And then what we can do now is to actually capture the return of this games.find call. So I'm going to say, so game, which is going to be the game, is equals to games.find, and then I'm just going to close the semicolon over there. And then we are getting this these curly braces here, this little warning here, because find is returning a nullable result, right? So we should fix this by saying not just game, but game with question mark, which turns game into a nullable value, right? So we could get a null here, so we have to handle that case properly. So now we're going to say, taking advantage of that nullable thingy, and I'm going to scroll down a little bit here, is the following. So we're going to say that if game is null, we are going to go ahead and return one specific result, and the right one for this one is going to be results.notfound. So that means we are not able to find that resource that you have requested. And otherwise, if we're able to find it, we keep going and we're going to say return results.ok. And in the parameter, we can specify the actual game that we want to return, which is the game. So now we're handling both cases, right? The not found and the successful case. So if we execute the API once again, I'm going to .NET run this again, and I'm going to go back into Postman. This time I'm going to ask for the game number 4 once again, and let's see what happens. Click send. And then, as expected, we are now getting a status 404 not found, which is correct. And if we go back and try to find an existing game, let's say game number 2, we should still be getting our 200 successful status like that. And we are getting, of course, the game on the left side. Okay, so that's how you should be handling those cases of the games that cannot be found. So with this in place, in the next lesson, we're going to see how we can create a request to actually create a game in our REST API. Let's now create the endpoint that's going to be in charge of creating games in our REST API. So for that, we're going to be scrolling down a little bit. Just after get, over here, we're going to be defining our brand new endpoint. And so it's going to be in a similar way. So app dot, but in this case, it's going to be a map post, right? So post is the right verb or operation that you want to use in order to create resources in the REST API. Now, once again, the pattern or the path is going to be very similar, right? It's going to be just games. And then for the request delegate or the handler, what you want to do is to specify here, of course, I mean, what's going to be the logic to create this game. But the parameter that you want to receive here is going to be the actual game, right? So for that, we're going to be adding just these parentheses here, and we're going to be defining our game like that. And then we define another function here, where we're going to be defining what to do about that, right? And I'm going to be closing this with semicolon. I'm also going to be closing this to have more space on the screen. So how should we go ahead and proceed with creating the game? So the entire game payload is coming and in the game object over here, but what's not going to come is the ID of the game. So that will have to calculate here, just like as if a database would calculate that ID. So in our case, we're going to keep it very simple for now, and we're just going to say that game.id is going to be games.max, and that's going to be, we're going to try to get the maximum ID that we have so far, and we're just going to increment it by 1. So we're going to say max from the list of current games, we're going to say game.id. So give me the max and then just add 1, right? Super simple. And after that, we're going to be adding that game into our games collection. So we're going to say games.add the game. All right. Let me scroll down a little bit more so we can see better. And lastly, we could go ahead and just say return. We could do a few things here. We could do results.ok. That would be one way to do this. But really, the right way to do this is to return a created result so that you return back the created object and the location of that object inside your REST API. So to do that, what you want to do is the following. Instead of saying results.ok, we're going to be returning results.created at route. And so the first parameter here is going to be the name of the endpoint that can be used to locate a resource, right? So that endpoint for us is going to be this one over here. Remember, this is the endpoint that we can use to actually get one resource by ID. However, we have not provided a name for this endpoint just yet. So we need to do that. So what we're going to do is just expand this a little bit, right? The map get, we're going to say dot with name. And here we want to specify a name for our endpoint. And the name is going to be just, let's say, getGame. All right, and I'll close this. So that's how you can provide a name for one of your endpoints. Now, since we're going to be using that name in the other endpoint, likely we don't want to just hardcode this over here, but we actually want to have some sort of a variable for this. So I'm just going to copy this getGame name over there, and I'm going to go close to the very top over there, and I'm just going to define a constant to define this name here. So it's going to be const string. Let's name it getGame endpoint name, and that's going to be equals to getGame. All right, and then I'm going to copy that and then use it right here. And now that we have that available, we can scroll down once again into our map post, and for the first parameter of created at route, we're going to say that the route is going to be the one identified by getGame endpoint name, and the second parameter defines the route values. Remember that that route has to receive the ID, right? So it specifies an ID that has to be received here. So we have to provide that ID, and the way to do that over here is by just saying, creating kind of an anonymous type. So you can just say new, and here we're going to just define an ID, which is going to be coming from game.id, the ID that we just generated. All right, and for the last argument, we can provide the actual entire object that just got created into the REST API. So that's going to be just game and closing semicolon. So by doing this, we're going to be creating a location header in the response after we have created the game into the REST API. So let's see how that actually works. So I'm going to open up my terminal. So Ctrl J, I'll do .NET run. Okay, and then let's go back into Postman. And this time we're going to be creating a post request. So let me just copy our endpoint over here. So I'll copy that. I'll click on the plus, and then let's switch this operation into post, and I'll paste the URL. And then this time we have to define an actual body, right? Because it's going to be a post request. So what you want to do is just go into this body section over here. So just go into body, and in body you want to select raw. And in the right side over here, you want to select not text, but you want to select JSON, because we're going to be creating a JSON body. Now let me scroll down this here. And here's where we can specify the JSON representation of one new game. Now, to not type everything by hand, what I'm going to do is actually just copy the representation of one of the other games, the one that we retrieved in the previous lesson. So I'll copy that, and I'll paste that over here. Now, like I said, we're not going to be providing the ID as part of the post request. That's going to be calculated directly by the API. So we're going to be removing this ID element over here. And then we're going to be filling in for all of the other elements, right? So let's go ahead and create our Minecraft game over there. And then the genre is going to be kids and family. And then for the price, it's going to be a bit cheaper. Let's say $19.99. And then the release date is going to be 2011. It's going to be 11 and 18. And then I don't think we need to specify a time for the release date, so we're just going to remove that piece. And then for the image URL, we just keep the same thing. So with that in place, and I'm going to expand this a little bit, let's go ahead and send a request and see what we get. So I'll click on send. And as you can see, and let me expand this a bit. As you can see, we are getting our expected 201 created status code. So that means that that was a success. The item was created in the API. We are also getting here a brand new ID for our created game. And of course, we have all of the rest of the payload of the game. But one very interesting thing is that we do have that header created for the location of our brand new resource. So if you go down into the console, so the console is going to be down here, the console. So this is always keeping track of what's going on with your request calls. So you just click on that one, you're going to see this, and then you're going to see at this point, I have one request for our get call, and then I also have one for our post call. So I'm going to go ahead and expand this. And if we go and look at the response headers down here, you're going to see that we have our location header, right? So that's a result of our use of the created@route method, right? So it calculated the correct location of the resource that just got created. So if we just copy that, for instance, you can just now copy that. You can go back into your getById endpoint over there. And I'm going to close the console for now. So I'll paste that over here. I'll click send. And now if we expand this, as you can see, we just got our Minecraft game using that endpoint that was provided by the post call. So that's a nice way to notify the client what is the location of the item that they just requested the creation for. So yeah, that's how you implement a post endpoint for a REST API in .NET. And in the next lesson, we'll see how to define an endpoint to perform updates to our existing resources. Let's now see how to define a put endpoint in our REST API so that we can update existing games. All right, so we're back into our program.cs file, and we're going to scroll down all the way to the end, just after the post endpoint over there. We're going to be defining one more endpoint, of course. So same idea, we're going to say app that, but in this case, it's going to be map put, right? And so the pattern here is going to be similar to the others, so games, but in this case, for a put operation, you have to specify what is going to be the ID of the resource that has to be updated. So for that, we're going to say just like this, ID, just like we did with the getById API. And then for the parameters we're going to receive in the second section, we want to specify two things. The first thing is going to be that very same ID, this ID that's over here has to be specified as a parameter. So I'll define int ID. And then the second parameter is going to be that updated game, right? So we're going to say game updated game, all right? And so just as before, we'll define our arrow function just like this, all right? And now comes the logic to find that game that has to be updated, right? So the very first section of this is going to be very, very similar to the section that we did for the getById endpoint. So I'm going to actually copy that section over here. So it's going to be this section here from getById. So I'll just copy that because it's the same idea. So scroll down here and I'll paste that right there. Okay, so we will go ahead and from our games collection, we're going to try to find the game. And if we cannot find it, we're going to say, well, the game is null. So we're going to be returning not found. And otherwise, we will proceed into the actual update of the game. Now, we're going to, just to keep things very clear, we're going to be renaming this game variable into existing game. And this, by the way, you can do by just typing, I'll do it again, just type F2 up on top of the variable, so F2, and then you can just say the new name for the variable, so existing game, and that's a nice way to rename variables across your code. All right, so now we just have to start updating all of the fields. So we're going to say existing game name equals updated game dot name, and then existing game dot genre equals updated game dot genre. Existing game dot price equals updated game dot price, and then existing game dot release date, and finally existing game dot image URI is updated game dot image URI. And then the correct result to return here from a put request is usually return results dot no content, right? You can also return an OK result, but the more traditional thing to return here is usually just no content. Now, one thing that I want to clarify here is this one here, right? So why are we returning not found, could we do something else here? Now, there is a line of thinking here that for a put endpoint in a REST API, what you really want to do is always create the resource if you cannot find it, right? So that would mean that in this case, if we cannot find the game, we just go ahead and create it, right? That way, the put endpoint is kind of idempotent, so it always returns the same thing, right? So it doesn't matter if it exists or not, we always end up with the resource created. Now, the reason we're not going to be doing that, and instead we're just going to be returning a result not found, is because in our future implementation, when we introduce a database, specifically a SQL Server database, it is going to be the database the one that's going to be providing the IDs for the created resources. So in that case, if we received an ID over here for the put endpoint, and then we cannot find the element and we let SQL Server just go ahead and create the ID for a brand new element, likely that generated ID is not going to match the ID that the user provided, right? So if user provides ID 123, which does not exist, and then we go ahead and say, hey, SQL Server, generate an ID, SQL Server is going to generate some 456 ID that is not going to match what the user requested, and that's just not going to make any sense, right? So because of that restriction from SQL Server, which is going to be the one generating those IDs, we're going to go with this other way of implementing a put endpoint where if the game does not exist, we're just going to return not found, right? But like I said, there's that other line of thinking, so just keep that in mind as we move forward with this implementation. And so with this in place, we should be able to go ahead and try it out. So I'll open up my terminal once again, so Ctrl J, and I'll do .NET Run, and then I'll go back into Postman. And this time I'm going to be creating a brand new request, which is going to be with the put verb over there. And then the actual URL is going to be, like I said, very similar to the one for the get by ID. So I'm going to be copying it from our second tab for get by ID. I'll paste that over here. And now let's make sure we use first a game that actually exists, right? So if you go back into the get by ID, I think that we can go back into ID number 2 here. So I'll send that. But let's actually go back into ID number 1. ID number 1 is Street Fighter 2. So let's work with this one here. So for the put, we're going to be using ID number 1. And then you have to go into the body once again, select raw, select text, and select JSON. We want to do a JSON input over here. And then let's go ahead and just paste the same, pretty much the same value as in the get by ID tab. We'll paste that over here. And we're going to make a few changes over here. First, we're not going to be providing the ID as part of the body because that's coming as part of the URL. I'll remove that. And then for the name, it's not going to be Street Fighter 2. Let's say this is going to be Street Fighter 2 Turbo. And then let's say that the price, well, it is on sale, so it's going to be just $9.99. And then release date is going to stay the same, but we're going to be removing the time portion of it. And then the rest stays just the same. Okay, so let's go ahead and click on send. And as we can see, we are getting the expected 204 no content result right there. So which means that this was a success. And if we go back into our get by ID endpoint and we request this element once again, click send, you can see that now we're getting Street Fighter 2 Turbo right there. And the price has also changed. So the update was successful. And then just to make sure that the implementation is correct, let's go back into put and let's try to update an element that does not exist. So again, let's say number 4 does not exist. I'm going to go ahead and click on send. And then as expected, we are getting a 404 not found because the element does not exist in the API. So now that we have our endpoint for updating games, let's go ahead and implement our final endpoint, which is the one that is going to allow us to delete games from the API. Let's now go ahead and implement our last endpoint for this API, which is going to be the delete endpoint. Right, so here we're back in our program.cs file, and let's just scroll down all the way to the end. And we're going to be defining our brand new map delete method. So app.mapDelete. And the route that you want to receive here is once again games, and then the ID of the element to delete. So ID, just like that. And then as the parameter, you want to receive here again that ID as an integer in ID. And then we'll define again our arrow function to define what is going to be the logic for that deletion. So once again, the logic here is going to be very similar to the previous, some of the previous ones. So what I'm going to do is just copy the logic that we have for the put operation. So I'll copy the put operation right there. I'll paste that down into our delete method. And all we're going to do is just remove this section over here. Okay, and then I'm going to remove this. And then what we're going to do is just say that if existing game is not null, right? So in this case, we were able to find the game. So in that case, we're going to say just games.remove, and that's going to be existing game. All right, and let me actually rename that variable. Existing game should not be needed here, so I'll do F2, and let's just rename this into game. Okay, so the idea is that we go ahead, we try to find the game, right? And if we are able to find it, we remove it from our list of games, right? So it's remove it from the REST API. If we are not able to find it, it really doesn't matter because this is a delete operation. What we want to do is always return the same result or have the same behavior, regardless of if we are able to find the game or not. Right? So it doesn't really matter if we find the game or not, we always return just no content, which means that it was a success, right? And in all cases, the game should just not exist after the invocation into this delete endpoint. So let's go ahead and test this endpoint. So I'll do Ctrl J, let's do .NET Run, and let's go back into Postman. And first I'm going to copy one of the games that we could go ahead and, well, let me just copy the route. So we know the route, so I'll copy that. And then I'm going to open up a brand new tab, which is going to be for the delete verb over here. And I'll paste the route over there. And let's choose just one game for deletion. Let's say we're going to be deleting game 2. Okay, let's see what is game 2. So let's go back into the first tab and let's get the list of games once again. Game 2 is Final Fantasy XIV, right? So this game 2 should be deleted after we made the invocation. So let's go back into delete and we're going to be deleting game 2. And yeah, that should be all it is. We don't need a body in this case. All we have to do now is just click on send. Okay, and we are getting the expected result. As you can see here, we are getting a 204 no content. So that means that it should have been a success. So if we go back again into our list of games and hit send, we can see that there is no more a Final Fantasy XIV game with a D2. There's nothing there, right? So the game has been removed. So that was a success. And just to verify that things are working properly, we're also going to try to delete a game that does not exist, right? So let's say number 4. And like I said before, regardless of what game we specify here, the result should always be the same, right? So I'll click on send. And as you can see, we once again got the 204 no content, right? And so that game 4 does not exist and it never existed really. So that is the end of this model, and now we have a complete REST API, right? It has all of the expected or traditional endpoints, and it is fully functioning, at least with our in-memory list for now. So with this in place, let's finish this model over here, and let's move into the next model, where we're going to be looking at a few techniques to improve the way that you organize your REST API code, and we're also going to be looking at validations of the inputs that you're going to be receiving in your REST API. In this model, you will learn a few techniques to improve the way you organize your REST API code and also to properly validate data received by the API. By the end of this model, you will have a solid understanding of the following: how to use route groups to organize your API endpoints, how to validate the API parameters, and how to use extension methods to better code organization. Let's see how we can start organizing our code a little bit better. And so here we're back in our program.cs class, and one thing that you may have noticed is that we have been using the very same root path for our endpoints over and over again, right? So we have, for map-get, we have /games, also for the other get we have /games, and then for post, we also have /games, same thing for put, same thing for delete, and for all of the endpoints, right? And so luckily there is a feature that we can use here, so we don't have to specify this thing over and over again. And that is called route groups. So with route groups, you can pretty much group a series of endpoints that share something common, right? So that you can apply things to that group together, as opposed to endpoint by endpoint. So let's see how to use that. So what I'm going to do is just go just under our app declaration. I'm going to do this following. So I'm going to say var group equals app.mapGroup. Okay, and in this declaration of the map group, you can go ahead and declare the prefix of your endpoints, right? So in this case, as we know, the prefix is /games, so I'm just going to copy /games over there, right? And that defines our route group. And now that we have defined the group, we can go ahead and just use it for each of the endpoints, right? So now we can say, instead of app.mapGet, we can say group.mapGet. And then instead of specifying /games for the pattern for the endpoint, what you can do is just either leave it empty because it's not needed, right? Because it comes from the group directly. Or what is more common, you would just put / like that. and that will be good enough for that endpoint, right? And the same way that you can do that, you can do the same thing for every other endpoint, right? So let's do it for the other map get, and in this case, we will only specify /id. That's all that is needed, right? And then coming down into our map post over here, again, we'll say group, and then we'll just say slash, and then for put, again, we'll do group, and then just /id. And lastly, for our delete method over here, we'll say again group and then /id. And so you're going to see how this feature is actually going to become very handy moving on, because we will be doing a bunch of things at the group level as opposed to the endpoint level. It's a nice way to group multiple endpoints together. Now let's verify very quickly that things are working just as expected. So I'm going to go ahead and open my terminal. I'll just do .NET Run here. And then let's go back into Postman and let's try just a couple of requests to verify that things are working. So here I am in the Get All Endpoint tab here. So I'll just click on Send. Let's see what we get. And so yeah, as expected, we are getting our 3 games just fine. No issues with this. And then let's go into our Post endpoint over here, where we're going to be creating this brand new game, right? So I'll go ahead and click Send. And as you can see, the game was created successfully without any issues. So as you can see, there is no change in behavior really, but now our code is organized in a much nicer way. And like I said, we're going to be using this map group for a few other things down the road. So now we have this in place. In the next lesson, we'll see how to add server-side validation to our API. One of the things that you should always consider when building a REST API is how you're going to perform the validation of the input parameters. And why is that important? Well, for instance, here I am in the in Postman in the post request, right, that we created a few lessons ago. And let's see what happens if I, for any reason, provide an empty name, right? So instead of providing the actual name, it's just an empty string over here. So let's see what happens when I go ahead and click on Send. So notice down here, I am indeed getting a created result, which is already strange, right? So the item should not have been created because it didn't have a valid name. And also I am getting, well, that empty name right there. So this kind of thing should not happen. And furthermore, I can do also other strange things. Like for instance, the price, I mean, the price should not be that, like perhaps more than $100 for a game, but I could go ahead and totally introduce a price of something like that. Right, I could do that and I could hit send, and now we have that huge price for our game, which is not making much sense. So we have to do something to validate those inputs before they can make their way into a REST API. So let's see what we can do about that. So let me go back into our API over here. I'm not going to stop my server, close my terminal. And the first thing that we're going to do is just go back to Explorer and go into our game entity over here. So what we're going to do is use this feature called data annotations to annotate each of the properties that should have some sort of validation. And let's start with the name, because we said that the name should not allow an empty string, right? It should be required. So for that, we're going to just add one attribute here, which is named required. Okay, and this attribute requires another namespace, so I'm going to do control dot so that we can use system.componentModel.data annotation. So let's select that one right there, and starting now, it is not possible to introduce an empty string for the name. That's going to be automatically validated and rejected if that comes in. And not only that, we can also make it so that the length of the string is also limited, right? So we can say string length, and let's say that we put a value of 50 here. So this means that from here on, the strings for the name cannot be longer than 50 characters, right? So that's a way to control also the length. And just like we can do that, let's go ahead and do the same thing for the other, a few of the other attributes. So I'm just going to copy that. And for the genre, I'm going to go ahead and say that it is also required. But in this case, perhaps 20 characters is good enough. We should not have genres bigger than that for genre. Now let's move on to the price. Now the case of the price is going to be that what we really want is to make sure that the prices are not either negative, and also we should not get a price more than $100, because that's really, I would say, the limit for the price of a video game. And usually they don't cost more than $70 perhaps. But let's say in this case we're going to add the range the range data annotation, and so we're going to say that it goes from 1 and to 100. Okay, so with that, any price that comes in, it has to be in that range. Any other value is not going to be allowed. And lastly, let me scroll down a bit more. We're going to do something about the perhaps the release date. We'll just keep it there, but for image URI, we're going to say that to start with, it should be a valid URL, right? So to make sure that it is a valid URL, we're going to be using the URL data annotation. So it has to be a well-formed URL. And also, we're going to be also using the string length attribute to make sure that these URLs should not be perhaps more than 100 characters. That should be good enough. And with that, we have introduced all of these basic data annotations that are going to make sure that we have valid values for all of our properties. Now, in order to use these data annotations, we have to do a little bit more, because just adding the annotations is not going to enforce them in our endpoints. So in the next lesson, we'll see how to use what is known as a NuGet package to import existing functionality to enforce our data annotations. In this lesson, you'll learn about NuGet and the multiple benefits of using NuGet packages in your software development workflow. So what is NuGet? Well, in simple terms, NuGet is the Microsoft-supported mechanism for sharing code in .NET. It is an essential tool that allows developers to create, share, and consume useful code. Let's see why this is useful with a quick example. Here we have John, who has been working in his brand new Web API project. The project currently produces one assembly, myAPI.dll, which contains all the code for John's API. However, this API is missing some essential validation logic, which John could certainly go ahead and implement from scratch. But fortunately, Jane, who does some open source work on her spare time, has already written all the validation logic that John is missing and produced an assembly out of it, coolvalidations.dll. Jane thought this assembly could be useful to others, so she created a NuGet package which contains the assembly and then published it to nuget.org, the public cloud service where anyone can share packages with other developers. John got news about this package and decided to install it in his Web API project. And thanks to this, he was able to quickly add all the missing validation functionality as opposed to having to write it from scratch. So using NuGet packages brings in several benefits to .NET developers. They allow developers to encapsulate reusable code and libraries into easily consumable packages. They simplify the process of managing dependencies in a project since NuGet automatically resolves and installs any required dependencies. Developers can avoid the need to write and maintain certain functionalities from scratch. Instead, they can leverage existing packages that have already been tested and optimized by the package authors and the community. NuGet has a vast ecosystem of packages available, covering a wider range of programming languages, frameworks, and tools. Finally, NuGet allows package authors to release multiple versions of their packages, which enables developers to choose the appropriate version based on their project requirements. In the next lesson, you will install your first NuGet package to enable the missing input validation in your REST API. Like I mentioned before, in order to enforce the data annotations that we added a couple of lessons ago, we have to do a little bit more because just adding the annotations is not going to enforce the validations in our endpoints. To do that, we have to introduce this feature called endpoint filters, which is something that we could definitely write manually, an endpoint filter for this case, but fortunately, somebody else already wrote the logic to enforce the endpoint filters that we need here. And that person created a NuGet package to share that logic. And if you ever want to look for a NuGet package, what you can do is just go into this page over here, which is nuget.org. Right here, and this is probably the biggest library of free NuGet packages available, and there are hundreds and hundreds and hundreds of NuGet packages for all sorts of purposes. Now, the one NuGet package that we want to use in our project right now is this one here called minimal APIs.extensions, right? And just looking for that, the one that we are looking for right now is this very first one, minimal APIs.extensions by Damien Edwards. So I'm going to click on that one. And that's going to take us to the page that describes pretty much what this package is for and how exactly you are going to install it and use it in your project, right? And not only that, you can also see all of the versions of this package available because there can be multiple versions, each version bringing in either bug fixes or perhaps new features, right? So at the time that I'm recording this, the last version is version 0.10.1, right? And so in order to use the NuGet package, you can see we have the command line that we can use to import and use the NuGet package. So I'm just going to go ahead and copy that. So I'll copy that, I'll go back into my project over here. And now what we can do is just do Ctrl J to open our terminal here. and I'm just going to paste what I just copied from there, right? So we're going to be installing this package. I'll hit enter. And with that, the NuGet package has been imported into our project. And just to confirm that, what we can do is just go back into our Explorer, into GameStore.api.csproc, the project file, and you're going to see that now we have that brand new NuGet package reference set in here. So from here on, we can use any of the classes or types introduced in that NuGet package. And because of that, what we can do is the following. So let's go into program.cs over here. And since we are using the endpoint groups feature, what we can do is just enforce these validations for all of our endpoints in one shot. So we're going to go into this line here where we define the group, and we're just going to add a dot at the second line here. We'll say dot with parameter validation, right? Which is a function that is offered by that NuGet package that we just introduced, right? So just by doing this, there's going to be an endpoint filter that checks for all the data annotations in our entities. So anytime somebody tries to post a request into our endpoints with invalid data, those are going to be rejected. So let's see how that works. I'm going to do Ctrl J, and I'm going to just run our project right there. And let's go back into Postman. Okay, over here, and we're going to be trying out the same invalid request that we tried before, right? Which has the empty string, and it has the invalid price, right? So I'm just going to go ahead and click on send. And this time, as you can see, we are getting a couple of validations, right? So first we have a nice title here that says that one or more validation errors occurred. So that's great. Then we also got a status code 400, which is the correct status code when we have validation errors, right? And not only that, we have one specific validation error for each of the errors that are happening in our API right now, right? So we have that for the name, we have that the name field is required right there. And for the price, we have that the price must be between 1 and 100. And so this is a well-formed error that was all created automatically just because we're using data annotations and the minimal APIs that extensions NuGet package. So that's fantastic. So now we can go ahead and actually fix this. So let's go back and put a proper name here, Minecraft. And then for the price, well, let's put again something reasonable, like $19.99 for instance. And then if you just click send, now this time it's going to succeed. As you can see, now it is all good and there are no more any validation errors. So yeah, so that's a very simple way to add server-side validation to your project. And in the next lesson, we're going to see how to use another feature called extension methods to further organize our code much better. One thing that might be bothering you at this point is how much code we have so far in our program.cs file. So if you remember, we have the code for defining our list of games, our in-memory list of games. As you can see there, we have our builder object, our app object, our map group, and then we have the definition of all of our endpoints, right? So the get endpoints, and then we have the post endpoint, put endpoint, delete endpoint, all of this code, right? And so I think this is just too much code for a file that is meant to be just the entry point of the application. So because of that, we are going to be refactoring all of the code here that has to do specifically with the endpoints into a brand new class that is going to be in charge of defining these endpoints. And we're going to be using what we know as extension methods to make this very easy. So first thing we're going to do is just to create a brand new directory under GameStore.api. So right click, new folder, and let's call this folder just endpoints. And inside endpoints, we're going to be defining a brand new class. So new C# class, and let's name it games endpoints. And so just like we have been doing so far, let's go ahead and clean up this file by converting to file scope namespace, just like that. And let's clean up these additional namespaces from the top. Now, since this class is meant for extension methods and all extension methods should always be static, we're going to make this class also static. There's not going to be instance methods over here. And now let's go ahead and define our extension method by stating public static. Like I said, all extension methods are static. And then the return type is going to be route group builder. The name of the method is going to be map games endpoints. And then the parameter here is going to be the type that we're going to extend, right? The type where we're going to add an additional method without having to modify the type itself. So the type is going to be endpoint route builder. And then the name of the parameter is going to be routes. Now, since we do want to extend iEndpointRouteBuilder, what you want to do is to specify this keyword here. So that enables us to actually extend the method by adding our brand new method. Now, why is it we want to extend iEndpointRouteBuilder? Well, if we go back into our program.cs class over here, program.cs, and if we scroll down, notice that if we go into the definition of, let's say, mapget, right? So mapget, I'm going to right click and go to definition. You're going to notice that this method here is actually an extension method on top of iEndpointRouteBuilder. Right here, you see it is extending iEndpointRouteBuilder. And if we go back again into program.cs and we also look at map group, for instance, I'm going to do F12 to also do the definition. This one also extends iEndpointRouteBuilder, right? So pretty much what we're going to do is to do yet one more extension method on top of that type to refactor all of the stuff that we're going to do doing over here, right? So it is the right type for us to extend, right? So iEndpointRouteBuilder. And so what we're going to do now is just to bring in all of this code, right? Starting with in our program.cs file with the declaration of group all the way to the end until the definition of our delete method, right? Map delete. I'm just going to go ahead and copy that and I'll paste that over here, there. Okay, so this is so far our extension method. And now at this point, the object that we are using to invoke all of the map methods is no longer named app, but is named routes, right? So I'm going to just copy routes, put that over here, right? So routes.mapGroup. And then let's also bring in the right type for game, right? So I'm going to select game here, do control dot, and then I'm going to select GameStore.api.entities, right? So we have that definition, okay? And then we're also missing, of course, the list of games and the definition of our getGameEndpoint name. So let's go back to program.cs. Let's go all the way to the top. And then let's select both the const over here and the full list of games. Let's select all of that over here. Yep. So let's go ahead and copy that into getGamesEndpoint. So let's define this just outside of method, just under the class definition. I'll paste it over there. Over here. So let's line up this a little bit better. And of course, since we're going to be using this games variable inside of a static class, we want to define this variable as a static itself. So it's going to be static list of games, right? Okay, so we have our const there, we have the list of games, and then we have map games endpoints, right? So most of the code is looking good now. And the only thing missing here, I think, is just a return type, right? So we said that we're going to be returning route group builder. And that is because that is a type that our group object is made of, right? So our group object, as you can see, it is a route group builder. So what we want to do is just to return group in case we want to making continuous calls into group from our program.cs class, right? So we're just going to go ahead and return group. And so, yeah, that's pretty much the definition of our map games endpoints extension method, right? And so that's what we have in our class right now. And what we can do now is just go back into program.cs and we can start getting rid of stuff. So now we can delete this const and the list of games. So we're going to delete that. Okay, those are deleted. And then we can go ahead and remove most of the code here. So I'm going to remove all of the map extension calls over here. Okay, except for the group. And then what we're going to do, instead of defining the group here, is just say, removing this app.map games endpoints. And of course, we will have to import another namespace here. So I'm going to do control dot, and then we'll have to select using GameStore.api.endpoints, like that, right? And then we can go ahead and clean up this because we don't need the entities namespace anymore. So now our program.cs class or file, as you can see, is just made of 8 lines that make much more sense. All we do is just declare the builder, declare the app, define the endpoints, and we're done, right? And all the logic for the definition of the endpoints is actually now refactored into this class which only purpose is to define and manage all of these endpoints, as you can see. And so, yeah, just let's make sure that these things are still working just fine. So I'm going to do .NET run here to verify that things are working properly. And now let's go back into Postman and let's test a couple of those endpoints, right? So let's go, this is going to be our get all games endpoint. So let's go ahead and hit send. And as you can see, we are still getting our list of games just fine. We go to post, we can go ahead and we have a body here, of course. Yeah, we have a body. hit send, and it is working as expected. All good. So yeah, extension methods are a very handy feature to, as you can see, organize code better. And yeah, that's going to be the end of this model. And in the next lesson, or in the next model, we're going to introduce a few design patterns that will help us future-proof our API for any future changes. In this model, you will improve your REST API with a few popular design patterns and best practices to ensure your code is ready to adapt to future changing requirements. By the end of this model, you will have a solid understanding of the following: how to use the repository pattern for better data manipulation, how to use the dependency injection pattern to write more maintainable code, which are the different service lifetimes available in ASP.NET Core, and how to use data transfer objects to define clear contracts between client and server. In this lesson, you will learn about the repository pattern and why you should use it in your applications. To understand why you may want to use a repository, let's say that today we have the application logic of our service talking directly to our SQL Server database. However, a few months or years from now, our application has become incredibly popular and the constraints of a relational database are not allowing it to scale. So it's time to move to a NoSQL database, like Cosmos DB perhaps. Sadly, given the way things have been set up, we would likely need to rewrite a good chunk of our application logic in order to talk to the new database, which is not just going to take a while, but also is very error prone since bugs in the application logic can easily surface as it gets adapted to the new data access code. Instead of this, we can take advantage of the repository pattern. But what is a repository? A repository is an abstraction that encapsulates the logic for accessing and manipulating data. Its main purpose is to abstract away the details of the underlying data access technology from the rest of the application. Going back to our example, we will now introduce a repository between our application logic and the database. This repository is the only one that knows how to talk initially to our SQL Server database and is the only one that our application logic will interface with. Then, if we ever get the requirement to move to another database, the only thing that we would need to change is our repository, but the application logic stays the same. So, the repository pattern is important because it decouples the application logic from the data layer and minimizes duplicate data access logic across our service. Let's now see how to apply the repository pattern into our REST API. Before we introduce the repository pattern into our codebase, I'll just have to mention that there is an associated pattern called unit of work that we will not be using here because it's mostly related to having to perform transactions across multiple entities or multiple tables in your data storage. But we will not be using transactions across this course, so we don't really need to go into the unit of work pattern. So we're going to be implementing a simple version of the repository pattern here that should be good enough for what we need to do. So the first thing that we're going to do here is to introduce a brand new directory just under GameStore.api. We're going to right click and say new folder, and this is going to be named repositories. And inside repositories, we're going to be, let's right click, let's do new C# class. And the name of this class is going to be, since this is going to be kind of an in-memory repository of games, let's name it in-mem games repository. So let's do a little bit of cleanup here. Let's step over here in the name of the namespace, control dot, convert to file scope namespace, and then also on the usings to remove unnecessary usings. So what should we bring into this class? So let's go back into our endpoints class, games endpoints. And so here's where we have declared so far our list of games. So we're going to, first thing to do is just to bring in that list of games into our repository class. So I'm going to select the entire definition of our games, just like that. Okay, and let's go ahead and cut it. We're going to go ahead and cut this, and let's put it into our in-main games repository right there. And then let's go ahead and select the game word over here, control dot, so that we can use GameStore.api.entities namespace, just like that. And then this should also be likely read-only because it's not going to be modified anywhere else in the class. So I'll do control dot, and I'll add a read-only modifier. And then we can start defining the repository methods, right? So let me collapse this for a moment, and let's start scrolling down here just under the definition of our games. There. So the first method we're going to be defining is the one to retrieve all of the games. So this is going to be public, and then the return type is going to be one of the most generic types that you can return here, just so that the client can easily manage the list that we're going to be returning. So that type is going to be IEnumerable, right, which basically represents a list of objects, right, that can be read in a sequential manner. The name of the method is going to be getAll. All right, and then what should we do in this method? Well, at this point, all we have to do is just return games. Okay, so that's going to return the entire list of games to whoever invokes this method. The next method here is going to be the method to return just one game by ID. So in this case, we're going to implement public game get, and then the parameter is going to be that ID, just like that. And so what logic should we have here? So if we look at games endpoints, so let's go back to games endpoints, and what we can do is just copy the logic that we have in our map get endpoint over here. Just copy not all the logic, but just the logic to retrieve the game. You see, we use a find method to get the appropriate game. So I'm going to copy that into in-mem games endpoint, and we're going to say return games.find, and then whichever game is found via the ID parameter, right? Via the lambda expression over there. Now this method might return a null, right? So it's a nullable return. So because of that, we're going to qualify the game return type with the question mark, making it so that this is also a method that can return a nullable object. So if we cannot find the game for any reason, we're going to be returning a null value. Okay, so let's scroll down a little bit more. And now we're going to be defining the method to create a game in the repository. So let's define this as public void create game. Okay, so we receive the game as a parameter, and then what we want to do is a couple of things. So, and let's actually go back into games endpoint to see what we were doing in the post endpoint over here. So yeah, it's pretty much the same idea. So we have to calculate the max number of the ID that we have so far, incrementing 1, and then we just add the game to our list of games. So let me just copy this logic over here. I'm going to copy that into our repository. Okay, so game.id, it just gets the ID plus 1, and then we add it to the list of games. So moving on, let's go into our update method. So public void update, and here we're going to be receiving our updated game, right? Updated game. Now this is the game with all of the properties updated, right? Which is going to be done by the game's endpoints. And so all we have to do now is just to set this updated game into our list of games. So what we want to do now is to somehow find the index of this of the game to update in our list of games, and then let's just go ahead and update that game in that index. So let's do this. Var index equals games.find index, and for which game? Well, we're game.id equals updated game.id. Right, so that's going to give us the index of the game in our list of games, and then we can just go ahead and say games subindex equals updated game. Right, so that's all we have to do for our in-memory repository for the update method. And lastly, let's go ahead and do the implementation for our delete method. So it's going to be public void delete, and then all we have to receive here is the ID of the game, int ID. And then the logic to find it is going to be very similar. So let's go ahead and copy the line from update, just like that. Except that we don't have updated game here, or we only have the ID. So let's just say ID. Okay, and after that, what we can do is just say games.remove at, and then the found index. And one last thing to do, if we go back all the way to the declaration of our class over here, is to make a small change to our games list over here, because this list does not need to be static anymore. Right now it's going to be part of our in-main game repository, so it should follow the life cycle of this class itself as opposed to be a static object. So we're going to be removing the static declaration here, and in fact let's just add private here, so clearly declare that this is going to be a private variable in our class. All right, so no more static for games. And with that, let's go back into our games endpoints.cs file and see how we can start using our repository over there. So let's go back over here. So let's go all the way up now here, and let's remove a bit of these spaces. We don't need those. And what we're going to do is just at the start of our map games endpoints class, method, we're going to be defining our repository instance, right? So we're going to be defining ingmem games repository, okay, and then likely we want to do control dot here to introduce gamestore.api.repositories, okay, and then equals new. Okay, keep in mind that our code base is constantly changing, right? So I'm going to be instantiating the repository just like this for now. Later on, we're going to learn another technique to bring in the repository in a much more flexible and testable way. And so now that we have the repository in place there, we can start taking advantage of it, right? So now for the map get all, the first endpoint here, what we can do now is just say repository.get all. And then keep scrolling down. If we go into our map get by ID over here, what we can do is the following. What we have to do is just say repository.get, and then we pass in the ID. And since we are here, one small update that we can do also here is to just refactor this bunch of lines. I think we can do this actually in just one line. So what we can do is just say return game is not null, right? So if it is not null, we say results.okay with the game, right? And otherwise we say results.not found, right? Just a small simplification, and with that we don't have to add all of these extra lines. Now let's go with our post method over here, and what we can do now, instead of these two lines, we can just say repository.create, and we have now our game right there. And after that we just return as usual. And then let's move on into our put method down here. And here we can use a repository in a couple of places. So first, to find the game, we can now say repository.get with the ID, and then all the way to the end, just before returning, we have to actually update the game inside the repository. So we have to say now repository.update existing game, right? So that's going to update the game in our list of games. So let's move on into our last method, our delete method over here, where once again, we're going to be finding our game using repository.get with ID. And then to remove it, we are going to say, instead of this, we're going to say repository.delete with that ID. So as you can see, we have now introduced the repository into our map games endpoints API here, extension method. And the main benefit is that now we don't have that list of games living in our endpoints anymore. The list of games, the memory list of games is actually living now directly in our ingmem games repository, right? So we have decoupled the management of the data from our endpoints themselves, right? That's going to be super useful moving on. And so, well, let's just go ahead and verify that things are working properly. Once again, .NET Run, we'll do a very quick test here. Just make sure that, let's go back to Postman and let's go ahead and do a send to get all the games. Yeah, that's working properly, right? And then for a post, let's go ahead and send, and that's also working properly. So yeah, things are working just fine. And in the next lesson, we'll learn about another very, very important design pattern known as dependency injection. In this lesson, you will learn about the dependency injection design pattern and the multiple benefits it brings in to your applications. To understand what dependency injection is, let's start by looking at two classes, myService and myLogger. myService uses the logThis method of myLogger to log messages to a file anytime myService performs an important operation. Since myService uses some of the functionalities of myLogger, like the logThis method, we say that myLogger is a dependency of myService. Now, in order for myService to start using myLogger, it creates an instance of myLogger in its constructor. And after that, it can start calling the logThis method. At first glance, it doesn't look like this presents any problems. But consider what happens when the authors of myLogger decide to slightly modify it so that a new myFileWriter object needs to be passed on its constructor, because that's where the output file is now defined. The required changes look simple to implement, but they reveal a few important problems. myService is tightly coupled to myLogger in such a way that anytime myLogger changes, there's a need to also change myService, as it happened here when the constructor started requiring a myFileWriter instance. myService needs to know how to construct and configure the myLogger dependency, like is the case here with the myFileWriter object, which needs to be configured with an appropriate file to send the output logs. This makes it hard to test myService since unit tests won't be able to mock or stop myLogger. An output.log file will always be created, which would slow down tests, and this assuming that the tests have access to a place to write files to. Fortunately, there's a better way to do this using what is known as dependency injection. Let's go back to my service and its MyLogger dependency. My service still uses the logThis method, but this time MyLogger is not explicitly constructed by my service. Instead, MyLogger is passed in as a constructor parameter. MyLogger is injected into the MyService constructor. This way, my service doesn't need to know how to construct or configure the logger. It just receives it and can start using it right away. But if my service doesn't construct the logger, who does it? Well, ASP.NET Core provides the iService provider, which is what is known as a service container. Your application can register MyLogger and any other dependencies with iService provider during startup, which is typically done in your program.cs file. Then later, when a new HTTP request arrives and your web app needs an instance of my service, the service container will notice its dependencies and it will go ahead and resolve, construct, and inject those dependencies into a new instance of my service via its constructor. This enables multiple benefits for your application. To start with, my service won't be affected by changes to its dependencies. It doesn't matter how many times the constructor of MyLogger changes, there is no need to change my service. Moreover, my service won't be created instances of MyLogger, so it doesn't need to know how to construct or configure it. If your application uses minimal APIs, dependencies can also be injected as parameters to your minimal API endpoints. Finally, dependency injection opens the door to using dependency inversion. But what is dependency inversion? The dependency inversion principle states that code should depend on abstractions as opposed to concrete implementations. Let's bring again our MyService class and its MyLogger dependency. Currently, MyService depends directly on MyLogger, which allows it to write logs to an output file. But let's say that now we're moving to the cloud and we need to start sending logs to some sort of cloud service. For this, we would like MyService to start using a new Cloud Logger class. We could modify MyService to receive and use a Cloud Logger instance instead of a MyLogger instance. However, what we can do instead is modify my service so that it depends on a new iLogger interface, which provides all the required logging functionality. Then we can have both MyLogger and Cloud Logger implement this new interface. With this, we are decoupling my service from the Logger dependency, allowing it to use MyLogger, Cloud Logger, and any future Logger implementations without ever having to modify my service. The only thing that the different loggers need to do is to implement the interface that my service depends on. In terms of the code, this is how you would now inject the logger into my service. So the main benefit of using the dependency inversion principle is that dependencies can be swapped out without having to modify the class that uses them. But also, it is now much easier to test my service since the logger dependency can be easily mocked or stopped. And finally, your code is now cleaner, easier to modify, and easier to reuse. Now, before we start using dependency injection in our code, there is one more important concept to understand, which is the service lifetime. In this lesson, you will learn about the different service lifetimes available in ASP.NET Core. We now know the basics of dependency injection in ASP.NET Core. We know that on startup, your application will register the dependencies like MyLogger here, and later, when an HTTP request arrives, iService provider will resolve, construct, and inject an instance of MyLogger into a new instance of your class, MyService in this example. What is not clear is what happens when a new request arrives. Should iService provider create a brand new MyLogger instance for the new request? Or should it reuse the same instance? What if another service that also has a dependency on MyLogger needs to be created in response to a new request? Same MyLogger instance or new MyLogger instance? The answer to this lies in the service lifetime, which you configure when you register MyLogger with iService provider. There are 3 available service lifetimes, so let's take a look at each of them. Let's say that MyLogger is a very lightweight and stateless service, so it's okay to create a new instance every single time any class needs it. In that case, you will register MyLogger with the addTransient method. When the first HTTP request arrives, the iService provider, as usual, will resolve, construct, and inject a new instance of MyLogger into my service. However, when a new HTTP request arrives, iService Provider will construct and inject a brand new instance of my logger, which has nothing to do with the first instance. Furthermore, if there's any other service that participates in any of these HTTP requests and also has a dependency on my logger, it will also receive a brand new instance of it. So, transient lifetime services are created each time they are requested from iService Provider. What if my logger is a class that keeps track of some sort of state that needs to be shared across multiple classes that participate in an HTTP request? In that case, you will register my logger with the addsCode method. Here, when an HTTP request arrives, the iService Provider will again resolve, construct, and inject a new instance of my logger into my service. But if there's any other service that participates in the same HTTP request and that also has a dependency on my logger, it will receive the exact same instance of this dependency. However, if a new HTTP request arrives, the service container will create and inject a brand new instance of my logger instead, totally related to the previous instance. So, scoped lifetime services are created once per HTTP request and reused within that request. Finally, let's say that my logger is not cheap to instantiate and it keeps track of a state that should be shared with all classes that request it during the entire lifetime of your application. Then you will register my logger with the addSingleton method. As usual, when an HTTP request arrives, the iService Provider will resolve, construct, and inject a new instance of my logger into my service. And if there is any other service that participates in that same HTTP request and that also has a dependency on my logger, it will receive the exact same instance of this dependency. But furthermore, if a new HTTP request arrives, the service container will once again provide the same instance of my logger to any of the classes that request it. And it will keep doing so until the application is shut down. So, singleton lifetime services are created the first time they are requested and reused across the application lifetime. Now that you understand dependency injection in ASP.NET Core and the different service lifetimes, let's get back to the code and see how we can use these concepts to register the repository instance needed to interact with the data. Let's see how we can use the dependency injection design pattern in our .NET REST API. So if you remember, if you go back into endpoints, games-endpoints.cs, you remember that we are creating currently the instance of our repository right here at the start of the map games endpoints method, right? So what we want to do now is to switch this so that instead of this, we're going to be injecting one instance of repository into each of the endpoints that actually need it. That way, we're going to be avoiding the coupling that we have today between our games endpoints class and the concrete in-mem games repository instance. So the first thing to do is to go back into repositories and in-mem games repository. And what we want to do here is to first extract the interface of this class so that later on we can inject that interface into the games endpoints class, right? So that way that class doesn't need to know really exactly which concrete instance is being created. And so to extract the interface, what you can do, you can create it manually, but there's also a good way to do this automatically. If you just click on the in-mem games repository type over here, you can use this label over here and just select the option that says extract interface, the very first one there. Go there, and that's going to go ahead and generate the interface for you. Okay, and not only that, now our class is actually implementing that interface, as you can see. And now that we have the interface, we would also rename that interface because that name is not making much sense, right? It should be a little bit more generic. So I'm going to just tap F2 in my keyboard here so that we can do a proper refactoring of this interface. So let's just rename this one into iGames repository, right? So it's more generic. Hit enter and notice that now we have the brand new name over here, and also we have that brand new name as the one that is implemented by in-mem games repository. And with that in place, the next thing that we want to do is to move this interface out into its own file just for better code organization. So I'm going to click on the label over here, and then you can select the extract interface, the move type to iGames repository option over here, there. And by doing that, as you can see, the file has been moved or created over there in iGames repository, right? And it's out of our in-mem games repository class. We go back into iGames repository, you're going to see it's just the same interface, but it has been moved into a new file. And with that in place, we are ready to start taking advantage of this new interface in our games endpoints file. So let's go back into games endpoints, and I'm going to collapse this so that we can see a bit better. And the first thing to do here is to stop declaring, of course, the repository like this. We're not going to have that coupling anymore, so that goes away. And then what you want to do is to, like I said, inject the interface into each of our endpoints. And to do that, all you have to do really is just go into the parameter that's defined for each of our endpoints and declare the type. So you're going to say iGames repository, like that. And just by doing that, whenever a request comes in that matches this endpoint, the service container is going to find out which is the class that implements iGames repository, and we're going to be doing the registration in a second. And it's going to instantiate in memgames repository, and it's going to provide that instance or inject that instance right here so that the endpoint can start using it like it is doing right now. And we can do the same thing with each of the other endpoints. So let's go ahead and let me just copy this, and then let's enter this as a first parameter in the next endpoint, the get by ID, just like that. And let's do the same thing for the other endpoint. So let's go to map post, we put it over here. And by the way, the order, it doesn't matter, the order of parameters, you can do it in any order. I'll just prefer to do this as a first parameter for now. So let's go for map put. And then finally, let's go for map delete. And so yeah, with that, there's no more coupling between games endpoints and our repository class. Everything is being done via dependency injection. So notice that games endpoints, now it doesn't really know which specific type is being used as a repository. It only knows that there is an interface and it will work with that interface, right? So somebody else has to figure out what is the actual concrete instance. So that's what we have to do now. So now we have to do the actual registration of the concrete instance that's going to map to iGames repository. So let's go back into our Explorer and into program.cs. Let's collapse this. And in order to register your instance of the repository, what you want to do is take advantage of your builder object, right? So what you can do is just say builder.services, and services here is the entire services collection that of the services that have been registered into our builder instance. Right? So this is the collection where you can add your services into. So to add a service, what you have to do is just do dot, and then you're going to find a bunch of methods here to represent the different ways that you can register the service. So you can do, for instance, a transient, right? If you wanted to do a transient service, or you could do add scoped for a scoped service, or you can do add singleton also. Now, the type of registration that we want to do here is add singleton. But before we do that, let's actually take a look at add scoped, and let's see what would happen if we use it add scoped as opposed to add singleton. So let's do add scoped. And what you want to do now is just to switch into exactly to declare the interface first. So in this type parameter, let's do iGames repository. All right. And to use that, we'll have to step into there and do control dot, so that we can use GameStore.api.repositories, this very first one over here. Okay, so we're using that namespace now. And then you specify the concrete type that you want to get activated whenever somebody asks for that interface. So in that case, in our case, it's going to be in memgames repository. So with that, we have registered our service with the service container. And now let's see how this works in action, right? Let's see what happens. So let's do Ctrl J. I'm going to do .NET run. And now let's go back into Postman over here. And we're going to try our first request, which is the one that gets all the games, right? So I'm going to go ahead and click on send. And as expected, this is working fine, right? So we are getting our 3 initial set of games from the in-memory repository. And now let's go ahead and create a brand new game in our post request over here, which is going to be our Minecraft game, right? Just like we did before. I'll click on send, and our Minecraft game has been created. However, let's see what happens if we now retrieve that full list of games, right? So the expectation is that it should have our Minecraft game over there. So let's go back here and let's go ahead and click on send once again. And notice this, there is no more the Minecraft game is just not showing up here. There is no Minecraft game. We only have 1, 2, and 3, the 3 initial games, right? No matter how many times we create the Minecraft game, so I'll click on send, and it was a success, right? It says here that it got created, but if you go back into get all, click on send, and the game is just not there. So what is happening there? Well, if we go back into our API, the reason why this is happening is because we are using the scoped service lifetime. This means that anytime we receive a new request in any of our endpoints, a brand new instance of in-mem games repository is going to be created, right? So in games endpoints over here, when the initial request comes for map get, then we get one instance of repository over here. And then whenever we do the post call, right, we get another instance of repository, a completely different instance. And furthermore, when we do get, once again, we get another instance of repository over here. And let's see if we can see this more explicitly by using breakpoints. So let's go back to in-mem games repository, and I'm going to put a breakpoint over here, right, which is where we are pretty much creating our games list. So this time I'm going to do F5, okay, to start debugging. And so I'll go back to Postman and I'm going to do the initial send over here. And notice we have our breakpoint over here, right? The games instance is going to be created in in-mem games repository. So we hit play, and so that retrieves the list of games. And now we go back into post, and we're going to go ahead and create a new game, right? So click on send. And notice that we're back in VS Code, and once again the list is going to be recreated because this is a new instance, because this is a new request, because we are using the scoped service lifetime, right? So a new instance gets created, and of course that's not going to have our brand new game. And in fact, if we go back to get all, we click on send, and then once again a brand new instance is getting created. And so that is what's happening here. So that's what this is not working. And so because of this, what we want to do is just go back to VS Code. I'm going to stop this, close that, and then let's go back to program.cs. What we want to do now, just while we're using the in-mem games repository, is to switch from add scope to add singleton. So that's going to make sure that we only get one instance of the repository for the entire lifetime of the application, right? This is likely not what you want to do when you start moving into database access, but for now, so that we can actually play nicely with this API, we want to stick to in-mem and with singleton, but later on we can switch to something else, right? And just for our curiosity's sake, let's see what happens now that we have a singleton, right? So let's do F5 now. All right, let's go back to Postman, and then once again, let's retrieve the full list of games, click send, and as expected, we hit the breakpoint over here where we are declaring the games array or the games list. Click play, let's go back to Postman, and here we have the full list of games, and then let's go back to post, and this time let's go ahead once again and create a brand new game, click send, and notice that no breakpoint got hit, right? So there's no breakpoint. Go back to VS Code, the breakpoint has not been hit, right? It's not there. And then if we go back to get all games, click send, again, there's no breakpoint because the instance is being reused, right? There's no need to create it again. And now we do have our fourth game right there. So only one instance is created because it is a singleton. And so one more thing to consider here is the following. So if you just stop this for now, is the fact that since in program we are using a singleton now, and since this is just one instance for the entire API, you might run into concurrency issues if you decided to just keep moving forward with the in-mem approach all the way to a production application, right? Because we are using that exact same array in-mem games repository. This array is being used for all of the methods that we have here, including the method for creation and the method for update. Right? So if there are multiple requests coming in, and for some reason multiple of these methods on the repository are being accessed at the very same time, you may have concurrency issues, right? Between the different elements that are being updated or created in the array. So because of that, this is not going to be the best option. This simple list here is not going to be the best option for you if you wanted to use this in a production application. So you want to switch into something perhaps like a concurrent dictionary or something like that, that is actually thread safe. But this one here is not thread safe, but it's going to be good enough for our purposes until we arrive into the new repository that's going to be based on a database. And so that's it for this lesson, and in the next lesson we will learn about another good practice, which is the use of data transfer objects or DTOs, and we'll see why they are essential for exchanging data between your REST API and your clients. In this lesson, you will learn about data transfer objects and why they are essential for exchanging data between your REST API and your clients. So, what is a data transfer object? Well, a data transfer object, or DTO, is an object that carries data between processes or applications. It encapsulates data in a simple and standardized format that can be easily transmitted across different layers of an application or across different applications. And in the context of a REST API, a DTO can be considered a contract between the client and the server, since it represents a shared agreement between the client and server about how data will be transferred and used. But why exactly do you want to use DTOs in your REST API? To understand this, let's look at a simple request to a REST API, where the client is requesting the data for one of the games. The API receives the request and then asks for the game data from the repository. The repository finds and returns the data in the form of an entity, and the REST API simply forwards that exact entity back to the client in the form of a JSON object. It doesn't seem like there is any problem with this, but consider what could happen if suddenly requirements change and we are asked to rename the price property to retail price. And not only that, we will also start storing a secret code next to each game, which is for internal use only, so it should never leave the backend. However, since we are returning the entities as is, we are now sending both retail price and secret code in our response to the client, which will not just break the client, since it was expecting price and not retail price, but opens the door for the client to read and show a secret that was not meant for it. Because of this, the REST API should never return the entities that came from the repository to clients, but instead it should translate entities into DTOs that conform to the agreement between client and server, which in this case means we always return ID, name, and price to clients and nothing else. So, the DTO acts as a contract that defines the expectations and requirements for how data will be exchanged between client and server, and you should make sure you always honor this contract on all communications with your clients. Let's now see how to start using DTOs in a REST API. Let's now see how to use data transfer objects or DTOs in our .NET REST API. Now, for this, we will be using the record types feature of C# because they allow you to create immutable classes primarily designed to hold data. And this matches our DTO requirements, since the data that comes from them should be immutable, meaning that once the DTO is created, its values should not be changed. So what we're going to do now is go ahead into our game.store.api directory, the root, and let's just right click and create a new, not C# file, but instead it's just a standard new file. And this is going to be named dtos.cs. Right, so in this one file, we're going to be declaring all of the DTOs that are needed by our REST API. Now, one thing that we have to remember here is to also add the corresponding namespace. So let's go ahead and add namespace game.store.api, and let's add here DTOs, all right? So that all of our DTOs are in that namespace. Now, to declare these DTOs, let's go ahead and also open our entities class over here, because the DTOs are going to reuse most of the properties of the game entity. So let's go ahead and use that, and let me go ahead and collapse this, and let's see if I can put the game on the right side. So I'll do split right so we can see better. And now we can see the entity on the right side and the DTOs on the left side. Perhaps I'll scroll a little bit to the right. Okay, so the first DTO that we're going to declare is the one that's going to be used for retrieving data from the API, right, for the get endpoints. So we will declare public record game DTO. And I'm going to open and close and just send this to the next line so that we can see better all of the parameters. Now for a record type, all you have to do to declare the properties is just declare them inline inside of these parentheses, right? So in this case, let's go ahead and start with our ID. So let's declare int ID, then we go with the name. Okay, then we go with the genre, and let's keep scrolling down. Then we have our decimal price and date, time, release date, and finally we have our string image URI. Okay, so that is our game DTO, and notice how it is much easier to declare than it is to declare an entire class. So that we will use to retrieve data, and then we have to declare a couple of more DTOs for creation and update of our resources. So let's scroll down a little bit, and let's go ahead and declare our next record type. So it's going to be public record create game DTO. Okay, so same idea. And to create a game, we don't need an ID, as we know so far. So we will start with our name. So string name. And in fact, I'm going to actually copy most of the properties from game DTO here to save time. So very similar properties, but here we have to remember that we also want to account for the validation of all of those properties, right? So we want to bring in all of the data, these data annotations that we were using in the entity, we want to transfer them now into the DTO. So our create game DTO, for the name, we want to say that yes, so it is required, right? And also let's do control dot here so that we can use and import system.componentModel.data annotations. And then this is also string length, and we said it is going to be 50 for the name. Next one, genre, same idea, but the string length is going to be 20, right? And so scroll down, and then we have for our price, we know that we want to use the range data annotation, so let's put that over here for the price. And then we have release date, we don't have anything specific, and for the image URI, we want to specify that it has to be a URL, and it also has to have the string length for 100. So I'm just going to copy that over here. Next, we're going to be defining the DTO, the last DTO, and it's going to be for updating resources, right? And as you're going to see, this is pretty much going to be the same thing as the create game DTO, but you always want to keep it separate because eventually it is fairly likely that the contract for creation and update is going to change, right? So right now our requirements are very simple, so we're not going to notice any difference, but eventually things could change. So that's why I'm going to keep them separate. So instead of create game DTO, this is going to be update game DTO. So what we want to do now is to define also an extension method so that we can easily map from a game entity into a DTO. And we're going to see how that's going to be very useful when we start using the DTOs in the endpoints. And so to do that, let's go back to Explorer, and under the entities directory, let's just right click and let's create a brand new C# class, which we're going to name entity extensions. Okay, entity extensions. Let me collapse this for a moment. And on this one, well, let's just fix namespace first, convert to file scope namespace, and also remove unnecessary usings. Okay, remember that all extension methods will be static, so they should live in a static class. So let's do this static, and then the method that we're going to define here is public static game DTO, and then we have to do a control dot to use gamestore.api.dtos, and then as DTO. And then since it is an extension method, we have to define what exactly is that we're going to be extending. So we're going to say this game. So we're going to be extending the game entity, right? With a brand new method that's named as DTO. And then the name of the parameter is just going to be game. Okay, so with this in place, we want to go ahead and do the proper mapping. So let me just actually transfer DTOs on the right side so we can see better. Okay, so really what we want to do here is just create a brand new instance of the DTO based on the values of the game. So we're going to say return new game DTO, right? And then for the parameters, the first one is going to be the ID. So we get the ID from game.id, and then we go for game.name, and then game.genre, game.price, game.release date, and game.imageURI. So now we have a very handy extension method that we can use anytime we need to convert a game entity into a DTO. And so a quick note on this, I know that we could be using also here Automapper or many other of these mapping frameworks that are available today. And that's totally fine. So feel free to use that if that works best for you. But in this case, things are super simple right now. And in general case, I have found that you don't really need to introduce another framework for something as simple as doing a conversion as we're doing here. So an extension method is very straightforward, it's very easy to reason about, very easy to create, and so this is the preferred approach that I have these days as opposed to using any other mapping framework. But it's just a personal preference, of course. So now let's see how we can use the DTOs in our endpoints. So let's go ahead and open up our Explorer and let's go into endpoints, games endpoints over here. All right, and perhaps I'm going to just move everything into our main tab now. Okay, and we're going to be focusing on games endpoints. So what we're going to do now is let's start using them, right? So for the first endpoint, the one that gets all the games, let's do this. So let's send this repository get all to the next line. And what we're going to do is that after we get all of the games, the entities, we're going to be using link with the select operator here, so that we transform each game into game.asDTO. Okay, that means that for each of the games that come from getAll, we're going to transform the entity into the corresponding DTO object, right? So that way we're not returning entities anymore back to the client, but only DTOs. Same idea for mapGetById. Instead of returning the game over here, we're going to say game.asDTO. Now let's keep going down into our post method here. And the thing here is that now we have to look into the parameters we're receiving. So now we don't want to receive the game entity anymore. We want to receive the corresponding DTO. So let's rename this into create game DTO. And let's just name it game DTO, right? And for this, we have to do control dot so we can start using gamestore.api.dtos, right? So let's start using that. And now we have to figure out how to actually create the entity, because now we don't have the entity. We cannot just send it over directly to the repository. We have to create it on the fly. So let's open up one more line here, and we're going to do the same thing, the following thing. So game equals new. And here we can go ahead and define all of the properties for our entity. So we'll say that name equals game.dto.name, and then genre game.dto.genre, and we'll just keep going with this, of course, until we complete all of the properties. So game.dto.price, release date, and finally image URI equals DTO image URI. And with that in place, the rest should be the same. So now we are creating the entity directly inside the endpoint, and we send that a new entity inside our repository, and we return the generated ID. So let's see what we need to do now for the put endpoint over here. So just like with the other endpoint, we are not receiving the game directly here. We have to receive the update game DTO. Okay, and perhaps we rename updated game into updated game DTO. Let me do F2 here. So updated game DTO. Okay, and here let's see. So we are retrieving the existing game from the repository as an entity, and then all we have to do is really just the same logic. So existing game, name, genre, price, release date, and image URI. We just take the values from the DTO as expected, and then we just send back that existing game into the update API of repository so that it can get updated. And then for our last endpoint, it turns out that we don't have to do anything special here because there's no DTO involved, right? So there's nothing other than the ID to be received here, and there's nothing to be returned. So we are pretty much done there. And so with this in place, we can go ahead and test this out and see if it keeps working. So again, the behavior should be exactly the same at this point because we have no difference between the entities and the DTOs so far, but this could change in the future, of course. So I'll do Ctrl J, and then I'm going to go into my terminal over here. I'll do .NET Run, and then I'll go into Postman, and I'll try out my getAll endpoint here. I'll click on Send, and as expected, we are getting the values just like before, same idea, but of course now the properties are all coming from the DTO, the game DTO. And if we try out our post endpoint, so over here, where we have our body, of course, for the Minecraft game, we'll click on Send, and we can verify that, yeah, it was created successfully. We can see that it now shows up in our get list of games right there. And we could even verify that the validations are working properly. So let me just clean up the name of Minecraft over there. See what happens if I try to do a send. And as expected, we are getting a bad request because the name field is required. So yeah, everything is working as expected now using our DTOs. So that's the end of this model. And in the next model, we will start looking at how to use something very important, which is the .NET configuration system to do things like, for instance, accessing our SQL Server. In this model, you will stand up a SQL Server instance in your box, and you will learn how to connect your REST API to it via the .NET configuration system. By the end of this model, you will have a solid understanding of the following: how to stand up a SQL Server instance using Docker, how to use the .NET configuration system to read application settings in a web API, and how to use the .NET Secret Manager to securely store application secrets. In this lesson, you will get a quick introduction to Docker, and you will learn how to use it to stand up infrastructure services needed by your REST API like SQL Server. So what is Docker? Docker is a platform that provides the ability to package and run an application in a loosely isolated environment called a container. Here's how it works. Here's our web API, which, as we know, needs a database to store and query for games. The piece of software that knows how to stand up and operate this database in our case is SQL Server. That piece of software, along with all its software prerequisites, has already been packaged in what we call a Docker image. And this image is publicly available in a place called Docker Hub. We want to download and run this image in our box, and to do that we use the Docker Engine, which comes with Docker Desktop, one of the pieces you installed at the start of this course. All Docker images are guaranteed to run anywhere the Docker Engine is available. To download this image to our box, we use the docker pull command, and to run it, we use the docker run command. Once the image is run or executed, it becomes what is known as a Docker container, a SQL Server container in this case. This is a fully working SQL Server ready to respond to the requests of our Web API. The Web API will create a database via the SQL Server Docker container, and it will start interacting with it via Entity Framework Core, which we'll cover soon. Notice that even when this container manages the game's database, the database itself does not live inside the container, but outside of it, to ensure it is not deleted once the container is destroyed. Let's now go back to our development environment and stand up our SQL Server Docker container. In this course, I'll be using Docker to host the local SQL Server instance that my REST API will use to connect to. But in your case, if you already have a running SQL Server instance that's either installed in your box or that is available somewhere else in your network, feel free to use that and just skip this lesson and move to the next one where we'll learn how to connect to that SQL Server instance. For now, here I'm going to show you how to stand up SQL Server using Docker. So here I am in the Docker Hub page, which you can get into by going to hub.docker.com, and here is where you're going to find hundreds and hundreds and hundreds of publicly available Docker images for many pieces of software. One of them is SQL Server. And here, what we want to do now is to find that SQL Server image to see how exactly we're going to be using it. So to do that, I'm just going to go into my search box over here, and I'm going to type Microsoft MS SQL Server, and I'll just hit enter. And usually it should be the very first entry here. So notice that this is Microsoft SQL Server, Ubuntu-based images, and this is by Microsoft. So there are going to be a few other ones, but this is the one that I'm interested in. Okay, so this is the one officially published by Microsoft. So I'll click on that one, and this page is going to show us a bunch of information about this image, including how exactly we're going to be pulling it down into our box and running it. All right, and so let's scroll down a bit, and as you can see here, we have kind of a command line example of how you can go ahead and run the image in your box. So what I like to do is to use this as a starting point for the actual command line that we're going to be running in our box to execute the Docker image. So now let's go back into VS Code over here, and what we're going to do is to actually create a README file for our repository here for our REST API, so that we can write down those commands to execute the SQL Server Docker image, just so that we keep them handy in case that we want to restart the Docker container later on. So just at the root of gamestore.api, I'm going to right click and I'll say new file, and this file is just going to be readme.md. Okay, so let's just put some title here. So it's going to be the Game Store API. And now let's go ahead and open up a section in this README file to declare those commands for running the Docker image. So I'm going to do a subtitle here, starting SQL Server. Okay, and I'll be running mostly this in PowerShell. So that's why I'm going to just put this as a PowerShell section. PowerShell. You could do the same thing in other command lines. And here's where we're going to go ahead and bring in that command. So going back into the page, I'm just going to go ahead and copy this. So I'll select this entire section here, copy. Okay, and we'll paste that. Let me collapse this for a moment so we can see better. Now we're going to be changing this command line a little bit so that it works much better for us. So what does this mean actually? So here we're using the docker run command, right? Which means go ahead and run the image, right? Which, by the way, is going to first pull down the image into your box, and then it's going to go ahead and run it, right? So it will do those two things. And then what it's doing is defining a set of environment variables, right? For things like accept EULA, right? Where you want to say just yes, there's no need for prompts for us. So that's the first environment variable, which is specified with -e. And then there's another -e for the password that you're going to be using for the SA user. Now, for the password, I would not like to have our password just hard-coded here at all, because it's not really a good security practice to introduce passwords in our code base at all, right? So that's a big no-no once again. So what I want to do is, instead of this, let's define a variable here that I'm going to just name SA password, all right? And I'm going to say this equals, and here is where we're going to be placing that password. I'm just going to say for now, SA password here, okay? And later on, when we put this into the command line, that is where we're going to be defining that variable, and that's the variable that we're going to be using. So here in MS SQL SA password, we're going to replace this with SA password. Next parameter with dash p is the port. So this is the port that we will expose in our host machine, the actual box where we're working, so that we can talk to the SQL Server instance that is running inside the container, right? You cannot just talk to it just like that. You need to open kind of a window so that you can actually start talking to the container that's running inside. So by default, that container is going to be running inside using port 1433. So we will expose on the outside, so in our host machine, we will expose port 1433 so that we can talk to that port. It doesn't have to be the same port. You could use any other port on the outside here, but by convention, and to keep things simple, we'll just use that same port. The next parameter here, dash D, is used to run in detach mode. That means that once we run the image, we will not just keep looking at the logs of that image as they come out. We will just return to our command line we'll just see a little GUID string, and then our terminal is going to be free to use, right? So, and that's usually what you want to do. You don't want to be looking at all the logs from SQL Server all the time. And then lastly, what you see here is just the name of the repository and the tag of the image that we'll be using, which, as you can see, is going to be Microsoft SQL Server, and we will be using version 2022, the latest version of 2022. Now, there are a couple of other things that we want to do in this command line. And the first one is to define what is known as a volume, a data volume. We want to do this to make sure that the data files for the SQL Server database that we're going to be creating are stored outside of the Docker container and not inside. That's important because otherwise, when you stop or destroy that Docker container, those data files will be gone with the destroyed container. And you usually don't want that. You want that data to persist between instances of the Docker container, right? So for that, what you do is you create a volume and you say where you want to start your volume, store that volume inside your host machine. So for that, what we're going to do is just, let's say, just after our dash P for the port, we'll say dash V, right? And we'll just give it some random name to our SQL Server volume. Let's just name it SQL volume. And then we'll do colon, and after colon, we will point to the location inside the Docker image or the container where SQL Server by default stores those data files. And that location, at least for a SQL Server Linux image, is going to be under var opt/mssql. Okay, perhaps I'll put this in the next line for a few moments so you can see it better. So this is how it should read. So the data files are going to be stored in SQL volume, which is a logical name for the space in your host machine where those files will live. And it will map to the internal var opt/mssql location inside the Docker container. And I'll just do Ctrl+C so that it is a complete line. The next thing I'm going to do is to specify just after dash D, I'll add a couple of other arguments. Actually, just one more argument, which is -rm. So this stands for remove. That means that anytime our Docker container is stopped, it will be automatically removed. Now this is optional, but if you don't do this, anytime you stop the container, either because you stop it manually or because you restart the machine, it's going to be a little bit more troublesome to restart the container because it just stays there in a stopped state, right? So I find that it's better to just go ahead and remove it. And then next time you need it, you just restart it with the same command line that we are running right now. And lastly, let's add one more argument for the name. So otherwise you will get some random name for your container. So you usually want to have some more meaningful name so it's easy to identify. So the name is just going to be MS-SQL. And so with that, we're pretty much ready to stand up our SQL Server Docker container. So what I'm going to do is just open my terminal. And the first thing that I'd like to do is to double check, make sure that Docker is actually running in my box. For that, I'm just going to do docker -- version. And as you can see, we are getting a version back. And then just to double check, I'll do docker ps, which is usually the command that you use to list all of the Docker containers that are running in your box. So at this point, both commands are replying successfully. And so this means that Docker is running properly. Remember that Docker will not usually auto-start when you start your machine, at least not on Windows. So make sure that Docker Desktop is running in your box and go ahead and start it right now if it is not running currently in your box. So with that verified, what we can do now is just to, well, the first thing is going to be to set up our SA password. So I'll just paste that here, and I'm just going to come up with some random password. So I'll do this one. Right, so I'll hit enter, and now we have our SA password variable. Notice that this is the way that you define a variable in PowerShell. If you're using something else that's not PowerShell, you may need to do this in a slightly different way. And so now I'll just copy this other line. I'll paste it over here, and that's going to be using that password, and now I'll hit enter. Okay, and so as you can see, the Docker CLI is not able to find the image in my box. So what it's doing right now, it is downloading all of the layers that compose that Docker image from Docker Hub into my box. And after it downloads all of them, it is going to go ahead and run the image in the box. And we can verify this by doing the following. You can now do, again, Docker PS. And you're going to see that now we have our SQL Server Docker image running, and you can even see the name that we specified for that Docker image over here. So this is our Docker image. It is SQL Server is up and running in the box. Now, the next time that you run your Docker image is actually going to be much faster because it has already been downloaded for you. So for instance, if I now do Docker stop MSSQL, right? So that stops the Docker image and actually removes it from my box. And then if I do the same command again to run the Docker image, notice that it is done. Right? It is done because all of the layers are already in your box. It is cached, so it is much faster, right? So that's one of the great benefits of using Docker. So now we should have a SQL Server running in the box. So what we likely want to do now is to just connect to it and verify that it's actually up and alive in your box. So for that, what I'm going to do is using the SQL Server extension for VS Code, which you can use to easily connect within VS Code to SQL Server. So I will go ahead and open my command palette via Ctrl-Shift-P right now, and I'm going to toggle my activity bar, which so far I've been just hiding. So I'll click on View, Toggle Activity Bar Visibility, and then I'm going to go into my extensions view over there. I'll just click on that one, and here I'm going to be looking for SQL Server. So it should be the very first one here. It is the one created by Microsoft. So this extension over here. Okay, I'll collapse this. This is the one that you want to install. And so yeah, I'll just go ahead and click on install. That should take just a few seconds. All right, so it is ready. And so notice that we now have a brand new icon on the left side over here. And that's how you can access all the SQL Server tooling. Okay, so I'm going to click on that one. Okay, and that's going to initialize extension for us right now. Should just take a second. And so yes, a little bit of a warning here. We're not going to look too much into that one. So I'll just close that. And then I'll close this. And then perhaps let's also close this and that and the terminal. So now what we can do is to add a connection to our SQL Server. So for that, you can just click on this button here that says Add Connection. And for the host name, since the SQL Server instance is running in a local machine, in a local host, inside Docker, you can just specify here localhost. All right. Again, if this would be another instance that you have running in your box or in the network, you will specify that host over here. So I'll hit enter, and then we are prompted to introduce the database name, but we don't have database right now. So we will just hit enter to move on to the next step. And then authentication type, we want to use SQL login right now. And the username is going to be our SA user, hit enter. And for the password, we will use that same password that we specified in the command line a moment ago, right? So I'll just type it here. Enter. Do we want to say the password? Yes, why not? And then this is an optional setting. Do you want to specify a display name? I don't really care, so I'll just hit enter. Okay, now here's a warning here about SQL Server and encryption. And the thing is that by default, encryption will be enabled to connections to SQL Server. But the thing is that we have not set up a proper certificate, right? A fully fledged certificate for our SQL Server instance. And that is fine because this is a local instance of SQL Server, right? So it doesn't really matter too much. And we can let SQL Server use a self-signed certificate to run our SQL Server databases, right? And so in order to do that, to use a self-signed certificate, what you can do is just enable the Trust Server Certificate setting that's prompting us to use here, so that SQL Server is happy by using that self-signed certificate, right? And will not complain about that. Okay, so this is fine for the local development environment. It will not be good for a production environment, but we'll talk about production way later in the course. So let's go ahead and click on Enable Trust Server Certificate. Click on that. And our SQL Server connection has been created, as you can see on the left side. So now if we just expand this a little bit, databases, we're going to see that we do have our system databases up and running right there. And so this means that we have successfully provisioned our SQL Server. So that's it for this lesson, and in the next lesson we'll learn how to connect to our SQL Server instance using the .NET configuration system. At this point, we need to figure out a way to connect our .NET REST API to SQL Server. And as you may know, the way that you do that is by defining a connection string. And the connection string includes all of the parameters needed to connect to the database. Now we could go ahead and define the connection string directly in program CS here. We could just define it here. However, that's usually not a good idea because the connection parameters are usually going to change across different environments, right? Like from your box into a test environment or into a prod environment, those parameters are going to change. And so that's going to mean that you're going to be doing a bunch of things in your code here to accommodate for different environments, right? And that's not really a good idea. The best thing that you can do in this case is actually to use the .NET configuration system. And there are multiple ways to use the configuration system in .NET, but one of the basic ways to do that is by using these files here, app_settings.json and app_settings.development.json, which is the developer version of the same file, right? And like I mentioned before, this is the file where you can define a series of configuration settings with different values that you can later on read from your code files. And later, when you move to a different environment, you can find other ways to provide those same configuration values into your code without having to change your code. Now, to define a connection string using app_settings.json, there's actually a well-known section that you can use here that ties very well to the configuration system APIs that we're going to see in a second. So in this case, what I'm going to do is just define a section here that's going to be named connection strings. And notice that it's actually offered here as per IntelliSense. So I'm going to click on that one. And it has to be named connection strings, right? So that we can use it the way that we're going to be using it in a moment. So make sure that you name it exactly like this. And here what you want to do is to define two things. The first thing is going to be the name of your connection string, right? And you could use any name here, but since this is going to be for the database context that we're going to be defining later on with Entity Framework, and this is for the Game Store application, here we're just going to name this Game Store Context. And then on the right side, we're going to be defining the actual connection string. So let me just collapse this. And then how do you define this connection string? Well, the first thing I want to define here is the server name. So in my case, the server is going to be just localhost. Just make sure to use your actual server here, depending on what SQL Server instance you're using. And then the database is going to be named Game Store, right? Because that's what our application is all about. And we don't have that database just yet, but that's going to be the name that we're going to be using. And then the user ID is going to be SA, the standard system administrator of SQL Server. And then the password is going to be, well, I'm not going to be typing it here, so I'm just going to leave a placeholder for now. Password goes here. And I'm doing this because I'm going to show you another technique in the next set of lessons where you're not going to be needing to worry about this password anymore. So for now, let's just do that. And then lastly, you want to specify one more parameter that is called trust server certificate equals true. And you want to specify this parameter because of what I mentioned in the previous lesson, which is the fact that SQL Server will be using encryption. It has been enabled for encryption, but to use encryption, you have to use a certificate. And we don't have a properly prepared or fully production-ready certificate ready for us at this point because we're just running SQL Server as a local thing, right? It's for local development environment. So in this case, we're going to let SQL Server use the self-signed server certificate that it comes with, right? And it will not complain about it because we're going to be saying trust server certificate equals true, right? So that makes SQL Server happy, it will all work. But certainly this is not what you want to do in a production environment. And we will see later in the course how we use a different connection string for a production-based database. So that's how you define your connection string. And I'll just scroll down a moment so you can see it better. This is how it looks like, right? So that's your connection string. And then, well, how do we read this connection string? So let's go back into Explorer and into program.cs. I'll collapse this. To read the connection string, all you have to do, and I'm just going to go here, you can go ahead and use the builder object. So builder dot, and there's going to be a configuration property here. So the configuration property you can use to read all of the configuration information that is being provided by the configuration system. In this case, by app_settings.json. So here what you can do is say get connection string. And just to reiterate, in order for this method to work for you, you have to make sure that you use it connection strings over here, right? That will make sure that get connection string can find your connection string. And then you want to specify the actual name of the connection string. So for that, we're going to be using game store context. So I'm just going to copy that. Game store context is the name of our connection string. And now we have a way to read the connection string. Now, of course, we want to set that into some variable so that we can see what we actually read. So I'm going to say var con string equals to the result of that. And I'm going to go ahead and place a breakpoint right here in line there. And so we can see what is the value of const string. And so now I'm just going to go ahead and hit F5 to start debugging my application. And we should hit that breakpoint right away when the application starts. So let's see, it is starting now. And as you can see, we hit the breakpoint. And as you can see, if I just hover over the const string variable over here, you're going to see the full value of the connection string right here in the pop-up. So we were able to read the configuration from app.settings.json, and that way our code, our C# code, is not really aware of what exact value we're using. It just comes from configuration. And that's going to be super, super useful as we move on with our application. So let's just stop this for now. Okay, and what we want to do now is to learn actually another technique to read configuration, because like I said, we don't want to be specifying our password right here in app.settings.json. That's kind of a bad practice. So let's move on to the next lesson where we're going to learn about the .NET Secret Manager, which is a much better option to store secrets that you can use in your application locally. In this lesson, you will learn about the .NET configuration system and how to use .NET Secret Manager to store your application secrets during local development. Let's talk about secrets management. As you know, at this point we have a fully functional web API for our game store, and we also have the SQL Server database that will store our games catalog. Now, somehow we need to get our web API to talk to the database, which of course will involve the use of a connection string with all the relevant details. We have seen that we can use the app.settings.json file to store this connection string. However, doing this is not a good idea because it would involve storing user credentials in this file, and this presents serious security concerns. For instance, imagine what would happen if you eventually decide to push your source code, including this file, to a remote code repository. If that repository gets compromised, or if someone else with access to the repo pulls your code into his or her box and that box gets compromised, your connection string might suddenly land in the hands of unauthorized people, which now will have full access to your database. And if that happens to be your production database, you can be in serious trouble. That is why you should never store any sort of credentials or secrets in your app.settings.json file. So, if you can't use this file, where can you store the connection string? Well, you gotta realize that the app.settings.json file is what is known as a configuration source. And just like that one, there are several other configuration sources supported in .NET applications, like command line arguments, environment variables, and even cloud-based configuration sources like Azure Key Vault. And the great thing about this is that the ASP.NET Core runtime takes care of combining information from all available configuration sources into a single configuration object that implements the iConfiguration interface. This configuration object is easily accessible to your web API in such a way that it doesn't really need to know where the configuration data actually comes from. Furthermore, your .NET SDK installation includes what is known as the Secret Manager, which acts as one more configuration source that is specifically designed to store secrets that developers can use in their local boxes for local development and testing. You can add your connection string to Secret Manager, and it will take care of storing these and any other secrets in your local machine's user profile directory, which lives outside of your code repository. That way, you will never risk leaking your secrets as part of your code changes, and your web API will still be able to read them as any other piece of configuration. Let's now see how to use the Secret Manager to store our SQL Server connection string. Let's see how to store and read our connection string from the .NET Secret Manager. So the first thing that you want to do in order to use the Secret Manager is to initialize it. So what you want to do is just go to your terminal over here, and then all you have to do is just use this command line here, .NET user secrets init, and by the way, I'm in the GameStore.api directory, right? The directory of your project file. So just hit enter there, and that's going to go ahead and set the secrets, user secrets ID for your project. So if you go now into GameStore.api, you're going to see that this secret ID that is right now in the terminal is now also defined here as a user secrets ID in your project file. So that's the first step. So that sets kind of an entry into the secret manager for your secrets for this specific project. And with that in place, what we have to do is to go ahead and set the secret into the secret manager. And for that, we want to use the command line. But before doing that, let's go back into our README file. And we're going to also, just like we did with SQL Server, we're going to be adding the command line that we want to use to, well, actually set the secret in secret manager, just in case that you want to set it later on. Okay, so let's go ahead and collapse this. And I'm going to open another section here. It's going to be setting the connection string to secret manager. Right, and again, this is a PowerShell section. Just like we did before, we're going to be capturing the password into a variable. So I'm going to repeat that line that we had in the SQL Server section over here. Okay, so that's going to be our SA password. And now comes the command line to actually set the secret. And let me scroll down a bit here. And so what we're going to do is just this, .NET user secrets set. Then we open our double quotes. And then what is the actual setting that or secret that we want to set? Well, for this, we want to remember what we said before in Explorer in appsettings.json. Remember that we had said that the connection string lives under connection strings and then game store context. So what we want to do is follow that same hierarchy of settings as we set up our secret. That way, the .NET configuration system is going to know how to properly grab that setting and use it exactly how we've been using it so far in the code. Our hierarchy starts with connection strings, right? So I'm going to copy connection strings and put it over here as the first piece of the name of the secret. And then I'll do colon, and then I'll go to the next level, which is game store context, right? So I'll copy game store context over here and I'll place it right there. Okay, and then I'll close double quotes, right? And that is going to define the name of the secret itself. Now we need to go for the value. Okay, so double quotes. And so the value, well, the value is going to be really the connection string that we've been using so far, right? So I'm going to go to appsettings.json and I'll copy the entire thing, right? So I'll copy everything here, copy, over here, paste. There we go. There, now we have our connection string. But of course, now we don't want to be using this placeholder. Instead of that, we want to do SA password. And now that we did that, we can go ahead and run these commands in the terminal. So I'm just going to go ahead and open my terminal over here, and I'm going to scroll down a little bit over there, right there. And so first thing, define the actual SA password. And remember that this is the SA password that we defined before for SQL Server, for System Administrator user. So make sure you type the correct password here. So I'm going to type mine. All right. And now that we have that in place, we can go ahead and run our command to set the secret. So I'll copy that, paste that here, hit enter, and the secret has been successfully saved into the secret store. And so to confirm that the secret is actually there, what you can do is the following. So you can do .NET user secrets list, and this should provide you the full list of all of the secrets that you have so far configured for your current project. And so now that that is in place, let's go back into appsettings.json and, well, guess what? We can go ahead and fully remove this connection string section. It is no longer needed, right? Which is great. And then if we go back into our program.cs file over here, we don't really need to make any changes because now the connection string with the exact same key should be coming from the secret manager and into our connect string variable over here. So I'll keep that breakpoint and I'm going to do F5 to go ahead and do a debugging session, and let's confirm that we can actually read the value from secret manager. So debugging session starts, and now let's explore our connect string variable over here. And as you can see, we are now getting our full connection string right there, now coming from the secret manager. So it is stored securely outside of the code repository, and we are able to use it right away. Notice how I didn't have to make any changes here, and this is the key about the .NET configuration system, because later on we will be changing the place where we're going to be reading this connection string from, and so the fact that it is already configured this way is going to save us so much time in the future. All right, so I'll just stop this. And so that's going to be the end of this model. And in the next model, we will learn about Entity Framework Core, which is going to be the ORM framework that we're going to be using to actually start interacting with our SQL Server database. In this model, you will use the Entity Framework Core ORM framework to start querying and modifying your database records using only C#. By the end of this module, you will have a solid understanding of the following: what is Entity Framework Core, how to implement an Entity Framework DB context, how to generate and apply database migrations, how to implement an Entity Framework repository, and how to use the asynchronous programming model to get improved performance. In this lesson, you will learn about the object relational mapping technique and how Entity Framework Core can help you write code that interacts with your database without having to learn a new language. At this point, we want to add database support to our web API, so that all our data is persisted beyond the lifetime of the application. So, whenever a request to create a game is received in our web API, we want to create that game in the database. And when the client requests a list of games, we want to query that list from the database. However, there's a problem. The database does not speak the same language as your ASP.NET Core Web API. Your Web API is coded in C#, but a SQL Server database only understands the Transact SQL language. That means that to fulfill the request to retrieve games, your C# code needs to translate the Web API request into a carefully crafted T-SQL query and then send that query to SQL Server. SQL Server executes the query, and then your C# code has to read back any resulting rows and translate them into a corresponding Web API response. This presents a few problems. As a C# developer, you now need to learn a completely new language, T-SQL, in order to craft the required queries, and you need to learn it well to ensure that you get good performance out of it. You'll need to write a lot of additional data access code, whose only purpose is to translate things from C# to T-SQL and vice versa, and of course, deal with expected errors. Talking about errors, this approach is error-prone, since it's very easy to make mistakes when mapping things from one side to the other. And you need to manually keep your C# models in sync with the corresponding database tables, which can be quite challenging. This is where Object Relational Mapping Techniques, or ORM, can make a big difference. But what is ORM? Well, going back to our Spotify example, imagine your application has been created using an object-oriented paradigm, and therefore it includes objects to represent songs, artists, and playlist. And if you're working with a relational database server like SQL Server, there's a good chance that your database will have corresponding tables for each of those objects. Now, instead of having to write custom code to map these objects to tables each time you need to send or receive data to or from the database, you can set up a map between them so that your program can keep working with objects while another component, an object relational mapper, takes care of transforming objects to tables and vice versa. So, in essence, Object Relational Mapping is a technique for converting data between a relational database and an object-oriented program. And as you can imagine, it brings many benefits to application developers. And fortunately, ASP.NET Core includes a great ORM framework called Entity Framework Core. So, what is Entity Framework Core? It is a lightweight, extensible, open source, and cross-platform object relational mapper for .NET. Entity Framework Core will sit between your Web API and your SQL Server database. Besides mapping your .NET objects to SQL Server tables, it will translate your C# data access code into Transact SQL statements that the database server can understand. And it will also translate any resulting data from the database into objects that your Web API can easily manage. Using Entity Framework Core in your .NET applications brings in multiple benefits. There's no need for you to learn a new language. You can perform all data access tasks using your familiar C# language. The actual data access code that you need to write is minimal, since Entity Framework takes care of most of it. In fact, you can use Language Integrated Query or LINQ to perform most of your database queries. There's tooling available to keep your C# models in sync with your database tables, so you don't need to do this manually anymore. Entity Framework can keep track of the changes made to your C# object instances at runtime, so it knows what changes to send to the database when it's time to persist the data. Also, Entity Framework Core supports multiple database providers, so you can use your same C# models with additional relational databases if needed. Let's now see how to use Entity Framework Core to add SQL Server support to our Game Store Web API. Let's see how to add Entity Framework Core support into our .NET REST API. And the first thing that we're going to need is a brand new NuGet package that will bring in the SQL Server provider for Entity Framework into our codebase. So let's go ahead and open our terminal here. And let's go ahead and, while being in the GameStore.api directory, let's do .NET add package. I'm going to collapse this for a moment so we can see better. The package that we want to add is Microsoft.Entity Framework Core.SQL Server. So I'll hit enter, And just like this package, there are other packages for other providers like SQLite or PostgreSQL, but in this case, we're using the one for SQL Server. So that is done, right? And what you should see in your project file at this point is that you have this brand new project reference or package reference, this one over here, SQL Server. And so with that in place, let's go back into our Explorer. And what we want to do now is to define a brand new directory to enter or to specify all of the classes related to Entity Framework. So I'm going to actually right click in the GameStore.api directory, new folder, and I'll put a folder named data. And in this data folder, we're going to be creating one class that is known as the data context or DB context. So new C# class, and let's name this one Game Store Context. And so I'll collapse this, and then let me arrange this by doing Control dot, convert to file scope namespace, and then Control dot over here to remove unnecessary usings. And this class, in order for it to become a DB context, it just has to inherit from the DB context class like that. Now I'll do Control dot, and we want to use Microsoft.Entity Framework Core. Enter. And now our class is a proper DB context. Now, a DB context instance represents a session with the database and can be used to query and save instances of your entities. Also, this DB context is kind of a combination of the unit of work and repository patterns. And so a quick note here. So you may be wondering, well, if the DB context can act as a repository, why do we have already a repository defined for our application, right? So remember, we already have our iGames repository interface and our in-mem games repository. And of course, we're going to have an Entity Framework version of the repository later on. So why do we do this? Well, the thing is that we don't want to tie our games endpoints class over here to as a specific implementation of a data access technology, right? So we could later on just inject GameStore context directly here, right, as opposed to our iGames repository. But that would mean that our endpoints are coupled now into Entity Framework directly. And if later on we want to move to something else, let's say we want to move to a NoSQL database because it is, I don't know, it is more performant, or we need to scale really massively our application, we would not be able to do that without having to make a bunch of changes all over the place in our games endpoints. But since we do have our own repository interface that we define and we control, we are not subject to that. Right? So it doesn't matter what kind of changes we make later on into our data repositories, that's never going to make or have any impact into our games endpoints here because we're using our own interface. So that's the reason why we keep all Entity Framework stuff directly inside our GameStore context here, and we'll see later on how we introduce our own Entity Framework repository. Now, for this GameStore context instance or class, what you want to do is to define a constructor. So I'm going to do CTUR. And this is a standard stuff for Entity Framework. What you want to do is to define just one parameter here that is known as DB context options. And for the type argument of the context options, you want to specify your actual GameStore context. So just GameStore context like that. And then the name of this is going to be just options. Okay, and we will go ahead and send those options into our base class, into DB context. We just send the options. Okay, so that's going to allow this GameStore context class to grab all the details on how to connect to the database, including the connection string. And so the next thing that we're going to need here, and let's just leave that to the side, scroll down a bit, is a property that defines our games entities in the database, right? So for that, we're going to be declaring the following property. So it's going to be prop dbset, and then this is going to be of type game, because game is the entity that we will be managing here. And then the name of this property is just going to be games. And so let's head into our game declaration here. I'll do control dot, so we can start using GameStore.api.entities. First entry there. And then of course we're getting a warning here, right? Because we have defined a property here that is not nullable, but we have not defined any default value for this property, right? So we have not defined a default value either in the constructor or as a default value for the property. So we need to define something here. And what you can use here is actually a direct implementation in the property by just doing arrow function here, like a little arrow, and then you will define this as a set of game, right? And so that is going to define the initial dbset instance for our games property of the DB context. And that's what we're going to be using for querying the data of our database. So with that, we have our initial basic implementation of our game store context, which we're going to be modifying in a moment in another lesson. But for now, this is good enough. What we want to do now is to actually register this game store context with our service container, just like we did with the repository. So for that, let's go ahead and do Ctrl+Shift+E to go to our Explorer. Let's go into Program.cs. And remember that we have already defined how to capture that connection string, so that's great. So that's exactly what we're going to use to define or to register our game store context. So for that, we're going to be doing the following. So builder.services, okay, the same collection of services that we used before for the singleton, but this time we're going to be using it to define .add SQL server. So this add SQL server extension method here is one that is going to allow us to register the game store context with the connection string for SQL server, right? So I'm going to specify as a type argument here, game store context. All right, and for that we'll have to do control dot, and we want to use game store.api.data, this one over here, and then we will pass in the con string as the one parameter over there. Now, keep in mind that this add SQL server method here is nothing more than doing something like add scoped. But in this case, instead of we specifying that we want to use add scoped, we are letting the creators of the Entity Framework SQL Server package to provide us with this extension method as SQL Server. And inside that method, they will do the add scoped call, and they will construct those options that we saw here. You see these DB context options, right? So they will construct our game store context instance with those options using the connection string that we have specified here, right? It's just a little bit of syntactic sugar, but it's super useful because now we only have to make this one call and the rest will be configured for us. And so with that, we're pretty much done with this lesson. And in the next lesson, we will learn how to use database migrations to define the mapping between our DB context and our SQL Server tables. It's time to define our first database migration, which in Entity Framework Core terms, all it means is that we have to define how we're going to go from one state of the database into another state of the database, potentially going from nothing into having our actual games table, going from the entities that we have defined already in our DB context. And the migration is also going to define how we can go back from the current state into the previous state if we ever need to. Now, to define a migration, the first thing that we're going to need is a tool from the Entity Framework team, right, that we're going to be using for performing the actual migration. So to do that, let's go back into our terminal. So I'm going to do Ctrl+J here to open my terminal. And the tool that you're going to need is named, so, well, you want to do this, .NET tool install. That's how you install .NET tools in your box. And this tool is going to be installed globally so that you can use it in any of your projects, right? So we're going to say global. And then the tool name is .NET EF. So I'll hit enter, and that's going to install the tool globally into my machine. So that's the first thing. The second thing that you're going to need is a brand new NuGet package that is going to enable Entity Framework to actually scaffold the migrations that we're going to need, because we're not going to be creating them manually, they're going to be generated by the tool. So let me clean this, and what you want to do is the following. .NET add package, and let me actually collapse this so we can see better. The name of the package is Microsoft.entityframeworkcore.design. All right, so I'll hit enter, and that will install the package. And just to confirm, you want to go into gamestore.api.csproc, and now you should see that you have this brand new package over here. This package reference is what confirms that the package has been added into your project. So with all this in place, we are ready to generate our first migration. So I'm going to open my terminal here, and I'm going to clear this. And to generate an initial migration, what you want to do is the following. .NET EF migrations add, and then you want to provide some name for this migration. Let me actually collapse this. The name for this migration, and you can put any name here, but since it's the very first one that we're going to generate, so let's just name it initial create. And then you want to specify where is that you want to generate the files, right? In our case, what I'd like to do is just to generate those files inside our data directory over here on the left side. And so because of that, I'm going to say -- output dir, is going to be data, and inside data, let's create a directory called migrations. So I'll go ahead and hit enter. What this is going to do is going to go ahead and build your project, and then it is going to be using your database context to define how exactly we're going to go from nothing to an actual games database in the SQL Server. Now, as you can see on the Explorer here, we do have now our migrations folder, and we do have our initial migration. And we're going to take a look at this warning in a second. I will go back to that. But for now, let's see what got generated. So as you can see, the main thing that got generated here will not go into all of these files, but the main one is this one here, which likely is going to have another timestamp here, depending on when you're running this migration. But the main thing is that it is named initial create, right? And if we can see here, if we go down, you're going to see that this is a class named initial create, extends from migration, right? And it will have two methods, right? The first one is going to be the up method, this one over here, up, which means that this is a method that's going to be used to go from the current state of the database into the new state. And for that new state, it is saying here that it is going to go ahead and create a table whose name is going to be games. And then it is going to have the following fields. It's going to have an ID field, which happens to be that it's going to be a SQL Server identity, meaning that it is going to be auto-incremented anytime we insert rows into the database, right? Which is what we want. And it is of type int, and it is not going to be nullable, right? So it has to have a value. Okay, and just like that, we can keep going with the other properties. Like we have the name here, which is of type string, right? But in SQL Server, it's going to translate into nvarchar of 50 because we defined that the name property can only have up to 50 characters. Remember that we did that in the data annotations of the entity, the game entity here. Remember that name has this constraint, string length 50. Because of that, in our migration, it decided that nvarchar was going to be 50. So that is why it is important to clearly define what's going to be the length of your entities in the properties. Okay, so max length 50, and again, it is nullable false. And then same idea with genre, and then with price. In this case, it decided or defaulted to a decimal of 18,2, right? So precision 18, scale 2. And of course, this means that we could have up to 18 digits in this decimal, where 2 of them can be can go after the dot, right? So as part of the actual decimal numbers. And then, so that's going to be nullable false. And then release date, it translates into datetime 2. And then lastly, image URI is an nvarchar of 100, right? Also nullable false. And it defines also the constraint, right? So it's going to be a primary key, right, of PK names on the ID. And this is just by convention, right? So it decided by convention, it decided that since we have an ID field, that is going to be the primary key. And also that's why by convention, it decided that it will go ahead and auto increment that one field because it is named ID, right? It's just one convention. And yeah, that is the up method. And then in the down method, what you can see is that it's going to revert that. So if we ever have to go back into the previous state, the down method will kick in, and it's going to go ahead and, of course, just go ahead and drop the table because that's what's going to take us to the previous state. So yeah, that's going to be our initial migration, but we did see that there is a warning here, right? What does this warning say? Well, it says no store type was specified for decimal property price on entity type game. This will cause values to be silently truncated. And so yeah, what this really means is that for our price, right? So notice this here, for price, it automatically decided to just go with decimal 18,2, right? But it doesn't really know if 18 with scale 2 is going to be enough or is going to be what we expect when we send our decimal values for the prices into the database. So it is warning us saying, hey, I don't know if this is going to work for you, so I'm warning you. You might as well just specify this very clearly, what exact value you want in SQL Server or what exact type you want in SQL Server, right, for your price. So that is a warning that we're seeing here. And so in the next lesson, we're going to see how to do the right thing so that we don't have to deal with this warning anymore. We ended the previous lesson with this warning that we have on screen here that is related to the fact that we have not specified which exact precision and scale we want to use for our price column in SQL Server. So in this lesson, we're going to see how to use what we know as an entity type configuration to clearly tell SQL Server what precision and scale we want to use here. So what we want to do now is let's just close this terminal and let's go back into our Explorer, and I'm going to also close this and the migrations folder. And what we want to do is to create a brand new folder just under data. So under data, new folder, and let's name this folder configurations. And in our new configurations folder, we're going to be creating a brand new class that we're going to be calling. So let's just right click, new C# class. The name is going to be game configuration. Let me collapse this for a moment. And once again, let's go ahead and convert to files called namespace and remove unnecessary uses. Now, in order to make this game configuration class an actual entity type configuration, we have to implement one interface that is named iEntity type configuration. And then for that one, we'll have to do control dot, and we want to use entity framework, Microsoft.entity framework core. So hit enter. So we use the right namespace, and then you have to specify a type parameter here, which is going to be the type of the entity that has the column or columns that you want to configure. So in this case is game, just game. And then for that one, we'll have to do control dot once again, and we can use gamestore.api.entities. And with that in place, what we want to do now is to implement this interface. And for that, you can once again go into these curly braces, and you can either use the light bulb, or you can do control dot as I'm doing now, and select the first option that says implement interface. Okay, so implement interface, that's going to scaffold this one method here is the only method we have to implement in order to satisfy the interface. And in this method, what we're going to do, and let me scroll down a bit here, what we're going to do is just one simple thing. We're going to define exactly what's going to be the precision of our price column. So for that, what we can do is the following. So we're going to say builder.property. And in this property, we're going to be defining kind of an expression. So in this expression, we're going to say game, and then arrow function here, game.price. And for that price, we're going to go into the next line, and we're going to say dot has precision. Okay, and here's where we can specify both the precision and the scale that we actually need for our price column. Now in our case, like we said, I mean, the default is 18 with 2 decimal places for scale, but that's way too much. We know that our prices should not exceed like $100, right? As per our restrictions. So let's go ahead and say, well, precision is going to be 5 and scale is going to be 2, meaning that we should be able to get up to a number that is perhaps 999, and then with 99 as decimals, right? Which is still too much, but it should be good enough. Let's just leave a little bit of room just in case, right? So this should be good enough. And now that we have our game configuration defined, we have to tell the context, the DB context, how to use this configuration. So for that, let's go to Explorer and let's go to Game Store Context over here. And what we're going to do is just to override one method from the base class, from the base DB context class, that is going to allow us to apply our configuration. So let's go down here and let's say protected override void, and this is going to be on model creating. Okay, and the parameter is going to be model builder. Okay, so we will be overriding that method. And what we're going to do here is just to use one and single method to apply every single configuration that we have defined in our project that implements the right interface, right? Remember that game configuration implements iEntity type configuration. So this method we're going to be using is just going to be looking for every single class that implements that interface, and it's going to be applied into our DB context. So model builder dot apply configurations from assembly. And what assembly is going to be? Well, it's going to be our executing assembly. So assembly, and then for that one we'll have to do control dot, and then we will use the very first option using system.reflection. Okay, assembly dot get executing assembly, right? So that will give us the current executing assembly of the line that where we are right now, which is just a single assembly for our web API. And so what this is going to do, like I said, is that whenever the model is getting created as part of the migration, the context is going to tell the migrations tooling that we have to apply that configuration that we have defined. So let's now go back into our Explorer, and what we're going to do is just to delete our migrations folder, the migrations folder we have over here. We're just going to go ahead and delete it because we're going to be regenerating it completely, right? So I'm just going to say move to recycle bin. Okay, so it is gone. And now we can go back into our terminal, and I'll do CLS, and then we can go ahead and do the same command that we did before, right? So if you remember, .NET EF migrations at initial create and the output there, and that will go ahead and regenerate the migration for us. So I'll hit enter, and I'm going to go ahead and build it. And then as you can see, there is no more any warnings here. So it's all clean, right? And if we look at the migrations folder, we have a brand new initial create over here. Let's collapse this and that, and let's see if everything worked properly. Notice this over here. So this one over here. Notice that now it is not defaulting to 18,2, it is now 5,2, which is the exact precision and scale that we want. And it's also defined over here, precision and scale. So now SQL Server knows exactly what type we want to use for decimal, and now it doesn't complain anymore. And now that we have this ready, let's move on into the next lesson where we're going to see how to actually apply this database migration into our SQL Server instance. With our database migration ready, it is now time to apply this migration into our SQL Server instance. And doing that is actually very, very straightforward. So let's go back into Visual Studio Code here, and I'm going to go ahead and open my terminal. And again, I am in the directory of GameStore.api. What I'm going to do is just run the following command: .NET EF database update. I'm actually going to go ahead and collapse this so we can see better. Okay, so by executing this command, we are going to run those statements in the migration into our SQL Server database. So I'm going to go ahead and hit enter. And the project is compiled. And just after that, as you can see, Entity Framework tooling will go ahead and translate what has been defined in our migrations into proper SQL Server commands. So as you can see, let's take a quick look. Over here, we have our create database statement right there. That's where the database is being created. So let's keep going down. Let's see what else is interesting here. Here we can see the creation of our table, the migrations table, right? We're going to take a look at that migrations table in a second, but this is the table that keeps track of the migration history. Okay, we'll take a look in a moment on that one. Then let's keep going down. And here you can see that the actual migration is being applied right here, right? So that's our migration. And of course that results in our table getting created in the next login line over here, right there. And finally, as the very last line, there is a new record being inserted into our migration history, which corresponds to the migration that just got executed, right? So that it can keep track of it. But of course, if all of this is succeeded, that means that we should have our table and even our Entity Framework migration history table ready. So let's go back into our SQL Server Explorer. And for that, I'm going to show up once again my activity bar right there. And I'm going to go over here. Okay, this one here is for the SQL Server Explorer. And what I'm going to do now is to just go ahead and right click on databases. And I'm going to refresh. And as you can see, now we not just have the system databases, we also have our GameStore database here. I'm going to collapse this. And under tables, we're going to see that we have two tables. The first table is going to be our EF migrations history, as you can see right here. And here's all the columns. And if we right click on this one and we select top 1000, right, we're going to see on the right side, it's a bit hard to see. So let me see if I can close this one. There it is. You can see that we have our very first migration right here, and with the version of Entity Framework. And so this is going to get populated with every single subsequent migration that you create, so that Entity Framework can keep track of what's going on with your migrations in your database. And the other one is going to be our games table, which is here on the left side. As you can see, it has all of the expected columns, but of course right now it doesn't have really any data because we have not inserted any data into that table just yet, right? We'll look into that in a future lesson. Now, for now, this works just fine, but in the next lesson, we're going to see how to apply migrations directly and automatically on application startup. In the previous lesson, I showed you how to apply migrations using the Entity Framework tools. But now I'd like to show you how to do this in a different way. So how can we apply migrations automatically on application startup? And that can be very handy to simplify your application deployment later on, because you will not need to be applying over and over again each of these migrations as you make changes into your entities. So let's see how we can do this. Let's go into our program.cs file over here. I'm going to collapse this for a moment. And here we're going to do the following, just under the declaration of our app, right? So let's go here under line 11. Over here, we're going to be adding the following set of lines. So first, we're going to be creating a scope, because everything that has to do with our GameStore DB context has to happen in the context of a scope. So we'll do using var scope, equals app.services.createScope. That creates a service scope that we can then use to start resolving services that we're going to need. And the one service that we need here is our DB context. So what we can do now is the following. Var DB context equals scope.serviceProvider, which is the one class that you can use to retrieve services from the service container from iServiceProvider. You can use this class over here, or this property, and then you can do get required service, and then you specify for what type. The type is going to be game store context. Okay, and now that you have the instance of the DB context there, you can do the following. You can just say DB context dot database dot migrate. And in order to use migrate, you will have to do control dot here so that you can use Microsoft.entityframework.core. So this migrate method here is going to go ahead and automatically apply any of the missing migrations in your database, including the initial migration to go ahead and create a database. So this line over here has the same effect as using the Entity Framework tools to apply the migration as we did in the previous lesson. Now we could leave things like this, but I think that a better way to do this is to actually create a specific class to take care of this code. That way we don't pollute our program class once again. So let's do the following. Let's go into our Explorer and into our data directory, and we're going to just right click and add a new C# class that we're going to be naming data extensions. Right, so here we're going to be creating a brand new extension method that can go ahead and perform the database migration. So I'm going to go ahead and clean this out to convert to file scope namespace and remove unnecessary usings. And this is going to be a static class because it is for an extension method. And now let's go ahead and define our method. So the method is going to be public static void initialize db. And then the thing that we're going to be extending is iServiceProvider. Okay, and the name is going to be just service provider. And like I said, iServiceProvider is the one thing that represents the service container, and it is from there that you can go ahead and always resolve those services that have been registered during application startup. And so here we can go ahead now and introduce those lines that we created over here. And so first I'm going to grab an instance of that scope, and I'm going to do it in the following way. So I'm going to say using var scope equals service provider dot create scope. Right, create scope. And yeah, these little squiggles here, what they're saying is that there is even a better way to define this. And so to define this kind of using context. And so yeah, let's go ahead and do that. So I'm going to do control dot, and then we're going to go for use simple using statement. I'll click on that. And as you can see, now we can do this in just one line, right? So there's no need for curly braces. So that makes sense. And then now we're going to go ahead and go back into program and actually copy these lines. Right, those lines over here, okay, for the same effect. And of course, we have to do control dot here to use Microsoft.entityframework.core. And with that, our extension method is ready. Thanks to that, we can now go back into program.cs, and what we can do is just say, instead of all of these lines over here, we can just say app.services.initializeDB. Right, so now we are extending the service provider instance that is defined over here. That's the idea of the extension methods. So with that done, let's go ahead and try out this new logic and see if we can actually run the migrations as the application starts up. So to verify that this actually works, what we're going to do is to go back into our SQL Server Explorer over here, and let's connect into our instance over here. And what we're going to do is just drop the game store database, right, which is fine because we don't have anything meaningful there for now. And so we're going to drop it, and then we're going to run the application and see if the database gets recreated. So I'm going to right click on localhost over here. I'll do new query. And to drop the database, all you have to do is just say drop database game store in this case. Okay, so drop database game store. I'm going to click on this button over here. That's going to go ahead and run the script. So I'll click on that. And the database should have been removed by now. So I'll close that. I'll close this. And if I refresh databases here, the game store database is now gone. Right? So it's not longer there. And with that in place, we can go back into our terminal. So I'll do Ctrl J to open my terminal, and I'm just going to go ahead and do .NET .NET Run, and I'm going to collapse T so that we can see better the logs. So .NET Run, hit enter. And as you can see, as the application started, it went ahead and executed all of those SQL Server commands that before were executed when we run the Entity Framework tool, right? So all of these executed, including the creation of the database, it happened right there, and the insertion of the value into the brand new EF migration history table, right? And after that, the application actually started executing, right? So it looks like it worked just fine, and I'm going to stop my server for now and just go back into the SQL Server Explorer, and then I'll right click on databases, refresh. And as you can see, the game store database is back. The tables are there. We have the EF migration history. We have the games table. Everything is right there. And so now that we have our database ready, we're going to move on into the next lesson where we're going to implement a brand new repository that will be able to use our DB context to start interacting with our brand new database. It's time to implement our brand new repository, which is going to make use of our new game store DB context to be able to both query and also make changes into our brand new game store database. So let's go now into our repositories directory over here, where as of right now, we only have our iGames repository interface and our in-mem games repository. So what we're going to do is to create a brand new class. So let's just right click over here, new C# class. And this one we're going to be naming Entity Framework Games Repository, right? Because this is a repository that's going to be pretty much dedicated to work with Entity Framework objects, right? So now let's collapse this and let's fix things a little bit. File scope namespace and remove necessary usings. Now, as we know, for this class to be an actual repository, it has to implement our iGames repository interface. So we'll go ahead and do that. iGames repository right there. And then I'll just do control dot here, and I'm going to select the first option to implement the interface. So that gives us the initial code for the repository. Now I'm just going to order these methods a little bit so that they follow a similar pattern as we did with the other repository. So I'm going to have create, go after our get, and then we have update, and at the end we're going to have delete, right? Delete. So yeah, so we have delete at the end, update, create, get by ID, and then get all. And so the next thing that we'll have to do in this repository is to define our DB context instance. And so for that, we're going to declare private read only, because nobody should change this instance after construction, and then game store context. And for that one, we'll have to do control dot, and then we're going to be using gamestore.api.data namespace. And then the name is going to be just DB context. And now what we want to do is to inject an instance of a game store context via our constructor. And so for that, I'm just going to click here on DB context, and I'll do again control dot, and I'm going to select the very last option over here that says generate constructor entity framework games repository with game store context as a parameter. So I'll click on that one, and that went ahead and generated this brand new constructor that receives the DB context as injected, dependency injection, and it assigns that parameter into the local DB context variable that we have there. And now that we have that, it is time to start implementing all of our methods, right? So let's start with getAll. So how do we get all of our entities using our DB context? So that's very straightforward. All you have to do is the following. You will do return DB context dot games, because that's our games collection, and then you can do toList, right? That will go ahead and return the full list of games back into the caller. Now, one thing that we want to do here as a small optimization is to make sure that Entity Framework is not trying to keep track of changes to these returned entities, right? Because that's kind of a built-in feature of the Entity Framework. It will go ahead and do additional logic to start keeping track of any changes that the caller makes to the game's entities. However, for the case of a getAll, we don't really need that because all we're going to do, as we know, is just return those entities back into the client. So there's not going to be any modifications. And so we can speed up things for this query by just asking Entity Framework to not do any sort of tracking, right? So to do that, all we have to do is just say dot as no tracking, just like that. And for that, we're going to do control dot, and then using Microsoft.Entity Framework core, just like that. And with that, like I said, there is not going to be any sort of tracking on this list of entities, and that's going to speed up the retrieval of those entities so we can send them back quicker into the client. All right, so let's keep going into our get by ID implementation here, which is going to be the following. So return dbcontext.games.find, and for the find method, we're going to pass in the ID. And that's all it is. Then let's go for our create method over here. And to implement create, all that we have to do is to add that instance into our collection of games. So what we're going to do is just dbcontext.games.add, and then we're going to set our game entity right there. And lastly, we have to invoke the save changes method of the dbcontext so that the changes are actually sent back into the database. So dbcontext.savechanges. Okay, keep in mind that this line here, all it is doing is asking Entity Framework to keep track of the fact that there is a new entity that is being tracked by Entity Framework in the dbcontext. But that line is not adding or inserting the row into SQL Server. Only when you invoke this line here, then the changes are all sent back into the database. And then let's go into our update method over here. So for update, it's going to be very straightforward too. So dbcontext.update, and then we send over the updated game. And again, dbcontext.savechanges. And then lastly, let's go for our delete method over here. And to implement a delete, there are a couple of ways to perform this deletion, but the way that I like to do it these days is by using a nice feature which is known as batch delete. This is going to allow us to perform the delete without having to first load the entity into memory, just so that we can later delete it. With this other feature, we can go ahead and delete it right away. And so in order to do that, what you want to do is the following: dbcontext.games.where, and this is going to be our selector. So this is how we're going to select which entities are going to be deleted. So we're going to say game where game.id matches the ID that we got as a parameter. And once we have selected which entities we want to delete, we're going to say just dot execute delete. Okay, like I said, this is kind of a batch delete behavior that allows you to first select which entities to delete, which is just the one that has the ID that was passed in, and then it goes ahead and deletes everything that matches that criteria. And so, yeah, that completes the implementation of our brand new Entity Framework repository. And in the next lesson, we'll see how to use our new Entity Framework repository to see our application start querying and storing data in SQL Server for the first time. Let's see how to take advantage of our brand new Entity Framework repository in our .NET REST API. So if we go back into our program.cs file over here, we're going to remember that in line 7 over here is where we currently register the InMem Games repository as the one that implements our iGames repository interface. And so the beauty of dependency injection is that now, in order to use the brand new repository, all we have to do is just switch InMem Games repository into Entity Framework Games repository. And just by doing that, the entire application is going to start using this brand new repository. And our games endpoints don't have to know that we're making this change. Those should just keep working as is. Now, one other important change that we have to make here is to switch this registration from @singleton into @scoped. So no longer singleton, but just scoped, just like this. And this is because, keep in mind that the GameStore context is registered as a scope service. And that's what @SQL Server is going to do inside this, is going to register the GameStore context as a scope service. And that is just because of the way that the GameStore context has been designed. It is designed to really just work for a small amount of time, right, during the duration of your request. You should not keep this GameStore context just living and hanging around for the entirety of the application. So you do need a new instance of this guy for every single new request. And since our GameStore context demands to be a scoped service, and if we kept the Entity Framework Games repository as a singleton service, it is not going to be possible to just inject GameStore context into the Entity Framework Games repository, right? Which is going to be a singleton. And that's because you cannot just inject a scope service into a singleton service, right? The singleton is expected to live for the entirety of the application, while the scope service requires a scope, and there's not going to be any scope in a singleton. If you wanted to, you can make that work by doing just something similar to what we did in the initializeDB method over here. So if we go and do F12 and initializeDB, remember that here's where we created a scope right here using the service provider. We created a scope, and via that scope, we were able to take advantage of our game store context because it is scoped. It has to use a scope. And you could do that if you wanted to in the entity framework games repository, but that's not really very usual. That's not what you want to do. You might as well just keep the exact same service lifetime for both the context and your games repository. Now, we could keep things like this and just go with that, but I'm not liking how much code we're writing right now just for the purposes of registering this repository and the context. And so to keep this file kind of clean, we're going to be writing a brand new extension method that takes care of everything related to registering the repository. So let's go back into our data extensions file over here. And what we're going to do is just scroll down, and we're going to be creating a brand new method that we're going to be calling public static iService collection. That's what we're going to be returning. And then the name is add repositories. Now this is going to be receiving two parameters. The first one is the type that we're extending. So this is going to be iService collection and services. It's going to be the name. And then the second parameter is going to be our iConfiguration instance. Okay. Remember that configuration is the object that you can use to retrieve any of the values that you have configured anywhere in the .NET configuration system, either appsales.json or .NET Secret Manager or anywhere else. So let's go ahead and open and close curly braces, and let's scroll down a bit. And what we want to do now is to bring in those lines. Let's start with these two lines over here, which are the ones that we use to register our game store context. So I'm just going to copy that and paste those over here. And in this case, instead of using the builder, we're going to be using the configuration object that we just received as parameter, like this. And then for the actual registration, we're going to be using directly the services parameter that we also got as a parameter over there. So that's that. And then what we want to do is to also bring in our add scoped call that we have over here. So I'm going to be copying this, and we can change that into our add SQL server call, just like that. And then for this, we may want to introduce other namespaces. So I'll do control dot, so we can use gamestore.api.repositories and entity framework games repository. And after doing that, what we're going to do is just return the services instance. Okay, so by returning services, we allow any other of our callers to just make other calls into that use that services collection. So with that in place, if we go back into program, we can now go ahead and do the following. Instead of having these three lines, we can just say builder.services.add-repositories, and then we will pass in just builder.configuration. And that's all it is. Okay, so keep things clean, and we can actually clean up these namespaces, remove necessary namespaces, and that's all of our pro.cs file at this point. And with that in place, we can go ahead and try out our .NET REST API with our SQL Server support for the very first time. So I'll do Ctrl J here. Okay, and so we're just going to do .NET Run. So that's going to start, and it is going to try to apply migrations if needed. But of course, there are no more migrations needed. As you can see right here, okay, the database is already up to date, so no more migrations. So we are ready to start using the database. So let's go back into our Postman over here, and let's see if we can actually get any gains by just querying the database right now. So I'm going to use my get all endpoint over here. I'll click on send, and as expected, there are no gains right now, right? This is completely empty. And what we can do now is to actually go ahead and create a game, right? So let's go back into our post tab over here, where we already have scaffolded the code to create our Minecraft game. And let me actually put here Minecraft, which is where it should be. Okay, and this should go ahead and create the Minecraft game. So let's go ahead and click on send. And as you can see, it was a success. So we got our 201 created status code, and we got our payload right there. And so this means that if we go back to our get all, click on send, we have our very first game now coming from the database. And yeah, so since that is working, we could also verify that updates are working fine. So let's go into our boot over here, where what this is doing right now is just updating game number 1. But perhaps, it would not make sense to update Minecraft into Street Fighter 2 Turbo. So let's go back into post And let me just grab this body over here. I'm going to replace it there. And all we're going to do is just modify the name. Let's say that this is Minecraft for Windows and the price is going to be cheaper. Let's do $9.99. So let's go ahead and send our put call. And yeah, it was a 2 of 4 success. So I'll go ahead and get all of our games and that is working just fine. I can also get game number 1 over here by get by ID, hit send. It is getting the 1 game. So that worked just fine. And lastly, we could go ahead and also delete the game. But before we do that, let's actually create just another one, right? Just so that we have 2 items and then we end up with just 1 item at the very end. So let's create one more Minecraft game over there. So now we have 2 Minecraft games, right? So get all, we have 2 Minecraft games. And in the delete call over here, we're going to be deleting game number 2. Okay, so delete game number 2, hit send. And then that was a success. We go back to get all, click send, and we only have 1 game. So the entire REST API seems to be working just fine. And of course, what we want to verify now is that everything is actually stored into the database. So let's go back into Visual Studio Code over here. And I'm going to Ctrl+C to stop my server. I'll go back into my SQL Server Explorer over here. And then I'm going to right click on in my games table, select top 1000. Okay, and if things are working properly, we should see here, let me put this on this side, we can see that we do have our Minecraft game stored into the database. So yeah, our REST API is now fully integrated into SQL Server database. And with that in place, in the next lesson, we'll learn about an important technique that you don't want to miss in your REST API implementation, which is known as the asynchronous programming model. In this lesson, you will learn about the asynchronous programming model and how to use it to your advantage in your ASP.NET Core applications. To understand asynchronous programming, let's go through a common scenario you might be familiar with, which is making breakfast. Let's say you start by heating your pan for a few minutes, and then, when ready, you fry some eggs there. We would also like to have some bread for our breakfast, so after our eggs are ready, we bring up the toaster and toast our bread. Then, when the bread is ready, we add some jam or peanut butter on it. Finally, our breakfast would not be complete without some juice, so let's pour in some orange juice. In total, it took us about 30 minutes to complete our breakfast. But is that really how you would go about preparing your breakfast? If it is a weekday, when you're usually in a rush, perhaps you would do it this way instead. You start heating your pan, and while that happens, you will also start toasting your bread. And while those 2 things are happening, perhaps you can also pour your orange juice. Eventually, when the pan is ready, you go back to it and fry some eggs. And once the bread is toasted, you go and put the jam or peanut butter on it. Doing things this way, you can be done in much less time, let's say 15 minutes, and perhaps you can spend the rest of the time enjoying your breakfast. When comparing these 2 ways of going about making your breakfast, we say that the first approach is synchronous, since you won't start a new task until the previous one is complete. However, the second approach is asynchronous, since you don't wait for a task to complete before starting your next task. Instead, you start as many tasks as you can, and eventually you turn your attention to the tasks that are ready for you so you can continue with the next task. In a similar way, you can perform asynchronous programming in your ASP.NET Core applications. When a client sends a request to the web server, you want to start handling the request in your endpoint in an asynchronous way so that your cook, the Kester web server, is immediately free to start handling the next request. So as your endpoint starts an asynchronous call perhaps to your repository, and the repository in turn requests data asynchronously from the database, the web server has also started serving the next request also asynchronously. When the database eventually returns requested data, the repository will resume work and send the data back to the endpoint, which in turn resumes work, transforms entities into DTOs, and sends the data back to the web server, who in turn responds to the original client request. After this, the application continues starting other tasks asynchronously and resumes work whenever necessary. As you can see, the asynchronous programming model brings in multiple benefits. Your application gets improved performance since you avoid blocking callers and free them up to perform other tasks, which also results in overall better responsiveness. you are able to scale your application better because it can handle more requests and users simultaneously without getting bogged down by waiting for I/O operations to complete. And also, the use of task objects in combination with the async and await keywords provide a simple and intuitive way of writing asynchronous code as opposed to having to deal with threads and callbacks directly. Now that you understand the asynchronous programming model and its benefits, let's see how to put it to work in our current web API. Let's see how to take advantage of the asynchronous programming model in our .NET REST API. So the first thing that we're going to do is go into our iGames repository interface, this one over here, and we're going to be modifying all of our methods so that they follow the conventions of the asynchronous programming model. So the first convention that we should enforce here is that since all of these methods are going to be for asynchronous operations, they should have a different suffix, right? So for instance, create should be renamed, and I'm going to just do F2 here. So F2. So create should be renamed into create async, right? And that's just a convention in the .NET world. You don't have to do it, but it is the right way to name any method that is going to perform any kind of asynchronous work. And so just like that, I'll do F2 for delete. So delete async, and then I'll do F2 for get async. And then for get all, I'll also do get all async. And lastly, for update, I'll do update async. Notice that I'm using F2 here because I want to make sure that these changes apply not just to my interface, but also to all of my repositories, right? So if I go into my entity framework repository, notice that the names have changed, right? And same thing for in-mem games repository, the names should have changed by now. Okay, that's what I'm using F2. The next thing that we want to do in this interface, and close that, is to make sure that all of them are returning tasks as opposed to the actual object or even void. That is what is going to allow the callers to not just block on the call into these methods, but actually take advantage of the asynchronous programming model by using the task library available in .NET. So we're going to rename all of these return types into task. So instead of void, we're going to just type task. And then again, instead of void, we do task. And instead of game nullable, we now have to say task of game nullable. And then instead of IEnumerable, we'll say task of IEnumerable of game. And instead of update async, it's going to be task update async. So with the interface fixed, now we can go and actually implement the asynchronous programming model in our repositories. So let's start with the entity framework games repository. I'm going to collapse this for a moment. So let's go up now. And of course, we now have to match the updated interface. So let's go and start doing that one by one. So let's start with our get all async method, right? So like I said, we have to return now a task, right? So this is going to return task of IEnumerable of game. And now when we invoke the toList method of the entity framework for the games collection here, we don't want to use toList, but we want to use the variant that is for the asynchronous programming model. And you're going to find this in most libraries that are going to perform any kind of time-consuming operation, right? There's always going to be some variant for asynchronous programming. So I'm going to do Control Spacebar here to find any other overloads. So if we go down here, we're going to find that there is a toList async method right here. So I'll do that one, right? So now we're going to not be blocking in our call to toList, but instead we're going to just let the asynchronous programming model do its magic, right? So that we don't have to block on that call. Now, in order to be start using this kind of API here, we also have to make modifications into two places in this method. First, we have to specify just after public, we want to say that this is going to be async. And also before returning, we want to say that this is going to use await. So that is that combination of returning task and using async and await for every single invocation is what's going to allow you to take advantage of the asynchronous programming model for this very specific method. So whenever somebody invokes this getAllAsync method, that caller is not going to have to block on the invocation of getAllAsync. It's just going to start the task, and whenever the task is complete, the results are going to be returned back into the client so that, or into the caller, so that it can continue the operation. Now let's keep going down into the next set of methods. So now we have our getAsync, which is going to return a task of game nullable. Okay, and now of course this has to be async, and then it has to do await here, and this is going to use find async, the synchronous version. Now let's do the same thing for create async. So this is going to return a task. It's going to be async here. And then it's going to do await dbcontext.save changes async. All right, so let's keep going down. Let's go for our update operation. So this is going to return task. It's going to be async. Then it's going to be await save changes async. And then lastly, for delete, same thing. We do task, async task, and then we're going to do await, and that execute delete async. And just by doing that, now our Entity Framework repository has been updated to follow the asynchronous programming model. Now, just like we did this, with this repository, we'll have to do the same thing with our in-mem games repository, right? So that it can actually comply with the interface. Now, at this point, of course, you could decide to just get rid of this in-mem games repository if it doesn't work for you. But I found it very handy to do a few tests later on. So that's why I'll be just keeping it around. And all we have to do is just comply with the changes required by the interface. So let's go down into get all async. And again, what we want to do here is just say that this returns task of IEnumerable of game. And again, we want to do async. And then we want to return await, but of course there is nothing really to await on, right? Because this is in memory, there's nothing that we're going to be calling into. So for these cases, what you want to do is just take advantage of this method called task.fromResult, okay? And then you can just pass in your result. Okay, so this is kind of a way to say, hey, let's spin up a brand new task, but just create it using the result that is right here. There's no need to wait on anything, just return a task that includes that result. So that's going to be very handy for our in-mem games repository. So let's keep going down into get async, which again is going to be task of game over here. And then we're going to do async and then await and then task.fromResult. And then games.find, and then we'll close over there. Okay, once again, we're returning a completed task out of that found game. Scrolling down into create async, we are returning async task, create async. And in this case, since we don't actually have to return anything, what you can do is just say await task.completed task, meaning that the task has already completed. There's nothing to wait for in this method. Same thing with update async. We're going to say that this is async task update async, and then we await task.completed task. And once again, we're going to go into our delete async method here. It's going to be async task, and then we await task.completed task. So now all of our repositories have now switched into the asynchronous programming model. But now we have to make also a few changes in our endpoints extension methods so that they can also work with this new paradigm. So let's go into Explorer and let's go into endpoints, games endpoints. And let's scroll down into our first method here, which is the map get for the get all operation. So now the first thing that we want to do here is to add the async modifier, right? Just before the parameter for this method here, we want to do async, right? So that we can do an asynchronous operation inside this method. And then before invoking repository.getAllAsync, we want to do await right there. Okay, and then we want to close into parentheses this invocation into getAllAsync. Okay, that way the asynchronous operation happens inside these parentheses and we get out the actual list that we can then use to select the games and transform them into DTOs. Then moving on to our get by ID, all we want to do is just do async here, and then we're going to do an await into repository getAllAsync, and that's all we have to do there. And then we're going to scroll down into post. Once again, we do async here, and then at the point where we invoke repository.createAsync, where we want to do is just say await repository.createAsync. That will do it. And then moving down into map_put, once again we do async, and then we're going to do await over here, and also all the way down into update async. This call has to also do await. And finally, for our map delete, once again we do async, and then we do await here and also await there. So now the entire REST API is following the asynchronous programming model. So this is what we know as async all the way, right? So whenever a request comes in, it's going to use games endpoints that are made for the asynchronous programming model, and also a set of repositories that are using the asynchronous programming model, and also, of course, the asynchronous programming model of the Entity Framework core. So async all the way. Now, before we test this in Postman, one more thing that we can do is actually modify data extensions over here, because remember that if you go a little bit up here, we have this initializeDB method, right, which is the one that we use to run the migrations when the application starts. This also has the capability of running in an asynchronous manner. So all we have to do to enable that is the following. So instead of void, we're going to be returning async task, and for the name of the method, we're going to rename this, and I'll do F2, initializeDB async, and then instead of calling migrate, we're going to be calling await database.migrate async. Okay, so that's the asynchronous version of this method here. So that will make sure that when we invoke the database at the very start of the application startup, we will also do it in an asynchronous way. So let's go back into program.cs, okay, over here, and let's make sure that we also use the await keyword right there before invoking the initializeDB async method. So with that in place, we have everything set up for the asynchronous programming model. So I'll just do Ctrl-J and I'll do .NET Run in my GameStart.api directory. And I'm going to go into Postman over here. I'll just make sure that a couple of APIs are working properly. So I'll do our get all games, hit send, and as expected, things are working properly. We just have one game for now, of course. We should actually create a second game. So let's go into Post, and in the body, let's see if we can create another game here. So this is going to be Street Fighter 2, and then this is going to be Fighting. Okay, let's leave the price as $19.99, that's fine. And then the release date is going to be 1991, and it's February the 1st. And the image array is just going to be that. So let's go ahead and try this post operation. I'll click on send, and then yeah, Street Fighter 2 has been created just fine. And if we go back into the get all, we'll see that it is right there. And so things are looking just fine. All right, so the asynchronous programming model is working just fine in our application. So it is really optimized for not having to do any kind of blocking calls when we have to invoke external services like the database. So that's the end of this model. And in the next model, we will switch gears to another critical topic in REST APIs, which is how to properly secure your .NET REST API. In this model, you will secure your .NET REST API to ensure only authorized callers can make use of it. By the end of this model, you will have a solid understanding of the following: how token-based authentication can protect your API resources, how to require authentication and authorization in your API endpoints, how to create and use JSON Web Tokens for local development, how to implement role-based authorization, and how to implement claims-based authorization. In this lesson, you will learn about token-based authentication, the modern approach to securing your REST APIs. When you start thinking about securing your REST API, one of the first questions is likely going to be how to tell if a given user can access the resources managed by the API. A first idea could be to add some sort of database to the REST API that would include the credentials for all users, and maybe even the roles they belong to. Then, after the client collects the username and password in a login screen, the credentials are sent to your API as part of the request. Your API validates the credentials against its database and then proceeds to return the requested resources. The problem with this approach is that the client will be sending the user's credentials on every request to your API, which presents a few concerns. If SSL is not enabled, which of course should not be the case, an attacker with a package sniffer could easily grab the credentials. Even if SSL is enabled, tools like Fiddler, capable of decrypting the URLs, could have been installed in the user's machine, assuming the user provided consent for it. The URLs will likely get logged on the REST API, and the logs might not be secured properly. The client would need to ask for credentials every time, or perhaps would keep them in its local cache, which is just as bad. And what if we need to stand up a new REST API later? Should we duplicate the credential validation logic? Or should we add a shared library and let the APIs share the credentials database? There's probably a better way to do this. There are many ways to authenticate users so that they can access your REST API. However, the ideal and modern approach is called token-based authentication, and it works like this. When a user wants to get access to the REST API resources via his client, let's say a browser, the client first requests authorization from what is known as an authorization server, which usually lives somewhere in the cloud. The authorization server presents a login form where the user enters his or her username and password. Once the user submits the form, the authorization server verifies the credentials and then it generates an encoded access token and sends it back to the client. The token includes information about how to verify it is a valid token, where it came from, where it can be used, who is authorized by the token, meaning the person that successfully logged in, what can be done with the token, and much more. The client can then use this token to try to access your REST API. If the API can verify that this token is valid and presents the required authorization, it will allow it, perform the requested operation, and return a successful response. Now, how do you protect an ASP.NET Core Web API so it can only allow requests that include valid tokens? Well, let's jump into the code and learn how to do this. Let's see how to protect our .NET REST API so that it only allows requests that present a valid access token. So the first thing to do is to go into program.cs over here, and what we're going to do is to add the services that are going to be needed for us to be able to also require authorization in each of our endpoints. So for that, let's just go over here in line 6. We're going to do the following: builder.services.add authorization. So those are the services required for authorization, and now that we have that, we can now go into our endpoints and start requiring authorization in each of them. So let's now go into endpoints and games endpoints, and I'm going to collapse this for a moment. Let's go to the very top, and we're going to enable authorization on an endpoint by endpoint basis, right? So for the very first endpoint, this one here that retrieves all of the games, we are actually not going to require any authorization. This is going to be our anonymous endpoint so that anybody can just go ahead and retrieve the full list of games. And that's just fine. But for our next endpoint, the one that retrieves a game by ID, this is the first one that's going to require authorization. And to require authorization, all you have to do is just chain one more call at the very end here after the .with_name call. And all you have to say is just say require authorization, just like that. So from here on, anybody that invokes this endpoint has to present a valid access token with the valid authorization metadata so that they can actually access the endpoint. And let me copy this because we're going to be doing the very same thing with the other endpoints. So let's go into our post endpoint here. We're going to say again, require authorization. Let's scroll down into map put. And at the very end of the put, we're going to say require authorization. And lastly, let's go into our delete endpoint and also require authorization. Okay, so all of the endpoints except for the get all are going to require authorization. However, this is not enough. There's one more thing that you have to do here. It is to add the services required for authentication, right? So we need to be able to receive that token, decode it, and extract this information, right? So that we can later use it for authorization. And for this, the first thing that we're going to need to do is to add a brand new NuGet package. So let me just do Ctrl J here to open my terminal. And the package that I want to add is the following: .NET add package. And remember that this is at the level of the GameStar.api project. And the package is Microsoft.ASP.NET Core.authentication.jwt better. Right? Hit enter. And now you should see in your GameStar.api.csproc, you should see the brand new reference added over here. And with that in place, now we can go into program.cs and actually add the services needed for authentication. So I'm just going to open another line here, and I'm going to say builder.services.add authentication, and that is going to add the authentication related services. But we also have to be a bit more specific, and we need to specify what kind of authentication we're going to be enabling in our service, because there could be multiple types of authentication. In our case, the type of authentication that we want to use here is JWT better. And what this is going to do is go ahead and extract that JWT access token that's going to come with a request. It will extract it and place it in the ASP.NET Core pipeline so that we can later authorize based on the contents of that token. Okay, and with that in place, what we can do now is test out the REST API and verify that authorization is actually enabled. So I'm going to do Ctrl J here. I'm going to do .NET run, of course. And then let's go into Postman over here. And first, let's try out our get all games endpoint, right? So this one is anonymous at this point. It doesn't require authorization. So if I just click send, it should be able to still retrieve the games. And as you can see, it is able to get the games without any issues. Now let's go into our post endpoint, right? Or in fact, let's actually go for the get by ID. So what IDs we have? We have ID 1 and ID 3. So let's go into games and when ID 1, and let's see what happens if we just try to go ahead and retrieve that one game. So I click on send. And as you can see, now we are getting a status of 401 unauthorized, right? Which is expected because now that endpoint is requiring authorization. And same thing if we go with the post and we try to create a brand new game over here, right? I'll just click on send. And again, we are not able to do it because we are getting an unauthorized error. Okay, so now we have a secured REST API, but of course what you want to do now is to figure out, well, how do we create these access or better tokens that are needed to actually access the protected endpoints? So that's going to be actually the topic of our next lesson. So let's move to the next lesson to see how to start creating these access tokens. Let's see how we can create access tokens that we can use to get access to our protected .NET REST API. So usually to get these access tokens, you're going to need some sort of authorization server, which is the one that can provision these access tokens based on the identity of whoever is logging into the system. However, provisioning an authorization server is not trivial, and you could even get access to some sort of authorization server in the cloud that you can just use for this, but even that is just overkill for what we need right now. All we need is some sort of simple access tokens that we can use to validate that the authorization has been configured properly in our endpoints. Because of that, we're going to be using a built-in tool that comes with the .NET SDK that allows you to easily provision access tokens for local development. So here's what we're going to do. Let's just go ahead and open our terminal. Just like this, location of GameStore.api, and all you need to do to create an access token is the following: .NET user JWTS create. Okay, I'll hit enter. And as you can see, this right away went ahead and provisioned an access token that should have the required permissions to access our protected endpoints. So the actual token is right here, right? It's this big section here, which is encoded. And we also have a couple of other details like the ID of this token over here and the name for which the token has been generated. Now, if you want to get more details about this token, right? So like what is behind this encoded string, what you can do is the following. I'm going to go ahead and just copy this ID, copy that, and I'm going to clean the screen and I'm going to say .NET user JWTS print, and then I'll just paste the ID. So I'll hit enter. And as you can see, this is going to give me a bunch of details about the generated token. For instance, besides the ID of this token and the name of the user that got access via this token, we also have something important, which is the audience right here. So the audience is the set of servers and ports that are actually authorized to use this token. No other server and port combination will be allowed to use the token. And where are those coming from? Well, if you just collapse this for a moment and go into launch settings.json, all of those ports are coming from the list of settings that are defined currently in your launch settings.json. Like here we have the default port for IIS and the corresponding SSL port. And then we have the port for our HTTP profile. And then we also have the port for our HTTPS profile, right? 70.20.24. The tool automatically inspected all of these ports, which are the ones where we can serve our application locally right now, and defining them as our audience for the access token. Then we also have these other settings here, like not before, expires on, and issued, which defines the dates on which the token is valid, right? So it will not be valid before this date, and it's going to expire on this other date, and it was issued in this date over here. So that defines the restrictions of this token. But not only that, the tool also configured our REST API so that it matches these restrictions, so you can use it right away. So if you now go into app settings.development.json over here, what you're going to see is that we have this brand new section, authentication, okay, right here, which has already been configured for the default better scheme, which is the one that we already configured in our project. It defines the same valid audiences, right? That means that our REST API is only going to accept tokens that includes one of these as part of the audiences that it is presenting. Right? So we noticed that it is already configured for those audiences right here. And so the service itself is configured for those same audiences, right? So now the generated token is going to match exactly the valid audiences that have been configured for our REST API, and that's going to make things just work, right? And finally, this also declares which is going to be the valid issuer. So who is the one or who is the entity that provisioned this access token, which in this case is just our local .NET user JWTS tool. If we take a closer look at this access token over here, there's actually a bunch of things going on there. And I think this is something very important to understand. In the next lesson, we're going to go ahead and start learning more about JSON Web Tokens. In this lesson, we will learn about JSON Web Tokens, their structure, and some of the elements you will usually find in them. A JSON Web Token, also known as JWT or JWT, is a compact, URL-safe means of representing claims to be transferred between two parties. This set of claims can be digitally signed to protect their integrity, at which point the JWT payload is part of a structure known as a JSON Web Signature or JWS. JWTs can also be encrypted, but in this course, we will focus on signed tokens only. Let's now look at the structure of a JWT. A JWT typically looks like this, which at first glance is just a lot of gibberish. However, there are two periods among all of these characters that divide the JWT in three well-known parts. The header, which contains information about the type of token and how it was signed, the payload, which contains all the transmitted claims, and the signature, which is calculated from the encoded header and payload, an added secret, and the hashing algorithm specified in the header. It is used to verify that the message wasn't changed along the way. In the header of a JWT, we will typically find at least these two fields. ALG, the algorithm used to sign the token. RS-256, for instance, would mean the JWT was signed using RSA signature with SHA-256. TYP, which is the type of token, and the type here is usually just JWT. And the header can also include an optional KID field, which is an identifier of the key used to sign the token, in the case the identity provider has more than one key available. Like mentioned before, the JWT payload contains the many claims that are being transmitted via the token. Some are well known and some are more specific to specific identity providers. Here for a few of the ones you will find during this course. The issuer, who is who created and signed the token. The audience, who is who the token is intended for. JTI, which is the unique identifier of the JWT. This prevents the JWT from being replayed. The subject, which is the principal that is the subject of the JWT. This is usually the ID of the sign-in user. The scope, which is the type of access granted to the client. MBF, which stands for not valid before. This is the time before which the JWT must not be accepted for processing. These and all datetime values are defined in seconds since Unix epoch, which is the number of seconds that have elapsed since January 1st, 1970 at midnight, not counting leap seconds. The expiration time after which the JWT must not be accepted for processing, and IAT, which identifies the time at which the JWT was issued. In the next lesson, we will decode a real access token and we'll use it to get access to our protected REST API endpoints. Let's see now how to use our access token to get access to our protected REST API. So if you remember, a couple of lessons ago, we generated this access token over here using the .NET User JWTs tool. Now, before using the token to access REST API, let's actually decode it and see what's really behind it, right? So let's go ahead and copy this. I'm going to just copy that entire encoded string, and I'm going to go into this page over here. It's called jwt.ms right here. Right? So this is my preferred one for decoding tokens, and there's a bunch of links. For instance, you also have jwt.io, this one over here, jwt.io, very popular, and there are many others. The preferred one for me, at least, is jwt.ms, so this is the one that I'll be using across this course. So I'm just going to close the other. And in this big text box at the top, we're going to go and just paste that access token right there. And as you can see, it does have those three sections we talked about, right? So the header, the payload over here, and then finally the signature. But more importantly, if we scroll down, we're going to see the actual contents of that decoded token, right? So you can see the algorithm and the type of token over here. And then you can see really what is behind the token, right? So you can see that we have a claim for a unique name, which by the way, is just inferred from the user that I'm using in my machine, right? So that's automatic. There's also the sub, which is the subject of the principal of this token, who was assigned this token to start with. Then we have the JTI, and then we have the audience that we talked about before, right? So the token is meant only for these servers and ports. And then the dates, right? Known before, expires at, and the issued at dates in Unix epoch, and then who issued the token, right? So that information that you're going to find behind your token, and this tool is really great to really understand what is behind this encoded token. You're going to see later on in the course, when we use a different kind of token, we're going to have another type of claims. Now, the other thing here is that you can also go into this tab that says claims, so that to get more information about any of these claims. It's not going to have information about every single claim, but it will at least have information about the most common claims, most well understood claims, because many of them are super well understood, are standard claims, while others are more specific to the specific identity provider. So now we know how to decode the token. Let's go back into VS Code, and now let's actually take advantage of the token. So to do that, what we want to do is just, well, let's start the server, right? So .NET Run, start it. And then what we're going to do is just go back to Postman. And as you know, right now, if you just try to hit send for our get by ID API, hit send, this is unauthorized, right? Right here, unauthorized. So in order to actually get authorized, we want to use a token. And to use a token, what you want to do is just go into this authorization tab over here, authorization, click there, and then open up this drop down over here. Just open up that, and we're going to be using better token, okay? Better token. Now, what better means, it just means, well, better authentication is just give access to the better of this token, right? So that's really what's behind that name of better. But yeah, what you want to do here is now in this text box over here, that text box, you're going to go ahead and just paste a token. So paste it right there. And now the token is going to be included as part of the headers. And in fact, if you now go into the headers tab over here in Postman, just go into headers, and what you're going to see is that there will be one new header over here that is called authorization, and that is the one that defines the header and the value that's going to be used for the token that's going to be presented as soon as the request arrives into our REST API. And so let's go ahead and, well, let's send this request and see what happens. So I'll go ahead and click on send, and notice that this time we do get a 200 OK over here. So it was a success, right? And of course we are getting the entire payload of the requested game. So the token allowed us to get access to the protected REST API. And we can do the same thing with our post call, for instance. We go to post over here, and we're going to go into authorization and into better token. And in this case, Postman is just reusing that same token that we had before. It's over here. And so at this point, we're going to go ahead and post this other game, which I already prepared. It's going to be Final Fantasy XIV. So it's going to be created in the REST API. So let's go ahead and hit send. And once again, notice that now we don't get unauthorized, we are getting our expected 201 created result. And if we go back into our get all games, we'll hit send, and we'll see that the new game has been created right here. Okay, so that's how you can use access tokens in Postman to access your protected REST API. And in the next lesson, we will learn about role-based authorization and how to enable it in our REST API. In ASP.NET Core, role-based authorization is a technique that allows you to restrict access to your endpoints based on the specific role that is presented in the access token. So let's see how we can use that. So let's say that we're going to go now into our endpoints class over here, and let's say that we want to restrict access to our map post endpoint, this endpoint over here, so that only administrators or people that belongs into the admin role can get access to this endpoint. Right? So in that case, it's not going to be enough to just say, okay, require authorization. So we do need to specify that specific role. So in order to do that, and let me scroll down a little over here, what you want to do is to define a policy inside this require authorization call. So right here, we're going to say policy, then arrow function, okay? And inside here, we're going to be defining what is going to be the required role. So we're just going to say policy that require role. Okay, and here is where we're going to say, okay, the required role is admin in this case. Okay, so from here on, only requests that present an access token with the admin role will have access to the post endpoint. So let's see how this works. So let's say that we want to just go ahead and run our server, right? .NET Run. And now let's head back into Postman over here, and let's try to go ahead and try to create a brand new game. In this case, it's going to be FIFA 23. Let's try to do this post using the exact same access token as before, which is the one that I have configured right here. Okay, so I'll go ahead and try to do the post. I'll hit send, and notice that this time we are getting a forbidden result right here. This means that whoever got access to this token got successfully authenticated, but is not authorized to get access to the post endpoint because that person does not belong into the admin role. So in order to get a real access token with the proper access, what we're going to do is the following. So let's go back into VS Code, and I'm going to stop my server, and I'm going to clean this. And we're going to be using the same .NET User JWTs tool that we used before, but this time we're going to be doing something slightly different. So .NET user JWTs create, and this time we're going to specify the role that should be included in this access token. So we're going to say role. So I'll hit enter. And now notice that the new access token has been created with the admin role. And in fact, if we just take this token and decode it, which is something that I like to do with all of these tokens to make sure that I understand what's behind them. So let's go to JWT.ms. I'm just going to paste that. Notice that this time we do have our role claim right there. That was not there before. And so now this access token is meant for people that is in the admin role. And so now we can go ahead and use this new token with our API. So let's go back here and let's do .NET run to start our server. And we're going to go back into Postman and we're going to go into authorization, into the token section here. I'm going to delete the previous token. I'm going to paste the brand new token. And then with that same body, I'm going to go ahead and post this request. I'll click on send. And as you can see, this time this was a success. We got our 201 created. So the game got created successfully. So yeah, that's how you can do role-based authorization. And notice that if you go back over here, that role is not really anything else more than a specific claim inside our token, right? It's just one more claim. And so what we're doing here really is just taking advantage of one claim, which is the role, to do this role-based authentication. But really there are many claims that you could use for multiple purposes. So in the next lesson, we'll learn more about this other type of authorization, which is known as claims-based authorization. Like I mentioned in the previous lesson, you can use multiple types of claims to define how to authorize the incoming request. It doesn't have to be just the roles. So let's see how we can use claims-based authorization in our .NET REST API. Now, in order to define the claims that we're going to be requiring in our access tokens, what we're going to do is create what are known as policies, right? These policies are the ones that can group all of the claims or all of the requirements of those access tokens so that I can access our endpoint. Before defining the policies, let's just define the names of these policies in a brand new class. So let's go ahead and create first a directory called, let's say, new folder, authorization. And in authorization, we're going to create a brand new class, new C# class that we're going to name just policies. Okay, and this is going to be a very simple class. Let me convert this and let me remove that. Okay, that all it's going to do is just have a couple of constants. So we're going to make this class as static, and then we're going to declare here public const string read access. Okay, and here you could use really any name, but the one that I'm going to be using here is just read access. Okay, so that's going to be the name for our read access policy, and then we'll declare public const string write access, which is going to be write access. Okay, so that way we can concentrate these policy names over here, and now we can go ahead and actually define the policies. So for that, we are going to go back into our program.cs file over here, and I'm going to collapse this. And here, where we declare add authorization, we are now going to define the policies that are included in this authorization. So for that, we're going to define here options and arrow function, just like that. There. And our first policy is going to be the read policy. To define the policy, what you want to do is the following. Options.add policy. And here you want to specify the name of the policy. So in our case, it's going to be policies read access. And to access this, we'll have to do control dot in policies to select GameStore.api.authorization, our new namespace. And next, you want to specify what exactly is that we're going to be requiring as part of this policy. So for that, we're going to specify a builder object here with an arrow function that will take to the next line. And here we're going to say builder.require claim. And the claim that we're going to require is the scope claim. Right? The scope claim is a standard claim that you usually use to define what kind of access has been granted to the access token. Okay, and so let's go now and define what is going to be the scope. Well, let's define the scope as games read. Okay, so that's how you can define a policy. And just like this, of course, you can define multiple claims and many other things. As you can see, there are a bunch of methods here available to define a bunch of things, but that's going to be good enough for our read policy. And just like this, we're going to be defining one more policy, which is going to be our write policy. So let's just do that over here. So read access, and then we'll do write access, and the scope is going to be games right. And with this in place, we can now go ahead and use these policies in all of our endpoints. So let's go now into Explorer, endpoints, games endpoints. And let's see. Of course, the first endpoint is just anonymous, so we're not going to care about that one. But then we go into our get by ID endpoint over here. So for this one, now instead of just saying required authorization, we're going to specify what policy has to be used for this authorization, for the authorization of this endpoint. So in this case, it's going to be policies.read access. And of course, we have to do control dot here so that we can use GameStore.api.authorization. So now anything defined in the read access policy will be enforced for this specific endpoint here. And just like we did that, we can now go into our post endpoint over here. And if we scroll down a bit, we remember that so far we are requiring that the user has to be an admin. That is role-based authentication. But now we're going to be switching things so that we actually require our brand new write policy. So we're going to be changing this so that it just reads as policies.write access. And then we're going to be doing pretty much the same thing with the other endpoints. So let's go into our put endpoint over here. We're going to define write access, and same thing for delete is going to require write access. And yeah, with that in place, let's now try out our API from Postman and see what we get. So I'm going to run my server. I'll do .NET run. And I'll go back into Postman. We'll be using that same access token that we used in the very first lesson where we were talking about tokens. We should not have just yet that scope that we just defined it, right? So I'll use that, and let's see how that goes for the get by ID endpoint. I'll hit send, and as expected, this is forbidden, right? So it's not granting us access. So we need to create a brand new token that actually includes this additional claim, the scope claim. So now let's go back into VS Code, and I'm going to top this, clean this, and then I'm going to do the following. .NET user JWTs create, and this time we're going to specify --scope, and the scope is going to be, as we know, games read. So that's going to create a JOT with the corresponding read scope. So as you can see here, that got included in this access token, and I'll just verify that very quickly in jwt.ms, come here, paste it, and of course, scope is now included in this token, which is great. So it means that now we can go and .NET run this, and we can go back into Postman and use our new access token over here. And I'm going to remove this, paste a new token in get by ID, hit send. And as you can see, now things are working properly, right? So we are able to get the game because the token is presenting the correct claim. And of course, we could try to do the same thing with a post. And of course, what we're going to find is that it is going to fail because the token that we have configured here is only meant for an admin role right now. So it doesn't really know about our new write policy. So let's actually go back into VS Code over here. And right now, our post endpoint over here is requiring write access. But what we can do is to modify the policy itself so that it not just asks for write access, but also requires the admin role. Right? So you can combine things like that, okay? So if you go back into program.cs, remember that here's where we defined that write access policy. So we're going to expand this policy a little bit more so that we will say dot require role, and that's going to be admin, okay? Which underneath is just going to go ahead and define that we need another claim, which is the role claim that needs to have the admin value. So let's go ahead and try out our brand new access policy that combines the write scope with the admin role and see how that goes. So I'm going to go back into my terminal. And first I'm going to go ahead and try to create a token that only has the admin role. So .NET user JWT create, and this is going to be role admin. Okay, so this one has the admin role. So I'm going to copy that token, and I'm going to .NET run, and I'll go into Postman. And this time, instead of using post, because we already used that, let's go ahead and try out our put endpoint, right? And so for this one, what we're going to do, and I mean, it follows the same write policy, right? And so let's go ahead and update one of our existing games. Let's not do Minecraft this time. Let's actually, well, first, let's paste the access token in the authorization header, bearer token. I'm going to remove that and paste this brand new token. And then for the body, let's go ahead and retrieve one of our other games. So I'll click on send on get all. Okay, and I'm going to retrieve our Street Fighter 2 game over here. I'll copy that into put. I'll paste that over here. And all we're going to do is just rename Street Fighter 2 into Street Fighter 2 Ultra. And then the price is going to be a bit pricey because it's Ultra, so $29.99. And then Like I said, it's going to use the brand new token that we just created, the request for admin role, and I'm going to hit send. By the way, is it ID 1? Let's confirm that. No, Street Fighter 2 is ID 3. So let's go back and put ID 3 here. So let's go ahead and send. I noticed that it doesn't work as expected. It results in a forbidden result, as you can see here. And it makes sense because we do have the admin role in this access token, but we don't have the right scope there. It is not complete. So it is not going to let us in. So let's go back into VS Code. Let's stop this. And let's modify our creation of the token so that it includes both the role and also we'll say scope games right. Okay. So with that, now we have a token that includes both the role and the scope right there. So we're going to be copying this token over here and back in the Postman, I'll do that for the authorization header. I'll remove that and paste the new token. Okay. And then I'll go into, well, we know this is the right body. So I'll just hit send. And of course we should first start our server or things are not going to work. So I'll do .NET run. Okay. So that's going to start the server. And now we can try this again, hit send. And as expected, we got the successful 204 no content. It was a success. And if we go ahead and query our games now, we're going to see that Street Fighter 2 is now Street Fighter 2 Ultra, and it has our brand new price. So it succeeded because the access token includes both of required claims. Right? So yeah, that's how you can use claims-based authorization in your REST API. And one more thing that I like to do here is if you go back into the REST API, let's go back here. As you can see, we once again have kind of too much code specifically for authorization, right, in the program.cs file. And that's one of the things that I keep mentioning that we should not have that much code right. So what we can do to improve this, well, as you guessed, we're going to create another extension method. So let's go back into Explorer and let's go into our authorization dir. We're going to right click, new C# class, and this is going to be authorization extensions. Okay, and let's clean up this a little bit, just like that. And then let's make it static. And this is going to be, let's collapse this for a moment. And then the name of the method is going to be public static. Let's make it return iService collection. And then the name is going to be add game store authorization. And then we're going to be extending iService collection services. Inside this block here, we're just going to bring in what we have right now in program.cs. This whole section here, we're going to bring it over here. But of course, this time we don't use the builder, we just use the service variable that we just received. And in fact, we're going to be just returning also services like that. And with that in place, we can now go back into program.cs. And instead of doing all of this stuff here, we can now just say builder.services.add game store authorization. Just like that. So once again, that keeps our program.cs file fairly clean, right? So that there's not too much stuff here. So that's going to be it for now in terms of security. And in the next module, we will take a look at another very important aspect of REST API development, which is how we use logging to keep track of important events in our application lifecycle. In this module, you will add logging to your REST API so that you can easily troubleshoot issues once your API moves beyond your dev box and into a production environment. By the end of this module, you will have a solid understanding of the following: how logging works in ASP.NET Core applications, how to use the web application logger, how to create loggers via iLogger Factory, how to inject iLogger to write logs anywhere, how to output logs as JSON, how to use structured logging, how to configure log levels, and how to enable HTTP logging. In this lesson, you'll learn how logging works in ASP.NET Core and the different places where you can send logs from your applications. As you probably know, there will be interesting events happening all the time across your application lifecycle. And as an application developer, you want to make sure you log these events so that you can tell what's going on, especially when you need to troubleshoot issues. In ASP.NET Core, anytime your application needs to log any kind of information, it can make use of logger objects, which you'll declare in your code via the iLogger interface. These logger objects are automatically registered for you during your application startup sequence, so you are free to inject them and use them in any of your microservice classes without any additional configuration. You can use the many methods of the logger object to log events with different levels of severity, like informational events, warning events, error events, and many others, according to the needs of your service. By default, these events are sent to your console or terminal, which can tell you exactly what's going on with your application as you run it or debug it in your debug. However, the console is just one of the possible destinations of your logs and is enabled by one of many logging providers called the console logging provider in this case. There are several other logging providers that allow you to send logs to different places. For instance, .NET applications come with other built-in logging providers like the Event Source provider, which can collect ETW events that you can later explore in tools like Purview, and the Event Log provider, which on Windows machines can send logs to the Windows Event Log, which you can later see in the Windows Event Viewer. There are also several third-party logging providers that can send logs to dozens of places, like the SIG provider, which sends logs to the SIG Search and Analysis server, the App Service provider, which sends logs to Azure App Service, and many other providers like Elma.io, Log4net, Nlog, Serilog, and others. In this model, you will learn how to send different kinds of logs to your console, and in a future model, you will see how to send the same logs to Azure App Service. In the next lesson, you will learn how to start sending logs from your program.cs file. Let's start exploring the logging capabilities of our .NET REST API. And to start with, let's go ahead and let's take a closer look at the current logs that we already have running in our REST API. So if I just go back into my terminal, Ctrl J over here, I'm going to collapse this for a moment. I'm just going to go ahead and do .NET run. Okay, and perhaps I'll maximize this so we can see better. As you can see, we already have multiple logs coming out of the REST API, and these are created by the built-in components of the ASP.NET Core application. Now, if we take a closer look at one of these log lines, so for instance, let's focus on this one, you can already see the different classic components of a log line. So each log line is going to have a log level, right? This one here, which in this case is just info for information, but could also be warning, error, or a few others, right? So that's what we know as a log level. Then we have the log category, which in this case says Microsoft.hosting.lifetime. So that's a way to categorize your logs into different groups. And in this case, it's really categorized according to the component that is producing the log. In this case, hosting.lifetime. Then we also have the event ID, this one over here, it says 14, which is just one way that the owners of that component decided to also categorize this specific event inside the hosting lifetime component. And lastly, of course, you have the message, right? Which in this case says, now listening on HTTP localhost 5115. Okay, so you're going to see that most of the logs that you're going to see all over the place have all of those basic components. The cool thing is that you can also create your own logs that follow the same idea, the same conventions, right? So how to do that? So now let's go ahead and get out of this terminal. So let's collapse this and let's actually stop the server and get back to Explorer view. And what we're going to do now, just to get started, is to go into program.cs. And over here, we're just going to add one new line here, just after initialize DB async, saying that, well, you know what? The database is ready. It's ready to go, right? So to do that, all you have to do is just say app.logger. And in this, and logger here, by the way, is the logger that is attached to the web application object, right? You see, this is web application.logger, and it's an object of type iLogger. From that logger object, you can go ahead and get access to a bunch of methods that you can use to log with different levels, right? You can see that we have here log critical, debug, log error, log information, log trace, log warning. So you can choose to what level you want to log. And so in this case, let's just do a simple informational message. So log information. And then here you have a bunch of overloads and different ways to use the method, right? But in this case, let's go for the most basic thing here, which is going to be just to put an event ID and a message. So let's say that we decide that for this message, that database is ready, the event ID is going to be 5. And then the actual message, I guess our overload is this one over here. The message is going to be just the database is ready. And that's it. Just by doing that, we're going to have a brand new log line that's going to show up in our terminal whenever the application starts. So if we now go back to terminal, and I'm going to clean this, I'll do .NET run once again. We should see now that our new log line is right here. Notice this. The database is ready, which again, it has the info log level. It has the GameStore.api log category because we are doing this directly into our program.cs file, right? So it's just inheriting the name of the entire project. And then we have our ID 5, and then we have our message. So that is a fairly simple way that you can start writing logs directly from your program.cs file. Now let's stop this. And then, well, what if you wanted to write logs somewhere else? Like for instance, what if you wanted to write logs inside this initialize DB async method, right, as opposed to outside? So in the next lesson, we'll see how we can do this using what is known as the iLogger factory. So let's see now how we can start writing logs in other places other than in program.cs. So for instance, like we said in the previous lesson, what if we wanted to go inside our initializeDB async method? I'm going to do F12 here to go inside our data extensions. And here we are in initializeDB async, which seems to be a much better place to write our log message because this is the one method dedicated to the actual initialization of the database, right? So how do we do this? Well, in order to actually be able to write logs here, the first thing that we have to do is to request an instance of a logger object that we can use to actually create the logs. And before we can do that, and let me expand this for a moment. Before we can do that, what we have to do is request an instance of another object that implements an interface that is known as iLogger Factory. iLogger Factory is an interface for which you can always request an instance, and from there you can create any logger that you want. So here we're going to say var logger equals, and once again we're going to be using the service provider to request or get required service. We're going to say, okay, so I need to get a required service. What is a service? The service is iLogger Factory. Now that we have the logger factory, we can go ahead and retrieve the actual logger instance. So I'm going to go into the next line here, and I'm going to say dot create logger. Okay, so this is a way to explicitly go ahead and create that logger object that we need. And here, as you can see, we can specify the category name. So you can put really any name here. So in this case, let's say this is going to be our DB initializer. Now we do have the logger object that we can go ahead and use to produce our logs. So now I'm going to go back into run.cs and I'm going to get rid of, actually copy or cut this line. So I'll take it out from program.cs and I'm going to paste it on this other side right here. And instead of using app.logger, I'm going to just use logger. And just by doing that, we should be able to go ahead and produce our log now directly from within initializeDB async. So I'm going to go back into my console. I'm going to clean this. I'll do .NET Run now. And as you can see, now we have our brand new log line over here, which is very similar to what we had before, but the main difference now is that we are presenting them using the DB initializer category. Notice this, DB initializer, right? That's the one that we specified. Because it's custom, we are creating that now via our own logger that was created from the logger factory. So yeah, that's how you can use iLogger when you don't have access directly to it like in program.cs. But the good thing is that there's even an easier way to start writing logs from your different components. So in the next lesson, we'll see how to write logs in a simpler way by using the iLogger interface. In the previous lesson, we learned how to create logger objects by using the iLogger factory. However, there's even an easier way to create these logger objects across your classes by using dependency injection. And you can do that by using the interface known as iLogger. So if you now go into our repositories and let's go into Entity Framework Games repository, okay? So let's say that we want to start writing logs over here, specifically in our create method, right? So we want to create a log anytime a game gets created. So for that, what we're going to do now is to use another logger object, but instead of using or creating it via the logger factory, we're just going to go ahead and inject it directly into our repository class. So here, let's scroll down a bit. Let's go ahead and declare a variable here, variable read only, and this is going to be of type iLogger, and iLogger needs to have a type parameter, and that type parameter is going to be the same name of your class. So in this case, the class is Entity Framework Games repository. We're going to be setting that up right there. And then let's give it a name. So it's going to be just logger. By doing this, you're declaring a logger object whose category is going to be actually the fully qualified name of your class over here. Okay, so that's the purpose of the type parameter over here. Now let's go ahead and inject this into our constructor by doing control dot in logger. And let's select the option that says add parameters to Entity Framework Games repository game store context. I click on that one, and now we have a new parameter in the constructor that receives the logger object, dependency injection, and then it assigns it to the variable logger. So now we can go down into our create async method over here, and we can go ahead and right away just write a log message. So logger dot log information, and here we can go ahead and write a message. So in this case, let's do a little bit of string interpolation to write the following: created game, and then we'll say game.name with price, and we'll say game.price. And don't worry too much about these little information wiggles that we have over here, because we're going to talk about that in a few lessons. There's another way to write this log message, but for now, that's good enough for going ahead and just write this simple log information via the logger object. So let's see how that actually works by testing this via Postman. So let's go back into our terminal here, And before running the service, one thing we're going to need is a brand new access token to be used in our post request in Postman, right? Because it requires authorization. So let me just create that access token quickly. Okay, so it's going to be an access token for the role admin and for scope games.write. Okay, so token right there. I'm going to copy my token. And now let's go ahead and clean this and .NET Run. And then let's go back into Postman over here. And let's go into, here we are in the post request. I have prepared a brand new game for us, which is Forza Horizon 5. And in this case, let's go back into authorization and let me paste my brand new token that I just copied. Okay, so we should be ready to go ahead and post our game. So I'm going to click on send. And the game got created, right? But more importantly, let's see what we have in our logs over here. So as you can see, at the very end, we have our brand new info message over there, which clearly says that, well, created game Forza Horizon 5 with price $59.99. But also notice that the category for this log is GameStore.api, the repository is that Entity Framework Games repository. And that is because, remember that we declared our log, if we go all the way up, we said that iLogger is of type Entity Framework Games repository. So the category that you can see here is the class name, and it translates into the fully qualified name of the class as the category. And also we have event ID 0, as you can see is event ID 0 right there. And that is because when we use the logger over here, we are not specifying any event ID, right? So it just defaults into 0. Yeah, so that's how you can go ahead and very easily start logging messages from your different classes. But one thing that I want to show you is how to present your messages in a slightly different way. So in the next lesson, we'll see how to present our logs in a different way using the JSON logger. What you can see here is the default way of presenting logs using the logger objects in .NET. It's the simple console logger. But it turns to be that there are other ways to present the logs. And one particular way that I want to show you is how to present the logs in JSON format. And so let's now stop our server over here, close that. And then in order to present the logs in a different way, all you have to do is go into program.cs. And what I'm going to do is I'll add a line here just before our app object creation. And I'll just say builder.logging.add.json console. By doing this, I am requesting a different console log formatter for my application, which should output the logs in the form of JSON. So let's run the application and see how the logs look like with this change. So I'm going to open up my terminal over here, and I'm going to clean this. And in fact, I'm going to collapse this so we can see better. And then I'm just going to do .NET Run. And as you can see, and of course it is a bit harder to tell right now, but now each of our log lines are now in the form of JSON. Right? So for instance, you can see one log line right here. This is one log line. Then we have another log line over here, and then yet another one over here. Each of them are presented in JSON format. But like I said, it's a bit hard to tell, but that is okay because there are options that we can apply to this formatter so that we can see things in a much better way. So let me do Ctrl+C to stop this and then collapse this. And now what we're going to do is that in the JSON console call here, we're going to specify options. So here we'll say options. And then we'll open up this section here. And now we can say options.json writer options equals new. And then we can go ahead and inside this, we can go ahead and define that we do want to see the logs in an indented way. So we'll say indented equals true. Okay, so that should go ahead and present the logs in a much nicer way. So let's go back into our terminal here and I'll clean up this and I'll do .NET Run. Let me actually expand the entire terminal here so we can see better. .NET Run. And now, of course, we can see things in a much better way. So if we scroll up a little bit, we're going to see all of our logs over here. And then for instance, so let's look at this log over here. So we have this log with event ID 14, and we have the log level information. We have the category, Microsoft Hosting Lifetime, and we have the message over here. Right? But interestingly, we now also have another element that we were not seeing before, which is the state over here. And so this state pretty much contains the message, but it also contains other things that have been extracted out of that message, right? For instance, here is the address, right? So the address has been taken out of the message. And then we also have the original format over here, right? So notice that original format is kind of the format string that has been used to produce the message that's over here. It says now listening on, and then we have the address. And the address somehow was extracted over here as part of the state. And then the message is the output of that combined string. So that is one capability of the ASP.NET Core logging system that is known actually as structured logging. And this is exactly what I wanted to show you, that you can present the logs in a JSON format. And it's because I also want to show you how you can create structured logs so that your messages can be composed of multiple elements that are going to be part of the state. But since we now have this capability of present logs in JSON format, well, let's stop this lesson over here and let's move on into the next lesson where we're going to learn how to use this very useful feature of .NET logging system, which is known as structured logging. Let's see how to take advantage of the structured logging feature in our .NET REST API. So to start with, let's go ahead and create a brand new game and let's see how it shows up right now before using structured logging. So I'll do Ctrl J and I'm just going to go ahead and do .NET Run. And then I'm going to go into Postman and I have prepared a brand new game here. This is going to be Super Mario Bros. 3. Yeah, so this is the post call, the post request. So let's go ahead and hit on send. So the game has been created, and remember that you have to use the proper authorization and access token over there for this to succeed, which I already have over there. So the game has been created, and then let's go down over here. And here we can see that we do have this message here that says created game Super Mario Bros. 3 with price $39.99. And in the state, as you can see, all we have right now is just a message, and then the original format is the same thing as a message. But the cool thing is that with structured logging, we can actually pull out the important pieces of this log message into the state. And how to do that? Well, let's just stop the application for now and then collapse this, and let's go back into our Entity Framework Games repository. And I'm going to collapse this and let's go down into our create async method. And so in order to use structured logging, all you have to do is, instead of using string interpolation as we're doing right now, we're going to be removing this $sign, remove that. And then in each of these spots where before we were inserting the actual variable, we're just going to put kind of a placeholder, right? Which is going to be the name of the property in the structured log. So in this case, we're just going to type here name. And in the second one, we're just going to leave there price. And then after this, we're going to go ahead and add the actual properties at the very end in the array of parameters, right? So game.name and then game.price. And in fact, if I quickly go back and, this is the way that it should look like, but let me just Control C for a moment so that we can see one other thing that I didn't mention, is that the reason why you have those squiggles here is that because the .NET compiler is alerting you that you should be using actually structured logging as opposed to this approach that we had before with the string interpolation. And that is because, as a message template warning is saying here, they don't like the fact that we are potentially changing these log messages with every new call of log information with these different values. What they want to see is that we just stick to just one template, one single template as it is right now, and then we just add the parameters at the very end. But by doing this, we are able to use structured logging. So let's now see how this changes our messages. So I'll do Ctrl J and I'll clean this, I'll do .NET Run. And then what we're going to do is go back into Postman, and instead of just creating once again another game, what we're going to do first is just delete this existing game, right? And for that, let me just first copy my access token. I'll copy my access token. And then the game that we created, Super Mario Bros. 3, is number 7. So let's go to our delete tab over here. And let's go into authorization, let's go into better token, and let's paste that over here. Okay, we have the new token. And then we said that the game is number 7, so we'll put number 7 here, there, and then I'll hit send. And then the game is deleted now, right? So it's gone. So now let's go back to post, and now we can go ahead and recreate the game. So I'm just going to go ahead and hit on send, and Super Mario Bros. Have been created once again now with ID 8. And now let's take a look at the log message. So notice that the message looks pretty much the same, but now we do have some other properties over here. We have our name right there, and we also have our price. So now name and price have been extracted from the original format, from the format template, which is just now one single template, and then name and price got extracted into the state, and then those we use it to create the final version of the message. And this is important because when you go into production, your production logging system, whichever system you're going to be using for production, will be able to actually pull out these different properties of your state, right? So that you can later query for your log messages, looking for specific values in specific properties of your state as you're using structured logging. If you're not using structured logging and the variables in the values are just hard-coded directly inside the message, you will not be able to make that kind of query. So stored logging becomes very, very useful when you go into a production environment where you can actually want to query for the different values inside each log line. So yeah, that's how you can use structured logging. And before moving on, what we're going to do is just go back to the original way where we were showing the log messages just as a standard simple console. So let me just close this and let's go back into Explorer and into Program.cs over here. And so we will not be using the JSON console anymore because just it's a little bit too verbose for the local environment purposes. So we're going to just go back to that. But we will keep using structured logging, right? It doesn't matter how we render the messages. The important thing is that you should be using structured logging in the right spots. Okay, so now that we have this in place, in the next lesson, we will learn how to configure the different log levels for our application. Let's see how to configure log levels in our ASP.NET Core application. So if you remember, we do have these two files, appsettings.json and appsettings.development.json, right? Which both of them will have this logging section. And this section is actually meant to configure the log levels. So if you go into log level, we're going to see two entries by default here, each of them representing one of the categories for which we want to configure log levels. And so for instance, this line here says that this is going to be the configuration for all of the log entries that have a category that starts with Microsoft.ASP.NET Core. And then the other one here that says default says, so for everything else, you're going to be using this specific configuration. And the value on the right side is the minimum log level that our application is going to be able to present, right? Like in this case, for everything that starts with Microsoft.ASP.NET Core, we are only going to be able to see warning messages or higher. And for everything else, we're going to be able to see information messages or higher. Now, these log levels have kind of a hierarchy, right? So when you specify one level, that immediately either includes or excludes some other set of levels. So what I'm going to do now is just copy and paste just one little section from the Microsoft docs. It's going to look a little bit ugly, but I just want to paste it here to show it to you right here. This is kind of the let me collapse this for a moment. This is kind of the order in which these log levels are set in the hierarchy of levels, right? So by far the most verbose level is the trace level here, which has a value of 0, and that is followed by debug, and then information, and then warning, error, critical, and finally none. So this means that if we set the level at warning, value 3, noting that it's on the left side, so information, debug, and trace, none of those are going to be presented in the logs in the application. But we will be able to see error and critical logs. And I guess none just means really just don't show anything, right? That's just turn off the entire thing. In the same way, if we say that we want to present messages with trace, the minimum level is going to be trace, that means that everything else is going to be shown because all of those are higher in the levels. And let me just undo this and let's see this kind of in action, and let's see how changes here can affect the application logging. And so let me actually go back to Explorer and we will make changes into appsettings.development.json, which is the one that's been used for the development environment, as opposed to the other one, because that's the environment where we're working on right now, right? So I'm going to be closing that other one and let's focus on appsettings.development.json. And so before making changes, let's go ahead and just run the application very briefly. I'll just run it. And let's see what we get by default. So these are the logs that we are getting by default, right? So, and that makes sense. But now what I'm going to do is make a small change in the log levels here so that the default level is not going to be information. It's going to be warning. That means that we are going to be excluding by default all of the informational messages. So let's see, after making that change, I'm going to clean this and I'll do .NET Run once again. Notice that it is not that the application is still being built. I mean, the application is running right now. Right, it's hard to tell, but it is running. But since we set this to warning, no log messages are being printed at all, even when the application is actually running. And I can prove it because I can go back into Postman over here and I can go into our get all call and I click on send and it is able to retrieve. Yeah, as you can see, it can retrieve the games, right? But we don't have any logs here. And that is because our default log level now is warning. And then let me do Control-C here. And then in a similar way, let's say that I want to switch this Microsoft.ASP.NET Core into a much lower level. So I'm going to switch this into trace. That will mean that everything that's related to the Microsoft.ASP.NET Core category is going to be shown off right now. So I'll do this and I'll do .NET Run. And notice that indeed, now we have many more logs going on in our application. Right, and let me actually expand this for a moment and let me Control-C and let's do this once again so that we can see better. Okay, there. So notice we have plenty of logs, so many that they are not fitting in the screen, right? And they are actually coming with debug level. You see, this is debug, 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 debug. So that is kind of a nice way for you to activate much more logging in your application if you want to see more of the internals of how your application is just booting or how different components of ASP.NET Core are working. Yeah, so let me Control-C this and let's minimize this for a moment. Okay, so now let's just stop our server and let's see if we can take care of something that has been bothering me a little bit for a while. And so I'm going to just clean this and let me revert these changes, going back to warning, and this goes back to information. And if we just do .NET Run, what you may have noticed so far is that anytime when we start the application, we are seeing the full set of Entity Framework logs stating that it is pretty much trying to check if we need to run any migrations into our application. And in most cases, there's no need to apply any migrations. So what I'd like to do is to, at the very least, not have to see so many logs about Entity Framework anytime my application starts. Specifically, any of these logs they're just related to the Entity Framework core.database.command category, right? Which they are not really telling me too much. Perhaps I'd like to keep this one here. It's interesting, it's important. The database is already up to date, it says, but really nothing else. So how can we change this so we don't have to see those logs all the time? So let's go ahead and stop the server and let's collapse this. And this time we're actually going to go back into app.settings.json over there. And what we're going to do is just add one more entry over here for the category for which we want to change the log level. So the category, if you go back into the logs once again, is going to be Microsoft Entity Framework Core Database Command. So I'll copy that and I'll paste it over here. And for that category, what we want to set now is that we only want to see warning message, right? So if there's a warning, let's see it. Otherwise, let's just not display anything. So now I'll do Ctrl-J and I'm going to clean up this and I'll do .NET Run. And notice that this time, all we are seeing is just that the no migrations were applied, and then we go right away into our DB initializer and the rest of the Microsoft hosting stuff. This way, our logs look much cleaner. There's no need to see so many logs. And so just like this, you can go ahead and play around with log levels as you need to see either more or less login information for your application. And so in our next lesson, we will learn how to automatically log all requests received by our REST API. One of the things that is going to be very important for you as you move into a production environment is the ability to be able to log each of the requests that are coming into your REST API. And fortunately, there is a built-in feature in ASP.NET Core that allows you to do exactly that. Just log each of the requests. So let's see how to enable that. If you go now into program.cs, the first thing that you want to do here is to, well, enable HTTP logging. And to do that, what you want to do is just take advantage of your web application object here. And I'm going to do it just before map games endpoint. All you have to do is just say app.use HTTP logging. So that's how you enable that feature, so that you can capture and log those requests as they come in. And then the other thing that you want to do is to explicitly configure your log levels so that you can see those logs coming in. Because by default, the log level for those is not really very high. So if you go back into app.settings.json over here, I'll collapse this for a moment. What you want to do is the following. So you will go ahead and add another entry here that says Microsoft.ASP.NET Core.HTTP logging.HTTP logging middleware. And for that one, you want to bump the level into information, or I guess lower the level into information. And with that in place, it should be ready to start logging your incoming requests. So I'll go ahead and open my terminal over here, and I'm going to make this actually bigger so we can see better. And I'll just do .NET Run, start my server. And now I'll go ahead and into Postman, where I have prepared a brand new post request that has a new game here. This is going to be Mario Kart 8 Deluxe. And I'll go ahead and send this post request. So I'll hit on send, game got created. And then let's look at logs. So as you can see over here, now we have a detailed set of logs of this request that just came in, which is very important. So we can see, for instance, that this was a post request with the scheme HTTP. Here is the path of the request. Here is the host that received the request. Here we also have the user agent, which gives us a hint of what was the client that sent the request. And then we have a few other things, like for instance, the content type, the length of the content. And then we also have the authorization header here, which we cannot tell because it is redacted. That makes sense. We don't want to have that logged. A bunch of important things, right? And that is pretty cool. And then if we scroll down, I mean, of course, we have our actual log that says that the game got created. But then we also have logs for the response. So we can see now that we have a status code that was 201, the content type of the response, the date on which the response was sent, and then we also have the location header that was created as part of that response. All of these details are now going to be logged for every single request that you send to your REST API. So if I go back into Postman and I go and do a get call for that brand new game, so it's ID 9, so I'll go back here and I'll do ID 9, hit send, and go back here, we're going to see that now we have the log for that request. You can see that now this is for game 9, right? So this is the get request, and then we have the corresponding response down here. And so this is going to be, I think, super useful for you in production, so that you can tell actual requests are coming into your REST API and what kind of responses each of them got. Now let's go ahead and stop this. And what I'd like to do is just to, well, let's minimize this for a moment. What I'd like to do is to not actually show all of those logs, for at least not for our development environment. It's going to be very useful for production, I think, but for development environment, it's just going to be too much verbose, too many logs. So what I'd like to do is to do something similar to this. Right, so we're going to copy this line, but now we're going to go into app settings.development.json, and we're going to paste that line in our login section, log levels. But instead of using information, we're going to be using none. That means that in development environment, we're not going to be seeing any of those requests coming in or coming out. But in production, since we have the other one, the production one is going to override what we have for development and actually show the logs, right? So if we now go back, do Ctrl J, and let's expand this, and I'll clean this and I'll do .NET run. And if we go and try once again our request for game 9, hit send, go back to the logs, and as you can see, there are no HTTP logging going on here because we are in development environment, but they should show up still in production. And so that is the end of this module. And in the next module, we will learn how to perform error handling and how to use middleware in our .NET REST API. In this module, you will learn how to catch, log, and report errors in your REST API so that you never miss unexpected issues that should get quickly investigated. By the end of this module, you will have a solid understanding of the following: how to catch and log errors in your REST API endpoints, how to return well-formed error responses to clients, how to create middleware components in ASP.NET Core, and how to use the built-in exception handler middleware. In order to learn how to do exception handling in our .NET REST API, I'm going to temporarily introduce a couple of exceptions into our Entity Framework repository, and we'll see in this lesson and in future lessons how to properly handle those exceptions and how to report errors. So let's go now into Repositories, Entity Framework, Games repository. And what we're going to do is just scroll down into our getAllAsync method. And what we'll do is, instead of just returning the list, we're going to say the following: throw new invalid operation exception, and then let's just put some message here. You could put any message really. I'll just say the database connection is closed. Okay, and then I'll collapse this so we can see better. Just like that. I'll do that, and I'm going to put the exact same message in our getAsync method. Of course, there's a small warning here. We're saying that, hey, this line is now unreachable, which makes sense because we are throwing the exception over there. But that is fine. Like I said, this is temporarily, and it's just so that we can see how to deal with these exceptions. So let's now go ahead and run the application and try out the endpoints that will use these two methods and see what we get. So let's just do .NET run in our terminal. Okay, and so let's go back into Postman, and I'm going to go ahead and just invoke my API to get all games. So I'll hit send. And as you can see, we are now getting our exception right here in Postman, right? The return from the API clearly says that, yeah, invalid operation exception, the database connection is closed, and then we have the full stack trace right here, which doesn't really look good, but we'll deal with this in the next lesson. For now, let's go back into our VS Code instance here. And then the other thing that we can see here is that we are getting kind of generic report of the exception over here, right? It says fail, and then we have our exception reported right here. Now this one here is reported by what is known as the developer exception page middleware, right? Which is by default just capturing the exception and just reporting it in the logs. That middleware is exactly the same one that is taking care of reporting the exception also back here as a response to our client. Now, the thing that I don't like about this is that the exception is too generic and it's not allowing us to customize this log a little bit more to add additional information that we can later use to troubleshoot issues. So for instance, perhaps we want to log what is the machine or the host name, and perhaps we want to attach some sort of correlation ID or activity ID so that we can correlate this error with the error back in the client. So let's see how we can capture this exception and log our own error message as opposed to get this random one. Okay, so let me just do Control-C to stop my terminal, and I'll close this. Let's go into our endpoints, games endpoints, okay, over here. And of course, the impacted endpoints right now are these two, right? So these two get endpoints are impacted, and those are the ones that are reporting deceptions right now. So what we're going to do is let's modify our get all endpoint so that we can handle deceptions. So I'm going to, instead of just have these, all of these in kind of one line, I'm going to open and close curly braces here. And I'm going to move this section over here. I'll move this there. Okay, and then we could do return just like this if we wanted to, but what we want to do is to actually handle deception. In this case, what we are going to do is just introduce a try catch block for now, try catch block, right? So in the try section, we are going to go ahead and invoke our repository, and then we are capturing deception. I'm going to remove system here. Let's declare a name for our exception variable right there. And then of course, now we're going to be needing some sort of an instance of a logger so that we can write our custom log. And so ideally in this case, you will go ahead and inject an instance of iLogger, right? That's what you want to use. But the problem with this is that you need to specify some type for this logger. And in this case, we are currently in a static class. So if you just try to do games endpoints, right, for your logger, you're going to find that you cannot quite do that because games endpoints is just a static type. A static types cannot be used as a type of your logger. So because of that, instead of using an iLogger, we're going to be using iLogger factory, right? Just like we did in a few lessons ago. Let's name it logger factory. And with that logger factory, we're going to go ahead and create our logger. Go here and let's say var logger equals logger factory dot create logger. And then let's give it some name. So this is just going to be our games endpoints. And with that in place, we can go ahead and log our message. So we're going to say logger.log error is going to be the right one in this case. So log error. And then the first parameter that you can pass in here is the actual exception. Let me switch overloads. Yeah, I think this is the overload. And so let's pass in our EX variable here so that the exception itself is captured in that log. And then we're going to add our custom message, right? So in this case, we're going to say could not process a request on machine, and here's where we're going to place the machine name. We're going to be using a structured logging like we learned in the previous model so that we get proper log messages. Here we're going to say just machine, and then we're going to put a dot, and perhaps we'll do trace ID, and then we're going to put our trace ID variable there. So now, of course, in the next line, we have to define what are going to be the values for machine and for trace ID. So for machine, what you can do is just environment.machine name. And the trace ID we can get from the activity class. So if you go into the next line, you can say just activity. And then for that one, we'll have to do control dot so that we can use system.diagnostics there. Activity is an interesting class because it will automatically generate both activity IDs and trace IDs for each of your requests, right? So that's a built-in feature of ASP.NET Core. So if you just do activity.current, that represents the current activity that was assigned for the current request automatically by ASP.NET Core. And then you can access trace ID. And that is going to be a unique identifier, like I said, for this one request that came in. The current property here is nullable, right? So it could be null for some reason. In this case, what we're going to do is just put a question mark here, which means that if it is null, well, let it go ahead and just present an empty trace ID because there's no trace ID. But for most cases, it should actually have a value. So in that case, we're going to be taking out that trace ID. Okay, like I said, activity is a very handy class. It's going to always have brand new unique value for trace ID for each of your requests. So now that we have this in place, let's go ahead and run the application and see what we get this time. So I'll do .NET run. And then let's head back to Postman over here, and we're going to go ahead and send another request to our get all endpoint. And of course, we're still getting the same exception on the client, but then back into the server in our console, let's see what we get. So now, as you can see, we are getting our brand new log line over here. That includes everything that we actually care about. So this is for the games endpoints now. As you can see, games endpoints, that's a category we assigned. And then it does have our brand new message, could not process a request on machine Julio desktop. And notice our trace ID. So we have a trace ID right here, which, like I said, is unique for each request. So this is going to be super handy to correlate this error log with the details that in the next lesson we're going to be presenting back into the client. And then, of course, we also have our exception stack trace over here. Now, of course, we still have the other exception, the original one, as you can see here, the one that comes from the developer exception middleware page, which is fine. We're going to be dealing this pretty soon in the next lesson. Yeah, so that's kind of the way that you can go ahead and log your errors in your HTTP APIs. But of course, like I said, this doesn't look good, and this is not going to actually show up for production purposes. This is only for development environment. And so what we should do now is just take a look at what is going to be the experience in a production environment and how we can make it so that it's actually meaningful for our clients. So in the next lesson, we will learn how to return well-formed error responses to our clients. Like we said in the previous lesson, this experience that we have today, where we're returning this entire stack trace back into the client when there's any errors in the server, is not appropriate for production purposes, right? And in fact, it is only going to be shown in your development environment. What we want to do now is to take a quick look at how this would look in production, and then we're going to see how to prepare a proper response that we can send back to clients, either regardless of if you're in development environment or not. Let's head back into Visual Studio Code over here, and what I'm going to do is, just for now, let's go into run.cs, and I'm going to go ahead and comment this one line over here, which is the one where we apply migrations, right? So to update our database, I'm going to comment this for now, and that is because we're going to be switching into what we know as a production environment, and in that environment, we don't have access to the .NET Secret Manager, where we have the connection string so far, and without a connection string, we just cannot connect to SQL Server. And that is fine because we don't need that for this lesson. So we're going to be doing this just for now, and then what we're going to do is just go into properties and then into launch settings.json, and we're going to be focusing in this HTTP profile section over here, right? Because this is where we define a bunch of settings for our development environment, but specifically what we want to do now is to switch from what we know right now as a development environment, which is set, by the way, by this very important variable, ASP.NET Core environment. This is the environment variable that sets the environment for your application. By default, that's going to be just a development environment, but what we want to do now is to switch this from development into production. Right? And by doing that, we are instructing the ASP.NET Core runtime that we need to turn off everything that has to do with just development and actually run this application as a production application. So let's go ahead and run an application with this setting in place. Go ahead and run this, and let's see what we get when we try to invoke our get all endpoint now. So I'm going to go ahead and click on send. And as you can see, as expected, we are getting the 500 internal server error. So that is expected, that's correct. But the problem with this is that we're not getting pretty much anything else. As you can see, the response itself is completely empty. And this is not ideal, specifically in a production environment, because, I mean, it is true that we don't want to reveal the details about the exceptions that we're having in the server side, but we should still provide some sort of hints or some details so that we can correlate with our logs so that we can do proper troubleshooting of the errors, right? So we want to present something here. To do that, let's go back into Visual Studio Code. Okay, let's go back here, let's stop our server, right? And let's head back into our endpoint, right? So we have our games endpoints over here. And as you know, we've been working on this on our get all endpoint, this one over here. And so what we want to do is that instead of returning or just throwing, right? Doing this throw here, we're going to be returning a proper error response. And to do that, let's do return. We're going to do results.problem. So that's how you can return a proper error response. And then I'm going to open up to the next line. And what we want to do here is to provide a few details about this problem, right? So the first thing is going to be a title. We need to provide some kind of user-friendly title here for this error. So this is going to say just, we made a mistake, but we are working on it, right? That's going to be our friendly error back to the client. The next thing that we can specify here is going to be, and let me scroll down this a bit more, our status code, because that's still very important to report back to the client. So status code, and then for this we can use the status codes class. That if you do just dot here, you're going to see that it has plenty of constants for the different status codes that you may want to report back into the client in a RESTful application. And in this case, what we want to use is just status 500 internal server error, which is correct for this kind of error that we're having in the application. And then lastly, we want to specify one more thing, which is known as the extensions. Right, so the extensions is just a dictionary, a key value pair, where you can put pretty much whatever you want, right? So anything that is related to this problem that we're having. For that one, we're going to just define a brand new dictionary of a string and object, and this is going to be, it has to be nullable, like that. And then let's go ahead and open and close over here, so that we can define the one key and value that we're interested in, which is going to be our trace ID, right? So here we're going to define the key as trace ID, and the value is going to be for that same value that we use it when we log the message. So it's going to be this one here, activity current trace ID. We're going to place here, but we will have to also make sure that we do dot to string in this case, because otherwise the trace ID is not going to be serialized properly when converted into JSON returned back to the client, right? So make sure that you use toString over here. Now we are getting this bunch of, red squiggles here. And why is this happening? This is really happening because now we have two branches of returns back to the client, right? So in one branch, we are returning here a list of game DTOs, but in the other branch, we are returning this thing here, which is kind of iResult, right? An iResult type. And so that doesn't match. You cannot return these two types just like that. That doesn't make sense for the compiler. So what you want to do is just make sure that you standardize the results that you're sending back to the client. So for that, what you can do is just update the happy path here so that we don't return the DTOs like that, but we're going to return results that OK, right? And in that OK, we're going to be including our current payload of the DTOs. So now in both cases, we are returning an iResult for OK and then an iResult for problem. So these things have to be of the same type. So yeah, so with that in place, we can go ahead and see how this experience works end to end. So let's do Ctrl J, let's go ahead and .NET run this, and let's go back into Postman. We're going to go ahead and do a send once again and see what we get. So once again, we are getting our 500 internal server error, but this time we are getting our actual exception. As you can see, our friendly exception is right here, where we have the 500 status code that we are returning, and we have our trace ID right there. And now that we have that trace ID over here, we can easily correlate this 1628D. We can correlate that, if we go back into our logs, we can correlate that with the 1628DE that we are reporting right here in our logs. So now when you're in production and you see this log over here, you can ask the client, right? So hey, client, what is the trace ID that you're getting back in your client or in your application? And you can then go back to the logs, correlate to this, and then okay, so the error is because we have this invalid operation exception, the database connection is closed, right? And so that's how you can correlate things later on production. And so, yeah, so that's the experience that we wanted to enable here. And at this point, we're just going to go back and stop the server and let's undo a couple of things, right? Because we're not going to need those for next lessons. Log says that JSON, we're going to revert this production back into development, right? So you're going back into development right here. Let me highlight it. Right here, you should have now back development. And then let's go also into program CS, and we want to uncomment this one line, right? This line here that initializes database. Let's go ahead and uncomment it because we want to re-enable that logic. Okay, so now one thing that is interesting and important here is that if you go back into games endpoints, notice that we have done all of this work to handle deception just for one endpoint, right? So for map get all, but we will still have the errors with the other get endpoint, the get by ID. So we will potentially have to add all of that logic to try catch and report the log exception and report back to the client for this get, and probably want to do something similar for post and for put and for delete, right? So this is going to look a little bit ugly with so much code there for handling deceptions. What I want to do now is to show you another important component of ASP.NET Core, which is known as middleware. So in the next lesson, we'll learn about middleware and what kind of benefits it can bring to your applications. In this lesson, you'll get an introduction to middleware and the ASP.NET Core request pipeline. So what do we mean by middleware in the context of an ASP.NET Core application? Well, middleware is software that's assembled into an app pipeline to handle requests and responses. And in this pipeline, each component can perform work before and after the next component in the pipeline. But what does that mean exactly? Let's take a look. As you know, in ASP.NET Core, you can define endpoints like your getGames endpoint, which can receive requests, process them, perhaps to retrieve a list of games in this example, and then return a response. However, your endpoint is just one piece of what is known as the request pipeline. See, usually when a request comes in, there will be one or more components that can perform some meaningful logic before letting the request reach your endpoint. These components are called middleware, and ASP.NET Core comes with a few ready-to-use middleware that you can enable anytime according to your needs. Once the middleware is ready, it calls the next delegate, which will activate the next component in the pipeline. Now, this component could be your endpoint, or it could be another middleware, which in turn will do some work before invoking the next delegate. The last middleware in the pipeline will invoke your endpoint so it can perform its job. Then, as your endpoint returns expected response, the last middleware in the pipeline gets a chance to do something else, if it needs to, before handing over control to the previous middleware and later return the response back to the client. Also notice that this same pipeline will execute for every request that reaches not just one endpoint, but all endpoints in your ASP.NET Core application. Therefore, a middleware is a very powerful way to centralize cross-cutting logic that would otherwise be duplicated across many places in your application. In the next lesson, you will learn how to write your first ASP.NET Core middleware. Let's see how to define middleware in our ASP.NET Core application. And to test this out, what we're going to do is just to create a very small middleware that is going to measure the time that it takes to complete one of our HTTP requests. So what we're going to do is go now into program.cs, and I'm going to collapse this. And to define our middleware, the simplest way to do this is by using the use method of our app variable that we have over here, which is of type web application. So if you just open a couple of lines here, and I'm going to scroll down this, what we're going to do is the following: app.use, right? And here we can define our middleware. So we're going to say async, and the parameters that we're going to receive here are the context, the HTTP context, and the next delegate. Then we're going to be using an arrow function here, and we're going to get ready to define our body. So here's where we're going to define what to do about this middleware. So like I said, we're going to be measuring the time that a request takes to complete. For that, we're going to be using first a stopwatch object. So stopwatch equals new stopwatch. So like that, we'll have to do control dot here to use system.diagnostics, that one. And then what we're going to do is just start the stopwatch, right? So stopwatch.start. So that's going to start measuring. So it's just going to start counting some time. And then after doing that, we want to go ahead and invoke the next delegate, right? So we're going to say await next, and then we're going to send in our HTTP context, just like that. So at this time, whatever comes after our middleware is going to execute, including, of course, the actual logic of our endpoint. And then when that is complete, the control returns into our middleware. And I'm going to scroll down here. And then we can do stopwatch.stop. And lastly, we're going to use a logger object to go ahead and print out how much time it has elapsed. So let's first capture that elapsed time. So it's going to be elapsed milliseconds is stopwatch.elapsed milliseconds. And then what we can do is just say app.logger.log information. And then we can say, let's see, we're going to print out a few important things about the request. So for instance, we'll print out the request method. So request method, and then the request path. And we'll say request took, and this is going to be elapsed milliseconds. And we'll put ms after that to complete. So request method, request path, request took so many milliseconds to complete. Okay, then we'll do comma, and let's define the other parameters. Let me actually send this to the next line so we can read better. So the next parameter is going to be the actual method, right? So it's going to be context dot request dot method. Next parameter is going to be the request path. So context dot request dot path. And lastly, the actual last milliseconds, which is last milliseconds right there. Okay, so let's close this. And now just by doing that, we have a way to measure any of the requests that are going to come across our request pipeline. And so to see how this works, let's go ahead and put a few breakpoints. So let's put one over here just before invoking the next delegate. And then perhaps let's put another one over here, which is when we are logging the information. So I'm going to go ahead and just hit F5 so that we start a debugging session. So F5, debugging starts. Let's also place a breakpoint in the endpoint itself. So in games endpoints, let's put a breakpoint, let's say over here, which is a place where the actual invocation to retrieve those games is going to happen, right? And with that in place, let's go ahead and hit F5 and see this in action. So hit F5, so our debugger starts. All right, go back into Postman, and I'm going to just go ahead and request a list of games, right? So I'll hit send. And now back in this code, as you can see, we have just hit our first line over here, right? So the middleware has been activated before hitting our endpoint as expected, right? So we have started to capture how much time it's going to take. And then if I just do step over, now we're jumping into games endpoints. So now we're in games endpoints, and we can see that we're just about to retrieve that list of games inside our endpoint. So I'll hit now continue. And then we go back into our middleware where we have captured the elapsed milliseconds, and we are about to just write our log line. So I'll just hit continue. And if we can see this perhaps in the debug console, it is at the very bottom over here, get games request took 34,267 milliseconds to complete. So yeah, it looks like our middleware execution succeeded. And of course, if we go back into Postman, we're going to see that, we still have this error because we are purposefully throwing an error from the repository still. So this is expected, but regardless, the middleware succeeded. And in fact, if we go and try another endpoint, so let's go now into our get by ID endpoint over here, I'll hit send. And once again, the middleware is activated. As you can see, middleware gets activated, right? And that's going to go ahead and invoke our endpoint, and then it will go back into the middleware. But in this case, we didn't get back into our log information line here because that endpoint is throwing an exception that is not being handled by the endpoint itself, right? So we just ended up with the exception right here, right, in the debug console. So we didn't get a chance to do something after the execution of the endpoint, right, of the next delegate. So this is something we should actually fix. So let me stop this and close this, right? So what we're going to do is to improve a little bit our middleware, right, so that we can do something about that exception that is coming in. And just to be clear, remember the game's endpoints, we are doing the try catch in the get all, right? So we are handling the exception, we are not throwing it, we're just returning a problem. But in the other one, the one that we just executed, we're just doing this. So there's no error handling, so the exception just flows back, right? So let's fix this middleware by adding a simple try catch. So just before stopwatch.start, we're going to do try, right? So try catch, and we're going to move these two lines, right? We're going to move them over here, right? Like that. And then where should we put the other lines? Well, actually, we don't want to do an actual catch. What we want to do here is switch into finally, because finally is a place where you can, that is guaranteed to execute regardless of if the try was successful or not. If there's exception or no exception, we always have to fall into the final block. And because of that, this is the perfect place to go ahead and measure the execution of the request. And let me copy this properly. Okay, I'll cut that and paste it right there. Okay, over there. And now we should have a nice way to always measure how much time a request took, regardless of the response result. So this time I'll put, once again, a breakpoint over here, and I'll put my breakpoint over there, and I'll hit F5. Okay, so back into Postman. I'll try this one again. So I'll click send. And here we are, just about to invoke our endpoint inside the middleware. Play. And now we are back into the middleware, right? Because we don't have an endpoint in the endpoint itself, but we're back into the middleware inside the final section, and we're just about to go ahead and report a lapse of milliseconds, right? We should be at the very end over here. Perhaps not completely at the end. Yeah, it is right here. Get game time request took 5,463 milliseconds to complete. And just like this middleware is going to start measuring the request time for every single request that comes across your application. So you don't have to write this logic over and over again. It is centralized in a nice place, and it will always execute. So yeah, so that is working great. But as usual, as you have seen so far in this course, we don't like to have so much code in our program.cs file, right? Even when this is working just fine, there is a slightly better way to define your piece of middleware, and that is by creating your own middleware class. So in the next lesson, we're going to move this code over here into a full class dedicated to measuring the request duration. Let's see now how to create our own middleware class, in this case to measure the time that our requests are taking to complete. So here we're back in program.cs, right? And we have our app.use method that's defining the request delegate for our middleware. So what we're going to do now is just to create this new class to put all this logic over there. For this, let's go ahead and let's go into our GameStore.api directory at the top, right click, new folder. And here we're going to be adding a new middleware directory, just like that. And inside this one, let's right click, new C# class, and let's name this one request timing middleware. Let's go ahead and fix our namespace, make it into a file scope namespace, control dot, remove unnecessary usings. And so for this class, we don't actually have to implement any specific interface. We just have to follow the conventions that have been set by the ASP.NET Core runtime. Here we have to do two things. First thing is to declare a variable that's going to represent the next delegate. So it's going to be private read-only request delegate next. Okay, and let me actually collapse this so we can see better. And then the next variable is going to be private read-only and iLogger, because this is the logger that we're going to be using for logging our messages, right? And this is going to be of type request timing middleware logger. And then what we want to do is to define our constructor, right? So CTOR constructor for our class. And so here we have to introduce both variables, right? So let's see if we can do control dot here, and then add parameters to request timing middleware parameters. Let's pick that one. And let me actually remove parameters from here. And let's do the same thing with logger. So I'm going to do control dot, and then we'll select add parameters to request timing middleware request delegate. Okay, so now we have our constructor, and it is injecting both the next delegate and the logger instance, and it's assigning them to the variables. So now let's scroll down And what we're going to do is to define a new method that has to be named the way that we're going to be naming it just by convention, right? So you have to name it exactly this way so that the ASP.NET Core runtime can acknowledge that this is an actual middleware. So you want to define public async task, and then you're going to call this invoke async, and then this is going to receive our HTTP context, which we're just going to name context. Okay, so now we have our method ready to introduce our middleware logic. And let me scroll down again. So as you might have guessed, here we're just going to copy the code that we have on the other side. So I'm going to copy everything starting with stopwatch all the way to the end of our finally block. I'll copy this over here, and I'm going to paste that in our invoke async method right here. Let's accommodate things. And I'll do control.in stopwatch so we can use system diagnostics. And for the logger, we're not going to use the logger from app. We're going to be using this logger that we defined a moment ago, right? So this logger here, with that, and I'll use that over here, there. And just by doing that, we now have our first middleware class, right? As you can see, there's nothing special about the name of the class. You could name it whatever you want. Nothing special about the constructor. Really, the special thing is going to be our invoke async method. So make sure that you name it exactly like this, and it should be able to receive the HTTP context, and it should be able to also receive the next delegate that you're going to be using to invoke the next piece of middleware or your actual endpoint that comes next. Now, in order to actually use the middleware, we have to do something in program.cs. So let's go back to program.cs. And now what we're going to do is, instead of all of this logic here, right, app.use, we're going to get rid of all of this. And now we can just say app.use middleware. So which middleware? Well, the middleware of type request timing middleware. Of course, to use that one, we have to do control dot here and use the again store.api.middleware namespace. And so, yeah, that's pretty much it. So now with this one line, we're able to configure our middleware that's going to take care of measuring the time of each of our requests. So let's go ahead and let's do Control J, and let's go back into our terminal here. And this time I'm not going to debug this. Let's just go ahead and run it, because we know that debugging should work properly. And so it is running. And then let's go back into Postman, and let's try out our get all call over here. So I'm going to hit send. Okay, so we get the expected error. Back into VS Code, and as you can see at the very end, we are still logging our call, which in this case took 20 milliseconds to complete, and it is coming from our request timing middleware. Perfect, this seems to be working. And if we try the other API, this one here, get by ID, I'll hit send. This one is going to throw an actual error, and then back here we're going to see that once again it successfully measured the time that it took. In this case, it took just 1 millisecond to complete. So that's awesome. And so we could certainly use the same idea of using creating our own middleware to centralize the exceptions that we are currently just capturing directly in the endpoint, right? And so you could do that, but fortunately there is a built-in exception handling middleware in ASP.NET Core that you can use for that exact same purpose. So I did want to show you how to do middleware by yourself if you need to do it, but we might as well just use the built-in stuff that's inside ASP.NET Core. So in the next lesson, we'll see how to centralize all the error handling logic in the built-in exception handling middleware. Like I mentioned in the previous lesson, we could create our own error handling middleware to centralize the way that we are managing exceptions in our application. However, there is a built-in error handling middleware included in ASP.NET Core that we can use for that same purpose. So let's see how to actually take advantage of that one instead. So first thing we're going to do is to create a brand new directory in GameStore API. This one is going to be called error handling. And inside this directory, we're going to create a brand new file, and this is going to be an extension methods class. So it's going to be named error handling extensions. And for this one, we're going to go ahead, just as before, let's go ahead and convert to files called namespace, and let's remove unnecessary usings. So in this one, what you want to do is to define just one method that is the one that is going to be configuring our exception handling middleware. So this method is going to be public static void. And you could give it any name really here. I'm just choosing to name it configure exception handler, right? And this is going to extend. So it's going to extend application builder app. And perhaps I'm going to collapse this for a moment so we can see better. Now, one thing that I forgot is that since this only is going to have extension methods, which are static, the class should also be static, of course. And so now inside the body of this method, we're going to use that app object to actually invoke, right, our terminating middleware, which is going to take care of exception handling. So here we're going to be receiving async context. This is the HTTP context. And then here is where we're going to write our actual logic. Okay, and then let's do this. And next, what we want to do is to define our logger object that we're going to be using for logging either errors or any kind of informational message. So for that, we're going to do the following. So we're going to say logger, and then we're going to be using from the context, from HTTP context, we're going to be requesting request services, right? So you can use this one to get any of the services available in the service container, right? Similar to the service provider. So here you can do get required service, and here we're going to request our iLogger factory, which, as you remember, that's the one that you can use to create loggers on demand. So now we're going to do from that one, we'll say create logger, and here we can give it any name. So let's name this one just error handling. So it's going to be our logger for error handling. And the next thing that we want here is to capture the exception details. So for that, we're going to do the following: var exception details equals, and then once again, we'll go for the HTTP context. So context dot features. And this features object, you can go ahead and say get, and this get will get you this exception handler feature, for which we'll have to do control dot. So we can use Microsoft.ASP.NET Core.Diagnostics, the very first one in the list. Okay, so we can import a namespace, and that's the one that is going to allow us to, in the next line, actually retrieve the exception, if there was an exception. So var exception equals exception details dot error. Now, exception details might be null, right? Because the compiler at this point is not sure if there was an exception or not, but there should be, otherwise it would not invoke our exception handling middleware, right? So in this case, we're just going to do question mark so that we get whatever comes in, right? Either the exception or just a null object. Okay, so let's scroll down this a bit so we can see better. And now we can go ahead and proceed with the actual error handling logic. Now we do have that logic. If you remember, we go back into endpoints, games endpoints. Over here, we do have some logic over here. So we'd like to go ahead and take advantage of as much of this logic as possible. So we're going to grab this line here, right? The one that logs the error. I'm going to copy that line into this place, and I'm just going to paste it over there. So this one is going to log the exception. So let's paste exception over here, right? So we not process a request on machine something with trace ID. And then for activity, we'll do control dot so that we can import system.diagnostics there. And that takes care of logging the error. Now let's keep going down, and I'm going to scroll down like that so that we can also produce those problem details that is a proper response to send back into the client. So for that, let's go back into games endpoints, and I'm going to copy this code right here. Okay, I'm going to copy this code. It's not going to be exactly the same over here. I'm just going to paste it for a moment, just so that we can have it handy here. And let me accommodate things a bit so that they make more sense. But I'm going to comment this because I just want to have it for reference for what we're going to write next. So here we're going to say var problem equals new problem details. Okay, open and close. And then let's see if we are missing a namespace here. So control dot. So using Microsoft.ASP.NET Core.MVC. And let's go ahead and define our problem details object. So first thing is going to be the title. So title equals, and here's our title, of course. Copy the title. And then we have our status is going to be status codes, status 500 internal server error. And lastly, we're going to define our extensions equals, and here we're going to declare just inline the values of what we want to set for those extensions. So let me actually scroll down better. Yeah, there. This is just going to be our trace ID. So let's go ahead and copy our trace ID over here. Okay, and that's going to define our extensions. And with that in place, we can go ahead and remove this commented code there. So we have our problem details now well defined there. And then all we have to do is just keep going down. We can go ahead and say await results dot problem, and then we're going to put our problem object over here, problem, and then you can go ahead and say dot execute async by sending the context object over here, and that's going to go ahead and continue the request pipeline. And so that should be good enough to define our built-in middleware for exception handling. But there's one more, I guess, a cool thing that we can do over here, because we may want to have that stack trace in the response that goes to the client just for developer purposes, right? So just if you're in the developer environment. So to do that, what you can do is the following. We're going to be opening a section here, just after problem, where we're going to be requesting first the environment object, right? So to know if this is in development or is not development, right? So we're going to say context dot request services dot get required service. And so I'll do I host environment. Okay, and now we can say that environment is development, right? So that's a function that you can use to tell if you are in the development environment or not, right? And otherwise you're likely in production. If that is the case, what you can say is, okay, so problem, we're going to be using the detail property of the problem object. Detail is going to be exception and then toString, right? Exception could be nullable, so that's why we have to do the question mark. And then we do toString to get the actual exception in the form of a string. Okay, so notice that this is only going to be appended if it is a development environment. So with that, we have our error handling extension ready. And now we can go ahead and configure it for our request pipeline. So let's go back into Explorer there, and let's go into program.cs over here. And perhaps just before our use middleware method, we're going to say now app.useExceptionHandler. Right, so that's the method that you want to use a built-in exception handling middleware. And then we're going to pass in here the exception handler app, and you can name this variable any other way if you wish to. And then for this one, we're going to say exception handler app dot configure exception handler. Of course, to use this one, we may want to do control dot and use our brand new GameStore.api.errorhandling namespace. And with that in place, we should have a centralized way to do all exception handling across the application. And because of that, we can now go into our games endpoints over here, and we can get rid of this entire try-catch block, right? So we can go ahead and just get rid of this and get rid of all of this stuff and just leave it like that. Still, exception handling should be happening for all endpoints. So now I'm going to go ahead and do Ctrl J, and I'll do .NET Run, and let's see if this is actually working. Okay, so I'll go back into Postman, and I'm going to try out our get all endpoint. So I'll click on send. And as you can see, we are getting now our proper response in the client as expected, not just with expected type, title, and status, but also with this brand new detail section right over here, this detail section that includes the entire exception, which is only going to be reported if we are in a developer environment as I am right now. And this also includes, of course, the trace ID, which is awesome. And then if we go back into the console, let's see what we get. So we have down here, over here, a bit hard to read, but it is here. Error handling, that's our error handling, and it clearly says that could not process a request on machine, and here's the trace ID, and here is the actual exception, including later the entire stack trace. So everything seems to be working properly and as expected. Okay, and if we try the other request, we can try the other request over here for game 9, I'll hit send. Again, we get the same error, and again, it is being logged just fine. Okay, now one thing that I do not like about this is that, as you can see, we do have not just one, we have one exception be reported here, and then the other exception reported down there, right? So we're reporting twice, right? So this is the one that we care about. This is our error handling middleware, but the other one is the built-in exception handling middleware, right, from ASP.NET Core. So because that built-in exception handler is logging already for us, right, by default, besides the other logging that we're doing. So we have two logs. So what we'd like to do is to actually mute the logs that are coming out of the built-in exception handler so that it can use our own handling logic, right, and our logs. So to do that, let's do the following. So let's stop this, and let's go into Ctrl-Shift-E, let's go into abstract.json. And here we're going to define one more login configuration so that we never let the exception handling middleware present any kind of logs. So for that, we're going to be using Microsoft.ASP.NET Core.Exception-Handler middleware. And then for this one, we're going to just say none. So as we saw in the previous model, this is going to just turn off all of the log messages coming out of anything that comes with a category that says Microsoft ASP.NET Core Diagnostics Exception Handling Middleware, right? So if you try this again, so I'm going to do clean this, .NET Run. Okay, so I'm going to go ahead and rerun this. So I'll hit send. Okay, this gets reported, of course. And then if you go back over here, we're going to see that we only have one exception, which is this one over here. Right, so here's exception, but there are no more exceptions coming out of the built-in middleware. And let me collapse this. And if you're curious, right, you want to make sure that these exception details here do not show up in a production environment, right? So let's go back over here and let's switch things a little bit so that we can test the production environment once again. So as you remember, what we did for that was in program.cs, we're going to comment initialize DB async for a moment. And then we go into launch settings.json over here. We're going to change development for production. And just like that, we are in a production environment. So now we can go ahead and run our application, .NET Run. So let's go back into Postman, and I'm not going to actually try this get by ID API at this point because it does require authorization, but let's go actually try out this one over here, which is one that is anonymous, and let's see what we get. So I'm going to go ahead and hit send. And as you can see, those details are gone, right? In the production environment, those errors are not showing up anymore. Okay, so we have a nice way to either show or not show the exceptions depending on the current environment. And anyways, we still always have the proper response back to the client. Okay, and so with that in place, let's just go back into our application and let's go ahead and undo a few things, right? So let's make sure that this is still development, right? So this is development, program.cs, let's make sure we re-enable our initialize DB async. And let's now go back also into repositories, entity framework repositories, and let's remove these things that we don't need anymore. The throw exceptions, right? From get all async and from get async. We don't need those, right? We want the normal behavior now. And yeah, before closing, let's just make sure that those keep working just fine. So I'm going to do .NET Run. Okay, we should be back in the right place. So I'll hit send. And as expected, now we are getting our games just fine. Okay, so that is working properly. Okay, so that is the end of this module, and in the next module we will switch gears to the world of versioning so that we can learn how to properly version our .NET REST API. In this module, you will add versioning to your REST API to ensure you are able to add new features to the API without the risk of breaking your clients. By the end of this module, you will have a solid understanding of the following: why you should use versioning in your REST API, how to use version-specific DTOs, how to implement URL path-based versioning, how to simplify versioning with the API versioning NuGet package, how to implement query string versioning, and how to specify the default API version. In this lesson, you will learn about API versioning and why it is a critical element of any well-defined REST API. To understand the importance of versioning, let's go back to an example we looked at a few modules ago. Here we see our clients requesting the game with ID 1 from a REST API, and as usual, the API returns a JSON response that includes the ID, name, and price of the requested game. We talked about DTOs before and how they will ensure this contract is maintained no matter how our database schema changes. But let's say that we actually need to break this contract because, well, the meaning of one of the fields in the contract is changing. The actual price of the game is now named retail price, and where we had the price before, we will now have the price with a 30% discount. This is not just a business requirement, but an actual feature we want to offer our clients so that they can present the discounted price to potential customers. However, since we have changed the meaning of the price field, we have basically broken all our clients, since it will take time until they can absorb this change and redeploy the clients to all users. Yes, the clients will still work, but the pricing information will be totally wrong. This is where API versioning can really help. What the REST API should do instead is define a version that corresponds to the different contracts it supports. For instance, by supporting the API version argument, the client could specify that it wants to use version 1.0 of the getAllGames endpoint, to which the API will always return the original DTO with the game's full price in the price field. And only when the client is ready to take the new feature, it can specify version 2.0 instead, to which the REST API will respond with the brand new contract. The contracts and behaviors associated to each version should always be honored by the REST API, so the clients will never break unintentionally and they can adapt to changes as they are ready. So, in summary, versioning ensures that clients can rely on services to be stable over time while still enabling service changes and new features. Let's see how to implement versioning in our .NET REST API. The first step towards versioning is using version-specific DTOs, so that we can later use different versions of the DTOs in different versions of our APIs. So let's go ahead and define a second version for one of our DTOs. So let's go back into our DTOs.cs file over here. And the DTO for which we want to create a second version is going to be our game DTO. Okay, and the idea is that in this second version, we are not going to have just the price, right? But we're also going to have a retail price. And later we'll see how that price actually turns into a discounted price as compared to the actual retail price. So to start with, let's go ahead and rename our existing GameDTO so that it has a clear version number, right? So this is now going to be GameDTO V1. So I'm going to do F2 here to properly rename this here and in all places where it is used. So GameDTO V1. Okay, I'll hit enter. That should rename the DTO everywhere we are using it. And now we're going to create a copy of this DTO, and I'll just place it under this guy right there. So this is going to be GameDTO V2. And in this V2, we are going to add after the price a brand new property that is going to be retail price. So with this in place, we now have to go into our extensions class. So under entities, entity extensions, so that we have a corresponding extension method that can use our V2 DTO. So let's collapse this again. And let's start by renaming our existing extension method to, and I'll do F2 here, as DTO B1. Okay, so this is going to convert any of our game entities into the version 1 of our DTO. And then we're going to get a copy of this entire method down here. And this is going to be as DTO V2. And in this one, we're going to be returning GameDTO B2. Right? So GameDTO V2, GameDTO V2. And of course, this one is now going to require not just the price, but also the retail price. So for retail price, and I'm going to just copy this to the next line. For retail price, that stays the same. So it is just the full price. But for the actual price, this is going to be the discounted price. So for that, we're going to say game.price minus game.price times 0.3M so that we get a 30% discount. So now price, discounted version of the price, while this other line is for the retail price, which is the full price. Okay, so that's the difference between our GameDTO V2 and GameDTO V1. Okay, so now let's go back into games endpoints to make sure that we are using the right version of our contracts. So let's go back into endpoints, games endpoints over here. And so for our map get method, this one over here, as we did already the refactoring, so this is correctly returning as DTO V1, so that's correct. And then in our other endpoint, the get by ID endpoint, we are also getting as DTO V1. So this is all correct. What we can do now is just to verify that things are working properly, right? Which they should, but let's just double check. So .NET Run, the application starts. Let's go to Postman here, and I'm just going to test my get all games endpoint. I'll hit send. And as expected, we are getting our games. Each of them have their price, and there are really no changes at this point, right? We are preparing a V2 version of the DTO, but we still only have a 1M.4 version 1. So in the next lesson, we will learn how to introduce URL path-based versioning to our REST API. Let's now see how to introduce URL path-based versioning into our .NET REST API. So the first thing that we're going to do is go down into the place where we declare our route group, this section over here. And what we want to do now is to define two groups, one group for version 1 and one group for version 2. So this group here is going to be, let's name it with F2, B1 group. Okay, so this is B1 group now. And the path that's going to be associated to this B1 group is going to be /B1. Okay, because this is version 1 of our API, and therefore we have to specify the version as the prefix right there. And since we can now have this B1 over there, we can also specify our second group. So I'm going to just copy that, paste it here like that, and this is going to be our B2 group, right? So B2 group. And this, as you expect, is going to start with /B2, and then it goes to /games. So everything that goes under B1 games is at the first version of our API, and everything that goes under B2 games is going to be the second version of our API. And with that in place, what we want to do now is to specify a second version of both our getAll endpoint and our getById endpoint over here. Okay, but before we can do that, let's go ahead and also define two constants here for the getGame endpoint name, because now we're going to have two. This first one is going to be getGame B1 endpoint name. Okay, and this is going to be getGame B1. And then we're going to say this is getGame V2 endpoint name. And so this is getGame B2. And with that ready, if we scroll down, we're going to see that our map get by ID is using, of course, getGame B1 endpoint name. So that's correct. And now we want to define version 2 of our endpoints, right? So what I'm going to do is just copy these two endpoints, copy these two, and redefine them down here, right? This is going to be version 2. So perhaps I'm going to put here, just so that it is clearer, B1 get endpoints Okay, and then down here is where our v2 get endpoints start. Okay, we're not going to be doing anything about our post, update, or delete endpoints, so those just stay as they are right now, but we will come up with version 2 of our get endpoint. So for that, we're going to change this v1 group declaration here so that it is v2 group for that endpoint and for this other endpoint, v2 group and v2 group. And then both of them have to use over here where it says asDTO v1, it has to change into asDTO v2. Right, so right there, and also here in line 45 asDTO v2. And lastly, the with name call over here should be for get game v2 endpoint name. That's going to make sure that this matches the v2 version of our endpoint. So with that in place, we should be able to go ahead and try out both first version and second version of our get endpoints. So I'm going to do Ctrl J and I'll do .NET Run here. And now let's go into Postman. And so this time, in order to retrieve our games, we can no longer just use this route over here, because if we just try it, it's not going to work. It is not there anymore. Now we have to start using the proper version. So this is going to be v1/games. So if you try that, hit send, what we're going to get is what we got before, right? So just the standard price in the price element there for all of our games. So that is working properly. But now we want to get version 2 of our games. So all we have to do now is just switch that v1 to v2, right? And if we say hit send, notice that now we are going to get both the price and the retail price. And our retail price is the real price, I mean the full price, of course, and then the price is the discounted version, 30% discount of this retail price, which satisfies the requirement for our version 2. And same way as we did with this, we can do the same thing with the other endpoint, get by ID. If we just go and do /v1 games and game9, hit send, and that's going to return our game9 for version 1, and with v2 is going to return v2 of the endpoint. As you can see, it has price and retail price. That's the right way to define versioning, and that's going to allow us, our clients, to gradually move into the next version without having to break them at any given point. And this is one way to do versioning, of course, and there are other ways to do versioning, but before we look at this other way, what I'd like to do in the next lesson is to show you a popular NuGet package that will allow us to introduce more powerful versioning features. Let's see now how to use the existing ASP.NET API versioning NuGet package to open up the door for more powerful versioning features in the future. So for this, the first thing we have to do, of course, is to add a package reference to this NuGet package. So I'm going to open up my terminal over here, and remember that I am in the directory of GameStore.api. And I'm going to say .NET add package, and the name of this package is asp.versioning.http. Okay, and with that added, what you should see in your GameStore.api CS proc is the following. Let me show you. Yeah, exactly the first line over there. Package reference, this is what you should be seeing over there. And so that included support. Now we can go back into Program CS. And the first thing is going to be to add the services into the service container that are required to enable the features of this NuGet package. So let's do that just after our call to add GameStore authorization. We're going to do builder.services.add API versioning. Okay, that's the method that is enabled by that NuGet package. So that enables all of those services for versioning. And what we can do now is go back into our endpoints, games endpoints over here. I'm going to collapse this section. And here we're going to do a few things. Let's scroll down into the start of our map games endpoints method. And one cool thing about this package is that we don't actually have to use multiple groups like we have been doing before for our different versions. We can just have one group and define all of the versions that are supported by that group. And then we will associate each of our endpoints with the corresponding group. So instead of having this as v1 group, we'll say that this is just once again group, right? So this is the group. And so what we're going to do now is let's just move this to the next line. Instead of just calling map group directly, we're going to say routes.new version API. Okay, so that's the initial point for you to start taking advantage of the versioning NuGet package. And after that, we're going to do, as usual, map group. But this time we're going to be using kind of convention of specifying here instead of the, v and the 1, we're going to open and close curly braces. And inside those curly braces, we're going to say version API version. Okay, so this is kind of a placeholder that is going to place there whichever version corresponds to the endpoint that we are invoking. And after that, we're going to go in the next line, we're going to say, okay, which versions are supported by this group. And so that's going to be has API version, and we're going to say 1.0. And then we're also going to say has API version 2.0. And then we'll keep our with parameter validation call just like it was before. So with that in place, what we can do now is the following. Now, of course, we don't need this v2 group anymore, so I'm going to remove that. And then here we're going back into our v1 group. We'll just switch this into group map get. But at the very end of the declaration of this map get, we're going to add one, or we're going to chain one more call at the end that says map to API version, and that version is going to be, in this case, version 1.0, okay, which makes sense because this is the endpoint for version 1.0. And then we're going to follow the same idea with the other one, right? So this is just group, and then it has to map to version 1. We're going to put that at the very end over there. And now, as you might have guessed, in the next set of endpoints, we're going to do something similar, right? So this is now group and then map to API version, but this is going to be for version 2, so version 2.0. Right, and same idea with this one here, group, and then at the very end, we're going to say that it maps to version 2.0. And then we'll keep going with version 1.0 for the other endpoints, right? So we said that map post is going to stay in version 1, so group, and then we'll go and do this, and then we'll go into our put endpoint, turn it into group, and then we go all the way to the end and define that this is map to API version 1.0, and same thing with delete. Okay, just like this. And then we return the one group there. And that should be pretty much it, right? So if everything is working properly, and we're going to just rerun the application, .NET run, everything should be working just as before, no changes really, but we are now using this, as you can see, very nice NuGet package. So let's go back into Postman over here, and then we're going to try out, let's start with our get by ID with version 2 in this case. I'll hit send. And as you can see, we are getting our Mario Kart 8 Deluxe game with version 2. It has price and retail price, right? So this is correct. And if we wanted version 1, we can switch to V1, hit send, and we now only have price. So this is correct. We go back into get all for version 2, hit send, same idea, we have price and retail price, and with version 1 we should get what we expect, right? So just the price. So the behavior is the same, but now we have this new NuGet package, which, as you can see, helped us to simplify a little bit how we use versioning in the API, and it's also going to open the door for a few other features that you can use in the future. So what I want to show you now in the next lesson is how to use another fairly popular type of versioning that is known as query string versioning. So let's go to the next lesson. Let's see how to use a different kind of versioning that is known as query string versioning. And the idea is that the version is now going to be in the query string, as the name says, as opposed to be in the URL path. So as if we are using the API versioning NuGet package, this is going to be fairly trivial to implement. So here we're back in games endpoints.cs. And before I forget, let's go ahead and clean up our namespaces here because we have more than needed. Just like that. And then let's scroll down into our map games endpoints method. And the cool thing about query string versioning is that it is actually the default type of versioning that this package supports. And to use it, all you have to do is actually not do anything special. So what we're going to do is just remove this from the path because we are not going to have the version in the URL path anymore, right? So we're going to remove that and we'll just stick to /games as we had it at the beginning. And believe it or not, everything else stays the same. And because each of our endpoints now knows what exact DTO to return and what version they map to, right? So this one's mapped to version 1, this one's mapped to version 2 over here. And so they all already know what to do. So all we're doing is just changing the type of version that we're doing over here. So with that in place, let's go ahead and test this out and see how that goes. So I'll do .NET run. Let's go back into Postman. And this time, instead of specifying the version over here, we're going to remove this. So it is /games for our get all games endpoint. But now you have to say the following: API version equals 1.0. That's how you specify the version now in the query string. And with that in place, you can go ahead and hit send. And once again, you're going to get the version 1 of our games, right? Notice that it only has the price. And if you wanted to use version 2, all you have to do is just switch to version 2.0. Hit send, and notice that now you're getting price and retail price. So that's all you have to do. And in a few ways, this is I think this is a kind of a better option because it doesn't require you to play too much with the URL path itself, which can be a bit problematic. And instead, you can just append the version right there whenever needed. And in fact, you can also specify what's going to be the default version for your API so that you don't even have to work too much with the query string itself. Talking about that, in the next lesson, we'll see how to specify a default API version when no version has been specified. One convention of many REST APIs is to allow for default API version when no version has been specified, right? That can be very handy also for migrating clients into a REST API that did not specify any version before, but now it does have versioning. So let's see how to make that work. To start with, let's see what happens in the following scenario. So let me go ahead and do .NET Run, and I'm going to go into Postman over here. And we are in our get all endpoint, and let's see what happens if I don't actually specify the API version at all at this point, right? So just like that, /games. So I'm going to hit send, and as you can see, we are getting a bad request over here, and that is because we are not really specifying the version, right? So it is not able to match any version. So what we want to do now is to specify that default version. So let's go back into VS Code, and to do that, what we can do is just go back into Program CS over here. And see, we're here. Let's go ahead and clean up these namespaces. I'll do control dot, remove necessary usings. So that's clean now. And let's go scroll down a bit into our call to add API versioning right here, line 12. To configure the versioning and the default version, what we want to do is say here, options, right? So we open this Lambda here. And here we're going to say just options dot, what is going to be the default API version, right? So our default API version is going to be new API version is going to be 1.0. And I think actually 1.0 is the default version already, so you may not need to specify this explicitly, but let's be explicit. I think it doesn't hurt. It doesn't hurt at all. The next option is going to be options dot assume default version when unspecified. So this is what is going to actually enable the API to revert back into the default version when no version has been specified. So this is going to be equals to true. And just by doing that, now our REST API supports a default API version, which is going to be version 1.0. So if you go back into starting our server and going back into Postman, let's try this once again with no version specified, hit send. And as you can see, we are getting our games just fine, and they are in version 1. As you can see, price is $9.99. It means that we are in version 1. Same idea with our other endpoint over here, which it was using the URL path versioning. We're going to remove this so that we don't specify any version at all as in the beginning. I'll hit send, and this is working properly, as you can see. And of course, there are many other features that you could use with versioning and with this NuGet package, but I think that's good enough for now. Hopefully you get a good idea of how to do versioning in your .NET REST API. So for now, in the next module, we will start diving into the challenges of integrating our REST API with a modern UI client. In this module, you will integrate the included Game Store client with your REST API, and you'll learn how to configure CORS to properly enable this integration. By the end of this module, you will have a solid understanding of the following: how to run the Game Store client, what is CORS, and how to configure CORS to allow the client to access your REST API. It's time to integrate our .NET REST API with an actual client application so that we can see what kind of challenges we find along the way. So for this, I have prepared a small front-end Blazor application that is ready to go. You don't have to code it. So all you have to do is just download it. It's going to be a zip attached to this lesson named GameStore.client. So please download that zip into your box and extract the contents and just place them next to your GameStore directory. So as you can see, I have done the same thing over here. Here is my GameStore directory where I have the REST API, and here is my GameStore.client application as it is extracted in my box. And so this is a new VS Code window where I'm going to be opening that directory. To open that, what I'm going to do is just say code, and then I'll do GameStore.client, right? So that we open in that directory, and then I'll do -r so that we can reuse this Visual Studio Code window into that new directory. So I'm going to go ahead and hit enter. And as soon as you open this directory, you may get this couple of warnings. The first one is to start debugging and to install the extension to debug Blazor applications. You may or may not want to install it. I'm going to install it, but it's not required, so it's really optional. And the other one is just to restore dependencies. So I'm also going to click on that one so that we restore all of the NuGet packages that are needed for this Blazor application. And so I'm going to close this. And like I said, there's this extension here. This is going to be used for debugging the Blazor application, but you don't really have to do that. That's really optional. And so I'm just going to close that. And then we're not going to be exploring really the code of this application. My intention here is just so that you just configure it so that it can start talking to your REST API, and then you see how the REST API react to it, so you can see things working end to end. Now, in order to get this Blazor client to actually talk to your REST API, you just have to change one configuration, and that's going to be found in this directory, www root. So go ahead and expand that and go into your app settings.json file, this one over here. So let's open that one there. And here you're going to find that there is one setting called Game Store API URL, this one over here. And so for that one, we need to place the URL of your REST API as it is in your box, right? And where do we get that URL from? So just go back into your other Business Studio Code instance where you have the actual REST API. And here you can go always into properties, launch settings.json. And if you look into your HTTP profile, that's always going to be located over here, application URL, right? So just go ahead and copy the URL. I'm going to copy that, and then I'm going to go back into my other VS Code instance for the client, and I'm going to paste that over here. And so with that, let's go ahead and start both our APIs. So I'm going to go back into my API over here. I'm going to close that, and I'm going to do .NET run in GameStore.api, so the API gets going. And let's go back to the client and also go ahead and open our terminal here. I'll do .NET run at the very root. That's all you have to do. Just do .NET run. This is going to compile your Blazor application, and it should go ahead and start it. Now, as you can see, our Blazor application also got its own URL right there. It's localhost 5259. So what you want to do is just copy that URL or just click on it and then open a browser like I have over here. Paste a URL, and that should load your Blazor application. So I'm going to do that. And here is a Blazor application. But of course, as you can see, right away, we are hitting a bit of a problem. As you can see down here, there is a bit of a problem. It's asking not to reload. So, well, what is going on here? The best way to understand what's going on in this case is to actually open the developer tools of the browser. That should light up what is the problem. So for that, just press the F12 key in your keyboard, F12. And that's going to open up your developer tools. And as you can see, on the right here, there is something going on here that doesn't look great. And if we scroll down a bit, you're going to find this one problem right here. Okay. So this problem, which says, well, access to fetch at the location of your REST API from the origin of your Blazor client has been blocked by CORS policy. And so no access control allow origin header is present on the requested resource. So what does that mean? So this is a very common CORS error. It is something that you need to understand, and it's very common when people try to integrate a client application with a REST API. So in the next lesson, we're going to be learning about CORS and how to deal with this kind of problem. In this lesson, you will learn about cross-origin resource sharing, also known as CORS, what problem it solves, and how it can help us enable the communication between our frontend and backend. To understand CORS, let's first understand what a cross-origin request is. Let's imagine that the web server that is hosting our frontend is also the server that hosts the backend that provides data support for the frontend. In this scenario, the browser initially navigates to the web server URL to load the frontend, which needs to render some games data. The browser makes a GET request to the backend REST API to the same web server URL, to which the server will reply with the JSON representation of the game's data. The address from which the browser calls the backend is known as the origin, and is made of the combination of protocol, host, and port, which in this example is HTTP localhost 5000. Notice how the origin in the browser matches exactly the origin of the backend server. Let's now move our backend to a different web server with a different address. Now, when the games page needs to get rendered, the browser makes the GET request to the backend at localhost 5007, a different origin. Since the port of the backend is different than the one in the browser, this is known as a cross-origin request. The backend will return the game's data just as before, but by now, the browser knows that this response comes from a different origin, since it had set the origin header in the request. Therefore, it rejects the response data with a CORS error. This happens because browsers follow what is known as the same origin policy, which states that a web application can only request resources from the same origin the application was loaded from. Browsers enforce this to prevent malicious websites from reading confidential information from other websites. Unfortunately, this is also preventing our front end from reaching the game's backend. So how can we fix this? Here's where CORS can help. CORS allows a server to indicate any other origins than its own from which a browser should permit loading of resources. Here's how it works. Once again, the browser has been asked to load games information in the frontend. The browser sends a GET request to the backend's REST API, and since the backend is hosted in a different origin, the browser appends the origin header. The difference this time is that the REST API has been configured with the access control allow origin header, which indicates all the other origins that are allowed to call the REST API. In this case, this header has been configured with the origin where the front end is hosted, HTTP localhost 5000. Once the REST API sends the game's data back to the browser, it appends this header to the response. The browser now compares the value in the origin header it sent to the value in the received access control allow origin header. Since they match, the browser now allows the response data to reach the frontend. This works for simple requests like GET, but for POST, PUT, and other methods, things work a little bit differently. When a cross-origin request may perform some sort of write operation to the resources owned by the server, like is the case when performing a POST, PUT, or delete request, the request needs to be first pre-flighted. This means that an additional initial request needs to be sent to the server to determine if the actual request is safe to send. Going back to our scenario, imagine we now want to create a new game in the game's catalog, and therefore our front end will send a POST request to the REST API. However, since this is a POST of JSON data across origins, the browser automatically sends first a request with the options method, this time not just adding the origin header, but also two other headers called access control request headers and access control request method. Access control request method indicates that when the actual request is sent, it will be a POST, and access control request headers tells the server that the request will come with a content type header in this case. The server should have been configured to respond with corresponding headers to indicate what it allows. The headers returned by the server are access control allow origin, access control allow headers, and access control allow methods. If the values returned in these headers match the values in the headers sent in the request, the browser accepts the POST request and submits the original request to the server with the JSON payload of the new resource to create. The REST API creates the game and returns expected 201 status code. As you can see, the key to a successful cross-origin request is in the appropriate course configuration on the backend that exposes the REST API, since only the backend can declare the allowed origins. How do we properly configure cores in ASP.NET Core? Well, that's the focus of the next lesson, where we will add the missing course configuration for our Game Store REST API. Let's see how to configure cores in our REST API. So the first thing we're going to do is go into our app settings.json file over here, and we're going to be defining one more setting here that states what's going to be the allowed origin. So what is the URL of our Blazor client that our REST API needs to allow? So we're going to go ahead and say here allowed origin. And so here the value has to be the URL of the Blazor client. So if you go back into our browser over here, we can see that the URL is right there at the very top. It's localhost 5259. So I'm going to just copy that, and this is going to be HTTP localhost 5259, just like this. And with that in place, we can now go into our program.cs file over here, and I'm going to collapse this. And let's go scroll down a bit, and we're going to go just under our add API versioning call. Perhaps we're going to add one more line here. I'm going to open another line, and this is going to be builder.services.add_cores. Okay, add cores is the one method that's going to take care of adding all of the services to the service container that are needed for cores. So on this one, what you want to do is pass some options. All right, so we're going to be defining a delegate here, and we will use these options to define what is known as the cores policy. Right, the cores policy is what really defines how you're going to be treating all of those cross-origin requests. And so to do that, we're going to be doing options.add default policy. So we are going to be just adding a default policy that's going to apply for every single request that comes in. So this is going to be the policy. And for this policy, we're going to be receiving a course builder object. That is also going to be another delegate over here. And now we can use that course builder to actually configure cores. Now the first thing to do here, and let me actually send this to the next line. First thing to do is to retrieve that allowed origin that we defined over there, retrieve it into program.cs here. So to do that, what we're going to do is just say var allowed origin equals builder.configuration, and then let's go ahead and put over here the name of that setting. So I'm going to copy allowed origin into here, right there. And with that, we can now say course builder, and then we have to invoke a few methods here. The first one is going to be with origins, right? So this defines what are going to be those allowed origins. So of course, here we're going to just say allowed origin. Now we are getting this warning over here because allowed origin might be null, right? Configuration might return a null value if we cannot actually find the value in settings. Because of that, we're going to do the following. We're going to say that if that is null, and we're going to be using this operator for that. So if that is null, the alternative is going to be to just throw an exception, because that value should always be there. And if it's not there, we do want to get an exception. So throw new, and it's going to be an invalid operation exception. Could really be any other exception, it doesn't really matter. I just think invalid operation kind of makes sense for this case. And so let's just say allowed origin is not set. All All right, and I'm going to send this to the next line so that we can see better. So I'm going to put it there. So we try to get the allowed origin, and if it's not there, if it's null, we're going to throw an exception. So that makes sure that allowed origin always has to have a value. So that's the first thing. So we allow that origin, but we also have to specify which headers and which methods we're going to be allowing. So for that, what you want to do is just say dot, and then you could specify very specific headers and methods. But for our case, we're just going to say allow any header, and then we're going to say allow any method. Okay, so it doesn't matter which headers or methods the browser is requesting, all of them will be allowed. So that is how you configure your course policy, just like this. And then the next thing to do is to make sure that the request pipeline is actually using the course middleware. So for that, we're going to scroll down a bit down here, perhaps just between map-gains endpoints and app run, we're going to just say app.use course. Let's just leave it like there. Okay, use course. So that enables the course middleware that is needed in the pipeline to make sure that we can process those course settings. And with this in place, we should be ready to go ahead and try out our portal with our REST API once again, and things should work. So let's do Ctrl-J, and I'm going to do .NET Run once again on my server. Okay, so REST API is up and running, and let's go back into our client over here, which I already started, right? I already started if you have not. So make sure you do .NET Run. So this restarts our Blazor client. So I'm going to go back into my browser, which still has this course error over there. But this time I'm going to go ahead and refresh this. And as you can see, and I'm going to close this now. Now we can actually see our games being listed into the Blazor client. Right? There's no more course error. And in fact, if we do F12 once again, and if we go into the network tab, we can see the actual requests that are going out. So I'm going to actually refresh this so we can actually see requests. So I'm going to refresh the page. And if you find the right request, so let's go ahead and look for this one that says games page number, right? So this one right here, this is going to be the request that goes into the server. Click on that one. And I wonder if we can make this smaller. Yeah, just like that. Here you can see the actual headers that are being used. So for instance, you can see here, access control allowed origin is right here. So that's the URL of the browser. And then if we scroll down, here is the origin, right? So this origin has to match the access control allowed origin that has been configured in the REST API. Since both headers are matching, that is why we're able to load our browser successfully with the data from the REST API, right? So yeah, so here, this is the client. This is kind of the idea of the application, right? We don't see any images just yet for the game because we don't have that functionality just yet. We just have those placeholders. But as you can see the name of each game, you can see the genre, the price, and the date that each game was released, right? There's a bunch of functionality here that's still not enabled. And so that's going to be our work as we move forward into the next lessons to see how to start enabling things like how do we do the search over here? How do we enable login on the right side? How to enable pagination and a few other things, right? So we're going to be working on all of these things. But for now, in the next lesson, we will refactor the course configuration into a new extension method so that we just don't have so much code in our program.cs file. In the previous lesson, we added all of these lines over here to add the course configuration into our REST API. So in this lesson, all we're going to do is just refactor this out into another extension method class so that we don't have to have so much code in our problem.cs file. So for that, we're going to be creating a brand new directory under GameStore.api. Let's right click and create a folder that's going to be called course. And in this one, let's go ahead and create a brand new C# class that we're going to name course extensions. And for this one, as usual, let's go ahead and clean up our namespace, doing convert to file scope namespace, and let's clean up our unnecessary usings. And so in this class, and by the way, we have to make it static. The first thing to do is going to be to declare the setting or the name of the setting that we use to retrieve that course configuration. So let's go ahead and declare private const string allowed origin setting. And this is going to be, as you know, in app.settings.json, the name is allowed origin, right? So let's copy that and let's put that over here. Okay, that way we don't have to hardcode that value directly in the code that we're going to be writing right now. Okay, next, and let me collapse this. Next, we're going to go ahead and declare our extension method. So let's declare public static, and this is going to return iService collection. Then the name is add game store course. Okay, this receives two parameters. The first one is the one that we're going to be extending. We're going to be extending iService collection, name services. And then the next one is iConfiguration configuration. Okay, let me send this to the next line so we can see better, like that. And now all we have to do really is just to bring in that code that we had over here. So I'm going to be copying this code down here. Okay, and of course this time we're not going to be going from the builder, but just from services. So we're going to say return services that add course, and then instead of builder configuration, we're just going to be using configuration, and then we're going to be placing here our allowed origin setting. Okay, and with that we should be pretty much done with our brand new method, right? So which now encapsulates everything that has related with course. So now we can go into program.cs, and instead of writing all of this stuff, what we can do is just say builder.services.add game store course, right? And for that we'll have to do control dot and use gamestore.api.course. The one parameter we're going to need here is the configuration object. So we're going to say builder.configuration. And yeah, that's pretty much it. Let's verify that things are working properly. So we'll do .NET Run here. And I already have my client, Blazor client up and running. So I'm going to go ahead and go back here. I'm just going to refresh this. And if things are working, yeah, the games are loading just fine. No issues. It's all loading. So yeah, that's the end of this lesson, and that's the end of this model. We have course properly configured now. And in the next lesson, what we want to do is to start looking into how do we enable proper authentication into our client so that our users can get identified in the client, and then we can make calls back into the REST API so that we can actually modify games in the client. Notice that there's no way to actually do any kind of modifications, edits or deletes or updates, anything like that, or even creating games is not possible here. And that's because our users are not identified in the client. In the next model, we will go ahead and configure an identity provider that we can use to identify users in our client application. In this model, you will learn how to configure Auth0 so that it can act as the identity provider for your ASP.NET Core application. By the end of this model, you will have a solid understanding of the following. What are OAuth2 and OpenID Connect? How to define an API in Auth0? How to define users and roles in Auth0? And how to create a client application in Auth0. In this lesson, we'll learn about the OAuth2 protocol, how it works, and why it should become the basis of your REST API authorization strategy. Let's start with the standard definition of OAuth2. OAuth2 is the industry standard protocol for authorization, allowing a website or application to access resources hosted by other web apps on behalf of a user. In essence, it is a security standard where you give one application permission to access your data in another application. The framework that describes OAuth2 was released in 2012 and as of today has been adopted by dozens of service providers of all sizes. Let's see how it works. There are multiple authorization flows supported by OAuth2, but here we will focus only in the recommended flow for single-page applications and native clients, which are the ones our REST API will integrate with during this course. Let's first understand which are the participants in an OAuth2 authorization flow. The resource owner is the person or entity that owns a resource. This would be any user that wants to manage the games catalog in our case. The resource server is the server or service that hosts the protected resources owned by the resource owner. In our case, this would be our REST API. The client is the application that wants access to perform actions on protected resources on behalf of the resource owner. This would be our game store portal. And the authorization server is the server capable of authorizing the client to get access to the protected resources after authenticating the resource owner. This will be the Auth0 service in our case. The flow starts when the resource owner uses the client to initiate an authorization request to perform some action, for instance, to create a game. The client generates a code verifier, which is a hard-to-guess value that will be used later in the flow. The client then generates a code challenge, which is an encoded hash value derived from the code verifier, and it sends it as part of the authorization request to the authorization server. The authorization server presents the sign-in page where the resource owner can authenticate. After authentication, the authorization server might optionally also present an additional page where the resource owner can provide explicit consent to which actions can be performed on the resources he owns. After this, the authorization server stores the code challenge for future verification and generates an authorization code which is sent back to the client. This authorization code is valid only for a short amount of time, ideally no more than 10 minutes, and is good only for one use. The client then can use the received authorization code plus the code verified it had created at the start of the flow to request an authorization token. The authorization server verifies these requests by generating the code challenge itself out of the received code verifier and comparing it with the code challenge it had already stored. If this doesn't match, then the request likely comes from a malicious application and an error is returned to the client. If all looks good, the authorization server verifies the received authorization code and generates an access token. The client can now use this access token to send a request to the resource server so it can perform the desired action on the protected resources. The resource server validates the received access token, and if all looks good, it executes a requested action and returns a corresponding response. This whole flow is known as the authorization code flow with PKCE or PKCE, where PKCE means Proof Key for Code Exchange. This flow is ideal for public clients like single-page applications and native mobile applications because there is no need to store a static, hard-coded secret in the client which could easily be stolen. With no secret, the client can't get an access token right away. It needs to first acquire a valid authorization code only available after the user authenticates and provides consent. And even if a malicious application steals the authorization code, it would not be able to acquire the code verifier, which is dynamic and is only known to our own app. In the next lesson, we will learn about another important component that complements OAuth 2, and that is known as OpenID Connect. In this lesson, we will learn about OpenID Connect, its mechanics, and how it complements the OAuth 2 protocol. What is OpenID Connect? Don't worry, it is not an entire new security protocol to learn. OpenID Connect is just a simple identity layer on top of the OAuth 2 protocol that allows clients to verify the identity of the end user. Notice the emphasis on verified identity. Identity is the one piece that OAuth 2 misses because, think about it, OAuth 2 allows an application to get access to resources on behalf of a user, but the client application never really knows who is that end user that provided authorization. Let's see how it works. Since OpenID Connect is based on OAuth 2, the involved participants are mostly the same, but they receive slightly different names. The end user is a person, and in this case the actual human that needs to get authenticated. The relying party is the client application that outsources end user authentication to the OpenID provider. The OpenID provider is the server capable of authenticating the end user and provide claims to a relying party about the user. The flow starts the same way as with the OAuth 2 flow, but a key difference is that in the authentication request, a very specific scope called OpenID is required. This is really the only thing that signals to the OpenID provider that the relying party needs authentication. Other optional standard scopes could be also used here to retrieve additional claims about the end user. Upon receiving this request, the OpenID provider redirects the end user to the sign-in page as usual, optionally asks for consent to specific permissions, and then returns authorization code. And just as before, the relying party then uses the authorization code to request tokens from the OpenID provider. Another big difference here is that the OpenID provider returns not one, but at least two tokens, the access token and the ID token. This additional ID token is what the relying party can then use to verify the identity of the authenticated user. It contains one or more claims about the end user, depending on the requested scopes. A key claim here is the subclaim, which provides the unique identifier of the user. After this, the relying party could either request more information about the end user via the OpenID provided userinfo endpoint, or it can just use the access token to make requests to the resource server. Like I mentioned before, the main benefit of using OpenID Connect on top of OAuth 2 is the fact that the client can now verify the identity of the end user. But there are several other benefits of using this protocol. Standard scopes. Scopes in OAuth 2 are very loose, so each service has to define them according to their needs. In OpenID Connect, there is a standard set of scopes that you can use to request additional claims about the user, like profile, email, address, and phone. Standard claims. There are several standard claims that the OpenID provider can return upon request, like the required subclaim, which provides the unique identifier of the user, but also other claims like given name, nickname, email, birth date, and many others. The userinfo endpoint. This is a standard endpoint in the OpenID provider that can be used to retrieve more information about the end user that might not be available as part of the ID token. Single sign-on. More than specific OpenID Connect offering, single sign-on is a side benefit since a single OpenID provider can be used to authenticate end users coming from different apps, and in most cases, the user will be required to perform the authentication only the first time. This happens, for instance, when after authenticating in Gmail, you are automatically authenticated to YouTube, AdSense, Google Analytics, and other Google apps. Configuration discovery. OpenID providers define a well-known endpoint that apps can use to discover the several other endpoints and features they can use as part of the user authentication flow. Certified OpenID providers. OpenID providers can get certified by the OpenID Foundation via a standard suite of tests and requirements. There are dozens of certified OpenID providers you can choose from today, giving you lots of flexibility to use the one that better suits the needs of your apps. Across the many certified OpenID providers available today, some of them come from organizations mostly focused on providing identity-related services, like Auth0 and Okta. And others come from giant software vendors like Google and Microsoft, which offer identity services as part of their cloud offerings. Most OpenID providers are hosted for you in the cloud, and some of them you have to host yourself, like is the case for Identity Server and Keycloak. You can certainly choose any of these providers for your applications, and you can get a full list of them at https://openid.net/certification. But our choice for this course will be Auth0, given how easy it is to get started with a minimal set of configuration steps. In the next lesson, we will see how to get started with Auth0 as the OpenID provider for our game store. Auth0 is a flexible, drop-in solution to add authentication and authorization services to your applications. It is fully hosted for you, and it is very easy to configure and integrate to ASP.NET Core applications. Now, to get more information about Auth0, all you have to do is just go to auth0.com, this page over here, and this is going to give you all of the information about all of the capabilities of Auth0, which are plenty, as you can see. But now what I want you to do is to please go ahead and sign up for an account. If you just click on the sign up button over there, click over there. And then, as you can see, this will let you sign up with a free plan. So there's no need to pay for anything, and there's actually no need to introduce any credit card. So it's a great option for learning purposes. And of course, in my case, I have already created an account, but let me walk you through this process very quickly so that you can select the right options. So here, all you want to do is to enter your account here. So I'm going to just enter some other account. Let's say, okay, so enter that account, and you can of course also choose to sign in with GitHub, Google, or Microsoft instead if you want to. Click continue, and then I'm going to just enter some password. Has to be fairly strong. Click continue, and in this page, what I like to do is just to choose other, because most people is just not a company, but just a single user. And then also like to check this box here. I need advanced settings, just because that will allow us to select a name for what they call the tenant, which is your Auth0 account pretty much, right? Otherwise, you're going to be assigned a random tenant, as it says over here. And then, so yeah, just tick that one. And then when you click on next, you're going to see this other screen, this one over here, which lets you select the options for your tenant. And so now at this point, I'm going to just sign out of this account and sign in into my actual account to create my actual tenant, okay? But from here, just stay with me in this screen for a second while I switch accounts. So I'm going to log out here, and I'm going to log in as my actual account. Okay. So I'm back into this screen, and like I said, here's where you're going to select your tenant, which is pretty much the name of your Auth0 account. We're going to be using that name in a few places in our application. So I like to select here a more meaningful name rather than the default random one that's over here. So in my case, I'm going to go for .NET Microservices O2. That's the one that I'm going to select. And of course, you can select really any name here. I would select just the .NET Microservices, but I already used that one in the past, so I cannot reuse it now. So I'm going to be using O2 in this case, but you can use whatever name makes sense for you. Now, down here, you can also see that you can select your region over here. And so this is where your data, the data about your tenant, including your users, groups, and any other configurations for applications are going to be stored. Likely, you want to choose here the region that is closest to you, right? So that your data stays closer to you. But it's really your option. In my case, it already suggests US because I am located in the US, but please go ahead and choose the region that makes most sense for you. So then I'll go ahead and just say create account. And this is going to go ahead and set up your tenant. And with that, as you can see, we have created our Auth0 account. And let me collapse for a second this. And so we are pretty much ready to start defining our API. In the next lesson, you will go ahead and define your API in Auth0 with all the relevant permissions. Now that we have created our Auth0 tenant, what we need to do is to define our REST API. So REST API has to be defined in Auth0, which is our identity provider, so that we can set up the permissions required for our application. So to do that, what you want to do is go into the applications option over here. So let me expand this. So just go into applications, expand that, and then you're going to go into APIs, this option over here, APIs. And then you want to go ahead and click on the Create API button on the right side, Create API. And here, of course, you can enter any name for the actual API. This is just for showing up into your Auth0 dashboard. So I'm going to enter here Game Store. And then you want to enter the identifier for your API, right? So this is the name that you're going to use to reference your application from your actual ASP.NET Core application to reference back into what you have configured in Auth0, right? And they recommend that you use an actual URL here. I don't think it's necessary, but it's okay. So what I'm going to do, enter here is just HTTPS and then game store. This URL does not exist at all, and it doesn't have to exist, but it is for some reason recommended to just select a URL. And I think you can choose the same one. I don't think this has to be unique or anything like that. Everything here is going to go in the scope of the tenant itself. So let's enter that, and then I think that's good enough. You can go ahead and click on create. Okay, and now you have created your API. As you can see, it has the identifier of HTTPS game store. And then what we want to do now is to define the permissions for this API, right? So these are the permissions, the same permissions that we have defined so far for development purposes. We need to define them also over here so that Auth0 can include those permissions as claims after our users sign in into the application. So what you want to do is just go into permissions. And at this point, what you can do is just go back into Visual Studio Code so that we remember the actual permissions that we're looking for here. So let's go into Visual Studio Code. This is my GameStore.api instance of VS Code. And then let's go into authorization and into authorization extensions. And here's where you're going to find, of course, the scopes that we have defined for both our read access policy and our write access policy. For the scope claim, we're setting games read and games write. So those are the two permissions that we're going to be defining in Auth0 so that Auth0 can later set them up as a scope claim when the user signs in. So I'll copy that, games read, and I'll paste that over here. And let's place just some description here that's going to say can query games. Okay, I'll click on add on the right side. And that has been added down here. As you can see, we have that permission now. And then the next one is going to be games write. Okay, I'll put that over here and we'll say can modify games. And with that, the permissions associated to your .NET REST API in Auth0 are ready to use. And the other thing that we have to set up, of course, are the roles. We've been using the admin role in our application, so we need Auth0 to also become aware of that role so we can take advantage of it in our .NET application when we start using Auth0. So in the next lesson, you will set up the user and the role that are going to be available for your application. It is time to set up our admin user and role in Auth0. So let's see how to do that. First, what you want to do is go, and I'm going to expand this for a second, go into user management, this option here, and then we're going to go into users. Right here, let's go into users. And here's where you're going to be creating or managing all of the users of your application, right? So this is going to pretty much replace the traditional users database that you would have in your REST API. Now Auth0 is going to do the management of all those users for you. So this is going to be your dashboard for managing those users. So in this case, we're going to go ahead and manually create our admin user. But after this, of course, within your application, your users will be able to sign up themselves to be part of the application if they want to. But the roles you need to assign manually here. So let's go ahead and create our users. I'm going to go ahead and click on create user down here. So create user, and my user is just going to be admin@play.com. And of course you can enter any other user that makes more sense for you. This is the one that I'll be using for my purposes. Let's go ahead and enter a password. And then I'll go ahead and just click on create. Okay, I'll click never. And then as you can see, our user has been created, right? It even has his user ID right there. And what we want to do now is to assign the role, the admin role that we have been set up in our ASP.NET Core application. So for that, let's go back into our menu over here and let's click on the roles option over there, roles. As you can see, there are no roles right now. So I'm going to go ahead and click on create role down here. And our role is going to be the same name that we've been using in the application. So it's just going to be admin, and we'll just say can do everything. And so I'll click on create. And so yeah, we have our admin role. And now we need to, of course, associate this role into our admin user. So I'm going to click on users, and then I'll click on add users. And then here we should see our admin user. So I'm just going to type admin@play.com. See the user over here. I'm going to click that user. I'll click assign. And now our user has been assigned into the admin role. We can confirm that by also going into users. If we see our admin user over here and we go into roles, you're going to see that it is assigned into the admin role. So now we have the user and the role, but one thing to consider here is that Auth0 is not going to append this role automatically as claims as part of our access tokens or ID tokens. That's not going to happen automatically. So we need to introduce what Auth0 calls an action that is going to happen anytime a user logs in into Auth0, right? Logging into our application via Auth0. It's kind of an automatic action that's going to say, okay, so what are the actual roles for this user? And they will take that role and assign it into the, as claims, as a role claim into the access token and the ID token that's going to be provided into our application. So let's see how to create that action. So let's go ahead and expand our menu here. What we want to do now is to go into actions and then into library, over here, library. And then you want to go ahead and click on this button that says build custom, right? It's going to be a custom action. And the name is going to be add roles. And we will leave the trigger as login, post login, just like it is right there. So because we want to execute this as soon as the user logs in, right? As part of the login process. Okay, so we'll leave that and then we'll leave the rest as is. I'll click on create. And this is going to give us this little section over here, as you can see down here, where you can write a little function that's going to be kind of a JavaScript function that takes care of assigning the role into the role claim. Now this is looking very, very small for me. So let me see if I can do something about it. Perhaps I'm going to switch the zoom here. Yeah, that reads a bit better. And as you can see, we have this on execute post login section down here. I'm going to scroll down. It says exports at on execute post login. So this is a function that we're going to be writing our code. So the first thing that we want to write right here is what is going to be the actual claim, the name of the claim. So we're going to say const role claim. And the actual role claim here, what I'm going to do is just copy and paste that over there because it's a bit long and I don't want to screw up that there. So it's just going to be like this. Let me show you. Like that. So that is the role claim that we will be using. So please go ahead and type in that one over there. Ideally, we would like to enter here just role, just like this. But unfortunately, that's kind of a reserved word in the Auth0 world. And so we cannot just use role. But this other claim here is actually is also valid, completely valid in ASP.NET Core terms. So it's going to serve us just as well to define the role claim for the application. So I'm going to do semicolon there. And then next thing I'm going to do is to say that if event.authorization, we're just going to signal that within the authorization flow here. So at that point in time, when the user has been authorized, we want to assign the token. So what you're going to do is the following. So you're going to say API.IDToken.setCustomClaim, and then we're going to say what is the claim? Well, the claim is the role claim that we just defined it. So role claim, and then what is that we want to assign into that claim is going to be event.authorization.roles. Okay, and I think I typed this improperly. Authorization, not authentication, authorization.roles. So that is what we want to assign there. So that is for the ID token. Remember, the ID token is the one that provides identity information into the client, right? So the client can tell who is got access to that token. And then the other thing I want to do is to set the same thing for our access token. So I just copied that same line and I'm going to set it here as access token. Right, with exactly the same thing on the right side. And remember that the access token is the one that is going to be handed over into the REST API so that the REST API can tell what is the user also authorized to do. So it's important to set this in both places, otherwise we will not have the roles available either in the client or in the REST API. When you have this ready, all you have to do is go ahead and click in the deploy button down here, click on deploy. And the action is now ready for use. Now to actually enable the action to execute at the right time, what you want to do is go into, let's expand this, actions, and then go into flows over here, flows, click there. And then you want to click in this login flow, this one over here, login. And then I'm just going to close this. And then if you scroll down a bit, and I'm going to collapse that, you click on custom in this custom tab over here. This is going to show up the action that we just created, add roles. This is the one that we created. All you have to do is just drag it over here in the middle. Okay, so that means that the user logs in, right? The user logs in, then we add the roles, and then the login has been complete. Like I said, the roles cannot automatically be populated into the claims. You have to do that manually. So I'll click on apply. And then from here on, anytime a user logs in, the correct role will be assigned into the corresponding claims. So now we have defined our REST API with its permissions, and then we have our users and our roles and the process to automatically set the role in the claim. So in the next lesson, we will define our client application that will be allowed to get access tokens to talk to your REST API. It's time to define our client application in Auth0 so that our Blazor client can actually get access and talk to our REST API. So to do that, we're going to do the following. So let's go ahead and expand our navigation menu over here. And let's scroll up into applications. And then this time we'll click on applications right there. And then we'll go ahead and click on create application on the right side over here. Okay, so we're going to give it a name. So the name that I'm going to give here is Game Store Client. You can really put any name here, but this should represent the client application that's going to access later your REST API. And in this case, this is going to be a single page web application, the second option over here. I don't think it matters too much at this point, but yeah, that's the one that makes most sense for our actual application. So single page web application, then I click on create. And then what we want to do here is to define a couple of settings that are important for our application. So let's go down into the settings tab over here, settings. And on this one, what you want to do is just scroll down into this section that says application URLs, right? Application URIs. And then we're going to be setting up both the allowed callback URLs and the allowed logout URLs. So allowed callback URL is a URL where Auth0 is going to redirect our users after they have successfully logged in. And allowed logout URL down here is the URL where the user will be redirected after she logs out of the application. Okay, so where do we get these URLs from? Well, for the callback URL, what you want to do is just go down into your client source code. So this is the Game Store client, not the REST API. This is the client. On this one, all you need to know is what is the actual host for the application. So if you don't know that host, what you want to do is just go into properties. That's in launch settings.json. And if you scroll down into your HTTP profile, that is going to be right here as usual, application URL. So this is the URL of your client application in your box at least, right? So I'm going to just copy that, localhost 5259. I'll copy that, and then I'll go back into Auth0. I'm going to paste that here. But that is not all for the allowed callback URL, because this is a Blazor application that has already been configured with a very specific URL for a callback. So in this case, that URL is going to be /authentication/login callback. So that is a callback URL that has been configured in the client application, and we're not going to go into more details about how that was configured in the client. That's just a URL for the client. And then let's also copy the host once again, because that's the exact URL we need to use for our allowed logout URLs. So paste that there, and that means that when the user is logging out, he's going to log out basically into the home screen of the client application. And so with these two settings in place, what you want to do is just scroll all the way down to the end and just click on save changes down here. Click on save changes, and that will make sure that these settings have been configured for our client. That will be the end of this module. We have our Auth0 settings all set up. What we have to do in the next module is that we're going to go ahead and integrate Auth0 with the settings that we just configured into our .NET REST API and into our client application. So let's go to the next module. In this module, you will integrate Auth0 with both your REST API and the client application so that your users can make authorized requests to your API from the client. By the end of this module, you will have a solid understanding of the following: how to configure an Auth0 scheme in your web API, how to use the OpenID Connect discovery endpoint, how to get Auth0 access and ID tokens in Postman, how to use claims transformations, and how to enable authentication in the client via Auth0. In order to integrate our .NET REST API with Auth0, the first thing that we have to do is to define a new scheme. So remember that so far in app settings.development.json, here's where we have defined the one scheme that we've been using in order to use the .NET User JWTs tool for local development, right? So remember that here we have authentication, right? And then here we have one scheme, right? And so the scheme defines one mechanism or one way to perform authentication based on some parameters, right? In this case, this is the better scheme that is defining the valid audiences like this, and then a valid issuer, which is the .NET User JWTs, right? So that works fine for local development. But in order for us to be able to integrate with Auth0, we have to define a brand new scheme that knows how to authenticate using Auth0. So for that, what we're going to do is the following. So let's go ahead and just copy this entire section over here. Let's copy this. And now let's go into app settings.json, not app settings.development.json, but app settings.json. And in this one, let's just open up a new section at the end after allowed origin and paste what we just copied, right? And I'm going to collapse this for a second. And so here we're going to be defining a brand new scheme. And so what we're going to do is just rename better into Auth0, because this is our Auth0 scheme. And then for this one, we're going to be defining a first parameter here, which is going to be the authority. And so the authority is the entity that is authorized to generate access tokens that can be used in our .NET REST API. Now, what is that authority? Well, if we head down back into Auth0 over here, you can get the value that you're looking for either by going into over here into the very top, clicking on settings, this option over here, settings, you can click there, and then you can go into custom domains, and here where you're going to find your authority, which is your actual domain, the one that's over here. In my case, it's .networkservices02.us.auth0.com. In your case, of course, it's going to be different, but you can find that value right there, or you can also go into applications, APIs, and then if you select your game store API, go to quick start, and then you scroll down a little bit, and you're going to find that authority also over here, as you can see. So I'm going to go ahead and copy the value, this value over there. I'm going to copy that value, and then I'm going to go back into VS Code and I'll place that value as my authority. And then for valid audiences, what you want to use is the identifier for your REST API. So you remember we set up that going back here, we are back again into APIs. And then this is our game store API, and that identifier is right here. Notice this. HTTPS game store, right? Remember I mentioned that we would use that into our REST API, so this is the time. Let's go ahead and copy that identifier, copy that, which by the way, if you just go into settings, you will likely also see it here. Yeah, so it's also right here, HTTPS game store. You can go ahead and copy that, and let's go down into VS Code, and let's just place that as the one audience that is authorized, right? So this means that a REST API is going to validate that whatever tokens come in, they have to be created for the HTTPS game store audience, right? Otherwise, our API is not going to accept them. And of course, at this point, only Auth0 is able to provision those tokens, right? So they will come with this audience. And then we're not going to be using valid issuer here. That's not required for Auth0. So these are really the only two settings that are required. With that, we have our Auth0 scheme ready. But now what we have to do is to configure the application to actually start using this new scheme. So how to do that? Let's go down into Explorer, and then let's go into program.cs over here. And remember, if we scroll up a little bit, so far we have this line over here, line 11 in my case. We were saying that we want to add the JWT Better authentication. So now we need to add the other scheme here. So for that, let's do the following. So let me add one more line here. So let me do this. So that's it, add JWT Better with the default scheme. But now we want to use a specific scheme. So I'm going to add again JWT Better, but in this case it has to be the name of the scheme that we just defined. So if you go back to appsettings.json, we're going to be copying Auth0, this one over here. I'll copy this and I'll paste that right here. By doing this, we're defining that there are two ways to authenticate our users into our application, either by using the default scheme, the one that uses the local tool for generating tokens that we've been using, or now we can also use the Auth0 scheme, right? The Auth0 mechanism for authentication. Both of those are supported. And of course, if you wanted to, you could just keep adding more and more schemes for authenticating with other providers if you wanted to. But so far, these are the ones that makes most sense for us. So we're almost there, but there's one more thing that we have to do, and is that we have to update our authorization policies so that they can also take advantage of this new scheme. So if we go back into Explorer and we go into authorization and into authorization extensions here, we now have to modify this so that we not just require the claim in the policies and the role in the other case, but we also have to specify which are going to be the schemes that are supported by each of these policies, right? Otherwise, it will just revert to the default scheme and it's not going to allow us to use the scheme that includes Auth0. So for that, we're going to just open up a brand new line over here. And we're going to say dot add authentication schemes, right? And like I said, we have two schemes that we have to support here. So the first one is going to be JWT Better defaults, and then for that one we'll do control dot, and then we're going to be using Microsoft.ASP.NET Core.authentication.jwt Better, and then we'll say authentication scheme. So that's the first one, the default one, and then the other one, of course, as you know, it is Auth0. So I'm going to be copying Auth0 once again over here, Auth0. Okay, so that adds support to both schemes into our read policy. And just like we did that, we're going to be doing the same thing with our access with our write policy. Okay, so just after require role, we're going to be adding our two schemes, just like that. And with that, we have properly configured Auth0 authentication for our REST API. And in the next lesson, we will learn how to get Auth0 access tokens directly in Postman. Let's see how to retrieve access tokens from Auth0 into our Postman application so that we can actually use them to authorize our requests. So here we're back in Postman. I have opened the tab for the get by ID request. This is one that you can use to retrieve just one get by ID. And you remember this one requires authorization, and the authorization that we've been using, if we go into the authorization tab over here, is just better token authorization. And so this is the simple token that we can create by using the .NET user JWTs local tool that will work just for the local development, but it will not work for production. So we have to switch to another thing, and that other thing is going to be the OAuth2 protocol. To switch to that protocol here, we're going to open up this drop down and let's select OAuth2, this option here that says OAuth 2.0, and that's going to open up a bunch of options on the right side. So what we're going to do is just scroll down into a section that says configure new token. So here we have to fill a bunch of details. The first one is going to be the grant type. So this option over here, grant type, which by default it says authorization code in my case. We're going to switch this to the authorization code with PXE, which is the one that we talked about in a previous lesson. So this is the one that's ideal for our single page application. And then we have to start also setting up a bunch of endpoints here. Being the first one, the callback URL, right? So this is the URL where Auth0 will redirect after the authentication has been completed in the login screen. So you remember we already configured this callback URL in Auth0. So let's go over there right here. So we're back in Auth0, and what you want to do is just go into your applications tab on the left side and then select applications. And here you're going to select your Game Store client, the one that we just configured a few lessons ago, Game Store client. All right, let me collapse that. And then here just scroll down a bit up to your application URI section over here. And here you're going to find your login callback URL, this one over here. So all we're going to do is just copy this URL, just copy that, and then let's head back into Postman and let's just paste it over here. That's going to be our callback URL. The next one that we have to configure is the auth URL. So let's scroll down here. So this one here, auth URL, is the one that's going to be used to initiate the authentication flow, right? So the code flow with PXE that we've been talking about initiates in that URL. But where do we get that URL from? Well, there's a nice endpoint that's offered by every single identity provider that can give us that information automatically. So if you just open another tab, so let's go ahead and open another tab over here, and then we're going to do a get request into a well-known URL, which is going to be starting with the domain that you got from Auth0. And that domain, if you remember, we already configured that in our applications. I'm going to open up, here's my Game Store REST API. And if we go into AppSettings.json, you remember that we have the authority configured right here, right? So in my case, it's .NET Microservices 02.us.auth0.com. So that's going to be the start of that request. I'm going to copy that. So just copy that and then paste that over here. And then the rest of the URL is a well-known path that, like I said, is available for every single identity provider. So you just have to put here well-known / OpenID configuration. Okay, this one is known as a discovery endpoint. If you just click on send, that's going to give you all of this information that you can see down here. So usually this will be used by different OpenID Connect libraries or applications so that they can automatically figure out what are the endpoints that are going to be used for the authentication code flow that you have to follow. In this case, we can also use it to retrieve this set of endpoints that we need in Postman. Being the authorization endpoint, this second one over here, as you can see, here's the authorization endpoint. We also have the token endpoint. And then there's a bunch of other interesting information in this discovery document if you want to explore it further. But for now, what we mainly care about is about these two endpoints over here. So let me just go ahead and copy my authorization endpoint. Let me close this. Authorization endpoint. So let me just go ahead and copy this one into my get by ID request over here, and I'll paste it in auth URL right there. And then for access token URL, I'm going back there and I'm going to pick this one that says token endpoint. So this is the one that's going to be used to exchange the authorization code that we got for an actual access token. Copy that. And then I'll go back here and I'll paste that over here. Okay, so now we have those two important details so that the flow can actually proceed. Now we need a few other details here, which are the client ID and client secret, which are the ones that actually identify our client so that it is a valid client requesting these access tokens. So for those ones, we can go back to Auth0 over here. And since we already have this page open here, what we want to do is just go back all the way to the top. Okay, for the Game Store client, you want to look for right here in the basic information, we have the client ID over here and the client secret over here. So let's go ahead and use those two values. So I'm going to copy client ID, paste it into Postman, and then the client secret, I'm going to also copy and paste it over here. So that's it. And then let's scroll down a little bit more. And now we want to define the scope, right? So what is going to be the access scope that we want to request? And remember, if you remember, so this is going to refer to the permissions that are going to be associated to the access token that we're going to request. And if you remember, if you go back to VS Code and we go into authorization and into authorization extensions, we do support these two scopes, right? So games read and games write. So let's start this time with games read. That's going to be the one that we're going to start with. So I'm just going to copy that one. So we can get a token that gives us the read access policy. So let's copy that and then let's paste that over here. So that's a scope. And then one more thing that we have to use here in this section that says advanced. So we want to open up that section there, which by the way is recent at the time that I'm recording this. So make sure that you have the very latest version of Postman. Otherwise you may not be able to see this section here, right? So use the absolute latest version of Postman. And then what you want to do is just go down into the auth request, right? So this section over here, auth request. Over here, we're going to be entering just one parameter, which is the audience. Okay, audience. So you want to use audience, and for the value, you want to just go back into Visual Studio Code and then go into your app.settings.json. Okay, app.settings.json, and remember that we set the valid audiences here, right? So we have these valid audiences, which means that the token has to be generated for that audience. That way, our REST API knows that it is intended for that REST API, right? So this is kind of what identifies our REST API. So let's go ahead and copy the audience, HTTPS, game store. So let's just copy that, and let's paste that on the right side over here for auth request. And one last parameter that I'd like to add over here is this one called prompt. Okay, with the value of login. I like to use this one over here because it forces Auth0 to always present the login screen. So you can just enter your username and your password and then go ahead and log in. Without that, it's going to do is just try to cache or to remember the last user that logged in, and it will just go ahead and reuse it to generate the token, right? I like to use this because that allows me to more easily go ahead and test multiple users in Postman without having to figure out a way to log them out and then go ahead and back and log in, right? So with this parameter, you will always get presented with the login screen. So I do recommend to use this one, at least within Postman. And with that, we are pretty much done. So let's go ahead and scroll down and click on the button here for getting a new access token. So click there and you're going to be presented with this screen over here. And so this is the login screen for Auth0, right? At least the default login screen. And so here we're going to go ahead and just enter one of our users. And the only user we have so far is the admin user, right? And so let's go ahead and log in as admin. Okay, so enter your password and then scroll down and click on continue. And you're going to be presented with this other screen here, which is a screen that is asking for consent, right? So you as a user need to consent if you want to allow, in this case, Postman to be able to use the read scope that's going to allow Postman to actually read the games, right? Via our getById endpoint. And this is also going to be presented later in the actual client, the Blazor client. So at this point, you have to decide if you want to allow it or not. So I'm going to say yes. So I'm going to allow Postman to do that. So I click accept. And then the authorization code flow completes. You can click on proceed. And now you have your brand new token over here. Let's go ahead and decode this token briefly to make sure that we understand what's coming in there. So with that copied, let me just go back into my jwt.ms screen over here. I'm going to paste a token and let's see what we got. Let's scroll down. Okay, so we have the expected structure here, but notice that we do have our admin role over there for the claim that we defined, right? So this is the one that we defined in Auth0. So the role claim, it has the right value admin. So the automation that we set up in Auth0 worked, right? So the actual role was assigned into the role claim into our user, into the token. So it's right there, so that will work. We have the correct issuer over here. Here's the correct issuer. Okay, we have the sub which represents kind of the ID, the user ID for the admin user. We have the correct audience, right? So this token is intended for our .NET REST API, which is identified by this HTTPS game store ID. And then of course we have the other issued ad and the expiration. And then the other interesting one is going to be the scope, right? We requested for the read scope, which is right there. So this looks good. This is the kind of token that we're looking for. So let's head down back into Postman and let's go ahead and use the button that says here, just use token, that one over there, use token, so that we can now use this token. So the token has been placed now over here in the token box. And then since we are in the getById endpoint, let's just go ahead and let me expand the response section a bit. And then let's go ahead and click on send. Oh, but before doing that, of course, let's go ahead and start our server, which I didn't do. Back here, I'm going to just go ahead and do .NET Run in my game store REST API. REST API has started. So now let's go back to Postman and let's try to retrieve our game. So I click send. And as you can see, we got our status code 200 OK. We got our game, and so everything just worked. Authentication is working properly with Auth0 as we can verify within Postman. So that is great. There is one more thing that we have to do in our REST API, which is to support multiple scopes coming from Auth0 because they come in a slightly different way than the local .NET user JWTs tool. So we need to do a couple of changes so that make sure that we can support multiple scopes. So in the next lesson, we'll go ahead and learn how to add that support for multiple scopes in our .NET REST API. It may not be evident, but we do have a small issue right now with our Auth0 scopes. So let me show you what's happening. So if you go back into the getById request that we have over here and into authorization, and then let me collapse this. And let's go into the scope section right here, scope. Remember that we have set up our game's read scope, but we also have another scope, right, which is the write scope. So our client will usually be requesting all of the available scopes. So let's test what happens when we try that. So games write, right? So now we're requesting two scopes, read and write. So let's go ahead and get a new access token, right? So I'm going to click on get new access token, and I'm going to go ahead and log in once again. Okay, I'll click on continue. Okay, so of course, now we are again being asked for consent if we want to also allow this client to be able to write into our games, right? So the game to write. So I'm going to say, yes, I accept that. I agree. So proceed. So now we have this new access token, which by the way, I'm going to copy, right? Because there's a slight difference here. So I'm going to copy that. And then let's just say use token, right? And with that token, we're going to go ahead and click on the send button. And let me actually expand the response. Click on send. And notice that this time we are getting a 403 forbidden response, right? Even when we are asking for the same read scope that we had before plus a new write scope. So this should have just worked, but for some reason it's not working. So let's see quickly into that token by going into our jwt.ms screen over here. I'm going to paste that new token. And if we scroll down, what we're going to see is that the scope here, it does have the two scopes, read and write. However, they are coming as a single string as opposed to come as an array. And the way that the .NET by default is expecting these scopes to come is in the form of an array and not a string. So since they are a string, it is treating these two scopes here as just one scope, and that is just not making sense with our authorization policy. It needs to come in the form of an array. And this is going to vary between identity providers. Some of them will return them as an array, some of them as a string. And so what we have to do in this case is to do a small kind of a transformation of this scope so that it gets into the right shape that we need for our .NET REST API. So to fix this, let's go back into Visual Studio Code. Over here, where we're running our server right now, I'm going to stop it. Okay, and I'm going to close this. And what we're going to do is to create what is known as a claims transformation, right? This is a standard class that is supported in .NET. So you just have to go ahead and implement one interface, and that's going to allow you to transform the scopes into a new shape. So we're going to go under our authorization directory over here, right click, new C# class, and this is going to be named scope transformation. You can give it any name, really doesn't matter. What matters is really the interface that you're going to implement. So let me go ahead and collapse this. I'm going to fix my namespace and my usings. And here, like I said, you want to implement just one interface, which is iClaims transformation. Okay, so I'll do control dot and then using Microsoft.ASP.NET Core.authentication. So let's go ahead and do control dot once again to implement the interface right there. So there's just one method that we have to implement to make this happen. So before implementing this, let's just define one variable here, one constant that is going to be the name of the claim that we want to work with, right? So let's define private const string, and it's going to be scope claim name, and that's going to be just scope, right? So this is the claim that we're looking for. So now let's go ahead and scroll down into our transform async method over here. First thing we're going to do in this method is to retrieve that scope claim. So to do that, let's just do var scope claim equals, and we're going to get that from the principal, which represents the identity that is getting authenticated or authorized here. So find first, and here we put scope claim name, right? So now we have the scope claim. And so one quick check we're going to do here is that if scope claim is null, which it shouldn't, but if for any reason it is null, then we'll just return task from result principal, just in case the user has not actually requested for any scopes. So there's nothing else to do there. If we do find it, this is what we're going to do. First, we're going to go ahead and split the value of the claim by just splitting by empty space, right? So var scopes equals scope claim dot value dot split, and we're going to be splitting just on an empty character, just like that. Okay, so make sure we have an actual empty space there. And with that, we now have an array of scopes, right? We should include both our read and write scopes and any other scopes that have been requested. And so that's great. So now what we're going to do is to first, let's keep track of that original identity that was requested. So we're going to say original identity is going to be principal dot identity as we're going to turn this into a claims identity so we can actually work with the properties of that object. What we're going to do is to create a brand new identity based on the values of that original identity. So we're going to say var identity equals new claims identity or out of the original identity. And this is because we cannot just modify the scopes in the original claims identity. We do need to provide a brand new one with our brand new arrays of scopes. So now we have this brand new identity that is based on the original one, but we do have to go ahead and actually remove the scopes, the original string scopes from that identity before we can add ours. So we're going to go ahead and say var original scope claim equals identity that claims that first or default, okay, and we're going to say claim, and it's going to be claim type equals scope claim name. So that way we are getting the actual claim object there, the original claim object. And we can say now that if we are able to find it, original scope claim is not null. Okay, we can go ahead and say identity.remove claim the original scope claim. So with that, we have our identity without the original scope, and now we can proceed to actually add our brand new scopes array. So we're going to say identity.add claims, and then for the array of scopes, right? So scopes, we're going to do a transformation, right? A select into scope new claim, and the name of this claim is going to be our scope claim name, and the value is going to be just scope. And so yeah, that's pretty much it. We have our identity ready, and then all we have to do now is to return a brand new claims principal object, which is what this method is requesting as a return value. And then since this is async, we have to return it as part of a task. So return task that from result, and this is going to be new claims principal, and then we'll put here the identity object. Okay, fix typo. So that completes our claims transformation class. And like I said, all this is going to do is to transform these scopes here. I mean, this scope claim value here that is just a single string, right? Turns it into an array and then places that array into a brand new identity and claims principal right there. So that's good. And then the next thing that we have to do is to actually register this class so that it can be used as part of the authentication flow. So let's go now into Explorer, into authorization extensions. This class over here, and just before our call to add authorization, we're going to be doing another call here. So let's send this to the next line, and now we're going to say services dot add scoped, so that we register this class as a scoped type service, so it's a new one for every single request. And so we're going to register iClaims transformation, okay, and for that one we'll have to do control dot. We have to use Microsoft ASP.NET Core.authentication, so that one, and then our scope transformation class over here. And with that in place, we should be ready to test this out. So what we're going to do is, let's just go ahead and place a breakpoint somewhere around here. Let's say over here, so we can see the scopes, and perhaps at the very end over here, just verify that we can actually do in the right split there. What I'm going to do now is make sure that my server is not running. It's not running, so I'm going to just hit F5 in my .NET REST API VS Code instance. Okay, we are debugging this. Okay, it's ready to go. So let's go back into Postman over here, and using that very same scope that we've been using, let's go ahead and click on send once again. Click on send. Of course, that's going to activate our debugging session over here. And let's see now what we have in scopes here. Yeah, we have our array of scopes right there. So that works. And then I'll click on continue. Then we get to the very end where we have now our identity. We have our claims. And as you can see, now we have two scope claims down here. If I can show that. Down here, we have our two scope claims. With that in place, let's let it continue. So click continue. Let's go back into Postman. And as you can see, this time things just worked. We got our 200 OK, and then we got our gain. Okay, and so now our REST API is able to properly interpret those scopes and use them, and it's not going to really matter how many scopes we specify, and it's going to work just fine, right? And like I said, this is just because of the way that Auth0 presents the array of scopes to us. It didn't happen with the local .NET user JWTs tool, but it does happen with Auth0, right? So this is one way to accommodate for that change. So with that ready, in the next lesson, we're going to see how to get another type of token, which is known as the ID token, the one that's used for OpenID Connect. So we'll see how to get that ID token within Postman. We now know how to use Postman to retrieve access tokens from Auth0. But what about ID tokens? Remember that ID tokens are the ones that can be used by client applications to actually figure out details about the authenticated user. So let's see how we can retrieve those ID tokens within Postman so that we can quickly explore them. So here I'm back in the Get by ID request tab in my Postman application. And so what I'm going to do is just go into the authorization tab. And then what I'm going to do is just scroll down into the scope section. And so right here on scope, what we want to do is to request one more scope. And as we talked about before, the one scope that you need to activate OpenID Connect and retrieve ID tokens is the OpenID scope. So all you have to do is just add just one space here, and then we're going to add OpenID. And with that, we're going to go ahead and just try to retrieve an access token. So I'm going to click on Get New Access Token. And then we're back into our screen where we're going to log in. All right, so I'll click Continue. And since we added a new scope into the set of scopes in Postman, Auth0 is asking us for consent to allow Postman to make use of that other scope, right? The OpenID scope. So I'm going to say just accept. It's fine. I'll click plus read, and now we have a brand new access token. But if you scroll down, notice that, we do have the access token. So yeah, that's correct as usual. But now if you could scroll down, we also have what is known as the ID token, right? So this one is new. So this token that we have on the right side is the one that is meant for the client, not for your REST API, but for the client. So let's see what kind of details we get in that access token. So I'm going to just copy that access token, copy that, and then we're going to go back into jwt.ms, paste that, and then let's see what we get in this token. So as you can see, this is not really that much different from the access token. We do have our role, the admin role right here. So that's essential. And then we have our subclaim right here. The subclaim which identifies the user. And that's pretty much what we're looking for here. We also have a few other details in there, but these are the absolute basic details that the client will be looking for when reading these ID tokens. However, of course, we want to have a little bit of more information, right? More information about our user. And to do that, what we can do is go back into Postman once again. And instead of using that token, we're going to go back here and into our scopes. And we're going to be adding one more scope. That scope is called profile. So we're just going to type profile here. And then with that, let's go ahead and retrieve a brand new token. So I click on Get New Access Token. Okay, here we are. Going to log in, continue. And then as you can see now, once again, we are getting asked for consent to also let Postman read our user profile, right? I'm going to say, yes, that's fine. Postman, you can go ahead and read my user profile. I'll click on proceed. And then let's take another look at this ID token, which now looks a little bit bigger now. So copy all of that back into jwt.ms. I'm going to refresh this page, paste my new token. Let's scroll down now. And notice that this time we have a few other details, right? So besides the usual things, now we also have a nickname here, right? The nickname for this user is just admin, right? We also have the full name here, which is the complete email of the user. And we even have a picture, right? This one here is a URL for the gravatar, the auto-generated gravatar for this specific user. Okay, besides a few other details. So this is the kind of stuff that client applications can go ahead and take advantage of to present some information into the client UI. I would say the most important one here is still the role, the admin role, because in the case of our client UI that we're going to see in the next lesson, the client needs to know what kind of role the user has in order to present a bunch of UI elements, like the buttons to create a new game or to update a game or to delete a game. All those things are behind that specific role. So it is thanks to this ID token and not the access token. The ID token is how the client will be able to modify the UI to present the elements based on the current logged in user. So now that we understand this new token, the ID token, in the next lesson, we will go ahead and configure the missing Auth0 details in our client application so that it can start sending authorized requests to our REST API. It is time now to finally add a few missing details into our client application from Auth0 so that we can finally try out authentication and authorization in the client and token into our .NET REST API. So here I am back in our GameStore.client code base, right? So this is the client application. And what we want to do now is go into www and into app.settings.json, this file over here. And we need to complete these couple of missing details, which are the authority and the client ID. And so for the authority, if you remember, we already set that in our REST API. So if you go back into GameStore, into our GameStore.api, into app.settings.json, we are going to find that that authority is right here, right? In the authentication schemes Auth0, authority is this one over here. Okay, so I'm just going to copy that and then back into the client, I'm going to paste that over here. Okay, so that's going to tell our client who to request the required ID tokens, access tokens, all of that from that authority. That's one thing. And the other thing is going to be the client ID. So what is the client ID? That identifies this specific client. So for that, all you have to do is just go back into Auth0, right? So here we are back in Auth0. You can go into applications, and then into our GameStore client. And the client ID is going to be right here in the basic information. Client ID is this one over here. So all you want to do is just copy that and then paste it over here. Okay, that's how we're going to be identifying our client application against Auth0. And as you can see, we also already have the response type as code. That means that we're going to be using the code flow for authentication, right? The OpenID Connect code flow. And with that in place, we can go ahead and try this out. I'm going to start my terminal here with just .NET Run. That will start the client. And I'll also go ahead and make sure that my .NET REST API is up and running. So over here, so REST API is not running right now. So I'm going to go ahead and run the REST API. So now client and server are running. Now I can go back into my browser here where I have the application already running, right, from the previous lesson. If you don't have it running, just go ahead and open your browser and just go into localhost 5259. That should be the port that you'll be using in your box. And so what I'll do is I'll refresh this to make sure that the OpenID Connect details are being used now. And now what we can do is go into the login button over there. You can click on login. And as you can see, we are now able to actually get into that same login screen that we were looking at in Postman. Now we're looking at it from the client because the client redirected into that location. And now we can go ahead and actually enter our details. So admin.com. Okay, I'll click on continue. Click never here. And as you can see, now we are authenticated, right? And we can see if we open up on the right side, we can see the details of the logged in user, right? And there's even a button for logging out, right? That was not there before. And then we also have a bunch of new buttons here, right? We have a button for new game and we have buttons here for edit and for delete for all of our games, right? And this is all enabled because we logged in as the admin user, which has the admin role, which has that claim as an admin that it came as part of the ID token. And then the client was able to enable all of this because of that role. And with that in place, we can go ahead and, for instance, we could go ahead and try to create a brand new game. So click on new game here. So let's say we're going to create here this game Fortnite, okay, which we're going to be, let's say we classify it as fighting, right? And then the price is going to be $19.99. The release date is going to be July 21st. 2017. And then we're not going to be choosing an image just yet because we have not implemented that in our .NET REST API, how to upload an image. We'll get into that soon, but that will be good enough for now. And then, one thing that you can notice in this client is that all of these fields, whatever is required, is actually not going to let you proceed to save until you enter that. So for instance, if I just don't enter a name like this, you're going to see that the name field is required and you cannot actually save the game, right? That's not going to be allowed. So those are being enforced in the client. And then, you can go ahead and hit save. And then, as you can see, the brand new game has been added right here. Okay, we have our Fortnite game, means that our post endpoint succeeded. It worked just fine, no issues there. Okay, and then let's say that we're going to be changing our Minecraft for Windows game here. So I'm going to click on the edit button for Minecraft for Windows. I'm going to edit. This is going to be Minecraft for Nintendo Switch instead. And then, yeah, let's just do that one. And then I'm going to click on save. And as you can see, that changed it. So that means our put endpoint is working just fine. It also requires authorization, as you remember. So that's working great. And then last thing, let's say that we're going to be deleting one game. So let's say we're going to be deleting Forza Horizon 5. So I'm going to click on the delete button over here. Just click on that. And then I'll click on delete. And as you can see, Forza Horizon is gone. No longer in our screen. So delete endpoint is working just fine. And so, yeah, most of this is working fine. And then one thing to notice, of course, is that you don't have to just use admin all the time. You can now actually register brand new users if that's what you want to do. So what you can do to register a new user is just first log out from admin. So I'm going to go ahead and log out. Okay, so we're back here. So you can see no more edit buttons or anything like that. That's gone. And then I'm going to click on login once again. But this time, instead of just logging in, what we're going to do is click on this sign up link down here, sign up. So you can click there. And that is going to allow you to sign in with your own email, right? So in this case, I'm going to say that I'm going to log in with my personal email, let's say, right? It's going to be, I'm going to set up some password. Notice that it even gives you the details for what kind of password you should enter here. And then I'll go ahead and continue. And then, of course, now Auth0 is asking us if we want to allow the browser or client application to access the profile, in this case, of my account. And as you can see, it already identifies the gravatar for my profile, I guess, my public gravatar. And so I'll say, yes, accept. That's fine. And now, as you can see, we are logged in as my account. You can see the image URL over there. Remember that that's been retrieved again via the ID token, right? That's the gravatar image in the ID token. And then, of course, since I am not an admin, I don't have the ability to do anything here other than just query for games, right? Which is just expected. And so, yeah, so at this point, everything related to authentication and authorization has been integrated both in the client and the server. So it's working great. But of course, we still have a bunch of features here that are not enabled, right? So we don't have the ability to set game images just yet. We don't have the ability to search a store, and we don't have yet also these links here are not really working for pagination just yet. But since pagination is a very, very important thing in your REST API, in the next module, that's exactly what we're going to do. We're going to be looking at how to implement pagination in your .NET REST API. In this module, you will implement pagination support in your REST API so that it allows for sending back smaller chunks of data to clients, which will result in a better user experience. By the end of this module, you will have a solid understanding of the following: how to add pagination support to your repositories, how to add pagination support to your endpoints, and how to use response headers to provide pagination data to clients. At this point, we have a fairly functional .NET REST API, but of course there's a few things that we still need to tackle, right? So one of them is the lack of paging, because right now, if we go into the get all endpoint in Postman, the one that retrieves all of the games, we click on send, and we're going to get the complete list of games as we have them in the database, right? And so I added a few more games into my database right now. And as you can see, this list is only going to keep increasing in size, right? And so the more games that we have, the bigger the response is going to be. And this is going to take more and more time for the REST API to return the data from the database into the endpoint and from the endpoint back into the client. And even if it doesn't look that bad in Postman, that's going to actually start causing issues in our client, right? Because now our client has to load all of these games in just one page, and it's just going to get bigger and bigger and bigger, right? That's not going to be a great experience for the client. So we need to figure out a good way to enable pagination there. And in fact, our client already knows how to do pagination. As you can see here, it does have that ability there, but we have not enabled this in the REST API. So let's start seeing what we can do to enable this. So let's go back into our REST API VS Code instance here, and I'm going to just stop this and close that. And the first thing we're going to do is to enable paging support in our repositories. For that, let's go ahead and go into repositories, and let's start with our Entity Framework Games repository, this one here. What we're going to do first is actually, before touching the repository, let's go for the interface, this one here, and let's go ahead and update our getAllAsync method so that now it is going to receive two more parameters. I mean, two actual parameters, we don't have any right now. It's going to be int page number and int page size. That way, whoever calls this method here is going to be able to tell what page within the pages that we're going to be offering is going to be returned and what's going to be the size of that page, how many records to return. And with that in place, we can now go into our entity framework games repository, which now of course it doesn't compile because we need to fix the interface, fix the implementation. And we're going to look for our get all async method over here. So of course in this method we want to receive now the page number and the page size. And this time, instead of just going ahead and returning the entire thing, we're going to do a few things. The first thing is going to be the skip count. So the skip count is how many records we want to skip from the very start on the database according to the specified sorting, so that we can return the next elements from that index on, right? So to calculate the skip count, we can say skip count equals, and then we're going to do a bit of a calculation here. This is going to be page number -1, and that's going to be times page size. And so for a little exercise, if page number was 0 here, page number was 1 here, we would say 1 minus 1 is 0, 0 times page size, 0, that means that we're not skipping anything. But if page number is 2, so we would say, okay, so 2 minus 1 is just 1, and then the page size, let's say is 5, so 1 times 5 means that we're going to skip 5, right? So to get into page 2, we skip the first 5 elements, and then we start rendering the next set of records. So now we have the skip count, we can go ahead and actually modify our query here to account for that skip count. So we're going to do the following. Let's open up this into a new line like that. And then in this next line here, first thing we're going to do here is add an order by. And this order by is going to be by game ID. So game.id. So this one here is important because SQL Server is not going to like the fact that we request to skip some records and take some records if we don't have a very specific order by, right? This is kind of a requirement of the server, and it's going to make sure that we get an accurate result out of the query that we're going to send. So with the order by in place, now we can go ahead and say skip and then skip count. And we need that comma. And next we're going to say, okay, after we skip that many records, we're going to take whatever is the page size. And after that, we just go ahead and say as no tracking and to list async. So once again, imagine that the page size is 5 and page number is 2. We say, okay, so 2 minus 1 is 1 times 5. We say skip count is 5. So we go ahead and say, okay, give me all the games, order them by ID, skip 5 elements, and then take the next 5, right? Because page size is 5. And then just return whatever comes out of that query. So that will do it for our getAllAsync method, but we're going to need also one more method, which is a method to be able to count how many elements we have. We'll see how we're going to be using that pretty soon, but we need a way to be able to count how many is the total count of elements that we have in our database. So for that, let's go back into our interface here, and let's add a brand new method at the very bottom here. It's going to be task of int count async. So this is a method that we're going to use, and then if we go back into the different games repository, of course now the interface complains, we're going to do control dot implement interface, and so if we go all the way to the bottom, now we have our count async method ready to implement there. And of course, to implement this is actually super straightforward. All we have to do is first let's make sure we return async, and then we will return await is the context that games that count async. That's all we have to do. Like I said, we'll see how to use this count method in the next lesson when we start looking into paging for the endpoints. But for now, what we also have to do is to fix our in-memory games repository. If you still have it in your code base, we'll have to make those changes. If you don't have it, there's nothing else to do here. But we do have it right now, as you know. Let's go into in-mem games repository. And so of course, it doesn't satisfy the interface, so we have to fix a couple of things. So let's go to getAllAsync once again. Now in the in-mem repository, we're going to be receiving page number and page size, and then the calculation here for the skip count is going to be the same. So let's go ahead and copy that from our entity framework games repository. Skip count, I'll copy that over here, there. And then for the result, we're going to just use task from result. Instead of just returning games, we'll say games that skip, and then we're skipping skip count, and then we're going to be taking the page size. A bit simpler than the entity framework implementation. And lastly, we have to also implement count async. So let's go ahead and click on here, control dot implement interface. Then let's go to the very end where we have our new count async method. And all we're going to do is just say return task dot from result. And this is going to be games dot count. And then just to keep following the same pattern as the others, let's make sure this returns async, and then we're going to be doing await here. It's not strictly necessary here, but let's make sure, we avoid any future possible problems by making sure that we always do async and await. And so with that, we have enabled our paging support in our repositories. And in the next lesson, we'll see how to also add paging support for our endpoints. Now that we have paging support in our repositories, let's go ahead and also modify our endpoints so that they can also support paging. So if you remember, if we go into endpoints and games endpoints, we're going to see that if we scroll down, and of course we still will have some compilation errors there, that's expected at this point, but we do have our get endpoint here for get all. And as it is right now, it doesn't really have a way to tell what is going to be the actual page number or page size that the client is requesting us. So we can pass down that into the repository. So the first thing we're going to do is to define a brand new DTO for this get all requests that includes both page number and page size. So let's go back into our Explorer and then into our DTOs class over here. And what we're going to do, perhaps at the very top, is define our DTO, which is, the name is going to be public record get games DTO. And since this is going to be for that endpoint that has been versioned, let's also make sure we also use versions here. So let's do v1, and then we're going to need two things here. First one is going to be page number, which we're going to just default to 1 in case the client doesn't specify it. And then the page size, which we will default to 5, again, if the client does not specify it. All right, and now that we have this one, all we're going to do is just copy that, and then let's scroll down a little bit. Just before game DTO v2, we're going to paste this guy, and then just rename it into get games DTO v2. There's no difference between v1 and v2 for this one here, but it will be a good practice to just have separate DTOs for each of the versions, right? And with those in place, we can now go back into our endpoints. So games endpoints over here. And what we're going to do is to expand the list of parameters that we are going to be receiving here by adding also the DTO. So let me start by just sending things to the next line so we can see better. And so let's add our next parameter, which is going to be, of course, get games DTO v1. And then let's just name this one as request. Now, since we want to get both the page number and page size directly from query team parameters, we have to do a small change into this new parameter here. And let me actually show you that. So what we want to do is that when we go into Postman, what we want to go and say is just question mark. And then we want to say page number, right? So page number, let's say it's going to be page 1, right? So we want to enable this, and to enable this, we have to make sure that we qualify this parameter here with an actual attribute that will make sure that the .NET on ASP.NET Core runtime can actually take those parameters directly from that DTO and place them in the right spot. So for that, all we have to do is just say here we're going to say as parameters, right? So that will allow, like I said, the runtime to take out those values from the query string and place them in getGames DTO into our request object over here. And now we have that, of course, now we can go ahead and just say request.page number, it's the first parameter, and the next parameter is request.page size. Okay, and let me send this to the next line so we can see better. Okay, so we retrieve all of the games now based on page number and page size, and then we just do the transformation into the as DTO v1. And that's pretty much all we have to do in this endpoint. So let's do a similar job in our v2 endpoint. So let's go down into our v2 endpoint over here. And let's send this to the next line, this to the next line, and then let's put our as parameters, but this is going to be get games DTO v2. And then once again, we will say request dot page number and request that page size. Okay, let's send this to the next line. And so we are almost ready to have our paging support enabled for the REST API, but we have to do still one more thing, which is to add paging support to the responses that we're going to be sending back into our client, because our client needs to know a bit of more information about these pages that we're going to be returning. So in the next lesson, we'll see how to add paging support to the responses that we send back to the client applications. Now that our endpoints are ready to support pagination, there's one more detail that we need to account for before we are ready to really start using pagination from the clients. And it is the fact that we need to communicate back into the clients what is the total number of pages that are supported in the REST API, because otherwise our clients will just have no idea how many pages are available, and it will just complicate how to enable that support. So to provide the information, we're going to be using a brand new header in our response, and we're going to be creating a new extension method that's going to make it very easy to add this header into our responses. So let's go into our endpoints directory, right? Endpoints, and let's right click and create a brand new C# class that we're going to be naming HTTP response extensions. So let's collapse this and let's fix our namespace and our usings. Right, this is going to be a static class because it's going to be for an extension method, and our method is going to be public void static void add pagination header. And in this header, what we're going to extend is our HTTP response, right? That's what we're going to extend. So this is going to be the response. And then we're going to be receiving two parameters here, which are the total count and the page size. So that's our method. And perhaps I'll send things to the next line so we can see better. And to define the payload of the value that we're going to be sending as part of this header, we're going to be creating just a very simple anonymous type on the fly because we only need just one property in that type. So we'll define here var pagination header equals new. And this is how you can go ahead and just create an anonymous type. So as you can see, there's no class here. It's just a type made on the fly. So what we're going to do is just set one property here. Total pages is going to be equals to. And then the formula here to calculate total pages is very straightforward, as you would expect. It's just the total count divided by, and we're going to be casting this into double. So to make sure that we get a double page size. Okay, so total count divided by page size. But in addition to this, we're also going to be wrapping up this into parentheses, and we're going to be calculating the math that ceiling of that value there, and we're going to be converting this into an int. And we'll do that just in case we get a fraction here, right? So in this case, let's say if we get a total count of 10 and the page size is 2, then 10 divided by 2, that's going to be 5, so total pages is 5. But if the total count is, let's say 11, then 11 divided by 2, that is going to be 5.5, right? And so we don't want to return 5.5 back to the client, that doesn't make sense. So we're just going to go up and into the number 6, right? Total pages is going to be 6. So simple calculation there. And now that we have the payload for the header, let's actually define that header. So we're going to say response dot, and you can use the headers property in the response object to add any headers that you want to specify here. Now here, the actual name of the header, I mean, you can use any name as long as your client is ready to recognize it. But in our case, we're going to go for one that we're going to be calling xpagination, right? Xpagination, but you can use any name really. And then we're going to serialize via the JSON serializer. Okay, JSON serializer, we'll do control dot to use system.text.json, JSON serializer dot serialize, and then we'll take our pagination header. Okay, so we take that header, we serialize it right into JSON object, and then we append that as a brand new xpagination header in the response back to the client. Okay, like I said, this is going to help the client to know how many are the total pages that it has to account for when it renders the UI. And with that in place, we can now go into our endpoints, right? So games endpoints over here, and we can start taking advantage of that header. So to do that, what we're going to do is let's go back into our get endpoint, get all endpoint. This is the B1 for get endpoint over here. And we're going to just open up a couple of lines here. And the first thing is to figure out, well, what is the total count? And that's what we're going to be using that brand new method that we added to the repository. So total count is going to be await repository.count async. So that gives us a total count. And now we need to add the header into the response, right? And so, but before we can do that, we actually need the response object so we can use it. So for that, we're going to be adding a brand new parameter into our endpoint. So we're just going to add one more here that we're going to be calling HTTP context, HTTP. Okay, and so this HTTP context includes all of the information about that HTTP request that is coming in, right? And gives you access to headers for the request and the response. And there's a lot of things that you can do with this object here. So we're going to be using this object to access the response. So we're going to be doing HTTP.response, and then we will do add pagination header, the brand new method that we created in the other extension method. And then we'll just say total count here, and then for the page size, that's going to come from request.page size. And that will make sure that that information about the total count is returned back into the client when we make a return back from this endpoint here. Yeah, so that will do it for this endpoint. And then we have to do, of course, the same thing for our V2 endpoint. So let's go ahead and let's just copy this HTTP context into our V2 endpoint. So let's go down here, V2 endpoint, I'll do comma. So now we have the HTTP context. And then let's also do the same idea, right? So I'll copy these two lines into our V2 endpoint there. So we get our total count, and then we add the corresponding pagination header. And then one last thing to do about this header is that we need to update our course policy so that it also allows this header. Otherwise, the course policy is just not going to work for us because of this new header. So let's go down into our Explorer. Let's go into course and into course extensions. Okay, so let's scroll down here. And then what we want to do is just go down into our add game store course method, into the add course. And here's where we configure the policy, as you remember. So all you want to do now is just say at the very end dot with expose headers. This is going to specify which headers can be exposed back from the server back into the client. And here you want to paste the name of that brand new header. So if you go back into HTTP response extensions, you remember the header name is xpagination. So I'm going to be copying that name, copy that into course extensions and just paste it here. And now that header is allowed to be returned back into the client. And so with that, our pagination implementation is pretty much done. And all that's left is to verify that things are actually working in our clients. So in the next lesson, we will try out our pagination support in both in Postman and also in our client application. With our pagination support now fully implemented in our .NET REST API, it is time to go ahead and test it out and see if things are working as expected. So let's go ahead and start our server. So I'm going to start .NET Run, my REST API right there. And then I'm going to go back into Postman, where if you remember last time when we tried get all, we got all of our elements from the database, right? So all of our games. And so it's just too much. So now we're going to start trying to use pagination. So in this case, I'm going to say that we're going to be using page number equals 1. So that's going to be our first parameter. And then we're also going to say that the page size is going to be 5, which also matches, I think, the default that we have set up. But yeah, so that's what we want to return. So just first page of 5 games. So I'll go ahead and hit send. And notice that this time, if I can collapse this better, we get 1, 2, 3, 4, and only 5 games. So we don't have that big list of games anymore. It's only 5 games. And in fact, notice that, so this starts with Minecraft for Nintendo Switch, right? So now I can say, okay, so now I want page 2. So I'm going to switch 1 to 2, and I'm going to hit send. And this time we start with Mario Kart Deluxe, right? So ID 9. So we get games 9, 10, 11, 12, and 13. So it is page 2 of type of size 5. And if you wanted to, we can also modify this so that the page size could be, let's say, only 3, right? So I'll say 3, I'll hit send. And now we are getting only the 3 elements of the second page of our list, right? So FIFA, Super Mario Bros. 3, and Mario Kart 8 Deluxe. So both page number and page size of the entire pagination experience seems to be working just fine from the Postman point of view. And so now let's go ahead and back into our client. And let's see if it can also take advantage of this new pagination support. So let's go ahead and just refresh the clients. If you don't have it running, let's just go back into the GameStore.client application and hit .NET Run from your GameStore.client directory in the root. So run it, and then back into the client. I'm going to go ahead and refresh this. And as you can see, now we get only 5 games here. So we don't have the big list of games anymore. It's just 5 games. And our pagination experience has been activated. As you can see down there, we are in page 1. We have a previous link, we have a next link, and those should work. So let's try it out. I'm going to go to page 2. Okay, and now we are in page 2. Let's start with Mario Kart 8 Deluxe. Page 3 now only has Hogwarts Legacy, right? And then back to page 1, and we can do next, and we can do previews. So yeah, all this pagination is working fine. And now this is a much better experience for the clients because they don't have to wait until we load what could be potentially hundreds and hundreds of games coming from the database. It's just as many as the client is requesting, right? So the client has it configured to return only 5 at a time, right? So that's why we see 5 here, which also matches the default in the REST API. Yeah, so this is great. So the pagination support is now enabled and bringing us great experience here. And then the next thing that we want to implement is what is known as search, right? So as you know, we have this search box over here, and we want to figure out a way to let our users search across our big list of games. So to search either by name or perhaps by game. So in the next module, we will go ahead and implement this new important feature that is known as search to support our clients. In this module, you will learn how to implement basic search functionality in your REST API. By the end of this module, you will have a solid understanding of the following: how to add search support to your repositories, how to add search support to your endpoints, and see how pagination and search can be used together when integrated to the client UI. The first step towards implementing search in our .NET REST API is going to be to update our repositories so that the relevant methods can accept a brand new filter parameter that we're going to be using for the input for the search. So let's go now into our repositories, and we're going to start with our interface, iGames repository. And let me collapse this. What we're going to do is to update our getAllAsync method over here by adding a brand new parameter at the very end, which is going to be a string filter. Okay, and the idea is that in this parameter, the caller can pass in whichever text we want to filter on, and then that filter is going to go into the name or into the genre of the games. So we'll only be returning the games that match either name or genre for that filter word. Now, it might be that the user or the client is not asking for any filter at any given time, right? So they just want to see all the games. So because of that reason, we want to allow for nullables in this parameter. So we're going to add a question mark here to say that this is going to be a nullable parameter. But then we need to do one more thing here, because remember that we also have our countAsync method over here. And that one, when it counts, it now has to also account for the filter that the user has specified if there is any filter. Otherwise, the count is going to be inaccurate. We're going to be returning the wrong number of pages back to the client. Let's go ahead and also add the same filter parameter into our count method there. So with that in place, let's go into our first repository, Entity Framework Games repository. And of course, we need to implement this new parameter. So let's go into our getAllAsync method over here. And let's go ahead and add our brand new parameter, string filter. Okay, and let's actually do the same thing for count, right? So let's go for countAsync. There is the filter. So going back into getAllAsync. Okay, and so what we have to do here is basically go ahead and run this very same query that's here, but before doing any order by, skip, take, or anything like that, we need to add kind of a where clause where we perform the relevant filter. And that's only if the filter actually has some sort of a value. Now, interestingly, we'll have to do pretty much the exact same where clause for the count down here, right? It's the exact same where clause, and also needs to account for nullable filters. So because we need to do the same thing here and there, we're going to start actually by creating a brand new helper method here so that we don't have to write the same code twice. So let's go at the very end of the file. Okay, at the very end, we're going to create a brand new function that is going to be just a private method. It's going to return iQueryable, which is what our methods need to keep chaining other calls. It's going to return game for the type parameter. So it's going to be an iQueryable of game. And then we're going to say filter games. And then we receive our string filter. So I'm going to copy that from there. So the filter could be nullable. And here comes the logic, right? So the first thing that we want to check is if the filter is null or not. So if, and we're going to do string.isNull or white space filter. That case, all we're going to do is just return dbContext.games because there's nothing to filter on. So we just go ahead and return that. Otherwise, let me scroll down a bit. We're going to go ahead and actually do the filter. And to do the filter is very straightforward. So all you have to do is the following. Return dbContext.games. And then we're going to go to the next line. We're going to do .where and then where game. So like I said, we're going to be filtering on name and on genre. So game.name contains the filter, or else game.genre contains the filter. And yeah, that's pretty much it. So this is always going to return the list of games either filtered or not. And if it is filtered, it's going to be because we have games that in the name have the filter or in the genre have the filter. And with that in place, we can now go back into our methods, getAllAsync over here. And instead of just saying await dbContext.games, what we're going to say now is await filter games, passing in the filter. And then we chain the other calls, right? So I'm going to do this. So whatever comes out of the filter, order by, skip, take, and as not tracking. And that should give us the expected result. I'm going to copy this call here down into countAsync over here. So that we do the same thing, right? So we're going to put the filter there, filter games, the filter, and then we count whatever comes out of that filter. That's pretty much it. That's what we have to do in our Entity Framework Games repository. And with that in place, what we're going to do is the same thing, well, something very similar in Memory Games repository, because we have to satisfy the interface. Once again, if you don't have that in Mem Games repository anymore in your code base, then you can skip this part. I do have it, and I like to keep it. It can be handy. I am now in Mem Games repository. At the very end, just after count, I'm going to add this helper method that we created in the other repository. But of course, in this case, things are going to be a bit simpler. We're going to just return games here. And of course, in this case, we're not returning iQueryable, but instead just enumerable, right? So this is not using Entity Framework. So iNumerable. And then lastly, at the very end, we're just using games, not the contest.games, right? So I'm going to do it like this, and that should do it. So that's our filter games in our in-main get repository. And then let's go down into our get all async method, where we're going to be needing that parameter string filter. And then we're going to say, instead of games, we're going to do filter games with the filter, and then we're going to be doing skip and take. And the same idea, we're going to copy that and into count async, and we're going to do filter games.count with the filter that we're missing here, string filter right there. Now in this case, count is no longer a property, it is a method, so we also have to change it so that we call the right. And with that in place, our repositories are ready to have this search support. And in the next lesson, we'll go ahead and also add search support into our endpoints. Now that we have search support in our repositories, we are ready to go ahead and update both our DTOs and our endpoints so that we can receive this new filter parameter from the client and then send it over into the repositories to do the actual search. So the first thing to do is going to be to update our DTO. So let's go into dtos.cs over here, and let's look for our get game DTO. In this case, let's do B1, get game DTO B1. And as you might guess, all we have to do here is just to add a brand new parameter, which is nullable because we don't know if we're going to get any search filter or not. So it's going to be filter, and then we will default to null. So now the client can specify if he wants to do filter or not. So we'll do that, and then we'll do the same thing with get game DTO V2. It's one over here, and I'm going to also add that same parameter. So with that in place, we can now go into endpoints and games endpoints, which is red right now because we changed the interface, right? So it is complaining about that. So that's exactly what we're going to fix now. So we're now in the get all endpoint, get all for B1. And all we have to do now is just to pass in that filter from the request into the repository. So in this line is where we are doing the count. So for count, now we're going to say request.filter. And then for get all async, this one over here, we're going to be opening a new parameter, and let me actually send this to the next line, otherwise we cannot see well. New parameter, which again we do request.filter. Okay, and after that we'll do select. So let me take this down there. And so that's how things are going to look like. And of course, we want to do pretty much the same thing with our V2. So let's go down into V2. So same idea, request.filter. And then we're going to again send things to the next line like that. And then we will do request.filter there. And then let's go ahead and accommodate things a little bit. And yeah, with that, we have our .NET REST API ready to do search. So in the next lesson, we will go ahead and try out search both from Postman and from our client application to see the new experience running end to end. All right, so now we have search support in our .NET REST API, and what we want to do is just test to make sure that things are working as expected. So I'm going to go ahead and start my REST API here in my terminal, in the Getting Started API directory, and then I'm going to go into Postman over here, where right now I do have the page number and page size that we've been using in the previous lessons. But for this purpose, since we want to do searches, what I'd like to do is just get a big page size so that we can search across of all of those games as opposed to just a small subset. So what I'm going to do is that, well, page number is going to be 1. And then the page size is going to be 15, just because I know I don't have more than 15 games in my database, so that should be good enough for all of my games. So I'm going to go ahead and hit send, and now I can see all of the games that I have available here, right? Yep, so these are all of my games, and so now I want to do the search. So to do the search, I'll just do ampersand to append a new parameter, and then I'll just do filter, and then here we can choose something to put in there, right? So let's say we want to look for all Mario games. So I'll do Mario right there, and then I'll click on send, and notice that this time I only get 2 games. So let me see if I can make this bigger. Yeah, so I only get these 2 games because both games have Mario there, right? So Mario and Mario. So searching by title seems to be working just fine. I could also look for, let's say, FIFA. I'll look for FIFA, and then I get my FIFA game right here. Awesome. And then perhaps I want to look now for a genre. So let's say I like role-playing, right? So that's the genre that I like. So I'll click send, and now I get all of the games that have the genre, the role-playing genre, as you can see. Or if I want to look for sports, and by the way, I can do this without, this is case insensitive, right? So if I just do sports like this without capital S, lower s, I'll hit send, and then notice that it works. I got my 1 game that has sports in there. So things are working properly from Postman, but of course we want to see if this actually works also from the client. So I'm going to go back into our client. Here's my client application. I'm going to do a quick refresh here, just in case. And so, yeah, so let's do something similar. I'm going to be looking for my Mario games here, and notice that right away the filter works, right? And it's very, very fast, right? So now I have all my Mario games. I can look for my FIFA game. I can look for my Final Fantasy games, right? It's right there. I can also look for sports games. I can look for kids and family games. As you can see, filter is working properly and it is very fast. Now, of course, one optimization that you may want to do in your client, if you wanted to modify this client, is to not do a search right away as soon as people types characters, right? Otherwise, it's going to be a lot of calls. But we're not going to be worrying too much about the client in this course. And so what we want to do now is to do one more thing, which is verify that this is actually working with pagination. And I think it is. I mean, as you can see, if we look for, once again, right now we have three pages, right? So, but if I look for Final Fantasy, notice that pages are reduced to just one page. So search is working properly, accounting also for pagination, right? So if I look for racing, so I have one game, so that's racing. Let's see sports, yeah, just one game. Let's look for role playing. Okay, we have 5 games, and again, paging is working properly right there. So search and paging are working great. And so of course, at this point, we have most of the features in the REST API needed to light up this client here. And of course, what we're missing is the images, right? So how to load images. But before doing that, what we're going to do in the next module is to touch on another important aspect of a professional developed REST API, which is how to generate your API documentation. So let's go into the next module. In this module, you will learn how to generate API documentation for your REST API so that other developers and clients can easily tell what it can be used for. By the end of this module, you will have a solid understanding of the following: how to add OpenAPI and Swagger support to your REST API, how to enable the Swagger UI experience, and how to add metadata to your REST API via OpenAPI. The first step towards documenting our REST API is to add OpenAPI support. And OpenAPI is nothing more than a specification, as you can see down here, is a specification language for HTTP APIs that provides a standardized means to define your API to others, right? So this is how you can let others discover how your API actually works. And so based on that, perhaps they can generate some client code to interact with your API, or just to figure out, exactly what is included in the API. And so luckily, in order to enable OpenAPI in your REST API, there are a bunch of NuGet packages that you can already use to do this kind of automatically. So let's see how that's going to work. So let's go back into Visual Studio Code here for our .NET REST API. And the first thing we're going to do is to add those NuGet packages. So let's open up our terminal here at the directory of GameStore.api, right? So we're going to add 2 NuGet packages. First one is going to be .NET add package. The package is swashbuckle.aspnetcore. Okay, swashbuckle.aspnetcore. So this is an open source NuGet package that already knows how to generate this OpenAPI specification for ASP.NET Core applications. And then the next package we're going to enable is this one called, let's see, .NET package asp.versioning.mvc.api explorer. Right, asp.versioning.mvc.api explorer. And so I'll hit enter, and this one here is to add proper support for versioning into this OpenAPI specification that we're going to be generating. So we have to use this one because we did enable versioning via the asp.versioning NuGet package before. And so with those 2 NuGet packages in place, let's now close terminal. And the first thing we're going to do is to create a brand new class, which is going to be what we're going to call the Swagger options, that are going to be providing the means to specify how we're going to be using the versioning information to fit that into the OpenAPI specification that's going to be generated. So let's go ahead and create a brand new directory under GameStore.api. It's going to be new folder. Let's name it OpenAPI. And in this one, let's go ahead and right click, new C# class, and the class is going to be configure Swagger options. So let's collapse this. Let's fix this namespace and let's remove these unnecessary usings. Now this options class has to implement iConfigure options. All right, and for this one, control dot, and let's use Microsoft.extensions.options, and then this is going to be Swagger gen options. Okay, just like that. So let me do control dot here so that we can use swashbuckle.aspnetcore.swaggergen. And one more thing, of course, is let's just do control dot here so that we can implement the interface. As you can see, all we have to do is just implement one method here. And before doing that, let's go ahead and declare just one variable at the class level over here. This is going to be private read only, and this is going to be of type IAPI version description provider. And let's do control dot so that we can use ASP.versioning.API Explorer. And this is going to be just provider. And of course, we have to inject this variable into our constructor. So let's do generate constructor configure side options with IAPI version description provider there. So this is going to provide us the information about the versioning of our REST API so that we can embed that as part of the OpenAPI specification. So now let's head down into our configure method over here and let's see what we have to do. Really, what we want to do here is first to cycle through the different API version descriptions. Then we're going to go ahead and define OpenAPI information about each of those versions. So we're going to do for each var description in the provider .api version descriptions. And for each of those, we're going to say options.swaggerdoc. Okay, and let's move to the next line for this one because there's going to be some code here to write. And then here we're going to say, and this specs a few parameters, right? So let's take a look at the parameters. The first one is the name for this SwaggerDoc, and then the other one is the OpenAPI info. So let's give it for the name. We're going to be using description.group name. And then for the OpenAPI info, we're going to say new OpenAPI info. Okay, let's do control dot using Microsoft.OpenAPI.models. Okay. And for this one, we need to set three properties. The very first property is the title, because this is going to be the title for the specification for this one version, right? So this is going to say, so let's say the following. I'm actually going to be using string interpolation here. So this is the game store API. And then here in curly braces, we're going to be using description.api version. Next property is going to be the actual version. So version is going to be, again, description.api version, and this one is going to be toString. It has to be a string. Lastly, we're going to add a description. So for description, we're just going to say that's something very standard like manages the game's catalog, because that's what it can do for now. So that's it for our brand new configure Swagger options class. And now it is time to go into Program CS to start taking advantage of this one and a few other things from NuGet packages. So let's go now into Program CS, right? Explorer, Program CS. And so we want to now go first into the section where we're doing add API versioning over here. And here is where we're going to be expanding the configuration for versioning so that it also accounts for our OpenAPI specification. So I'm going to just add a dot here. So we can do add API Explorer, and this is going to receive some options. So options, and for those options, we're going to say options.group name format, because here's where we're going to be providing the format for how the version information is going to show in the OpenAPI specification, right? And so that group name format, ASP.NET versioning package provides some kind of formatting convention that we can follow here. So that format is going to be the following. So check this out. It's going to be, let's add double single quotes in there, and inside those single quotes we're going to put the small v, right? So that's going to be the prefix, so it starts with small v, and then we want to put v. So what that means is that the version is going to show as a v with the prefix, and then the first v is for the major version, next v is for the minor version, and then the last v is for what they call the status. I have not yet seen that happening, and I don't think we have a status in our versions so far. But yeah, that's how you configure the API Explorer that the versioning NuGet package is going to need. And with that in place, what we can do now is to add the actual services for OpenAPI generation. So for that, let's do this. In this case, in my line 25, we're going to just say builder.services.add SwaggerGen, right? So SwaggerGen is the method that's going to add all of those OpenAPI generation services. And then the next thing we need to add here is a transient service, which is going to be of the type of our configure Swagger options class that we created before, right? So this is going to be add transient, and then this is of iConfigure options, and this is of type SwaggerGen options, just like that. And let me do control dot here to use Microsoft extensions options, and control dot here to use swashbuckle.ASP.NET Core.SwaggerGen. And then the next parameter here is of course the name of our class. So configure Swagger options. Okay, so for that one, control dot and we're going to be using GameStore.api.OpenAPI. So that will make sure that the options that we have set up here for versioning in OpenAPI will be used, right? Last thing is that we need to make this call to add endpoints API Explorer, because this is needed only when you create the API endpoints the way that we created them with the minimal API framework. You will not need this if you did ASP.NET MVC, but for minimal API framework, you have to enable this other set of services. And lastly, now that we have configured all the services in the service container for OpenAPI generation, we also have to update our request pipeline with some middleware so that the OpenAPI specification can actually be generated. So let's do that at the very end, just before calling app.run. So let's go down here and we're going to invoke app.useSwagger. Okay, and that will be pretty much it to add those OpenAPI specification documents into the pipeline. However, usually you don't want to expose this beyond your development environment because it really exposes everything about your API, right? So you want to think twice before exposing this in production. So usually what people will do is just hide this behind a flag that says that only do this in development environment. So that's exactly what we're going to do here. So we're just going to say app.environment.isDevelopment. So only in that case, we are going to go ahead and use Swagger. So that prevents that the information about your endpoints is available in production. So it's really up to you, but in most teams where I have worked, it's only shown in the development environment. And so, yeah, that's pretty much it. So we should be ready to go ahead and try this out. So I'm going to go and open up my terminal over here, and I'll do .NET Run. Okay, and if we configured everything properly, we should be able to now go into Postman over here, and I'm going to go ahead and reuse my very last tab over here, the one that we've been using for the OpenID Connect Discovery endpoint. I'm going to just reuse this one for this purpose because we don't have to play more with OpenID Connect here. So let me just grab my host, HTTP localhost 5115. I'm going to paste that over here. And then what you want to put here is the location of your Swagger document or your OpenAPI specification. So that's going to be located in Swagger, and then / and here comes the version information, right? You have to specify the version information because we're using the version in NuGet package. And then you're going to say swagger.json. Okay, so now you can go ahead and hit send. And as you can see, if we can collapse this a bit, we have our OpenAPI specification here. So you can see that we're following version 3.0.1 of the OpenAPI specification, right? Because it has its own versioning. But then we have our information here, right? Information that we defined via our classes over there. So this is GameStore API 1.0. Here's the description that we set in the code. And here is the version, right? Version 1.0. And then you can see that here we have all of the paths and the endpoints that are defined in our API. So we have /games and we have our get endpoint, and we can see the parameters, right? Like for instance, the page number, the page size, the ones that we enable for pagination are right there, the filter, and then the actual API version to request the version, the version of the endpoint, right? You can see the responses that it supports, right? In this case, at 200, okay. And then we go for our post endpoint, and perhaps I can collapse this a bit. So we have our post endpoint there. And then we can also go for the games by ID, right? So games/ID, that's the endpoint to retrieve stuff by ID. And you can see, so it has an operation ID and it has the parameters. And then, I mean, you could keep exploring this and you're going to find that this describes everything about your REST API as expected, right? So that's the idea of this. So it's a machine readable presentation of everything your API can do so that any other tool can go ahead and inspect this and do something about it to interact with your API. And then remember that since we have versioning, we should be able to also look for version 2 of this. So we can now do v2 right there. And then if we go ahead and hit send, you're going to see that now we have GameStore API version 2.0, right? So version 2.0 right there. And this should only include the endpoints that are available in that version 2.0, which is just get all and the get by ID as expected, right? And so, yeah, so that's a way that you can enable OpenAPI in your REST API. But of course, this is kind of a machine readable version of that OpenAPI specification. What if we want to get more of a UI friendly version of this so we can better tell exactly what is in the API? That's what we're going to see in the next lesson, where we're going to see how to enable Swagger UI in our .NET REST API. Let's see now how to enable UI-friendly version of our OpenAPI specification for a REST API via the Swagger UI tooling. So let's now go into Program.cs and let's scroll down into that section where we already enabled the use Swagger in the pipeline, right? So let me collapse this. Okay, close to the end. And what we're going to do is to make one more call here to call another method related to Swagger. So this is going to be app.useSwaggerUI. And for this one here, we're going to pass in this options object, and we're going to be opening a Lambda expression there. And here what we're going to do is to generate a Swagger endpoint in the UI for each of our versions. So what we have to do is the following. For each var description in app.describe API version, which is provided by our API version in NuGet, we will go ahead and first thing is going to be to calculate the URL for the Swagger JSON file, right? So that's going to be var URL equals, and this is going to be string interpolation. So here is going to be Swagger, and then it's going to be our description dot group name, and that's going to end in swagger.json, right? Next, we're going to be defining the name for our endpoint. So the first one is the URL, the next one is going to be the name. So for the name, we're going to say description dot group name dot to upper invariant, right? So to make it all uppercase. And finally, we're going to set options dot Swagger endpoint, and then we'll pass in the URL and the name. And so that's pretty much what we have to do to enable the Swagger UI experience. So what we can do now is to just go ahead and test it. So let's go ahead and do .NET Run, and I'm going to copy the location of my host. I'm going to copy this, keep it on my clipboard, and I'm going to open up my browser over here, and I'm going to go into that location /Swagger, right? Hit enter. And as you can see, now we have the UI experience enabled for our REST API. And at the very top, you can see the name of our version 1 of our API, which is GameStore API 1.0. Then you can see the corresponding Swagger OpenAPI specification that is related to this UI version that we're seeing right now. And you can always just click there, and I'm going to right click and open this in a new tab. And that's going to take us back into that OpenAPI specification that we talked about in the previous lesson, right? So it's right there. Yeah, you can see the description over here that we specified. This manages the games catalog. And then you're going to see all of the endpoints that are available right now in the API, right? So you can see our get all endpoint, this one over here, and it's going to show a few details about the API, like all of the parameters that are supported, right? Like the page number, the page size, the filter, API version, all of these things are supported, as well as it's going to give you the basic responses that it supports. Right? In this case, it's saying that it supports 200 OK. And then for each of the other endpoints, you're going to see a similar thing, right? So here we have post, right? We have an API version, and then here is an example request body for the post. If you want to get an idea of how you would post something into it, here's the example that you can follow for that. And then you can see an example of the responses too, right? So here's an example response, but this is kind of a response for the error response, right? So it's only showing the error response. It's not showing a successful response just yet. We're going to tackle that in a future lesson, but yeah, it's showing that. And then same idea, it will keep showing all of the details about all of your other M. Also at the bottom, you can see that we have the schemas, right? So this section has all of the schemas for the supported DTOs that we have so far in our REST API. It's not all DTOs, but some of them are here. So we'll tackle that later too. And then you can expand this and you'll be able to see what is supported for each of these DTOs, all right? And of course, for each of these endpoints, you can also go ahead and if you wanted, you can click this button here that says try it out. If you wanted to try out the API and see what kind of values you can get. So I'm going to just click on that one, try it out. And then that will enable all of these boxes here, as you can see. Enables these boxes. You can change the values. I'm just going to leave the defaults. I'm going to click on execute. And down here, you can see the actual request that was sent. Here is the real request right here. And then down here, you can see that we can see the actual data that is coming down from the API, right? It's the real data coming from our database for our get all endpoints. Now you could do the same thing with the other endpoints, right? With post and with put and all of those, but those ones actually require authorization. So there is extra configuration that you would need to enable that kind of experience here. For that, we're not going to cover that in this course because really I have not seen many developers actually trying to execute and try out payloads directly in this page. For that, you most usually will just import the OpenAPI specification into Postman, and in Postman you will do all of your tests with the API, but not really in this page. So that's why we're not going to cover that additional configuration. One more thing that it's available here, so let me show you, is the versions, right? So if you can see at the top over here, we are looking at version 1 of the API. But of course, you can then switch this into version 2. And now you are seeing version 2 of the API. So in this case, as you know, we only have the get all and get by ID endpoints. Those are the only ones available in version 2. So yeah, that is the Swagger UI, and it can be very handy for other developers when they onboard into your project. You can just point them to this URL and they can right away see all of the endpoints available in the API and what can be done with them. Now let's head back into VS Code very briefly here, and what we're going to do, just so that we don't have too much code over here, we're going to wrap up this section here into another extension method so that we can clean up things a little bit. So let me just go into Explorer here, and let's go into the OpenAPI directory. We're going to be creating a brand new C# class. This is going to be named Swagger Extensions. All right, Swagger Extensions. And in this one, as usual, first thing is to convert the namespace and remove needed usings. Let's make it static. All right, static class. And the one method we're going to define here is public static iApplicationBuilder, and then use game store Swagger. We are going to be extending web application, and the name is going to be app. And here, all we're going to do is just copy that code that we have over here, all of this code, including the if, right? We'll paste that here, there. At the end, we're going to be, sorry for that, we're going to be just returning the app object so that other calls can be chained into the call into this method here. So yeah, with that, we have our extension method, and now we can go back in Program.cs, and then we can just invoke. And let me come here. Instead of all of this, we're going to say app.use game store Swagger. And with that in place, let's just test it out, make sure that it keeps working just fine. So I'm going to run this, and then I'm going to go back into the Swagger UI page. I'm going to refresh this, and yeah, it keeps working. Switch back to version 1, and things are looking great. So perfect, that's great. And then what we want to do is to start adding a few more details into this description of the OpenAPI so that we get proper details for every single endpoint, right? So for instance, for post, like we said, we only have details about the 400 bad requests, but there's actually a good request that we could return from this, right? That's not showing up anywhere here. So in the next lesson, we'll see how to further describe the different response types supported by our endpoints. Like we mentioned in the previous lesson, we are currently not able to see all of the response types that are available in each of our endpoints, right? And that is because we have not added enough description of those response types in the endpoints themselves. Let's see how to fix that. Let's go into endpoints and then games endpoints. And let's start looking at our endpoints, right? So if you start scrolling down, the very first endpoint that we have here is our map get for all, right? So get all games. Now this one, we're not actually going to document anymore, at least not for response types, because really, I mean, the only response type is going to be okay. So there could be like a 500 error. Of course, if we cannot talk to the database, for instance, for some reason, or there's some errors with the database, but those ones we're not going to be worrying too much about. So what we're going to do is just scroll down into our second endpoint, which is map get by ID. Because this one here, as we know, could return an OK in this case, right? When we are able to find the game, or a not found if we are not able to find the game. Now, that is not being reported properly back into the OpenAPI specification. So how to fix that? Well, what we can do is to actually switch from this results class over here and into another one that is called typed results. So by doing this, we're going to be returning back enough metadata for ASP.NET Core to be able to actually report that those response types back into the OpenAPI specification. So we're going to do type results.OK in this case, and in the other case, we're going to do type results.notfound. Now, of course, this is causing kind of an issue here because each of these ones are now returning kind of a different type. So if we quickly look at the OK case here and we do F12 on OK, we're going to see that this returns an OK of t value, right? While in the other case, type results.notfound, if we do F12, this returns just a not found object. So there is kind of a mismatch between the two different types of results that we can get here, which is different from the results class we were using before. So we have to do something to accommodate for that. And that something is to just modify the signature of the delegate that we're defining here. So what we're going to do is the following. Just after async, we're going to define here that we're going to be returning a task of type results of type OK, and then of type GameDTO-v1. And so that's going to be one of the types. And let me do on top of OK, I'll do a control dot. So we can use Microsoft.ASP.NET Core.HTTP results. So that's the first type. And then the other type just next to this one is going to be not found. And then we close the type argument. So by doing this, we are saying that it's kind of a multi-results object that's going to be coming back that could be of type OK of GameDTO-v1, or it could also be not found. Okay, and that satisfies the restriction of the different types that we have down here. And just like we did this, we'll have to follow the same idea with our v2 endpoint. So not with the get all, but with the get by ID. So now we are in get by ID in version 2. So this is version 2 of the endpoint. We'll do type results, and then we'll do type results. And then let me just go ahead and copy the signature that we added up here. Copy that and scroll down into our other endpoint. And I'm going to paste that over here. But remember that this is not GameDTO-v1, this is GameDTO-v2. So that's how your method should look like. And just by doing this, you will notice that the results are going to be different in the Swagger UI. So let me just run this very quickly so that we can take a quick look. So I'll do .NET Run now. And then I'll go back into Swagger UI. I'm going to refresh this. And then let's look at the endpoint that we just changed it. So we just changed it get by ID, right? So now if we scroll down here, you're going to see that now we have both of the results, right? We have the 200 error, the 200 code, which is a successful code. And we also have the 404 not found error code. Right? And we also have the example value for the successful case here. So both the results are reported now. So whoever is going to consume or use this API knows of the different types that we will be returning from the endpoint. Okay, so that's the benefit of what we're doing here. And just like we did this, we have to do something similar with the other endpoints, of course. So let's go back into Visual Studio Code, and then let's go back into map post in this case. And here where we're saying result, we're going to say now type results. Right, type results that created at route. And at this point, we do have to change things, the ordering a little bit, because I think the order of the parameters changed by using type results. So what we're going to do is just take the game object at the very end, put it at the first parameter there. But this is going to be game.asDTO-v1. And then we have our getGameV1 endpoint name, and then we have the anonymous type with the ID. Okay, I think that should do it. And then of course, at the declaration of the delegate here, we're going to be adding, just after async, we're going to be adding task of created at route, and then of GameDTO-v1. Okay, that should be enough for us to present the correct successful result for the post operation. Then we are going down for our put endpoint over here, which, as you remember, it can return either a not found or a no content. So we're going to do here type results not found, and down here type results dot no content. And again, since we return two things, we have to modify the signature. So we're going to do here task of results, and this is going to be not found for the error case, and then no content for the happy path. So that takes care of put. And lastly, we're going to take care of delete, which again can return no content as the only type. So we're going to just say here in this case type results no content, and that should be good enough for this endpoint here. And yeah, if you didn't do this for delete, even when there's just one return type, if you don't do this, then it will believe that it always returns just 200 OK, where are actually returning a no content result, 204, right? So this is kind of required in the case of delete. Now, since there's only one return type, you don't have to modify the signature over there. So just returning no content with type results should be just fine. So with that, let's go ahead and rerun this. So let's run the server, and let's see what we get in Swagger UI. Over here, I'm going to refresh the page, and then let's see, we just modified post. Let's see what we get for post. So in this case, now we have our 201 created, and then now we have also our 400 bad requests, right? Now we also have the payload for the post over there, which is awesome. So that is working fine. And then we also modified put. So let's see what we get for put. So yeah, we have, again, we have our 204 no content and our 400 bad request. That makes sense. And then we even have the 404 not found, right? So T response types there, right? So that's great. And then lastly, we have for delete, we now have the expected 204 no content. So yeah, this is working great. And so at this point, we have a much better idea of what exact responses each of our endpoints can return. And so at this point, what we're going to do is go into the next lesson where we're going to see how to add even more details like summaries, tags, and descriptions to our API documentation. Let's see how to add even more metadata information into our different endpoints via OpenAPI. And for that, what we're going to do first is to add a brand new NuGet package. So let's go ahead and open up our terminal here, and we're going to be adding, so let's see, .NET add package is Microsoft.ASP.NET Core.OpenAPI. Okay, so this is a package that allows us to actually extend even more the types of documentation that we can do in our different endpoints. So I'm going to close this now. And now let's go back into our games endpoints class, this one that I have open right here. Scroll down into the start of map games endpoints. And then into this chain of calls that defines our group, we're going to go ahead and chain two more calls. First one is going to be dot with OpenAPI. Okay, so that's going to enable all of these additional metadata that can be used by our endpoints. And then we're going to add our first piece of additional metadata, which is going to be a tag. We're going to say with tags, this is a group of endpoints meant for game management, right? So just for games. And you'll see in a future model how we're going to be standing up another group of endpoints with pretty much one endpoint, but another group that's going to be for another purpose. So this is going to be a good way to say that this is the group that is meant just for game management. So we're going to say here, just games. So that's the first thing. And then the next thing we're going to do is to go through each of our endpoints and add a meaningful summary and description. So let's go down into, this is our get all endpoint here, right? So this is get all for B1. And we're going to go at the very bottom, right? So let me scroll down. At the bottom, we're going to say now with summary. And here you can provide whatever summary makes sense for you that describes clearly what this method is about, right? So giving even more information to whoever is looking at your API. So we'll say that this gets all games, right? Gets all games. And then we'll do even more with description. And we're going to say gets all available games and allows filtering and pagination. And then since we also have a v2 of this endpoint, let's go ahead and copy this documentation into that v2 endpoint over here for get all. I'm going to just paste that over there. I'm going to remove this. And okay. And so, yeah, so that will document our get all endpoints. And let's now look at our other endpoints, right? So let's go a little bit up into get by ID, this one over here. So this one here, with summary. The summary for this one is going to be gets a game by ID. And then with description, so this one gets the game that has the specified ID. And then let me just copy this so that we can go ahead and pretty much document the same thing for v2 of our map get by ID. There. All right, so it's time to go for our post method. So let me scroll down here. So this is going to be our post method. So let's open up a section here. I'm just going to paste the same thing here so that we can just change the description, right? So about post, we're going to say that this endpoint creates a new game. And for description, we're going to say creates a new game with the specified properties. So that's going to be for post. And then let's scroll down into our put method. Down here, just here. And then for summary, we're going to say that this updates a game. And for description, this is going to be updates all game properties for the game that has the specified ID. And lastly, of course, we are going to go for the delete at the very end over here. And so this one here deletes a game. And then we will say deletes the game that has the specified ID. Okay, so that should do it for documentation of all of our endpoints. So let's go ahead and see how this changes our Swagger UI experience. So I'm going to go ahead and do Ctrl J. I'll do .NET Run. Okay, so we are running this. So let's head back into Swagger UI. So take a quick look at how things are looking right now. Okay, I'm going to collapse this. There. Let's just refresh this and notice that now our entire group of games endpoint has been renamed into just games. Look at this. It doesn't say Game Store API anymore. It's just games because all of these endpoints are for the games, and that allows us to then have another group later on that's going to be potentially for other set of endpoints. And then if we open up gets all games, you're going to see that actually, I mean, if you notice, this was not there before, right? So it says here gets all games, creates a new game, gets a game by ID. All of these were not there. We just added all of those. So now whoever looks at this Swagger UI can really tell what exactly this endpoint is about, right? These endpoints are about. And then if you further expand this, you can now see a complete description right here of what this endpoint is about, right? So, okay, so gets all available games and allows filtering and pagination. Okay, awesome. So now I know what this endpoint is about. And same idea now for all of our other endpoints, as you can see. Okay. So for get, for put, we have all of that information all the way to our deletes. Yep. So that's all there, that's all in place. And yeah, I think one thing that I didn't show before is that we also now have all of our schemas reported here. So that's all working great. So yeah, so with that, we are pretty much done with documentation for our REST API. And we're ready to move to the next exciting thing in this course, which is going to be our integration for production environment, right? So in the next module, in preparation to take our REST API to a production environment, we're going to start learning about Microsoft Azure and the many things that you can do with it. In this module, you will get a quick introduction to Microsoft Azure in preparation to using the few Azure resources you will need in the following modules. By the end of this module, you will have a solid understanding of the following. What is Microsoft Azure? How to get your free Microsoft Azure account? How to use the Azure portal? And how to create an Azure resource group. In this lesson, you will get a quick overview of Microsoft Azure, what it's used for, and the range of services it provides. The video that follows was taken directly from the Introduction to Azure Fundamentals module in the Microsoft Learn site, since it provides a better overview of Azure than anything I could come up with. Let's see the video.
What is Azure? Azure is Microsoft's cloud computing platform with an ever-expanding set of services to help you build solutions to meet your business goals. Azure supports infrastructure, platform, and software as a service computing with services such as virtual machines running in the cloud, website and database hosting, and advanced computing services like artificial intelligence, machine learning, and IoT. Most of Azure's services are pay-as-you-go. You only pay for the computing time that you use. If your business needs complete control over your computing environment, Azure allows you to host virtual machines in the cloud. You can create virtual machines from scratch, upload your own virtual hard drive, or choose from an array of templates that Azure provides. Azure also provides cloud-based storage, which allows you to store your application or backup data safely and securely. Azure's app services provide a scalable hosting platform where developers can create web-based applications using popular development frameworks. You can easily deploy, operate, and scale your apps in a fully managed environment. With Azure Functions, you can create event-driven, serverless applications with no coding required. Azure Container Instances and Azure Kubernetes Service allow you to deploy containerized applications with fully managed services. Azure offers a choice of fully managed relational and in-memory databases, spanning proprietary and open-source engines, and Microsoft's Cosmos DB provides support for several popular NoSQL APIs. Azure's artificial intelligence and machine learning services empower developers and data scientists with a wide range of productive experiences for building, training, and deploying machine learning models faster. Azure's regional data centers allow you to distribute your applications globally, so you can locate your data and apps where they're needed most, thereby improving your application performance for your customers. The Azure portal lets you create, configure, and control all your services and resources from a single, easy-to-use web-based interface. Microsoft Azure offers a wide array of cloud computing services where infrastructure management, scalability, availability, and security are handled for you, saving you time and money.
In this lesson, you will learn how to get access to Microsoft Azure by signing up for a free account on the Azure website. The video that follows was taken directly from the Introduction to Azure Fundamentals module in the Microsoft Learn site, since it provides a great overview of how to get started. After watching the video that follows, you can go to https://azure.microsoft.com/free to get your free account, which should be good enough to get through the rest of this course. Let's see the video.
In order to start taking advantage of the wide array of Azure services, you'll need to first sign up for an account. If you are completely new to using Azure, you can begin exploring what Azure has to offer by signing up for an Azure free account. An Azure free account includes access to 20 Azure products free for 12 months, access to additional products that are always free, and a $200 credit to spend during your first 30 days. For more information on signing up for an Azure free account, head here. If you work for a large organization, you may be able to purchase access through a Microsoft representative or through a Microsoft partner. Finally, you can purchase access directly through Azure.com. With pay-as-you-go pricing, you pay only for what you use each month, with no upfront commitment, and you can cancel at any time. Once you have an active Azure account, you may want to create additional subscriptions for resource or billing management purposes. If you have multiple subscriptions, you can organize them into invoice sections. Each invoice section is a line item on the invoice that shows the charges incurred that month. You can also set up multiple invoices within the same billing account by using billing profiles. Each billing profile has its own monthly invoice and payment method. Once your account is active and billing is set up, you're ready to start using Azure. As a part of your subscription, you have 24/7 access to online documentation, community support, and new Azure Capabilities demo videos created by Azure engineers. For more information on the support resources available to you, head here.
At this point, you should have your Azure free account activated, but if you have not done so, if you don't have it ready, please go to azure.microsoft.com/free. So this URL that you can see right there, that's going to take you to this page, and here you're going to go ahead to be able to activate that account, get your Azure free resources, and that should be good enough for the rest of the course. And after that, you're going to be landing in this other page over here, which is what we know as the Azure portal. And the Azure portal is the one place where you manage all of your Azure resources. So let's take a quick look of what you can do with this portal, just so that we don't get lost in future modules. So at the top section here, these are the list of the most recent Azure resources that you have been using so far, right? So the list that you're going to see in your screen now is likely going to be a bit different than mine because, like I said, it's the most recent resources that you've been using. But if you want to see the full list of all of the available Azure resources, all you have to do is either click over here in More Services, or you can also expand this menu at the top over here. You can click over there, and that's going to expand this section where you can click on all services, right? You can keep all services there or more services here. You click on that, and that's going to take you into this screen where you can see on the right side, you can see the full list of all of the available resources, as you can see. And there are dozens and dozens and dozens and dozens of resources available here. Or you can also look at different categories over here for different types of cloud services. So that's in terms of locating the different resources. And then whenever you want to actually create a resource, there's also a few ways to do it, but the simplest way would also always be just going to this screen, and you can click here where it says create a resource, right? So create a resource, and that's going to take you to this screen where you can go ahead and search for the different types of resources that are available, and you can go ahead and create one. So for instance, if you wanted to create a storage account, you can type there storage account, you can click there, and that's going to take you to a few options, I think, for different storage account options in there, which this one will be the most interesting one, right? But I'm going to show you how to create a storage account and other things in a future mode, so that's okay. Now, if you keep going down in the home page here, you're going to see also the list of the actual resources that you have created in your subscription, right? In this case, really the only thing that is showing right now is my subscription over here, my .NET Microservices subscription. So in your case, it's going to show also at least one subscription. It's not going to be named, of course, .NET Microservices. It's going to be named something different, something very generic. But you can always just go ahead and rename that. And in fact, let's click on the subscription over there. Let's click on there. And there is an option to rename your subscription over here. Right there, rename. You can use that option to rename it to whatever name makes sense for you, which is more useful when you have multiple subscriptions, right? If you have one, it's okay. As you have many, then it will make sense to rename it. And Over here, you can also find a few other things that I'm not going to go over everything because it's huge, but an important thing will be access control over here, where you can go ahead and define the different role assignments for people in your team, right, that can have different types of roles, like an owner. In my case, like over here, you can see I am an owner of my subscription. You will be the same, but you can assign other people here so they can have different roles to do things. For instance, a contributor will be able to do most of the things, but they cannot manage permissions, right? You can also have a reader that can read resources but cannot make any changes or create resources or modify resources and stuff like that, right? So it's kind of an important thing. And this access control is at the subscription level. There will be other access control sections for other levels that we're going to be seeing later. And then in this tab here, if you scroll down, you're also going to go into this section here called resource groups. You can find resource groups. And if you click there, you're going to go into this section where you're going to be managing this concept of resource groups. And a resource group is nothing more than a group of Azure services that serve a same or similar purpose, right? You're going to see how we're going to be creating one resource group in the next lesson, I think. And then that group is going to contain everything that we're going to need to deploy our service into the cloud, including database, including the web host and all that stuff. So it's a nice way to group everything together. And when you're done with it, you can just go ahead and delete the resource group and everything goes with that. Now, another important thing in the subscription level here is going to be this tab here, cost analysis over there. Of course, you have your free Azure subscription now, but if you don't, or after a while, you may want to know how much cost is being accumulated into your subscription, right? Just to make sure that you don't get into a point where you actually have to start paying, or you want to keep the control of costs down, right? So this is going to give you a nice chart of how much you have spent so far. You can see my recent usage right there. And so if you have a free account, you will have a limit on the free credits, right? You can use Azure. So just make sure that this is not exceeding those credits after a while. Okay, and this will give you a breakdown per resource and yeah, a lot of good stuff in there. Okay, and then going back to home, and you can always just click over there, just go back to the home, or at the Microsoft Azure logo here to go back to home. Let's see what else we have here. Another handy thing from this portal is the dashboard that you're going to see here in the navigate section over here, the dashboard. So if you click on that one, you can click there, and this is going to take you to a section where you can build your own dashboard of resources, right? So I don't have any resource just yet because we're going to be creating resources in the next lesson. But in this section, in this left side, you're going to be able to just pin any resources that make most sense for you to have very handy on startup. Because if you just go to home, this is going to start getting populated with the most recent resources, right? But if you want to have a static set of resources that you always want to get a handy access to, you just go to the dashboard, you just pin them here, and then you have easy access to them all the time, right? I think you can also configure the portal to just always just go to the dashboard if that makes sense for you. So that's the Azure portal. And one last thing that I can tell you here, and like I said, we're going to be exploring a lot more about this portal across the course, but one more thing is just customization across the UI. And one thing that I like to do is to change the theme to a dark theme, just because this is just too much white for me. So one thing that you can do is just go to this year over there, go to that year, you can click, and then you can go into appearance and start views. And one thing that I like to do is just change my theme to dark. So I'm going to be clicking this one here that says dark. Click on that one. I'm going to click on apply down there. And that's just going to take my theme into that different color. So that works much better for my eyes, at least. So it may work better for you too. So yeah, so that's it for the quick overview of the Azure portal. And so what we're going to do in the next lesson is to create the actual resource group that we're going to be using across the next modules in this course. Like I mentioned in the previous lesson, the way that you group your Azure resources is by using what is known as an Azure resource group, right? A resource group is just a way for you to have all of the resources that have some similar purpose grouped into just one place, so that you can perhaps assign the same permissions to all of those resources in one shot, or perhaps if you want to just clean up everything at the end, again, in just one shot, right? And so it is handy to just put everything together in one place. So to create an Azure resource group, there's a few ways in this portal. So one way would be to click here where it says create a resource. You just click there, and then here you can just type resource group. Okay, so you're going to click on resource group, and then you're going to find the resource group template right here. You can click on create resource group, and that's going to start the wizard, right? Another way to do it, if you're in home, you can also just scroll down, and you could click again in these resource groups section here, and that's going to take us here. Or one last way is by just going into your subscription. If you see the subscription right there, you can click on it and you can go into resource groups on the left, and then you can click on create, right? So many ways to get to this one spot. But regardless, you're going to land into this wizard, and what we want to do here is to first thing, select your subscription. So I only have one subscription here. You may have more than one. Just pick the one that makes most sense for you. And then the name of the resource group, you can give it any name. So I'm going to be using one very specific one that I'm going to be calling Game Store. So I like to name these resource groups with the name of the project itself, right? So our project here is the Game Store. So I just chose the name Game Store. You can use the same name. This is constrained within the context of the subscription. So it's fine if you use that same name, that's okay. And then what you want to do is select a region. So a region is nothing more than a data center of Azure somewhere in the world, right? Where they have all of these racks of computers, right? Where you're going to be hosting your resources. So ideally what you want to do is just pick whatever region is closest to you, right? Or whatever region has been activated for your subscription. Sometimes some subscriptions only have availability to create resources in some regions. So just pick the region that makes most sense for you. In my case, that region is going to be West US 3, right? Sometimes there's always also regions where the capacity is limited. For instance, West US 2 is traditionally the one where there's always too much usage, right? So sometimes you try to create things in West US 2 and it's just not available because there's too many people trying to create stuff in there. So I like West US 3 because there's always availability and it's fairly close to me. Okay, so and after doing that, what you want to do is you can just click on review plus create at the bottom, review plus create, validation passed, and then you can just go ahead and click on the create button, and that will go ahead and create your resource group. And as you can see, the group was created. It was super fast, right? Because it's really just a logical thing. There's nothing really to create physically. So the group has been created, and then you can click on that notification, go to resource group, or you're going to find now that your resource group is going to show up in the list of resource groups right there. So either way, you can click on it, and then you're going to land in this section where you have all of the details of your resource group. So being in this resource group, you're going to have a list down here. There's nothing right now. We're going to start creating stuff soon. But you also have access control at this level. So here you're going to be able to go into role assignments, and now you can grant people access directly into this resource group if that makes sense for you. All right, and there are many other things here. We're not going to explore this course, but another thing that I can also comment is that you could also, if you wanted to, you could pin this resource group into a dashboard if that makes sense for you. So you can use this button here, right there, to pin your resource group into either a private or a shared dashboard. Like I mentioned, dashboard is a nice way to have everything together right there when you log in into the portal. So let's say I do have this dashboard called My Dashboard. I don't know if it's a default one or I created that, I can't remember. But you can pick a dashboard or you can create a dashboard somewhere in here. And then you can just select the button that says pin, right? It's going to be a private dashboard. I'm going to pin there. So, okay, and then it says, okay, so I pinned the Game Store to the dashboard. And so that means that if I go to home now and I go to my dashboards over here, I have my dashboard right there. I can click on it. And as you can see, my resource group is right here. It has been, I guess it's a bit hard to distinguish, but it is right here. Right, it's just a big square that is showing here that there's no resources because we don't have anything here. But I could always go ahead and perhaps make this a bit smaller, right? You can use these three dots to say customize, and then you can say, okay, so 4x2 is better, or perhaps 2x2, let's say. No, I'll just stick with that. And then I will click on save, and that puts stuff there, right? So it's a bit smaller. And then you can just move things around, right? So now you can say, I'm going to say customize, and then I'm going to move this up, perhaps even higher and higher. Yeah, there, save. So that now this resource group is the one thing that I'm going to see right there when I go into my dashboard, right? So that way I don't have to look too much for it if it didn't show up in the homepage. But that's really optional. What we wanted to achieve here is just to have the resource group. And then in the next module, we're going to start to see how to start creating our first Azure resource, which is going to be our storage account, so we can store the images that our users are going to be uploading into our web API. In this module, you will enable a brand new endpoint to upload files to the Azure Storage Service from your REST API. By the end of this module, you will have a solid understanding of the following. Where should your REST API upload files to? What is Azure Storage? How to create a storage account? How to add an endpoint to upload files to the Blob Storage service? And how to upload files from Postman and the client UI. In this lesson, you will learn about the different options you have for uploading files provided by your users. There are a few options to upload files provided by your users. You could upload the files as blobs to your database, you could store them in your website's file system, or you could upload them to a cloud service. Let's quickly explore each of these options. The first option is to upload files as blobs to your database. This can work well for small to medium-sized applications with moderate image volumes. However, it will present issues as the application grows. Storing images in a database can significantly increase the size of the database, which will lead to slow queries. Retrieving images from a database can be slower than retrieving them from a file system or a cloud service. Databases are optimized for structured data, not large binary objects like images. As the number of images stored in a database grows, it can become challenging to scale the database to handle the increased load. Backing up and restoring large databases that include images can be more challenging than backing up and restoring databases that only contain structured data. Finally, using a database to store images can be more expensive than using a file system or a cloud service, especially if you're using a cloud-based database service that charges based on the amount of data stored and transferred. The next option is to store files in the website's file system. This seems like a very intuitive and efficient option. However, it also presents multiple issues. It opens the door for attackers to upload viruses or malware to your website, which will allow them to get complete control on your system, crash it, or compromise user data. It makes it hard to scale since as soon as you need to spin up a second server to handle the increased load, you'll need to figure out how to make images available across multiple servers. There's only a limited amount of space available in your web server, depending on your service tier. Backing up and restoring large sites that include large amounts of images can be challenging. And the cost of storing large number of files is certainly higher than using a cloud-based service. Compared to the other options, storing files in a cloud service like Azure Storage presents multiple benefits. A cloud storage service can handle massive amounts of data and is designed to scale as your application grows, without requiring expensive hardware upgrades. It offers high availability and can ensure that your images are always accessible to your users, even in the event of hardware failure or downtime. It provides high reliability and can ensure that your images are safe from data loss or corruption. It offers built-in security features like encryption, access control, and auditing to protect your images from unauthorized access or manipulation. It is optimized for high performance and can deliver images to your users quickly and efficiently, especially when used in conjunction with a CDN. Finally, it offers a cost-effective way to store and manage large amounts of data without the need to upfront hardware investment or maintenance costs. Because of all these benefits, a cloud storage service like Azure Storage is a highly recommended approach for storing user-uploaded images, especially for large applications with high image volumes. In the next lesson, we'll learn more about Azure Storage. In this lesson, you will get a quick overview of the Azure Storage service, its different capabilities, and the scenarios where you can use it within your applications. The video that follows was taken directly from the Describe Azure Storage Services module in the Microsoft Learn site, since it provides a great overview of the service. Let's see the video.
Azure Storage is Microsoft's cloud storage solution for modern data storage scenarios. Core storage services offer a massively scalable object store for data objects, disk storage for Azure virtual machines, a file system service for the cloud, a messaging store for reliable messaging, and a NoSQL store. Azure Blob Storage is an object storage solution that you can use to store massive amounts of unstructured data, such as text or binary data. Blob storage is ideal for serving images or documents directly to a browser, storing data for archives or distributed access, streaming video and audio, and disaster recovery scenarios. Azure File Storage offers fully managed file shares in the cloud, and shares are accessible using industry-standard network protocols. Mounting Azure file shares is just like connecting to shares on your local network. Azure Disk Storage provides disks for virtual machines and applications to access and use as they need, similar to how they would access disks that were on premises. Azure offers both solid-state drives for higher performance workloads and conventional hard drives for your less critical business scenarios. Azure Table Storage offers a NoSQL data store for key value pairs using large-scale datasets. You can use Azure Table Storage to store petabytes of semi-structured data and keep your costs down. Azure Queue Storage provides asynchronous message queuing for communication between application components, whether they are running in the cloud, on the desktop, on premises, or on mobile devices. There are 3 Azure storage tiers that you can use to balance your costs: Hot, Cool, and Archive. The Hot storage tier is optimized for storing data that is accessed frequently, such as images for your website. The Cool storage tier is optimized for data that is infrequently accessed and stored for at least 30 days, such as customer invoices. And the Archive storage tier is appropriate for data that is rarely accessed and stored for at least 180 days, such as long-term backups. Regardless of your business scenario, Azure has a solution to help you manage your storage needs.
Let's create the storage account that will hold the images that our users will be uploading into a .NET REST API. So here we're back in the Azure portal, and to create your storage account, you can do it in a few ways. One way would be to go into your resource group, which I have down here. You can go to the resource group, and then you could go ahead and click on the create button here, which will take you to the wizard to select the storage account and create it directly into this resource group. But the other way will be from the home. You can always just go into create a resource over there, and that will take us also into the same place. So let's do this one. Let's go and type storage account here in the search box. So I'm going to click the first option, storage account. And in this screen, you're going to see a few options. And the one that you want to choose here is this one that says storage account by Microsoft. And we're going to go ahead and just click on this create button down here. Okay, so let's click on create, storage account. And this starts the storage account wizard. So scrolling down a little bit here, make sure that you have the correct subscription selected here. In my case, that will be .NET Microservices, but you may need to pick another subscription. And then the wizard here has already pre-populated the game store resource group that we created in the previous lesson. Right there, if it has not pre-selected it for you, just make sure that you select that game store resource group. That's where we want to have all of the resources for this course. All right, so scrolling down, we have to give it a storage account name. And I think this one has to be unique. In my case, I'm going to select Game Store 01, okay, which is available. So in your case, you'll have to pick another name because, like I said, this is unique, I think, globally. So make sure that you pick a correct name there. And then for your region, I would pick the same region that you selected for the resource group. So in my case, that was West US 3. So I'm going to go with West US 3. And then I'm not going to really make any more selections here. That's good enough for the storage account that we need. So I'm just going to go ahead and click on this review button down here. So just click on review. So that's going to do some sort of final validations. And everything is looking good for me. So I'm going to go ahead and just click on create, that button over there, create. So I will go ahead and get started with the creation of the storage account. This should not take too much time. All right, so a storage account is ready, and you can click on this go to resource button over there to just go to a storage account. And as you can see, it is ready to go, has been provisioned. Now we're ready to start writing the code to start using this storage account. So in the next lesson, we will implement a new class that will handle image uploads from our REST API to the Azure Storage Service. Let's now implement the class that will take care of uploading images into Azure Storage from our .NET REST API. So the first thing that we'll have to do in order to be able to upload those images is to get a brand new NuGet package provided by the Azure Storage team so that it makes it super easy to upload those images into the storage service. So let's go ahead and open our terminal here, and let's go ahead and do .NET add package. And the package that we want to use here is azure.storage.blobs. Azure.storage.blobs. That's the one that includes all of the classes and types needed to interact with storage service. So let's go ahead and hit enter. And with that ready, we are able to just close this, and just to confirm, in GameStore.api.csproc, you should now have the following reference. Collapse this one here. So this one you should now have in your CSproc file. With that in place, let me close this, and let's go now into GameStore.api, and we're going to be creating a brand new directory. So let's right click and let's create a new folder. Let's name this one image upload. And in this one, let's right click and let's create a new class, new C# class. Let's name this one image uploader. All right, and we're going to collapse this, and let's fix our namespace and our usings. there. So the first thing we're going to need in order to upload images is the blob container client. That is the object that you can use to interact with the blob containers service. Because we're going to be uploading the image as a blob, we need the client to be able to interact with that part of the storage service. So private read-only blob container client, and then let's do control dot here to use azure.storage.blobs, and then let's name this one just container client. Then let's go ahead and generate a constructor that includes the injection of an instance of the container client. So let's do control dot here. And let's use the very last option here, generating constructor, image uploader, blob container client. Okay, so you can see it injects the container client that will be later provided during the startup of the application. And now we're going to implement a brand new method here. And let me scroll this down for a bit, which is the method that a REST API is going to be using to actually upload the file. So this method is going to be named public async task of string, because we want it to return a string that's going to be the URL of the uploaded file. And then let's name it upload image async. Okay, and the object we're going to receive here is of type iForm file. Let's name it file. An iForm file is the type of object that you can receive from our client in the form as a form object, right? So we're going to see how to use that form file in the next few lessons. But for now, let's go ahead and implement this method here. And the first thing that we want to do here is to go ahead and create what is known a container, right? The container is think of as a folder in your storage account where you're going to be storing your blobs, your files. And so we already have the container client in there, but we have to create the actual container. So let's go ahead and say await container client that create if not exists async, right? And then we'll say public access type, and I'll do control dot here to use azure.storage.blobs.models, and then we will do dot blob. Okay, so the idea is that if that container does not exist yet, it will go ahead and get created the very first time. And if it does exist, it will just get reused. There's nothing to create really, so it's just fine. And then also we're saying here that we will be using public access type.blob, meaning that all of the blobs created inside of this container will be for public access, right? So the URL for those blobs can be accessed from anywhere in the web, which ties well with our client, because our client, as you remember, has anonymous access when it lists all the games. So it is okay to show all the images with the public access. You could also change this to other access types. For instance, you could do blob container, meaning that only the blob container is public, but the images themselves or the files inside the container are not public. You could do that. Or you could say that no, none of the blobs inside are going to be public, as well as the container, right? So nothing is public, everything just stays private. In this case, we're just going to go with this option. And then now that we have the container ready, we have to go ahead and actually create the blob, which is the storage for the image. So we're going to say var blob client is container client dot get blob client, and here's where we have to specify, okay, so we want to create a blob client, but for which file? So the file is going to be file.file name. And let me scroll down a little bit here. And now that we have the blob client, we can go ahead and say await blob client dot delete if exists async. And we want to do this because that exact file for that exact image may already exist. So the idea here is that we just delete that one so that we can go ahead and re-upload a file with that exact same name. And lastly, we need to go ahead and actually upload the file. So let's go ahead and do the following. We're going to say using var file stream equals file.open read stream. Okay, so that's going to go ahead and open the stream to start uploading the file. And then we can do await blob client that upload async. And for this one, we want to pass in first the file stream, and then we want to pass in a new object of type blob HTTP headers. And in this one, all we want to pass in is content type equals file.content type. So pretty much setting the content type for the content type that has been provided directly by the iForm file object. And with that in place, and perhaps let me just send this to the next line so that it looks better for you. With that in place, all we have to do now is just to return back the URL of the uploaded file. So for that, what we can do is just say return blob client.uri.toString. And so with that, we have our method pretty much ready. What we can do now is to also extract an interface out of this class here so that we have a nice way to register the object later on back in our program.cs file. So let's go ahead and scroll up To the definition of our class, image uploader, I'm going to just do control dot here, and I'm going to say extract interface, right? As you can see, now we have our iMessageUploader interface, which now is implemented by our class down here. And I'm going to do, in my Explorer, I'm going to actually go ahead and create a file for that interface so we don't have it in the same file. So let me actually do control dot in iMessageUploaded, and I'm going to select this option, move type to iMessageUploader.cs. And as you can see, the file has been moved over here, iMessageUploader, and that's just our interface. And so with these two in place, we are pretty much ready to configure our image uploader. So in the next lesson, we will configure the new image uploader class so that it can start talking to our storage account. It is time to configure our image uploader class so that it can actually talk to the Azure Storage Service. And so for that, what we're going to need is the connection string provided by storage in order to be able to actually connect to it. What we're going to do now is just go into a README file. And just like we did with SQL Server, we're going to be defining just a little section here that describes how to store that connection string into our .NET Secret Manager, right? So we can do this in the local development environment. So let's go ahead and scroll down at the very end here. So let's open up a section here that says setting the Azure Storage connection string to Secret Manager. Okay, so I'm going to just say here, PowerShell. And we're going to define a variable here first that is going to be named storage constring. Of course, this is going to have storage constring here. And then we're going to do something very similar to this other one, .NET user secret set, right? So I'm going to copy that from there, .NET user secret set. And then let's name this one. It's going to start with connection string. So let me just copy this because it's just another connection string. So connection strings, and then let's name this one just Azure Storage. You could use any other name if you want to. And then here's where we're going to be placing the value of storage connection constring. Now we're ready to, well, run these commands. So let's open up our terminal here and let me actually collapse that and clean my terminal here. And so let me scroll down a bit. And of course, now it is the time to set our storage constring variable here to the right connection string. And so for that, what we want to do is now go into the Azure portal, right? So let's go back to Azure portal over here where I have opened my storage account, right? If you're not here, in order to get there, what you can do is just go to home, right? So just look for either your resource group or your storage account will likely just show up here as a recent object, or you can also just search for it in the search box at the top. In my case, it's going to be Game Store 01. So you can see it shows up right here. So you can just click on that one and that's going to take you into this screen. All right, which is the screen for the storage account. And then what you want to do is just scroll down into this section in security and networking that says access keys, right there, access keys. So click there. And then you're going to see that you have a couple of keys generated here for you. So key 1 and key 2. What we're going to do is just click on show over here so that we are going to be using this one here that says connection string for the key 1. That will be good enough. So let's go ahead and click in the copy button here to copy this connection string to the clipboard. And then let's go back into Visual Studio Code and I'm going to just paste what I just copied right there. So that's my connection string. I'll close double quotes. I'll hit enter. And now we have that new storage connection string variable ready. So now I'll go ahead and just copy my second line to actually set the user secret. I'll hit enter. And now the secret has been set. Again, make sure that you're in the GameStore.api directory. That's where you should be setting these secrets. Okay, and if we can configure that by doing .NET user secrets list. Okay, and we should see that we have our brand new storage connection string right here. Okay, so it has been set. And with that in place, we are ready to configure our image uploaded using that connection string. So let's close this and let's go into our program.cs class. And let's go a little bit up. Okay, so just before we construct our app object, let's do one more registration for our image uploaded. So we're going to say is the following: builder.services.add singleton. Okay, and the singleton is going to be of the type of the interface that we defined, right? So iMessage uploader. Okay, and let me do control dot here so we can use GameStore.api.imageUpload. And in this case, we're going to be very specific on the concrete type that we want to use with that interface. We have to do the following. So let's go ahead and open and close parentheses here. And let me close double quotes there. And then inside this, we're going to define actual instance of the image uploader. So it's going to be new image uploader. And then let me go to the next line here. For that image uploader, as you remember, we need to provide that blob container client in the constructor. So we're going to say new blob container client, and I'll do control dot here so that we can use azure.storage.blobs namespace. And in this one, we are going to go ahead and actually configure this client by using the connection string, right? So that's the one parameter that the blob container client needs in the constructor. And so as we know, we can retrieve that from the configuration object. So builder.configuration.getConnectionString, right? And what would be the name? Well, the name is the one that we set over here, right? It's just Azure Storage, right? So just copy that. Azure Storage is the name there. And then there's a second parameter here, which is going to be the blob container name, right? So the first parameter is the connection string to connect to the account. And then the second one is going to be the name of the container. So where are we going to be storing all of those images? Well, let's give it a name of just images, right? It could be any other name, but I think images will serve us quite well. And so with that, our REST API is ready to start using the image uploader to upload images. In the next lesson, we will implement a new endpoint in our REST API that will receive the images provided by users in the client applications. Let's now create a brand new endpoint, which is going to be responsible for receiving those images uploaded from the client applications, and that we can then go ahead and send over to Azure Storage via our image uploader. So the first thing that we're going to need is a brand new DTO to represent the URI of that uploaded image. So let's go into dtos.cs over here, and let's scroll down all the way to the end. And it's going to be a very simple DTO. Let's just name it public record image upload DTO. And this is going to receive just one parameter, which is going to be the URI of that uploaded blob. So string blob URI. And with that in place, we can now go ahead and actually implement the new endpoint. So let's go ahead and close this. Let's go into our endpoints directory and let's right click. We'll say new C# class. This is going to be named images endpoints. All right, let's collapse this and let's fix once again namespace, and let's fix the unnecessary usings. And so in this class, we're going to be defining just one method to map any of the new endpoints we're going to be defining for the image upload purpose, which is really just one endpoint. But let's define this method. And but before doing that, let's make sure we define this as a static class because it's only for extension methods. So public static route handler builder. And then the name of this method is going to be map images endpoints. And it is going to be extending iEndpoint route builder as we have done before, and the name is going to be just routes. And to define our API, just like we did with the other endpoints, we will be using also versioning here. And so because of that, we're going to be defining our API like this. So our API is routes.newVersionAPI, right? So that will make sure that we use the versioning services with this brand new endpoint. And now it's the time to actually define that endpoint. And so that endpoint is going to be a post endpoint, right? Where it's going to have a URL of just images. That's where we're going to be sending these files. So let's define return API.mapPost. And here we're going to provide two parameters. The first parameter is going to be the route or the pattern, and that's going to be just images in this case. And the second parameter is going to be, as usual, the actual delegate that represents the action to execute when the image comes in. So this is going to be async task, and then we're going to be returning multiple results as with other of our endpoints. We're going to be using the results type here. So results, and then the first results type is going to be OK of type. Let's do this OK, and then let me just do control dot here to use Microsoft.ASP.NET Core.http.results. So OK of type image upload DTO, which is the brand new DTO that we created, and I'll do control dot here to use GameStar.API.DTOs. And then the other type that we could return is just a bad request, okay, which could happen. We'll see in which case we will return a bad request. And then the actual parameters for this delegate here are going to be the iForm file, which is what we're going to name file. And this iForm file, by the way, is nothing more than an interface that represents the file that has been sent within that HTTP request. Okay, and we'll see how to actually send the file in the next lesson. That's the first parameter. And the other one is, of course, our brand new iImage uploader. Okay, for which one we'll do control dot here to use GameStar.API.image upload. Okay, iImage uploader, we'll name it image uploader. All right, and so we will go ahead and open our arrow function there so we can start introducing the actual code. Now let me actually send things to the next line. So let me close semicolon there and let me send things to the next line so we can see a little bit better. Okay, so yeah, that's as much as we can see here. I'll just scroll down briefly so you can see it completely. So So it's async task of results of type OK, image upload DTO, or bad request, and then the file as an iForm file and the iImage uploader over here. And so now we can go ahead and implement this post method. And the first thing we're going to do is just to check if we actually have any length for this file. So if the file has no length, that is going to be our bad request, right? So that's kind of an invalid file. So if file.length is less than or equals to 0, then we're going to say that this is return type results dot bad request. And after that, if that's not the case, then we have a valid file. So we're going to say the following. We're just going to say var image URI equals await, and here we're going to be using our image uploader. So image uploader dot upload image async, and we're going to be sending that file right there. So that's how we use it. And that image uploader, as you know, it will take care of the whole thing of loading the file into blob storage. Finally, we're going to return our good response. So type results dot OK, and we'll say new, and here's where our DTO comes in place, image upload DTO with the image URI. That's pretty much the definition of our post method, right? This is the only endpoint that we're going to be defining here. But of course, we need to define a few more things about this post endpoint. So let's scroll down a bit, starting with authorization, right? So we do need to require some level of authorization here so that not everybody can just go ahead and upload files here without the proper authorization. So we'll say require authorization. And for this one, we're going to be requiring our policies. So we'll do control dot GameStore.api authorization. We want to import here policies.write access. Okay, so that's the first thing. So now it is secured. And then we have to specify for which version of our API this endpoint is going to work. So this is going to be has API version. It's going to be version 1.0. Let's just stick with 1.0 for now. And then we need to add some metadata to describe the API, right? Via the OpenAPI specification. So we're going to say first with OpenAPI. Okay, and let me scroll down so we can see better. And then let's add a summary. So with summary, and the summary will say uploads a file to storage. All right. And then let's also add a description. We're going to say uploads a file to storage and returns the URL to the uploaded file. Let's say of the uploaded file. All right, and finally, we're going to add a tag to describe that this one endpoint belongs to the images group of endpoints, right? Not to the games endpoints, but to the images endpoints. So with tags, it's going to say images. So that's the end of our endpoint. So it's all ready to go. And the next thing, of course, is going to be to map this endpoint in our program.cs file. So let's go back into program.cs over here. And we're going to scroll down into the section where we're mapping our games endpoint today. So line 51 now, I'm just going to open a couple of lines there. And then I'm going to just say app.map images endpoints, just like that. And so yeah, with that, our brand new endpoint is all ready to go. In the next lesson, we will try out our new image upload endpoint, both from Postman and from our Game Store client. It's time to try out our brand new image upload endpoint to verify that things are working properly. So here I am back in my .NET REST API Visual Studio Code instance. And so I'm just going to go ahead and open my terminal and run the server. And now I'm going to head into Postman over here. I'm going to open up a brand new tab because the thing is that we can actually use Postman to try out our image upload endpoint. And to do that, what you want to do is just switch your operation from a get. We're going to switch this into a post like this. And so what we want to do now is put the host URL here. So I'm going to copy that host URL and port from another tab. So I'm going to just put that over here. And then remember that the actual endpoint that we're going to be using here is, if we just take a quick look at the API once again, we go to endpoints and we have images endpoints. The actual endpoint is called images, right? So images. I'm going to copy that and then back into Postman. I'll just put images right there. For the actual payload, the actual image we're going to send, what we want to do is just go into body. And in body, you can select form data. And here, and let me expand this a little bit, we want to enter is just one key that in this case, we're going to name it, let's say, file. Okay. And there is going to be one new element on the right over here. It's a little bit hard to see, but it's right here. It's a little drop down that is inside this box. So you want to click on that one. and then select File. Okay, so I will make sure that the file is actually sent as a file into the REST API. And now you can see that you have this kind of a button here that says Select Files. So that's where you can go ahead and click to select your file. Now, in this lesson, you're going to see that there's a zip file called gameimages.zip, and that zip file includes a collection of game covers that you can use to test out this functionality. What I did in my box is I just downloaded that zip file, so please do the same. Download the zip file, extract it in a location convenient for you, and then inside the directory, you're going to see all of these images that I'm seeing right now. Okay, and so for this exercise, we're going to pick one of these images. Let's say we go with Minecraft, so I'm going to select Minecraft.jpg. I'm going to click Open, and you're going to see that that new image shows up right here, Minecraft.jpg. And that pretty much sets our body ready to be sent to the REST API. Now, the other thing that we don't have to forget is that we need authorization, right? We need authorization in order to be able to post into this new API. So I'm going to go into authorization. And since this is local development, what I'm going to do is just select our bearer token option here, just bearer token. And remember, what we have to do now is to come up with a token that has the right values for our right authorization policy, right? So let's go back into Visual Studio Code over here, and I'm going to actually just stop my server for a second, right? I'm going to clean this, and let's come up with a token that we can use for writing. So that's going to be .NET user JWTs, and then create. Then remember that for this policy, we're going to need both the admin role, so it's going to be admin, and we also need, in the scope, we need games write. So that's how you create the access token for writing into the API. So I'm going to hit enter. And now we should have the right token, right? So I'm going to copy this token now, and I'm going to go ahead and restart my server. Okay, server started, back to Postman. And now I'm going to go ahead and delete that token and then paste my brand new token over there. Okay, and so with that in place, we should be ready to send this image. So I'm going to go ahead and just click on send. And as you can see, this was a success, 200 OK, it was a success. And we have our resulting blob URI right here, okay? Meaning that the image was actually uploaded into the Azure Storage Service. And we can verify that by just going into, let me just copy this URL. You can just click on it also, but let me copy that URL. If we go into our browser, say over here, I'm going to paste it here, and I'm just going to hit enter. And notice how the image shows up right there. So it is publicly available now from our storage account. And of course, if we now go, and let me close this, if we go back into the Azure portal, so I'm back in the storage account in the Azure portal, right? From the home of that storage account, what you can do now is just go into containers, over here into containers, and then click on that one, and you're going to find that now we have a brand new container called images. That's the one that we specified in our image upload class, right? So images, and in images, you're going to find that right there is our Minecraft.jpg file. So it's ready to be used. Okay, so image upload is working great. And of course, what we're going to see now is if we can actually do this image upload directly from our game client, right? Game store client. So let's go back into the client, which I have loaded over here in my browser. And if you're not running it already, please go ahead and go back into your GameStore.client VS Code instance and just do .NET run at the root, and that is going to start your client. And then back in the client, I'm going to just do a quick refresh here, just in case. And then what I'm going to do is actually create a brand new game here and see if we can attach an image to it. So I'm going to click on new game, and this game is going to be Super Mario Bros. 3, and then the genre is going to be Kids and Family, and then the price is going to be $19.99. The release date is going to be 10/13/1988, a while ago. And now we can go ahead and click on choose file right here. You just click on choose file. Okay, and now I am back in my game images directory. So I'm going to pick the image for Super Mario Bros. 3, this one on the right side. I'm going to open that. And if things are working properly, what you're going to see is that the image shows up right here as kind of an image preview. But really at this point, the image upload have already happened, right? So at this point, we already talked to the REST API. The REST API talked to Azure Storage, and the image should be there by now. In fact, we can go into the Azure portal very quickly over here. And if you just refresh this, you're going to notice that the brand new image is right there. It was already uploaded, right? So yeah, that succeeded. And if you just save this, we should be able to see, if we go to the very last page, yeah, we can see that the image for a brand new game is right there, right? Because the URL was sent back from the REST API back into the client, and now the client is able to display the image right there. And then, of course, we can also let's go back into the first page, and we could set images for our existing games too, right? So you can now click on edit, let's say for the Minecraft game. And then I'm just going to scroll down, select choose file, and I'm going to select my Minecraft file, which in this case, of course, is going to replace the one that we previously added via Postman. So it's going to replace it, and then it's going to show up right here. We're going to click on save, and now we have Minecraft over there. And of course, just like that, you can go ahead and start adding images for all of your games, so you don't keep having these placeholders. But that is okay, because really at this point, we are pretty much done with the local development portion of the course. And at this point, in the next module, we're going to start looking into how to go ahead and publish this Game Store REST API into the Azure cloud so that you can see it working end-to-end in a production environment. In this module, you will create a SQL database in Azure, and then you will deploy your REST API to Azure App Service so that you can finally see it running in a cloud production environment. By the end of this module, you will have a solid understanding of the following: how to create an Azure SQL database, how to create and configure an Azure App Service for your REST API, how to enable logging to Azure App Service, and how to deploy a REST API to your Azure App Service. Before we can deploy our REST API into Azure, we of course need to also have the database available in the cloud, right? So that the REST API can access that database as opposed to the local one that we have right now. Here we're back in the Azure portal, and we're going to go ahead and create that SQL database. So to do that, I'm going to click on create a resource right there, create a resource. And so we're going to be looking for SQL database, and we're going to be picking the first option that says SQL database here. And then this is going to pop up a few options down here. So we're going to go for the one that says SQL database by Microsoft, this one over here. So let's go ahead and click on create down that option, and then let's select SQL database. So it's going to start the wizard for the creation of the database. And so as usual, if you scroll down, make sure that you have selected the correct subscription. In my case, that subscription is .NET Microservices. Otherwise, pick the correct one for you. And then for the resource group, of course, you want to select the same resource group that we've been using in this course. So let's select just Game Store in my case. And then let's scroll down. Let's see what else we have to do. We need to enter a database name. So we're going to be using the same database name that we've been using locally. So let's name it just Game Store. And then we have to select a server, right? So this is the actual SQL server that's going to be created for you in the cloud. We don't have one, so we're going to be clicking on create new, this one here that says create new. Just click on that one. That's going to take us to this other wizard page where we have to select first thing is going to be the server name. Now this server name is going to be unique across the world, right? So you have to pick a unique value that nobody else has claimed. So in my case, I'm going to claim Game Store 01. That's the one I'm going to claim. It's available. So you have to pick a different one. So please go ahead. It doesn't really matter what name you use, but just pick a unique one. For the location, I'm going to select once again West US 3, as I did before. For the authentication, we will be using SQL authentication. And that means that we have to enter SQL Server admin and password. For admin, let's just enter admin user. Okay, and then just pick a good password for you. So I'm going to pick mine here. So I'll do... So password is ready. Let's go ahead and click on OK. Okay, and that completes the details for the SQL server. But we need to still configure a couple more things for our SQL database itself. Yeah, notice that the SQL server appears right here. So that's the one that's going to be created for you. And then let's keep scrolling down. And then the next option we're going to select is, let's see, for compute and storage, make sure that you have selected standard S0. Because I think that's the one that is available in your free Azure subscription, right? So that's included as part of those credits. So you can also click here to select many other types of SQL servers, which is just going to give you better performance or more storage or different capabilities, right? But for learning purposes, a standard S0 should be good enough. And then let's keep going down. We will just click on networking. So let's go to the next step, networking. Okay, so we're going to scroll down here, and when it says network connectivity, we're going to select the public endpoint option here, public endpoint, so that we can actually connect to it. And then if you scroll down, what you want to also tick is this option here that says add current client IP address, so that your machine IP can actually connect to this SQL server and you can explore the contents of that SQL server instance and database, right? Otherwise, you will not be able to connect to it. So by default, it is locked down so that nobody can access it. But in this case, if you just do yes, it is going to figure out what is your current IP, and it's going to allow only your IP to connect to that SQL server database. We're also going to be ticking the other one here that says allow Azure services and resources to access this server. We're going to say yes, because that is going to allow your Azure App Service, which we're going to be creating in our next lesson, so that it can actually connect to SQL Server. Again, the SQL Server is very locked down, and if you don't allow that checkbox there, nothing can connect to it, even your Azure App Service, even if it lives in Azure, okay? So make sure that both of these options are yes. And then I think that's pretty much it. I don't think we have to set anything else. We're going to just click on review and create. And here we're just going to say, this is the last page. We're going to say create, and that's going to go ahead and create our SQL Server. So let's give it just a few seconds until the deployment is complete. All right, so the SQL Server database has been deployed, right? So it's ready to go. So I'm going to just click on and go to resource over here to go to that resource. And you can see we have our SQL Server database ready to go over here. And not just the database, but also the actual SQL Server. So if we just go back into the resource group, and you can do that by just clicking over here, right? So that is the resource group. I'm going to click on that one. That takes us back to the resource group, and you're going to see that we have both the SQL Server database and the actual SQL Server over there. And so with those in place, what we can do now is, well, verify that the database is ready to be connected from Visual Studio Code, right? We may want to just explore a little bit that database. To do that, let's go back into Visual Studio Code over here, and let's go back into our SQL Server view over there in the left. Click on that one, and of course, as you know, we do have our connection to the local SQL Server over there, but now we want to connect to the one that is in the cloud. If the permissions have been set correct, we should be able to connect to it. So let's click on the plus icon over here, and for the host name, let's go back once again into the portal over here. So let's click on the SQL Server, and the server name is going to be located right here. Here is your server name. That's your host now in the cloud. So now let's go ahead and copy that. So I copied that. Back in Visual Studio Code, I'm going to paste that name over there. I'll hit enter. And then the database to connect is our game store database, right? As we defined it in the wizard. So game store, and then I'll hit enter. And then authentication type is going to be SQL login. The username is going to be admin user. I'll hit enter. And then the password is the password that we set in the wizard, right? So hit enter, and I'll say yes on this one to save the password. And this last one, I'll just hit enter. And the connection is going to be established against that SQL Server database. And as you can see, we have established the connection on the left side. We can see that we don't have any tables right now, right? But we are connected to our game store database, as you can see right there. If you wanted, you can also explore a little bit the database directly in the Azure portal, right? So here's the Azure portal, and in your SQL Server, all you want to do is just scroll down until you can see the database, SQL database. And you can always go here into your query editor, and here in the editor you can go ahead and again use your admin user, your password, click OK, and that's going to allow you to go ahead and connect to the database, and you can start running queries against the database directly here if you wanted to. But in any case, our database is ready to go. Now we're moving into the next lesson, where we will go ahead and create the Azure App Service, where we're going to host our .NET REST API in the cloud. With our Azure SQL database ready to go, it is time to figure out where is that we're going to be hosting our .NET REST API in the cloud. And in the Azure cloud, there are actually multiple options for hosting ASP.NET Core applications. But since we don't have time to cover all of those options in this course, what I'd like to do is to show you the most straightforward way to get your ASP.NET Core application deployed to the cloud. And that's going to be via what is known as the Azure App Service. So to use that, let's go into create a resource. And then in the search box, let's look for web app. So web app is going to be the first option over there, web app. And over here in this results page, you want to choose this option here that says web app by Microsoft. That's the one that we want. And so let's go ahead and click on create, and then let's choose web app. And this is going to go ahead and start the web app wizard. So as usual, let's make sure that we are selecting the correct subscription over there. And then for the resource group, let's go ahead and select that same resource group that we've been using so far, game store in our case. Okay, and then we're going to scroll down into instance details. And for the name, as you can see, it has to be a unique name across the world. So in my case, I'm going to go for Game Store 01. In your case, you'll have to choose a different one, right? Because I'm claiming this one right now. So please choose a different one that's unique. It doesn't matter what name it is, just choose a unique one. And then for the publish option, we're going to go with the code option over here. There are other options, as you can see, but the code option is going to be good enough for us. For the runtime stack, if you open this drop down, you want to select the .NET 7 version, because that's the one that we've been using in this course. So .NET 7, that will make sure that the entire environment has been prepared for .NET 7 for you. So you have to place your bits over there, and the application should just run without any issues. For the operating system, we're going to pick Windows, basically because it is the option that offers the most features of Azure App Service. You could also pick Linux if you wanted to. There are some tiers that are not available in the Linux version. So let's pick Windows in this case. And then for region, I'm going to pick the same region we've been using so far. So that's going to be West US 3. Now let's scroll down here. And what we have to do now is to select what is known as a pricing plan right here. Okay, and so there are many pricing plans here. If you just click on explore pricing plans, you're going to find a big selection that really gives you is more compute power, right? And more storage. As you can see, more capabilities depending on how much you want to pay, right? So as you start reaching production, you may want to pick one that has more capability, like more memory, more storage, more CPU, whatever makes sense. But for our learning purposes, the one that I like to use is this one here that says free, right? So this is the free tier. That's, as you can see, it can give you up to 60 minutes per day of usage for your Azure web app. So let's go ahead with the free option. I'll click select. Okay, you can see that free has been selected right there. And then let's scroll down. Yeah, we're going to go into the next option. So let's go for deployment. We're not going to select continuous deployment. We don't need that right now. And then let's go to networking. Let's make sure that enable public access is on, right? So that way we will be able to access the REST API from anywhere in the web that we want to have. And then let's go into monitoring. We don't really want to do application insights just yet. So we're going to go with no in this case. That will give you additional monitoring capabilities, but for learning purposes, we don't need to go into that just right now. Yeah, with that in place, we can just click on review and create. And let's confirm that everything looks good. So yeah, let's go ahead and just click on create. And that's going to get started with the deployment of our brand new web app. So let's give it a few seconds for it to complete. All right, so our deployment is complete. So we can now click on go to resource to see our web app right here. And as you can see, yeah, it is up and running. And we even got our default domain right here. That's going to be the URL for our REST API. But one thing that we have to do in this web app right away is to go ahead and configure the details to tell the web app how to connect both into our SQL Server database and into our storage account. Remember, for storing images, right? And to do that, what we can do is take advantage of this tab here that says configuration on the left side. Look for configuration right there. And what you can see here is that there's kind of two sections over here in this first tab, application settings. There is a section for you to set up application settings that can override whatever you have specified in your app settings.json. You can override that with values over here. But also we have connection strings, right? So these connection strings are going to act as another configuration source for your application so that you can override whichever connection strings we were previously using from the .NET Secret Manager. Remember that we were using Secret Manager to store the SQL Server connection string and the Azure Storage connection string. Well, now in the cloud, Secret Manager is not available. And so to provide those connection strings, we're going to be using this facility here, which is going to just provide those values in the cloud, and they're going to fit straight into a configuration system that our REST API can use right away. So let's go ahead and click on new connection string. And let me see if I can collapse this for a second. Yeah, we can see better. Let's enter the details for this connection string. So the first one is going to be for our database. So what is the name of the connection string for the database? So if you go back into Visual Studio Code, over here, let's go ahead and just open our README file. I think we have those details over here. So yeah, as you can see, our connection string for storage, which is detailed in this section, is just game store context, right? That's the name of the connection string. So let's copy that name into this wizard right there, game store context. And for the value, what we want to do is to enter the actual connection string from SQL Server. So to get that one, let's go back into, and I'm going to keep this open. I'm going to right click in Microsoft Azure to open the link in a new tab over here. And so now what I want to do is to go into my SQL Server database. And so we can do that as usual in many ways, but the database is showing up for me right here, okay, in the recent resources. So I'm going to click on the database. And then let's scroll down into the settings section on the left, look for connection strings right there. And here you're going to find your connection string. So if you scroll down a little bit, I think the option that we want to use is this one here, because this uses SQL authentication. And so this is a fully fledged connection string to connect to your specific database in the cloud. So I'm going to go ahead and just copy that. And then I'm going to go back into the other tab where we're going to just paste that in the value section right there. And now we have a SQL Server database for the cloud. Now, one thing that we have to complete in this connection string is the actual password, right? So notice that the password here is just a placeholder. So you have to put the actual password that you set in the wizard when you created the database, right? So I'm going to put that password over here. Okay, so that's my password. And then the rest just stays as is. And then on this drop down here, it says MySQL. Let's see what options we have. So we may want to use SQL Azure. So let's pick SQL Azure. And then let's go ahead and click on OK, so that the connection string is now showing up down here at the bottom. Okay, if you click there, you can see the actual value is right there. Okay, and don't worry about entering those details over here because these values are, this section here in app service is actually designed to store secrets, right? So the connection strings are, as it says here, connection strings are encrypted at rest and transmitted over an encrypted channel, right? So this is a safe place to place your connection strings. And so, but yeah, that's the first one. And for the second one, we need one for storage, right? So let's click again in new connection string, and then the name, if you go back to Visual Studio Code, the name is going to be Azure Storage, as it says down here, Azure Storage. Let's go back here, that's for the name. And for the value, once again, let's go back to the other tab. So let's go to home, let's find that storage account, which in my case shows up right here. This is my storage account. Let's go to, scroll down on the left, let's go into access keys, right? Access keys, it's going to be pretty much the same access key we'll be using for local development. So if you just scroll down, we want to use this one over here that says connection string, this one right here. So the first connection string, I'm going to copy that value, and then back into the other tab, I'll paste that here. And now we have our value for storage. Yeah, for type, I don't think there's a type for storage here, so we'll just say custom. And then we're going to click on OK. So now we also have our storage connection string. And with that in place, we can now go ahead and click on the save button up there. So click on save and click on continue. That makes sense. That's good. And now our Azure Web App knows exactly how to connect to both the SQL Server in the cloud and the storage account. So the Web App is ready to go. It is time to actually move into the next lesson where we're going to learn one more detail before deploying the application into App Service, which is how to enable logging to Azure App Service for our .NET REST API. One important thing that you have to keep in mind when deploying applications to the cloud is to make sure that you have a good way to troubleshoot issues when they arise. For that, the thing that you must absolutely not forget to do is to enable logging. Logging in this case to the cloud. Luckily, in our application, we do have logs implemented, but we don't have a good way to log into Azure App Service. In this lesson, let's go ahead and add just one more configuration to the .NET REST API so that it knows how to log into the cloud. So for that, let's go ahead and open our terminal. And in the directory of Kingstore.api, we're going to be adding just one new NuGet package, which is .NET package. It's going to be Microsoft.extensions.logging.Azure App Services. Okay, and let me collapse this for a second so we can see better. Yeah, so that's a NuGet package that you have to add. And then let's hit enter. And that's going to bring in the necessary code to be able to use the Azure App Service as another potential output for our logs. And so with that in place, what you want to do now is go into Program CS. Okay, Program CS. And we're going to look for our builder. So let's scroll down a little bit. Let's do this just before we convert the builder into an actual web app. And let's do just builder.logging.add Azure Web App Diagnostics, right? So this is the one method that will make sure that you have logging capabilities for Azure App Service and the corresponding Azure Web Apps. And so, yeah, that's pretty much what we have to do for this lesson. And in the next lesson, we're actually going to go ahead and deploy our .NET REST API to the Azure App Service. It's time to deploy our .NET REST API to the Azure App Service. To do that, the first thing we're going to do is to just install one extension to Visual Studio Code that is going to make this much easier. So let's go into our extensions view over there. Let's go into extensions. Let me scroll that. And then what you want to install here is one called Azure Tools. Okay, so Azure Tools brings a bunch of tools that you can use with different Azure services. So I'm just going to click on install. And when the installation is complete, and I'm going to just close this, and I'm going to close that, what you can do now is one of two things. You can either go ahead and open your command palette, which I'll do with Ctrl-Shift-P here in my Windows box, and then look for this option that says Azure App Service, right? Deploy to web app, this first option over here. You can use that over there, or you can also go ahead, and in my case, I'm going to open up these three dots over here so I can see more. And you're going to find this brand new Azure option right there. Azure, if you click on that one, I'm going to click on that, and that's going to open up this new pane on the left side where you can explore all of the Azure resources available in your subscription. You should be able to see all of your subscriptions and then all of the resources that are available for you in that subscription, right? So in that case, you can go ahead and open up for app services. You can open up this, and then you should be able to see your Azure app service right there, your web app. In my case, it is Kingstore 01. And when you locate that one, and let me collapse this a little bit, you can just right click and then you can say deploy to web app. This option right here, deploy to web app. So I'm going to go ahead and use that option, deploy to web app. And then the next thing is going to be to select which folder you're going to deploy. Okay, so the folder you want to select here is the root folder where you have VS Code. In my case, that root folder is going to be just the projects game store. So let me do browse here to confirm that folder. So in my case, it's the projects game store, not game store game API in this case, because my VS Code configuration is one level above. Right, it is over there, so it has to be at the root in this case. So I'm going to select the game store directory, and then this one here is just going to prompt us if we want to add a little configuration, just so that it can remember for the future that we want to just keep deploying that same directory. I'm going to say yes, add config. And then this is just a warning saying, hey, are you sure you want to deploy? Because this is going to override whatever you had deployed. This is going to override that. So I'm going to say yes, deploy. And then we're going to say yes to this warning here to make sure that you can always go ahead and deploy things from that same location. And I'm going to also, as you can see, I mean, right now what it is doing is creating a release version of our application, right? So it's building it for release because it's going to go to production. And then it will go ahead and, as we can see in the output window, it will go ahead and take the DLLs for that release version. It zips them, it puts them in the zip file. It copies that zip file into the Azure App Service in the cloud, and then it extracts all those files in Azure App Service, and that will be your fully deployed .NET REST API. Okay, so as you can see, that was completed already. So it did all of the steps, and the REST API should be ready to go now. And if we go in the Azure portal over here, there's not really any good sign saying that, that the deployment completed. But what you can do now, since we have login enabled, we should be able to go down here into this monitoring section on the left side where it says Logstream. That's a place where you can go ahead and take a look at the logs of your application. So let's go ahead and click on that one. One thing that you have to do before you can actually see the logs is to enable this logging in Azure App Service. So to do that, all you have to do is just go to this other option that says App Service Logs. So just click on that one. And that's going to go ahead and present you to all of these options here. And the option that you want to enable is this one here that says application logging, this one right here. So just turn it into on, right? Turn it into on, and let's switch the level into information so that we can see pretty much all of the information level and above messages that are being sent by our REST API. Okay, so let's do that and let's click on save. And that's likely going to restart the application, which is just fine. But now we can go back into Logstream. And this screen here is now ready to start showing us all of the logs that are coming out of our application. Now, we do need to start interacting with the application in order for the logs to actually start popping up here. So let's go now into Postman over here, and we're pretty much ready to start querying our REST API. Now, one thing that we're going to need for that is the actual host name of the API in Azure. So for that, let's go back one moment into App Service. Let's go all the way to the top into the overview. And here, let's go ahead and copy the default domain that is specified right here. Let's copy that because that's going to be the domain in the cloud. And let's just go back into Logstream so that it can be ready for us for later. And then let's go back into Postman, and right here in the URL, I'm going to paste my new URL, right? And this is my first tab, the tab that I've been using for getting all of the games, as you can see. And just make sure that you also change your protocol. It's no longer HTTP. Now we're doing HTTPS because you get HTTPS by default in Azure App Service for your web app, which is very nice. But now we are pretty much ready to go ahead and query the API. And then I'm going to remove this filter, okay? And I'm going to keep page number 1 and page size 15 so we can get all of the games. So I'm going to click on send. And as expected, I mean, we do get a successful 200 OK, but we don't get any games just yet because, of course, this is a brand new database and we don't have any games defined there. So of course, if we wanted to create a game, all we have to do is use our post API now. So let's go ahead and let's first just copy this URL into our post tab over here. And let's replace this URL with the one from the cloud. Let's go into our body here to make sure that we have something to post. And indeed, we do have the Mario Kart 8 Deluxe game over here. If you don't have one, you can easily just craft one post request right here. So that looks good. And then the missing piece is going to be authorization, of course. So we need to have proper authorization to be able to post into that endpoint. But since we are now in the cloud, we cannot keep using that local development tool for generating tokens. We do have to use the Auth0 to get the proper token. So let's go and open up this drop down here and let's choose OAuth2. And in the right side, very likely you already have pre-populated all of the arguments that you used the last time that we tested this with Auth0, right? So make sure that you have the correct callback URL and the correct auth URL, access token URL, client ID, client secret, all these parameters, right? And the correct set of scopes, which I have used all scopes. You don't need all of them, but why not? Let's just add for all scopes for now. and then and the audience and the prompt, right? So with all that in place, let's go ahead and retrieve a brand new access token. Okay, and here we are in our login screen. And so I'm going to log in as an admin. All right, logged in, proceed. I have my token here. I'll use that token. And then I should be able to go ahead and post my Mario Kart 8 Deluxe. So I'm going to hit on send. And sure enough, this succeeded, right? We have created our very first game in the cloud, right? It says that it was a success. We can see the game right here. And likely if we go back into the first tab, we can now hit on send and we are able to retrieve our first game now coming directly from the cloud. And of course, we can now also go into App Service and you can see that the logs, are full of information now. You can see that all the information about the game that we just created. Look at this, even our custom logs are showing up right there. So this is a great way for us to tell, okay, what exactly is going on with our application in the cloud. If something is wrong, your exceptions should likely go ahead and show up here. So you can start diagnosing, okay, what exactly is going on with my application in the cloud. Okay, one more thing that we can confirm is that the game is actually in the database if you wanted to. So you can go into Visual Studio Code, you can go into your SQL Server. Let me do 3 dots and then let's do SQL Server on the left side. Okay, and I'm going to collapse this. And then let's open up the one for GameStore 01 in the cloud. Let's look for tables. So we do have our Entity Framework migrations history right there. And we do have our games table. Let's open up games. It's looking good with the structure. Right click on games, select top 1000. Let me collapse this a bit. And as we can see on the right side, let me see if we can close this query one there, don't save. Okay, we can see on the right side that the game has actually been created in the database in SQL Azure. So yeah, so your REST API is now fully deployed into the Azure cloud. And then if you wanted to, as an additional exercise, what you can also do is just try to connect your local client, right, your local Blazor client into your REST API in the cloud. To do that, it's actually very straightforward. What you have to do is just go back into GameStore.client over here, and you want to go into www-root and then app service.json. And then for GameStore API URL, you want to replace that with the one that we've been using in Postman, right? For the Azure App Service. So I'm going to just copy this URL from Postman into here, replacing localhost 5115 with that brand new one. And then I'm going to just go ahead and open my terminal, .NET run. And now our client application should be able to run connected to the cloud. So let's go now into our application, which last time I ran it over here. So let me just go ahead and refresh this. And as you can see, it is now loading our Mario Kart 8 Deluxe game, which is now living, of course, in the cloud. It doesn't have the image because we didn't set an image via the Postman URL, but we could go ahead and just click on there and we could go into choose file. And I'm going to select my Mario Kart 8 image right there. This is going to upload the image into Azure Storage, right? We click on save, and now we have our game right there. So this is our local client talking to our .NET REST API that is completely running now in the Azure cloud, in the Azure App Service. With that in place, I'd like to just revert this change. So I'm going to stop my client. I'm going to stop that, collapse this for a second. I'm going to close that, and I'm just going to do Control C here so that we just revert back into this setting over there because we don't want to just keep that there. Yeah, so that's pretty much it for your REST API. It is done. And then as a kind of an optional, another model in this course, what I'd like to do is just offer you this other model where you can see how to deploy also this client into the Azure cloud so that you can see the entire thing running end to end in the cloud. So like I said, it's an optional model, but I think it's a good exercise for you too. So let's go ahead and start that other model. In this model, you will deploy the client application to the Azure Static Web App Service so you can see the full stack application running end-to-end in a production environment. By the end of this model, you will have a solid understanding of the following: how to configure the client to talk to your cloud-based REST API, how to publish the client code to GitHub, how to create an Azure Static Web App, how to deploy the client to the Azure Static Web App Service, how to configure your REST API to allow calls from the cloud-based client, and how to add Auth0 support to the cloud-based client. We will deploy our GameStore client application into the Azure Static Web App Service, which is a great option for Blazor WebAssembly applications. But one prerequisite before we can do that is to have our code hosted in some sort of source control system, which could be either GitHub or Azure DevOps. So for this lesson, what we're going to do is use GitHub as the place where we're going to just push our code for the client. And in the future lesson, we're going to go ahead and use that code from GitHub to deploy the application to the Azure Static Web App Service. So let's go ahead and let's switch into this other tab. And I have already signed in into my GitHub account. If you don't have an account, please just go ahead and go into github.com to that URL over there. And creating an account is free. It is very easy and very quick. And so you can get started with that right away. Now here, I won't be using my personal account for this purpose, but instead I will be using my .NET Microservices GitHub organization, which is just another way to group a series of repositories that have some similar purpose, right? But you don't have to use an organization, you can use your personal account, things will work just the same way. And so what we want to do now is to just click on New over here to go ahead and create a brand new repository. And then, like I said, I'm not using my GitHub account here. I'm using just my .NET Microservices organization. And you can pick a repository name here. So the repository name that I'm going to pick here is just Game Store Client. So it's going to be Game Store Client. And then I'm going to just scroll down into the very end, and I'm just going to go ahead and click on Create Repository. And the repository is ready to go. Okay, and so now we have the repository ready, it is time to publish the code over there. So let's head back into Visual Studio Code, into the instance where we have the source code for the client, not for the web API, just the client. And here we'll have to make just one change, which is in this file, www.root in app settings. So look at this, app settings.production.json. So not app settings.json, but production.json. So this is the file that's going to get activated when we are running in the production environment, right? For this one, all you have to do is just place the URL of your REST API in Azure. So if you remember, if you go back to the Azure portal over here, and if you go into the app service, which is this one over here, Game Store 01, we will have that URL right here. It's this one here, Game Store 01, azurewebsites.net. So I'm going to go ahead and copy that to clipboard. And then back into VS Code, I'm going to just paste that over there. But of course, we have to append to this HTTPS, like that. The Blazor client in production will know how to actually talk to the REST API in production. So with that in place, we can go ahead and push this code into GitHub. So what I'm going to do now is go ahead and just follow the instructions in the GitHub page over here. We're going to go ahead and add a README file. If you don't have one, let's see if we have one. We don't have one, so I'm going to just paste that line here. We're just going to go ahead and just create this README file over here, which pretty much has nothing, which is okay. And then next line, git init to initialize our repository. Stat git init. And I'm actually going to go ahead and do Ctrl+Shift+P to show my activity bar on the left side. As you can see, there are just way too many files to be checked in over there, and we don't want to add that many. So what I'm going to do is just add a git ignore file into this repository so that only the files that make sense to check in are going to actually get checked in. Okay, so I'm going to do .NET, let me clean this a bit, .NET new git ignore. Okay, and that's going to go ahead and create a git ignore file. As you can see it right here, this is the brand new file that got created. Okay, so that excludes a bunch of things. And as you can see, now we only have 48 files to check in, which sounds just fine. And let me close these ones. With that in place, let's go ahead and continue the steps here. I'm going to go ahead and add all of my files. So I'm going to go to the source control view over there. I'm going to go over there and I'm going to select all of the files over here. Let's close this and let's close that. Right click and then stage changes. So that's going to place all of the files into staged, so ready to go. And we are going to say, just like it says here, it's going to be first commit at the very top, first commit. And then I'm going to commit all my files. Okay, so you're committed. And then git branch -m main, that this is kind of optional, but it renames your branch from master and into main, which is not a bad idea. So let's do that. And then we're going to add the remote, right? So that we can point the local repository into the repository that is in GitHub. So let's put that right there. And finally, we're going to go ahead and do git push -u origin main over here. And with that, our code should now be all in GitHub. So I'm going to go back into GitHub right here, and I'm going to just refresh this page. And as expected, the entire code is now published into GitHub, right? So you should see something like this in your GitHub repository now, which means that we are ready for the next step. So in the next lesson, you will create an Azure static web app where you will deploy the code that you just published into GitHub. Let's now go ahead and create the static web app that is going to take care of hosting our Game Store client application. So here we're back in the Azure portal, and as usual, we're going to go ahead and click on the create a resource link over there. And then we're going to be looking for static web app. Okay, it's going to be the first option here, static web app. And then in this list, it's likely going to be your first option too. So it's going to be this one over here, static web app by Microsoft. That's the one they want to choose. So click on create and then static web app. And this starts the static web app wizard. As usual, in the project details, make sure that you have selected the correct subscription. In my case, that's .NET Microservices. And for the resource group, in my case, it is going to be Game Store. This is the same resource group we've been using across the course. So it's just one resource group. So that's one that I'll be using here. And then I'm going to enter a name for my static web app. I'll just name it Game Store 01, because I'll be using that name in a few places. And then we will keep that free option there for hobby or personal projects. So we'll keep scrolling down. We are not really going to use Azure Functions with our static web app, so we can skip this region drop down there. But the option I want to choose here is this one that says GitHub for your deployment details. That's going to be the source of the files that we're going to be using to deploy our static web app, right? So it has to be GitHub. And then the Azure portal may or may not recognize your GitHub account. As you can see, in my case, it did recognize my GitHub account. It says it may just not show it for you. So if it doesn't, so use the option here to sign in into your GitHub account. And then what we want to do is just scroll down here. And in my case, for organization, let's just open up this. I'm going to pick the .NET Microservices organization that I used in the previous video. And then this should show up now the repositories that I have available. And then one of them is going to be our GameStore.client, right? GameStore.client. And then for the branch, it's going to be just the main branch. Now let's keep scrolling down. There are more options here. And so for build presets, if we open up this, there's going to be one preset for Blazor. So that instructs a static web app how to go ahead and build your application and get it ready to get deployed into the cloud, right? So that's why you want to pick Blazor here. And then lastly, for app location, you don't want to just use client here. So this is going to be the location in your code repository where your client files live. So if you go back into GitHub over here, you're going to see that all the files actually live at the very root of the repository. There's no client directory. Well, there's clients, but that's different. So everything is at the root. Since everything is at the root, what you want to do here is just put here, let's put slash, meaning that we want the app location is actually at the very root. Now for API location, this value here doesn't really matter because static web apps have a feature where they can also deploy your API if you wanted to, but we're not using that. So it doesn't matter if you put a value here or not. And for the app location, we're going to leave that as is. And then you could click on preview workflow file, but we don't really need to do that right now. We're only going to go ahead and do review plus create. And let's go ahead and click on the create button to get our static web app deployed. Okay, so deployment starts. So let's give it a few seconds to complete. All right, that was actually very fast. So the static web app has been created and I'm going to click on go to resource. But the thing is that even when we have the static web app created at this point, the actual code have not been deployed just yet, right? It is going to get deployed. And that's why we have this kind of a warning over here, right? Kind of an informational message saying that we have the static web app, but the code is not there yet. So what's happening is that if you go back into GitHub over here, and if you go now into actions, you're going to see that there is a brand new GitHub action running in your repository. And so the GitHub action or the GitHub workflow is, and I'm going to click on that, it's kind of an automation that static web app, the wizard, created for us right into the repository so that anytime we push changes into the repository, it will automatically go ahead and build the code and deploy it into the static web app. So if I click here, let's say in build and deploy job, you're going to see that it is following a bunch of steps into getting the code deployed. So as you can see right now, it is getting the contents right of the static web app, and then it's going to go ahead and build it, and later it's going to go deploy it. Right? Now I have seen a few cases where the very first time that you try this, the first workflow is going to fail, the first job is going to fail, but then it will immediately and right away just kick off a brand new workflow, and that one is going to succeed. So that may be an existing or known issue of static web apps, but in the end, it always just executes a final workflow that it will go ahead and succeed. Yeah, so as you can see right now, it is getting things deployed right into the local directory, and later on it's going to get deployed into static web app. So let's give it a moment for this workflow to complete so that we can try out the static web app. Okay, so the deployment has been completed at this point. The code should have been deployed into a static web app. So now let's go back into the Azure portal over here. And what you can do now is just use this URL over here as the entry point to get into your static web app. So let's just click on that one there. And it's going to be a very random URL. As you can see, it just says Mango Island here. So it's a strange one. But as you can see, we have our portal up and running over here. But of course, we do have an error, as you can see here. And let's explore what's going on. Let's just hit F12 in the keyboard there, and let's go into our console. Let me open up here. Let's go into the console and let's see what's going on. And what you're going to find is kind of a familiar error, this one over here. So guess what this is? This is CORS, right? So that we have a CORS policy error, which is expected because our REST API doesn't really know just yet that it should be allowing calls from the browser calls from this new domain where the static web app is. So this is expected, is fine. In the next lesson, we'll see how to fix this CORS error so that our REST API allows calls from the Polish Game Store client. As we saw in the previous lesson, we are having currently a CORS error because our deployed .NET REST API is not allowing calls from our brand new domain for the Game Store client, right? So let's see what we can do to fix this. So let's actually go back into our Azure portal over here. And the first thing we're going to do is to just go ahead and copy that URL for our static web app. So this URL that is over here, let's just copy it to clipboard because we're going to need that. And then let's go back into home. And then let's go into our app service, right? So the Game Store 01 app service that I have over here. Let's go over there because what we want to do is to go down into the configuration section here in configuration. And what we want to do is to add a brand new application setting to override to what we have set up as an allowed origin in the code. So you actually go back into Visual Studio Code over here, and this is for the REST API. Remember that if we go down into app settings.json, we have defined our allowed origin as this one over here, right? Which is the localhost 5259, which is the local address of the Game Store client in our box, right? So what we want to do is just override this with the right value for the application in the cloud. So if you go back into our web app over here, all we have to do is just click on where it says new application setting. And then, since I have the value in my clipboard, I'm going to just paste the value first, right? That's the URL for our static web app in the cloud. And for the name, all we have to do is just go back to Visual Studio Code and just copy the allowed origin, right? So allowed origin is the value that we want to override with this new setting from Azure App Service. So I'll copy that. And then back here, I'm going to paste that value over there. And then I'm going to just hit OK, right? So as you can see, now we have the brand new allowed origin value over there, right? Which if we show here is that value for the static web app. So I'm going to click on save, click continue, and that will go ahead and set this new value. It restarts the web app, right? The entire REST API. And then, like I said, Azure App Service can act as another configuration source for your .NET application. So just by doing this, the value is being overridden, but your application doesn't really need to know. It will just get the brand new value and it thinks it is the value that was used before, but this is the one from the cloud. And so with that in place, we can go back into our deployed application and let's go ahead and refresh this and let's see what happens. So I'm going to refresh. And it took a while, and let me just close this. It took a while because it had to restart the application, right, on the backend. But after that, you can see that now we are able to actually load our games, our one game from the cloud. So the integration is working properly. And so that's great. And if I refresh this, it's going to be faster now, right? So it will go ahead and load the image right away. That is fantastic. And one more thing that we want to try out is our actual login experience to make sure that login authentication, authorization, everything is working. So let's go ahead and click on login. And what is going to happen here is that, this is kind of actually expected at this point, and it is because our Auth0 configuration doesn't yet know about our brand new static web app in the cloud. In the next lesson, we will go ahead and update Auth0, the Auth0 configuration, to let both authentication and authorization work properly in our cloud-based Game Store client. Let's update our Auth0 configuration so that both authentication and authorization will work properly in our deployed Game Store client. So here we're back in Auth0, and what we're going to do is go into Applications, and then again into Applications. And here, let's look for our Game Store client. So Game Store client right there. And then we're going to be scrolling down, and let me collapse this for a moment. Let's scroll down all the way to the application URI section. And as you remember, we do have one allowed callback URL here. Remember, this is the URL where Auth0 will redirect the user after login has completed, which works fine for local development, but in the cloud, it doesn't make sense, right? So why would it return back into localhost 5259? That makes no sense. So what we're going to do is to add the corresponding URL here for the deployed static web app. Now let's remember what is the URL of our static web app. So I'll go back to my Azure portal over here. And here I'm going to go into my resource group, so the Game Store resource group, and I'm going to look for my static web app, this last one over here. And of course, the URL is going to be right here on the right side. Here's the URL. So let's go ahead and copy that URL And let's go back into Auth0. And what we're going to do is just put a comma. So it's comma there, and you can have multiple callbacks URLs, right? So I'm going to just paste what I just copied. And then starting with that domain, we're going to just go ahead and add /authentication and /login callback right there. So that's all we have to do for allowed callback URLs. And then let me go ahead and copy the URL once again, because we have to do the same thing for allowed logout URLs. So allowed logout URLs, we have localhost 5259. This is the place where we return after logging out from the application, from Auth0. So we're going to do comma and then paste our URL once again, and that should do it. So I'm going to go ahead and I'll go all the way to the end and just click on Save Changes. And now we can go back into our client, which I have running over here, right? So here's the client. I'm going to just refresh it quickly. Just refresh it. And I'm going to go ahead and click on login this time. And as you can see, this time login succeeded. It did remember my last login, so that's why it didn't prompt me. So it just remembered from the cache. But you can see that now our administrator has been logged in right there. There's administrator. And but then let's confirm that the whole flow actually works properly. So let's go ahead and do logout for a second. Okay, so now we're logged out. And then let's go ahead and do login again. And as you can see, yeah, we do get our login screen right here, which is expected. Now, if this red mark over here at the right side is bothering you, that's really just kind of because the Google authentication that you can see down here at the bottom has been enabled, but it's using kind of some test settings for connecting to Google, right? Which are not the right settings. So that's kind of what this warning is saying, is that you're using kind of development keys to configure this Google authentication. So if that one is bothering you, what you can do to get rid of it for now, because we're not going to be enabling Google over here, is just go back into your Auth0 portal over here, and then let's expand the left side and let's go into authentication, social, and see that there's a, let me collapse this, there is this Google authentication right here, right? This Google authentication, and we're not going to use it. So we're just going to click on these three dots at the right side, and we're going to click on delete. Okay, so I'm going to type Google Auth 2. I'll click on delete. Okay, now it is gone. So now we can go back over here. I'm going to just go back to the application, right? And I'm going to click on login once again. So click on login. And notice that this time that warning is gone, right? So that red mark is gone, Google authentication is gone, so it's much cleaner now. And so yeah, so this time let's go ahead and log in again as admin. Okay, so yeah, login succeeded. And then, well, let's verify that we can actually create a game. So let's go ahead and create one by clicking in new game here. And we're going to be entering, this is going to be again our Super Mario Bros 3 game, which is Kids and Family. The price is $19.99, and then the release date is 10/13/1988. And finally, let's choose our file, right, for the image, Super Mario Bros. 3. I'll click open. And as you can see, the image shows up right here, the preview, which means that it got uploaded into Azure Storage. So we can click on save. And now our game is showing up right there. So indeed, our application seems to be working now end-to-end from the client all the way to the .NET REST API. And of course, we could try something else. Like we could try an edit also. Let's say that we want to lower the price to $9.97, for instance. And let's go ahead and hit on save. And as you can see, the update also worked, right? So that's great. And we can also try out delete. Let's say we're going to delete Mario Kart Deluxe. I'll click on delete. And that is working properly. So yeah, pretty much the entire experience is working end to end with both your client and your server running in the cloud. So that's the end of this model, and I hope you're pretty excited to finally see both your .NET REST API and your Game Store client all working and running end to end in the Azure cloud.